Good morning, everybody. Time to start .NET Conf 2025 Community Days. We've got a great lineup for today. We've got a ton of great presentations and sessions, starting with everything from System.Json all the way down through Blazor and Aspire and all sorts of really interesting and entertaining sessions. Our first one coming up right now is Tomas. He's going to be talking about Newtonsoft.Json and System.Text.Json. So let me go ahead and get that queued up for everybody. And we'll be back at 8:30 after the session. Thank you.
Hello, everyone. I'm thrilled to be here at .NET Conf. And this session will be about the lessons we learned when we migrated from Newtonsoft.Json to System.Text.Json on a quite large project. The project is actually an open source framework for building web applications. So it's not a common web app that would just expose some APIs. We did quite advanced things with JSON, and the differences between these two libraries are quite significant. So in this session, I will go through quite interesting scenarios we run into. My name is Tomas Herceg. I'm a Microsoft MVP from the Czech Republic. I'm running a small software company called Riganti, and I'm maintainer of .vvm, the open source framework, a member of the .NET Foundation, and the framework I will be talking about in this session. The things I will be describing are relevant for you if you are trying to modernize some REST APIs. Typically, if you have a web application written in .NET Framework, which is using ASP.NET Web APIs, and you are trying to migrate it to the new ASP.NET Core, because then probably you will switch to the new library as well. Also, if you have been using ASP.NET Core since the first versions and for some reason you used Newtonsoft.Json and now you feel that it's the time to finally convert to System.Text.Json, or if you are like me and you maintain some library which usually wants to support both .NET Framework and the new .NET, but since System.Text.Json runs also on .NET Framework, then this migration can be interesting if you are if you are a library author. So before I start showing the use cases we have run into in .vvm, I would like to just shortly, briefly describe what .vvm is and what we actually do with JSON. So as I said, .vvm is an open source framework for web, and it's using MVVM, model view model approach to design your applications. Basically, you just write an HTML file with some data binding, and then you accompany it with a view model written in C#, so you don't need to write JavaScript. And basically, the framework will make sure that the view model is accessible in the browser, and the MVVM experience with the two-way data binding happens there. So in short, .vvm needs to create a C# view model and then render the HTML page and serialize this view model in JSON and send it to the browser as quickly as possible. And if the users do something with the page, for example, click a button, if they, for example, want to submit an order or save a customer or something like that, this requires some server-side action. So in that case, the view model is deserialized, and basically the changes are applied to the C# object. And because sending the entire view model from the server to the client and back could be use quite a lot of bandwidth. The view models can have hundreds of kilobytes. So in this case, we are doing JSON diffing. So we are just comparing two versions of JSON and sending only what changed. And also then we need to apply this diff to an existing view model or a JSON object. So we also do JSON patching. And because some parts of the view model might need to be protected, so nobody can even read it on the client, or if they can read it, they shouldn't be able to change it. We implemented our own encryption and digital signing mechanism that you can apply to some fields in the JSON or some child objects, some subtrees. So part of the view model can be protected by a digital signature, so the user will not be able to tamper with that. Just to have a better idea how the syntax in .vvm looks like, so on the left side you can see the HTML with our custom components like a text box or a button and data binding syntax. This is somehow translated to JavaScript, so you don't need to write it, but that's handled by the framework. And on the server side, you declare a view model. So here we have a simple C# class with an integer property called number and a method which can increment this number. So whenever you do something on the client which requires server-side cooperation, you can do also local changes in the view model, but these are not that interesting from the perspective of this session. So once you invoke an action on the server, the view model has to be JSON serialized, sent to the server. On the server, we need to deserialize it, run this increment method, and then serialize the changes that were made to the view model and send them back to the client. So the page on the client side, it stays loaded all the time, and the view model lives sometimes in the C# version, sometimes it lives as a JavaScript object while the user is looking at the page, and these transitions are transparently handled by .vvm. As I said, we implemented a couple of advanced features. So for example, this first property says bind direction server to client, which means that this property is only sent when it's going from the server to the client. So it's part of serialization. But if the client would send it back, it would be just ignored. Yeah, so like we need to conditionally include some properties based on this attribute. Also, there are other things. Some properties are just sent to the browser, but they are never updated. The list of countries can stay there while the page is loaded, and it will never need to go back to the server and back from the server to the client. So this means the server to client first request. And as I mentioned, you can, for example, digitally sign some parts of the view model. So this needs to be readable because you need to display the total price in the browser. However, if the user would try to change this property and send this modified view model to the server, it will not be allowed because we also keep digital signature of the fields that we protected in this way. And this is a part of view model. There is some special property called encrypted fields, and that contains signatures for all the data in the view model that should be protected. So as when we were trying to change System.Text.Json as a new backend for the serialization and the view model in our .vvm repository, we kind of thought that it would be quite easy because there was just few places where we call JSON convert serialize or JSON convert deserialize. Then we found out that's not that simple because we didn't do only this. We were also building the J objects, which is basically a tree of objects in the view model. We were building it, we were reading it, we were comparing these trees because of the JSON diffing and patching. So what was initially thought to be quite simple was actually this big pull request with 252 changed files. And that's the reason why I'm speaking about that, because I think that this can be useful to see for other people who want to do a similar change. After this pull request, which was merged almost 1 year ago, we did a couple of smaller PRs with some bug fixes or some additional features. We found out that the old version with Newtonsoft.Json supported, and because System.Text.Json is a different implementation, they behaved in a different way or they were missing. So the first thing that you would probably expect is that the new implementation has a different API for defining your own custom JSON converters. So if you use Newtonsoft.Json and you have implemented your own JSON converter, you will need to rewrite it to System.Text.Json. They are not that different. There are different base classes, some namespaces, some enums were like changed, renamed, but overall it's a lot of trivial changes in the code. So basically you will change the base class, you will run the compilation, you will see the compile errors, and then you need to go one by one and fix these. Nice thing is that the System.Text.Json is using UTF-8 encoding. So if you want to, for example, compare the property names, you can use these new APIs that will allow you to compare this property name or value with UTF-8 literals, which basically this function accepts something like read-only memory of byte. So because one typical performance bottleneck in JSON serialization would be that you are creating a lot of strings. System.Text.Json doesn't do that, so this is more efficient than comparing with a string, which allocates twice as much memory. So we had to rewrite all JSON converters, and we found out we have quite a lot of them because the framework needed to do various things by using the converters. We had some breaking changes in some objects, so we wrote JSON converters to produce the JSON in the same format without these breaking changes. We also, for one feature of .vvm, we changed the way how dictionaries are serialized to the client. We also want to provide the users client-side type annotations. So .vvm serializes some type metadata in the JSON object. I already mentioned the encryption and signing, which is also done by converters, and the serialization attributes that affect the way in which the value could be or could not be serialized. And we also implemented a custom handling for dates because in some cases it was behaving quite unpredictably with respect of whether the date time is local or UTC. So we built a custom converter that somehow fixes this behavior to be more intuitive for the users. Another feature of Newtonsoft.Json was that you could decorate entries in enum with this enum member attribute. It's part of system runtime serialization namespace, a built-in namespace in .NET, and you can provide custom strings for these values. So instead of if you use the JSON string converter, JSON string enum converter, typically the result would be 0, the word 0 in the JSON. But if you want to change that, you could specify this enum member attribute, which was supported by Newtonsoft.Json. System.Text.Json has a similar attribute, but it's called JSON string enum member name. And because we are implementing a framework, then we want that people who already had enums with this attribute, we wanted to support that as well. So we had to implement our own enum converter, which would look at these attributes and these old attributes and implement other logic as well. For example, also there are some special cases when you serialize enum, which has flags, so there are the bitwise combinations of the options. So we also needed to tweak this a little bit. If you were using System.Text.Json 8, it didn't have this attribute. This appeared in the version 9, so we are glad that we can support it as well. Newtonsoft.Json had a little bit unknown feature called should serialize pattern. If you want to conditionally include some property in the JSON based on some other condition, then you could declare a method called should serialize and the name of the property. And this method could return a Boolean value saying if this property should be included or not. So in this example, for example, I have a customer who has some name and a flag if it's a company or a person. And if it's a company, I want to include also this company number property. So basically, this should serialize company number function is true only if the customer is a company. So if it's just a normal person, only the name and is company false would be present in the JSON. However, if it's a company, there will also be this company number property. This is not supported in System.Text.Json yet, so we had to implement that. Again, we were not using that in the framework itself, but we weren't sure if some users might try to use that, so we implemented that as well in our converters. System.Text.Json handles inheritance in a different way than Newtonsoft.Json. So in Newtonsoft.Json, you had to turn on some type annotations, which would basically render a $type attribute to every object. However, because of some security reasons, this is not very much recommended approach, because anyone can send you any type, and some types, when you try to create them, they are not doing very nice things on your machine. So basically this is discouraged in System.Text.Json. Instead, you need to, if you want to use derived classes, you need to explicitly allow them with this JSON derived type attribute. So we had to somehow detect that polymorphism was used in the view model, because we supported it in some scenarios with some restrictions. However, in System.Text.Json, it doesn't work. So we just had to detect the cases and throw exceptions. Otherwise, we would suffer breaking changes. And sometimes it could be just by mistake that somebody is using some refactoring tools and some property remains of type object. So there is polymorphism involved in that in every case. So we want it to be not to break too many people. Another issue is the naming policies and how are the casing of property names solved in each library. If you try to use these libraries in a standalone version, like call JSON convert or JSON serialize or .serialize, then the defaults are quite similar. So both are using Pascal case, and so the same name as the C# property would appear in the JSON. However, if you are using ASP.NET Core Web APIs, and System.Text.Json, by default, it's configured there to be camel case. So if you are migrating some APIs from old .NET framework to the ASP.NET Core, just be careful that you configure the same casing. Otherwise, you will have a breaking change, and sometimes it's not very obvious to use. We had one scenario where we changed accidentally the casing in ASP.NET Core, so suddenly the API endpoints started to return different property names, which were different by the uppercase letter in the beginning. And because our client was written still in Newtonsoft.Json, we didn't notice that, because Newtonsoft.Json by default is case insensitive when reading the JSON. However, other clients who migrated to System.Text.Json earlier, they reported this breaking change to us. So it's a little bit tricky, because Newtonsoft.Json was less strict in general than System.Text.Json is. So when going from less strict environment to more strict environment, you will probably run into some tiny differences. Another thing that worked with Newtonsoft.Json, some people, they want their model objects to be a little bit safer, so they prefer using private setters. And to make it work, you need to explicitly specify JSON property in Newtonsoft.Json. So that was sufficient. So people used private setters and applied JSON property attribute on that. And it worked. So Newtonsoft.Json called the private setter while deserializing the object. However, in System.Text.Json, if you just fix the compile error that the JSON property attribute would be renamed to JSON property name, that's not enough. You have to add explicitly this JSON include parameter attribute. Without that, this property would not be deserialized because the setter is private. So the deserializer will just ignore it. It will say, no, I cannot set value in that. You have to explicitly include that. So be careful about this, because if you just fix the compile errors, change JSON property to JSON property name, that's not enough in this case. We had quite a lot of issues. Also, there was some code generation tools which generated objects like that, so we had to fix these tools to add this JSON include attribute as well. And that's just a bunch of the issues we run into. We found more differences. However, they were more caused not by the differences in the libraries. They were caused mostly by our customizations and our custom converters. So I'm not mentioning that. We did some benchmarks. Currently, we have a benchmark just one way of the data serialization, and the results of this change are quite nice, because we saved about like 60 to 70% of time while serializing the view model. However, to be fair, this difference is not entirely because of the differences between the library like Newtonsoft.Json versus System.Text.Json, but we were also doing some things that were not that much efficient with Newtonsoft.Json. On one place, we were building a JObject, which is an object representation of the JSON tree, and then calling toString on it. However, the new implementation writes everything directly to UTF-8 JSON writer, which is, of course, a little bit faster. However, we can still go a little bit further, because on some places in the framework, we still use the serialized view model as a string. If we keep it as a UTF-8 byte array, we would save also some memory allocations, and it would be easier, because now we use UTF-8 JSON writer. We then convert it to string, and then converting it back to UTF-8 to send it over the wire, or have ASP.NET Core to do this for us. So like, these are unnecessary conversions. Even with those, we are faster than we were, but we are also trying to get rid of this final piece. And we expect quite similar performance benefits on the reading side, on deserialization side of this, because System.Text.Json allocates much less memory. Basically, you just get the input, and then System.Text.Json is just looking at ranges of this one input. It's not creating bunch of strings for reading and accessing every property. So that can also help us to reduce memory allocations as well as increase the performance. So we are really thrilled about this change. If you are interested in more details, you can look in our pull request. However, be prepared that it's a lot of changed files, so it can be a little bit difficult to navigate through. So if you are just migrating an old application, you probably not run in all these changes, all these details I pointed out. Just in some cases, it can be a little bit tricky. For example, adding these JSON include attributes, which you will not get a compile error for. For most things, when you do migration, you will get compile errors. So it's quite easy to go through all of them, change namespaces, change the names to the new ones, because some things were renamed. However, if you fix all compile errors, you should be 95% or 98% ready. However, there can be some subtle scenarios where you need to add something or tweak something, and you will not get compile error for that. So be sure, for example, to generate OpenAPI definition and then compare it if it's exactly the same. If you are building a library, it's a little bit more complicated story, because you may still want to support .NET Framework. And the good news is that System.Text.Json runs also on .NET Framework, even though it's not that fast as on the new .NET. But typically when you are serializing something in a library, you have much wider area of features in this serialization that you expect your users are touching. So if you just serialize your own stuff, then you are quite aware of what features you use. However, if you let anyone serialize anything through your library, then you don't know what feature set your users are actually taking advantage of. So that's a little bit tricky. We had years ago, we did one mistake. We relied on global JSON serializer settings. Newtonsoft.Json had a static instance of the configuration anyone could change. So if people change it, they broke our framework. So then we had to create our own, but also that produced some breaking changes. So if you are making a library, make sure you don't rely on any global settings, because this serialization to JSON can be used by multiple libraries with different settings. So make sure you have your own settings. And the last note is that the converters are very powerful, because they allowed us to do a lot of crazy things, extend the serialization with a lot of advanced features. Of course, these converters we wrote are not simple, but the nice thing is that the infrastructure in the parser actually makes this possible. So it's great that both libraries are very extensible. So that was just a short brief what we did in .vvm framework. If you didn't try .vvm and you want to see how to build web apps with just HTML and C# using model view model, which you may know from .NET MAUI or Xamarin or WPF, check out .vvm.com or check out our GitHub. Enjoy the rest of .NET Conf.
I want to thank Tomas for that great session. And we've got our next presenter lined up, Iris. Hi, Iris.
Hello. Thank you for having me. How much time have I got?
Oh, we have like 2 or 3 minutes before your session starts. I saw you backstage crocheting a little bit. My wife does that all the time.
Knitting. I'm always knitting. It's perfect for people with ADHD.
Yeah, so you're going to be talking to us a little bit about Xamarin.Forms and .NET MAUI. Where are you connecting from today?
Sweden, Gothenburg.
Oh, awesome. I love Stockholm because I've been up to DevSum a couple of times, but it's great to have you connecting over from Europe. Have you been following all of the .NET Conf announcements and sessions with 10 and Aspire and Visual Studio?
A couple of sessions. We have new features coming out and a deadline, so I've sort of been working instead. But I've watched a couple of sessions when I had the time.
Awesome. So why don't you tell us a little bit about yourself, since we have a minute or two?
Yeah. Where do I start? I used to work as a clinical dietitian before I decided to become a programmer. I've been on Microsoft MVP for like 13 years or something, I don't know. And a couple of years ago, I started writing books. So I have written 15 books. I have a psychological thriller coming out tomorrow, actually. 100,000 words. Oh my God, that one took forever to write. And I have like programming books. Seems like every speaker on this conference had like this book in the background, like a book, like some A-Press book in the background.
I've never written a book. It just seems like so much work. I have many friends that have done it. I just, wow, 15
It's
books.
It's a lot of work, and you're not going to make any money.
Well, let us go ahead and give you space to talk about things. And I'll go ahead and turn it over to you. Have a great session.
Thank you. Hello. Well, I feel so alone doing this remote. I'm used to doing sessions live, so I'll try not to ramble on too much. Thank you for attending my session. I'll be talking about migrating to .NET MAUI. I will, however, not do step-by-step how to migrate to .NET MAUI, because you're probably already on that journey if you're not done with it. And if you want to have a step-by-step walkthrough, you'll find plenty online. There's also a book. I wrote one book on the topic, but there are other books as well. I don't know if you watched the other session. It seems like there are several speakers at the .NET conference that has like an A-Press book behind them. So I don't know if it was a requirement to speak at this conference, but yes, I'm an author. I write books, non-fiction, technical non-fiction, and also fiction. And I have a dream job as an app developer at Plaid. Plaid is a company that provides smart home solutions and smart home lighting. And I have several here, like when I work from home, I have so many things here that I need to use for development. It's what we have is everything from lights to the modules that you have in the wall, where you have light switch and so on. And we have about 30 plus unique products, and then each product has variations of it. So this is not like a sort of like sales commercial of any sort. I just want to explain sort of the scale of the problem we were facing. We have approximately 3 million users and more than 7 million installed devices. These are old numbers I found, so I don't know where we are at now. When we do our testing, we test on over 40 different phones and tablets. So we have extensive automated and also manual testing, all kind of testing. I'm actually working, like the testing team we're working with is the largest one I've ever worked with, and they do a lot of fantastic work. My team opted out of having our group photo, so you have to deal with the stick figures instead, but that's the team. The app team consists of 15 people. I'm pretty sure you can find me as the only woman on the team. But yeah. All right, let's just jump straight in, because I have a lot of things that I want to cover. So when we started migrating, we started quite early. We started in 2023, I believe. Yes, that's when we created the Slack channel, at least. So probably a couple of weeks before that, we started looking into it seriously. We had been discussing it for quite a while, for at least half a year. And we knew that we are going to need a lot of time. Because worst case scenario, you finish the migration early, but nobody is upset if you deliver early. But if you deliver late, we might end up not being able to push updates to the store that needs to get out immediately. So we had the pressure from the Apple Store, and we also have the pressure from Android. And now Android gave us a little bit more leeway. And as you'll see throughout the session, we have been prioritizing iOS, not only because Android was much harder to migrate than iOS, but also because we had more time with Android, and we're very thankful for that. Some of the challenges we had that also led to us starting migrating really early was that we weren't able to just put everything on hold and focus on migrating. So we have to have sort of like several branches going at the same time. So we have to maintain the old application, the Xamarin application. We had upcoming deadlines on product expansions. We plan our products 3 years in advance, but they might change at any time because we are agile after all. But we still have sort of like deadlines to meet because we are so many teams, like large teams. And if we don't have a deadline to work towards together, it's going to sort of be hard to meet up at the same time with the same things needed to sort of get the product out. So we had product expansion, a whole new line of products, the luminaries. So before, this is quite new, like a couple of years, the downlights, just lights in general. We have outdoor lights as well, and so on. These are new products that were coming out at the same time. A new product means a lot of work, and particularly with testing, and also working tighter with the firmware and the hardware team, which also means that it's eating up more resources, not only in our team, but also other teams. At the same time, we also have new features to push out to the application, new capabilities, and of course, fix bugs, because there will always be bugs. And we thought that wasn't enough. So why not just add a facelift to the application at the same time? So we had 4 things going on at the same time: migrating, new product launches, the facelift, and also new features. So the only way to do this was to sort of split our team up, which I'll explain very soon. We did look into different alternatives for .NET MAUI, because we were a bit uncertain about the maturity. It was super early on. A lot of people were complaining. A lot of people were pulling up like old Silverlight stories. Silverlight is dead, and so on. So, of course, to be wise about it, we did look into alternatives just to feel like we could check those off, that we looked into it. So we looked into Uno, which at the time didn't have that collaboration they have with .NET MAUI, which they introduced now during the conference. Avalonia, Flutter, somebody made like a mock-up version of the app in Flutter, Ionic, and so on. But at the end of the day, and we knew it when we started looking into it, we would end up with .NET MAUI, because that's where our knowledge is. We have a lot of Xamarin experts on our team. I don't know if I can call myself that, but we certainly have experts on our team in Xamarin. And also it's the same language, same libraries, the same tooling. And most important of all, like these different directions I was talking about, all these like parallel branches, not different directions, but parallel branches. It's much easier if it's the same language and sort of the same framework, because Xamarin.Forms is not that different from .NET MAUI, because .NET MAUI is sort of the next evolution of Xamarin.Forms, although you've got to rewrite a fair bit of code. I've written a lot of books on migration because I've done quite a few migrations. ASP.NET to ASP.NET Core was a favorite migration of mine. Yeah, I don't know why I keep doing that to myself. But I usually recommend these steps. In an ideal world, you do your analysis and you do an inventory of the things that require more work to migrate. Then you got all those in a spreadsheet. And because there's always this one weird person on the team that loves spreadsheets and knows all the Excel shortcodes, that person will make the perfect spreadsheet to have everything in. And you can use that spreadsheet for your planning and preparation. And when you have everything done, this sounds like homework. You can do the execution, which will go without any issues, and then some little post-migration polish and fix some minor bugs. It's not what we did. We jumped straight to execution. But there's a good explanation as to why. It was summer. We were all on summer vacation, except Johannes, because he chose to work during summer. And he also decided to start migrating to .NET MAUI. And by the time we came back from vacation, we all just like prayed that he'd be completely done with it. But he wasn't, but he got a lot of work done. Now, Johannes is the most senior developer on our team. He's been there since the beginning. So he has an inventory in his head. So that's sort of why we jumped straight to execution. And also we realized we're going to need a lot of time. We got to get started now. So the hard part, which is what I've talked about now, the first hard part we ran into is the logistics and timing of everything. The parallel maintenance, the deadlines, testing across so many different devices. If we have one bug and we have 7 million installations and then we have 3 million users, I don't know what the formula for this would be, but there's some sort of like square root or something here to calculate how this will multiply into into a black hole if we messed something up. So we couldn't afford messing anything up, which also means we need to coordinate with other teams. And also the .NET MAUI application that we migrate must be backwards compatible. So we also need to test that aspect. So there's a lot of testing going on. And what we learned from all of this is that the 80-20 rule exists and it's very real. So 80% of the migration is going to go quite easy. It's just a lot of renaming, changing dependencies, and just tedious work that is sort of boring. But then you have the last 20%, 1%, if we're talking about the UI and Android, that is going to take up as much time as the 80%, if not more. So we spent maybe a couple of months migrating to .NET MAUI and getting to the first green build. And then we spent a couple of years fixing all the minor issues or all the other issues. So what we did is we split up the team. It's quite a luxury to have a big team, but we split up the team. We have the UX team, which is always the UX team, Jimmy and Yulia. They do fantastic work. They were focused on the current application. And Roger, who was tasked with building a new UI builder. All our UI is written in code in C#, not in XAML. And we have this sort of like builder that we use to create all our pages and we have our own concept of a grid and rows, or cards and rows, we refer to them as. So he created a new one that would work both on Xamarin as well as .NET MAUI. Then we had the MAUI team. I was on the MAUI team, and then a couple of others. And then we had 2 teams that would deal with new products and new features. And then in green, the master merger. We keep punishing Johannes, but he and I believe Max was involved as well with this to merge everything new that is added in the Xamarin application to the .NET MAUI application. It's not a fun job. You got to really love your workplace to have that as your sort of full-time job. But yeah, we had one person dedicated to do that, which I highly recommend if you're going to do parallel branches. So the goals were pretty straightforward. Make it build, be able to log in, see a couple of views, then we can enable the tests again and make sure those are green, and then make sure that we have all the base functionality. We can open all the pages and the important dialogues. And once we have this sort of like stable foundation with minor things, then we'll use this as our main branch. Well, talking about more about the initial phase of the migration, that was also the hard part. Well, more hard part because we had to change from a multi-project to a single project, which wasn't what we wanted at the beginning. And I know you're looking at our branches there in the beautiful colors, rainbow colors, and you're thinking, this is the most fantastic branching strategy I've ever seen in my life. This is real life branching. This is how it looks like, and it works for us. But as you can see, we have a lot of parallel branches that we need to be able to manage. So when we, and I say we, but it was mainly Johannes, started migrating .NET MAUI, we did so as a multi-project, but we just couldn't get it to build. We kept getting AOT errors, and this can depend on a lot of things. It could be trimming that has removed some assemblies that you need, or you have double references somewhere, or just random error, or who knows. We spent a lot of time looking into it until we decided, you know what, we're going to stop fighting against the new architecture and accept .NET MAUI as it is, which is meant to be a single project because it better represents the concept of a single project targeting multiple platforms. And in the beginning, we all struggled with this because we like to have things separate. But I think now that we've gotten used to it, we wouldn't go back to the multi-project layout again. We did, however, lose our Git history when we moved to a single project, which is a real pain, in particularly as we merged in new products. So those new lines of code would be nice to actually have the Git history from the beginning. But that's what happens. And our lesson was, don't get stuck, pivot early. if you run into a major issue and it's eating up a lot of time, don't try to force it to work. Look into alternatives and pivot early, because you can really get stuck on one idea and it's not going to work. And I know a lot of other teams that had similar problems, other companies with multi-project and a single project. So I usually always exclusively recommend the single project structure, almost. So some of the changes when you migrate, you use the upgrade assistant. The stuff the upgrade assistant does is stuff you need to do manually otherwise, and you still need to do a lot of manual work, so you might as well let it go to town and do a lot of stuff for you. It'll go ahead and migrate some namespaces and update your dependencies and restructure the project, and also to update the project files and a few more things. But then you need to dive in and you need to do a lot of namespace corrections, which if you have some nice refactoring tooling, we use Rider, so we use that to help with renaming. Find replace works really well. And that same person who loves spreadsheets and Excel is also the same person who loves regex. So you could even use that, but commit early. So you can always sort of like step back if something goes wrong. So yeah, refactoring tooling, regex search and replace helps a lot. You got to fix all your cross-platform paths and make sure that they work on both platforms or all the platforms you're targeting. Update packages, replace some packages. We don't have a lot of external dependencies, so that was really easy for us. But I know it's a pain point for some other applications that are reliant on third-party dependencies that have not been migrated to .NET MAUI. But we didn't have that issue, thankfully. And also some minor code cleanup. And yeah, moving to the new structure. All in all, 3,000 files changed, lines added, lines deleted. If you want to do something really fun, if you have Cloud Code, you can give it like a hash code for a commit and then ask it to summarize what happened in that commit. And that's what I did to sort of get the stats for some of the changes. So hard part number 3. Renderers, which are now referred to as handlers because they handle UI. So the renderers, you're always going to have more renderers than you think you have. We didn't do an inventory, but I have done an inventory of a fitness application I have, and it looks something like this. So if you do an inventory, this is the spreadsheet somebody loves but everybody else hates. You have your category, component, current usage, MAUI equivalent, and some nodes. We didn't do that, but we would have needed several pages or tabs for renderers because we had quite a few. What happens is like when you run into like some issue in Xamarin, you just quickly wire up a new renderer and then you forget about it. And then like 5 years later, you migrate to MAUI and you go like, what does this even do? So we had quite a few. Now you can have something called shimmed renderers. It doesn't give you full API access, but basically lets you reuse some of your old renderers as is without migrating them to handlers. But I don't recommend that. Just stick to the new architecture and the new patterns, which is the handler pattern, and re-architect your renderers to handlers. And when you do that, make sure that you take a look at what's already existing. If you can just sort of like extend an existing mapper, that's much better than actually writing out the whole new handler. Now, the architecture and the lifecycle differs. You'll find plenty of information of that online. So it's a lot of work, and also debugging handlers is not as straightforward as debugging any sort of like backend code for an application. So it eats up a lot of time. So try to remove the ones that you don't absolutely need while you're at it. That's what we learned. Do an inventory and embrace the new pattern, which we did. And we talked about the shimmed renderers. Now, there's also the compatibility package. And I know this was promoted really heavily early on. It wasn't heavenly, that's what I'm getting to. I'm going to get in trouble for this. But it was promoted a lot in the beginning. Oh, we also have the compatibility package. So it makes it easier for you. Well, you know what? It didn't make it easier for us. Maybe we did something wrong, but we added a compatibility package very early on, before Roger started working on this new UI builder, because we wanted to keep all our relative layouts and our stack layouts, and we didn't want to change all that, and we want to be able to build quite fast. So to speed things up, we added a compatibility package. And in the beginning, it looked like it worked. And then we started running into issues because it wasn't compatible with other things. So while it added compatibility for some aspects, it added incompatibility for other aspects. So it's sort of like whack-a-mole, you know, keep whacking, but a new thing pops out. So we ended up removing the compatibility package and looking over our layout and rebuilding them. And again, embrace .NET MAUI and don't try to force Xamarin on .NET MAUI. And with the new UI builder that worked on both, with just some minor changes for .NET MAUI, that made the work much, much easier for us. But we lost a lot of time trying to sort of force it in the beginning. And we've been talking about layout. So I said the 80-20 rule when it comes to UI, and in particularly when it comes to Android, because Android is what gave us most issues. And I do believe if you look at the MAUI repository and you look at the Android tags, you'll find that Android has a whole lot more issues than iOS. Because Android is special, it has different implementations. So there's a lot of US level bugs to handle. From different providers. So it's not easy. I don't envy the team that has to deal with all that. But the UI is what we've spent most time, tears, blood, sweat on, because there's a lot of differences. And you'll find a really good list online in the Microsoft documentation on the UI differences, in particular for layouts, but also controls. But one of the things is like you have new defaults, which are 0 basically. But before, Android would have its own defaults like 4 or 6 and so on, which means that you have to go in and add some manual padding, and also managing safe area, which now is much easier in .NET MAUI, latest version of .NET MAUI. There are also a lot of platform differences. After all, there are different layout engines underneath it all. So you have to do testing. And if you test on the emulator, I mean, is it even an emulator? Yes, it is, but because it is a virtual machine in the background, that's the definition of an emulator. But at the same time, you can't really test on different Android OS implementations. So that means if you're not testing on all the different physical devices, you're going to not notice some of the bugs. For example, Galaxy with the API level 13 had a particular bug in the first few builds of that API. That basically rendered the shadows like as really harsh shadows without any blur. And we spent a lot of time trying to fix that until we decided, you know what, we're just gonna we'll let the user update their phone, okay? But things like that is hard to manage. And if you choose to manage it, it's going to eat up a lot of time. .NET MAUI is not going to handle all the minor differences underneath it all because it's not realistic. What we learned from this, except from shadows, and we have 36 merge requests only on shadows, and I believe I've done 2/3 of those. And we've had issues with shadows even before .NET MAUI. We had this in Xamarin as well. And despite having shadow now in .NET MAUI, we still have to manually handle shadows for some of our more special custom controls that we have. What we learned from this was You got to set a lot of time for this and be prepared to move things a millimeter, a pixel here, a pixel there. The UI is going to eat up most time out of everything. And you have to test on physical devices. There's no going around it. You have to have a collection of physical devices that you test on. Don't rely on the emulator. Never do that. And also specify the layout values explicitly. It will also help in the future if you do so. And obviously you want to unify that in a style and have everything in one place and also like sprinkled throughout the project as magic little numbers. Number 6, the last hard part I'm going to cover is performance. So we were so excited going to .NET MAUI because like things are going to get so fast now, like woo, we were ready. And it was faster in the beginning, but then it regressed because it turns out that nesting tons of grids and stack layouts is not the best idea, and also nesting gesture recognizers, so you're triggering these layout changes and sort of let it bubble up through the tree. Yeah, that's not ideal. So we actually had a regression in performance, which we did not expect. And at first, we were very quick to blame .NET MAUI, but turns out we hadn't read the documentation properly, where it explicitly says to use the right layout and the right controls for the right things. And now that we are wiser, we're also much faster. And that fast person on that slide is me, Stockholm Marathon this year. Any opportunity I get to brag about running that marathon, I'll use it. So yeah. What we learned from performance is also that profiling was really tricky 2 years ago. And what we did, and I think this is pretty cool, like Pontus, I believe, in our team, we have a developer version of our application where it has like a developer menu. And you can go in this developer menu, you can select to sort of build an in-app inside the app, and you use this UI builder to add new cards and rows and sort of build like a fake page and get performance output on that. So instead of actually implementing it and then doing profiling, you can sort of test a little bit ahead before implementing. And that's actually really, really neat. I like that. Now, profiling has become a little bit easier. So I'm very thankful for that, but it's something you want to do quite early on. Even though .NET is getting faster and faster, you can still mess things up on the dev side. So don't rely on the changes in the language and the framework for performance. Don't rely on just that. So lesson learned from that, except besides read documentation, obviously, MAUI rewards clean layouts and early profiling, which seems sort of like given. There's so much more I could talk about, and I'm already talking super fast, so I won't be able to cover more, but I'll give some honorable mentions to effects, which are now behaviors. They're cleaner now, but you have to redesign those. And working with touch is also a bit different. Theme management has changed and it's easier to work with, but keep in mind that if you change your controls inside the handler, it's not going to automatically apply the new theme when the theme changes. So you got to make sure that you actually manage that inside the handler as well. If you change the color, for example. Navigation, we had some issues, but most of all, more because we have our own implementation of navigation. We have our own navigation concept that is very specific to our application. App Center obviously was retired, so we had to find a replacement for that quite early on. 1/3 of the team, or some people in the team, were using Visual Studio for Mac, so they had to adjust to a new development environment, Visual Studio Code or Rider. And we've had a lot of problems anytime we've had to update Xcode and the Xcode tooling. Not as much when we're updating our MAUI workloads, but it's definitely been a challenge. All in all, the takeaway is 3 things to remember. Plan for reality and not like ideal conditions. It's going to seem really easy in the beginning, but the last bit is going to take more time than anything else you've done so far. And it's an evolution, not a retrofit. Adapt as soon as you can to the new way of thinking and the new architecture and patterns, and it will make it much easier moving forward.
Great job, Iris. I know that we're at time, and I know you had to rush.
I'm more out of breath than when I go running.
Well,
I don't even know if anybody's watching this. If my colleagues are watching this, I'm going to die.
This is great. And yeah, definitely the sprint, not the marathon. I want to thank you so much for sharing everything, and great job. That was really interesting and informative.
Thank you. Thanks for having me.
Thank you. Bye. And now I want to bring Stace onto the stage. She's going to be...
Hello there.
Hi. So, I mean, who are you? Oh, wait, you're going to be talking about identities with Blazor. So
I'm going to be talking about, I don't know who I am yet. By the end of this session, I should know who I am, hopefully.
Yeah, hopefully we will too. So thank you for joining today. Where are you joining us from?
I'm joining you from Sweden. Normally, this is not what's behind me when I stream. Normally, I have a load of Lego and other geeky stuff, but I'm traveling right now, and I'm really lucky to be in the Coding After Work studio. So I have a wonderful setup here, which is supremely complex. Thanks so much to Jimmy and Jessica for letting me use it and showing me how to use it. Yeah, wonderful space to do this.
I don't want to take from your time, so I will turn it over to you to get into, being authentic with Blazor and Entra ID. So thank you.
Okay, thank you very much. Okay, well, hello everybody, whatever time of the day it is where you're watching from. Thanks so much for spending the next 30 minutes with me here. I want to talk about Blazor and I want to talk about Entra ID, and it's a little bit like JFK and the moon. I decided to do this not because it's easy, but because it's hard. I have spoken to so many developers, and if you look at examples when people are doing authentication, it's always using something like Auth0. It's never with Entra. There's a lot of fear out there. So I thought, I'm going to write a talk, and I'm going to learn how to do this, and I'm going to dispel the myths and make it really easy. Sorry. There are a lot of moving parts here. However, once you get into those moving parts, you can kind of see how to put it together, and it's not as scary as it first appears when you open the documentation. So today, we are going to take the Blazor web app Entra example from the, the .NET Blazor samples GitHub repo, and we're going to implement what we need to do in order to get the application working with one of my tenants. That is, we're going to log into a Blazor server application. That authentication is going to be used in the client WASM application. And we're going to be calling a downstream API, so not within our Blazor application at all, and seeing how we can secure that using application registrations within Entra ID. And hopefully by the end of this, fingers crossed everybody, we're going to be able to see who I am. Or at least who I could be. Who I am, we'll very quickly do right now before we move on. I am Stacy Cashmore. I am a Tech Explorer DevOps for Omniplan based in Amsterdam in the Netherlands. We make financial software. I have been coding since the middle of the 1990s, and this is possibly one of the last talks when I'm going to use that phrase because it makes me feel really old. And I'm lucky enough to be able to call myself an MVP since 2020 in developer technologies. That's enough of me talking. We have 25 minutes left, and I have about 25 minutes of demo to do. So we are going to switch to our desktop, and I'm going to talk you through the solution as it comes down from that GitHub repo. We have in our repo, if I can control my mouse, 3 projects. We have our Blazor Web Entra application. That is our Blazor server application. We have the client application. That is the WASM application that is going to be running inside of the client's browser, which is always fun when it comes to authentication because that's going to be running inside the user's machine. So you need to make sure that you're not leaking anything dangerous there. And then we have our minimum API JWT project. That's just going to be our downstream server. So what we're going to be implementing is the weather forecast. As you see it in every single Blazor demo, you have the counter, you have the weather forecast. And we are going to be calling the weather forecast from the WASM client through the Blazor web, and then passing that down to the minimal API JWT. How do we do this? Well, if we come into this first program, that one is from our Blazor web app Entra. Ignore all the usings at the top. We're just going to have a look at what we need in order to get our authentication working. Number one, and the one that I think is so cool, is this add authentication state serialization. I love this because one of the bits that could be super complex actually isn't. Remember I said that we need to make sure that we leak nothing to our WASM application because that's on the user's machine, running in their browser, super insecure. You can dive in and just assume anything on there is compromised because, it's on the user's machine. They have access. Well, by using this setup, that application never actually needs to authenticate itself. It doesn't need to know how we authenticate. Rather, we're going to authenticate with the server application. We are going to serialize that authentication state, and we are going to give that to the client with just the information it needs to know to ensure that it can call APIs with the correct rights and to ensure that you can use it when displaying or hiding things on the screen, depending on the authorization that that user has. Then we have our authentication itself. We're going to be connecting using OpenID defaults. And we're going to be adding this Microsoft Identity web app. This is where we do that connection to the Entra authorization. We need to add a few things here. First of all, we need a callback path so that once we've authorized, we can go back to our web app, get the information that we need, and then move forward. This one's just going to be sign-in-OIDC. Then we need to know the client app of the app registration set up to authenticate the users for our application. Now, we're going to be getting this from a secrets file because always put your important stuff in a secrets file. I'm going to go against that in a minute because I'm going to show you my secrets file because you're going to need to see it. Hopefully, it's not going to be too bad because as soon as I finish this demo, I'm deleting the web app. So again, fingers crossed. Always fun when you're giving demonstrations. Then we need to know the domain that we are using for our authentication. Now, for this one, this is your on Microsoft, if you've not got a custom domain set up inside of Entra, domain. So mine will be stacytardis.onmicrosoft.com. But again, we're going to add that to the secrets file so that we can set that up when we push this down the pipeline into production. Then we need to know the instance where we're going to log in, and we're using Entra. We're just going to use login.microsoftonline.com. We need to know how we should. We don't need to know. We need to let Entra know how we want to consume that authorization data. So what is it going to send back? We want to get a code back, which is one of the most secure ways that you can do it, especially if you're on your server side. We will get a code back. We will then immediately check that code against the authorization, and it will give us our client principal that we need. Now, I say we here, we're not going to do anything because this is all built in for us. We don't need to worry about that level of complexity, which is kind of awesome. And finally, we need our tenant ID. So what tenant do we need to authenticate against? There's this last one here. You can see that it's commented out. Now, I am going to ask the people in the chat to help correct my research here. Because anytime I tried to run this as it came out of the samples repo, I got an instant explosion of an exception saying hey, you need to prove that you're allowed to access this. You're not just allowed to do this with some publicly known details. What is it that you can use to prove that you're you? And so I needed to add in this extra one. The client secret, so I can prove that I should have access to the authentication. I couldn't get it working without this. I am really happy to be proved wrong here. So if there's anybody in the chat that wants to tell me what I did wrong here, I am open to receiving those comments. So that is how we're going to connect to our authentication. But then we also need to call downstream to get the weather from our downstream API. And we actually do that inside of our authentication again. We are going to enable the token acquisition to call downstream, which kind of makes sense. And then we're going to add a downstream API. We're going to give it a URL. This should, of course, be in the settings, but it's not. And we need to give it the scopes that we need in order to call that downstream URL. And then finally, we're adding the distributed token cache. This is all in memory because it's a demo running on my local machines. Of course, in production, you're going to have to do something way more complicated than that to make sure that it stays safe. I'm not going to go through that because there is no time today. But if you download the sample from the GitHub repo, you will see that there is a load of commented out code here that tells you what you need to do, what extra things you need to add to your solution in order to get that distributed cache working for you in a proper, safe production way. Then we just have the standard things. We're going to add the authorization, which of course we need to use inside of our Blazor app. And we are adding our server weather forecaster service. This is what we're going to use in order to get the client data from the downstream API. We'll look at that in just a second. And right down here, this is the one API that we're exposing from our web app, our first weather forecast endpoint, because our client application is going to call our server application, and that's going to deal with all of the authentication for further down the chain. And for that, we're just using that weather forecast, get weather forecast async. The rest of what you see underneath is kind of just standard Blazor, so we're not going to look into that. Rather, we're going to have a look at our server weather forecast. And I hope you can see this. Having the text slightly bigger so that you can see it at home also means it's hard to get everything on the screen, of course. What happens if we drag that across? Well, that kind of works. So, get weather forecast. We do not call our HTTP client in order to get this information. Rather, we pass in our downstream API, and then we use this downstream API saying, find the configuration for the one that we want. Now, this is all magic text. I would strongly recommend you put this in some way that it's not a magic text, but as long as it matches what you've got in your program, it's going to work for you. We are giving the URL that we need within the base URL that we've given in this program CS. And with the call API for user async, that is automatically going to use the credentials from the user accessing the server. So again, we don't need to set anything else up ourselves. All this so far looks kind of cool, and it seems to take a lot of complexity away from us. The Blazor side for this is fairly awesome. This all then gets returned, and we display it on the page inside of our client app, which is where we're going to go next. This is our WASM application, and there is only one line that we need in order to add the user authentication from the server here. You can see me smiling because I just think this is so cool. We have this line of code here. Add authentication state deserialization. It does what it says on the tin. On the server, we serialize it. It gets sent to the client. On the client, we deserialize it. We have an authentication state provider that we can use inside of our Blazor WASM application. This so far is keeping stuff nice and simple. Then we need to get to our minimal API, and that is also fairly simple. We need to add authentication to our service for our minimal API. We are just going to be adding a JDBT token to this, And we're going to pass in a couple of options that we need for it. We need to know the authority, who can prove that the token you've been given is good. And we need to know the audience, which is what is the API URL for your application that you're running, your application registration inside of your Microsoft Entra. We don't need any secrets here because this is not giving out any tokens or credentials. All this is doing is saying, hey, I have this token. Am I supposed to have this token? Is this a valid token? And getting that information back from Entra ID. Then we can scroll down a bit, and here we have our weather forecast, which looks kind of the same as it does for most of the other weather forecast demos that we have inside of .NET. We're just returning a random list of temperatures for the coming days with authorization. So that's it. All of this will make our application work. Now we just need to set a few of our secrets. And we're going to start that with... Well, we're not going to pin that because that takes even less space. We have our two secrets files. This is a secret file that we have for our Blazor application. And here you can see the JWT bearer authority and audience that we're using in the other one. So I need to just come down here and bring up my Entra ID portal. And this is, I'm just going to zoom out a bit because that's really unreadable for me. Looking at the screen in front of me, I think that's still readable for you. If not, Chris, please put something inside of the chat window. You can see here that I've got all of my app registration set up because I play with this an amount. You can also see we have a Blazor Web Entra app and we have a minimal API JWT app. That's because if you're giving a live demo, always have a backup plan because you never know when it's go wrong on you at the last stage. But let's hope that we don't need that today. We're going to make a new app registration, and this is going to be for the minimal JWT API, and because we already have one, we're going to call it a demo. We only want people from within our TARDIS tenant to do this. We are going to skip the redirect URI because this doesn't handle any login information. This is only going to check that you've got the correct tokens. It's not going to give you any. We're going to register this. We now have it available for us. And we are going to expose an API from here. So this is going to be our WeatherGet API. So we're going to add a scope. First, we get our application URI. This is going to be that audience that I was talking about. And it creates one for you on the fly because I've not set one up yet because I've only just created it. So we'll accept this one and move on. And then because I want it to work everywhere, and because I am the queen of typos, I'm just going to copy paste the scope name that we're going to be using everywhere, which is weather.get. Admins can consent to it. We're going to look at that one in just a minute. And then we need to give it a nice name. So why don't we call this allows... Well, we're going to call it weather.get because that's simple, isn't it? And allows some users to know if they need an umbrella. The user consent name you don't need to fill in. I'm going to leave it blank for now just for time, but one is to let admins know, no, this is really what you need to do, and one is for the users to know what they are consenting to when they add this scope. We need it to be enabled, and we're going to add that here. So now we have this scope for weather.get. This is all that we need to do to set up our minimal JWT API. Go back to the registrations. How are we doing? 10 minutes? We should be okay. We're going to add another new one. And if the first one was for the API, you've guessed it, this one's going to be for the Blazor app. So Blazor Web Entra Demo. Again, this one is only going to be for the TARDIS. Now we do need a redirect URI because people are going to be logging in with this one. So we're going to select web. And then we're going to come back to our original program. And what did we say it was? We said it was sign in -OIDC. So that is going to be HTTPS localhost, because I'm running it locally. We don't want it to be a port. We want it to be an endpoint. Now you notice here, I'm not putting the port number on because we don't need to. This will just validate against localhost. This one is fine. So let's register this one now. And then we need to do a couple of different things in order to get this to work before we can start copying all of those values over and actually use them inside of our application. The first one we need to do is add an API permission because, wow, that's a lot of information hiding on the screen. We need this application that the user is going to be logging in with to have permission to access that downstream API. So we're going to add a permission here. It is a permission that my org uses, and it's going to be minimal, and we want this demo. And we want weather.get, add permissions. And that should... Okay, so we have this now. Now you see this isn't granted for TARDIS, so at the moment this won't work because we haven't granted it admin permission. They do give a nice useful tip here. You can go to Enterprise Applications, and here we can just say grant consent as me. Next, I just want to set all the permissions, and that should, if we go back now, say granted for TARDIS. So we now have that working downstream API. Last thing we need is a certificate and secret. This is what we're going to do to prove that we can access this application. So let's try new client secret, and this is going to be, what is it? It's .NET Conf demo. We're going to add our secret. We see the value here. You only see this once. Once you leave this page, you can never see this again. So make sure you note it down when you're doing this, or you're going to have to delete it and add another new one. So before we forget, let's copy that, come over to our first secret, and we'll set the first secret up inside of our application. And then we'll save just in case I do something stupid, trying to look over two different screens to get this working. Then we can come back into our application. There's one more thing that I want to do here. I think I've got enough time, so I'm going to do it. Everything that we're doing today is just going to be a random, everybody gets everything authentication. I don't like just leaving it at that point because it kind of leaves you grasping for more, and how do you get that fine-grained control that you want? Well, what we can do is add a role, and where do we add that? App roles. We're going to add an app role. And this app role, although we're not going to use it today, I'm going to demonstrate where you see it when you are using it. It's weather.get. That's going to be our app role. It's going to be users and groups. It's going to be weather.get yet again. And we don't want everyone to know if it's raining. So we only want the people who have this role to know if it's raining. I'm British. I can be nasty sometimes. So now we have this weather.get. We now need to give it to people. Now, because I'm on the free tier of Entra, I can only give it to users. I can't give it to everybody, or to give it to groups and large groups of people. If you're on a paid version, you can do that. It's going to make it a lot easier to organize your life. But instead, we're going to come into our users, and we're going to go to Amy Pond, Donna Noble, Stacy TARDIS. Guess what's my favorite TV program? And Amy has roles assigned to her as applications. She has applications assigned to her. And this is a point where my brain fog kicks in. And it's like, how do we add this? Assigned roles, add assignment. You know what? I might have to put this online afterwards because I am running out of time now and my mind has just gone, whee! Because it always happens when you're live streaming to the world. Okay, we'll come back. We'll do that later. Let's go back to our enterprise applications and actually get it working first of all, shall we? So we want to come into our Blazor Entra web demo, and we want to add the things that we need here. So we need our application ID. Why are you in enterprise applications? I want app registrations. Because then you can see everything a lot easier. So we want our client ID. That's the first thing that we're going to put in here. So that's our client ID. Go. Then we need our domain ID. That's the directory. That is our directory. Copy that. Oh no, that's a tenant, isn't it? I just told you exactly what all of this was, and then I've just done it wrong because, of course, I have. And then we want our domain, which is, come on, give me the domain. Overview. That one, Stacy.Tomas. How are we doing for time? 5 minutes. This is not stressful at all. No. What are you doing, computer? It's deciding to put everything on a new line, because of course it's deciding to put everything on a new line. Why wouldn't it? Thank you. And now we need our downstream scopes, which if we come back to our app and go to our enterprise applications, our demo, not enterprise applications, we want normal applications. You see, this is where it gets complex. The Blazor stuff is really easy. It's when you get into Entra ID that you have to keep your head about you and make sure that you're in the right place, because for some reason you need to set it up in many different places in order to get it working for you. But now we can come into our API permissions. We can come into here, and we need this permission here. This is our scope that we want to set inside of our application. And then just to make it easy, this is the audience for our second. So we need, our audience is going to be just the API URI of the enterprise application. And we need the tenant ID as the authority. So we're going to sts.windows.net, and then we're going to my tenant in order to do this. Is this going to work? Who knows? We'll find out in 2 seconds. Let's give it a run. So there's our API running. It doesn't have a Swagger. That's fine. I don't care about that. Now we need to run our Blazor web application. This one should give us something on the screen. Come on, 2 minutes. You can do this. So here's our application. We have a counter. If we log in, then you can see I'm logged in as Stace Cashmore here. But I can get the weather, and that is coming from all the way downstream. Fun thing, although that is not my OnTardis account, that is my account because I own it, so I'm kind of allowed to use it. Normally, when I don't mess up a little bit earlier in the demo, I prefer to log out here, log in as Amy. And yeah, my identity at that point is Amy. But no, today, I'm really me. So that is kind of a very whirlwind tour. 20 minutes to get this done is tight, as you saw. As I said at the beginning, I wanted to do this because I wanted to demystify what you can do in Entra ID. Unfortunately, whilst the Blazor side is easy, I've had to accept that, yeah, the Entra ID has a lot of moving parts. once you get your head around it, it is perfectly doable. You can go a lot deeper than this. Follow the Blazor samples. You can get this working for yourself. I have 1 minute left, so just seriously, have a go, have a play, demystify it for yourself, and have fun. And the last thing I have to say is a huge thanks to Julie, who was with me at OraDev on Friday, helping me pull my hair out because I'd forgotten to set one thing and nothing was going to work.
Well, Stace, that was awesome. Thank you.
Thank you so much.
So back to that first question. Are you Stace? Are you Amy? Who are you again?
Yeah,
But
you know what? Stacy and Amy, they both have red hair. I'm fine with either.
Well, I want to thank you for doing that. Like I said, it definitely looked like the Blazor side was much easier and kind of making sure that we understood where to look in Entra. Entra is always
interesting.
It's interesting to do it the right way so you don't open it to the world, like you were talking about. So
absolutely, but it's a good thing to learn and get used to. It is such a powerful thing, but it's very scary to get started with. So sometimes you just got to be afraid and do it anyway.
Well, thank you very much. I'm sorry we didn't have time for questions, and I just want, like I said, thank you, and have a good rest of your day. You're
welcome. Thank you very much. Bye-bye.
And now we've got our next speaker joining us. Alexandre, how you doing, sir? You're mute. Yeah, there you go.
Yeah, I'm muted. Yeah, well, thank you for the invitation. I'm super excited.
Oh, I'm very excited too. Like I grew up with Commodore in my childhood, so like being able to go Commodore with .NET and C#, like I'm really excited to hear about this. Where are you joining us from today?
From France, so from my home, and yeah, it's a beautiful weather today, so it's a perfect day for the talk.
Well, I don't want to take from your time, so I will let you go ahead and get started. Thank you again for joining us.
Thank you so much. Let's start. Okay, so let me reset my things. So today we are going to time travel from the 80s, 8-bit world, straight into .NET 9. My name is Alexandre Mutel, and I'm VP Engineering at Data Galaxy, working in data governance. And in my spare time, I love contributing to open source projects in the .NET ecosystem. Some of them became popular, but most of them are pretty niche, but I like them. And above all, I'm a .NET performance enthusiast. So today, I'm going to talk about this project, what made the 8-bit era so magical, and why the Commodore 64 in particular. Then I will introduce the .NET SDK I've built for it, like the retro C64 SDK, with hopefully an entertaining live demo. I hope that things will all work. And if time allows, I'll wrap up with a look at the architecture and what's coming next. So the very first computer I ever touched was a Texas Instrument TI-9948. I didn't own it. It was at my uncle's place. But later, I was lucky enough to get my own Amstrad CPC 464. And then my beloved Amiga 500. I had a nice retro red tracksuit at that time. And one of the magical things about the 8-bit era was that you could jump straight into coding right there from the machine itself. And you would start coding with BASIC. Sometimes you could move on to assembly language. Or, of course, you could just play games. And it was a pure moment of creativity. And I love doing both. I still love doing both. So back then, there was so many different 8-bit machines, each with its own charm and quirks. So why did I choose the Commodore 64 for this experiment? And the reason is quite simple. Actually, the Commodore 64 is actually coming back thanks to Perry Fratic. He's a well-known YouTuber in the retro computing scene. And he bought the Commodore brand just a few months ago, in the middle of the year, like in July. And he brought together the community to design a brand new machine that is fully compatible with the original Commodore 64, but built with new hardware. So I ordered one, and it's called the Commodore 64 Ultimate. And while waiting, I thought it was the perfect opportunity to start learning about the Commodore 64 and see what I could do already with it. So I'm going to receive it this month. So I'm super excited to try also some of my code that I prepare for this presentation and try it on real hardware at the end of the year. So let's take a look at what's inside the Commodore 64. At its heart, there is the 6510 CPU, and it's running at about 1 megahertz, and it depends on PAL and TSC stuff. Then you have the VIC2 graphics chip, which is responsible for all graphics, color, sprites, smooth scrolling, and things like that. There is the C chip, which is the sound synthesizer of the 664, and it's amazing. It's very popular for its legendary music. 2 CIA chips for I/O with the disk drive, external disk drive, for example. And of course, the system had a whole 64 kilobytes of RAM and 24 kilobytes of ROM. So you are wondering, how can we access 64 kilobytes plus 20 kilobytes of ROM? So if we look at how memory is organized in the Commodore 64, the address space is 64 kilobytes. But it's not all RAM by default, because the system maps part of the space to ROM. And there is a basic interpreter, I/O register for communicating with the coprocessors, and the kernel, not the kernel, but the kernel, which acts as a kind of like a built-in operating system layer. And if we look at the very bottom of the RAM, we find two important areas, the 0 page and the stack. The 0 page is special because it's 256 bytes of memory. It's a page. And many instructions can access it with shorter opcodes, so which makes them running faster, and it's smaller. So it's used for optimizing programs. And then there is the stack, which is another page of memory just above. And it's interesting as well, like compared to our modern computers, because it wraps around automatically when you pull data. If it goes back at the bottom or the top, it will come back at the top of the bottom. So it's a ring stack. And finally, if we zoom in even more, there are two tiny registers, 0 and 1. And the 1 register, it's what makes the memory layout possible, because by just flipping these few bits here, you can switch between showing the ROM or accessing the underlying RAM entirely. So when programming the 64, usually these days you program it from a PC, and some people are very brave and program it from the machine itself, a real machine. So I'm not that lucky, and so usually people are writing assembly code in a specific dialect. Most of the time, there are plenty of assemblers with different features and so on. But usually it's rarely enough. You need often to have C code on the side to generate, for example, cosine tables for demo effects, or like plenty of pre-compute data that you would need. And of course, you need to usually like some kind of make files to glue things together, to assemble, to link and generate program files or D64 image files that once built, you will be able to manually load it into the, for example, one Vice C64 emulator that is a popular emulator, or on a real machine. And then after you need to copy to the real machine. And I'm also alluding the fact that like, and the challenges that like of debugging. So that's why I developed the Retro C64. It's a modern SDK for the Commodore 64 development, straight from .NET. So it comes with a zero friction dev loop, which is going to auto-launch Vice, the Vice emulator, and doing live coding, and we'll see that later. I've developed also a Fluent assembler, ASM6502, that I released earlier this year. which can manage labels, sections, data blocks, and helpers with source mapping back to C#. There is some basic integration, like where you can quickly prototype things, and several core helpers to allocate data into the 0 page, for example, or initiate all the interrupts for the raster line, or using sprite classes and things like that. There's, of course, like a seed tooling, which is going to help with loading seed files, which are music with the player integrated in it. And there is a relocator and player inside. And then we have like all the things to manage the format that are used by the Commodore 64, the program files that you can store on the disk, or the D64 image that you can use on your PC to transfer it to a real disk. And then, last but not least, one of the really cool things that I wanted to have for this development experience was first-class VS Code debugging support with respective registers, memory, setting breakpoints, execution control, step in, step over, etc., etc., and viewing disassembly, memory, and all of that. And of course, supporting all the .NET platforms, all the OS with .NET 9 Plus, so it can work with .NET 10. So now let's experience a live demo. I hope that everything is going to work as planned. Here's my screen. I have here, like on the left, a basic program, which is very simple. You can see it here. And I can zoom in a little bit if you want up. And then after here, I have the command line where I can launch a command. And here I'm going to launch .NET Watch Run, which is going to run this program. It's just a console application. And what it's going to do is going to compile the project, build it, and deploy it to the VI simulator. And here you can see that on the screen, with the VICE 64 Commodore emulator, I have my program running straight into the emulator. And at the bottom, you can see that I have .NET Watch Run still running. So that means that I can edit while the emulator and the application is running to see in real time the changes that I'm going to make. So for example, if I change this, I'm going to resize. If I change this here and I'm Command here and I Control S, it's going to recompile here. And here we go. We have the program that is automatically reloaded in the VI simulator. So you can actually live program very easily from C# directly, and it's going to reflect on the screen on the emulator. So that's the first program, and like it's the most basic experience that you can get with Retro 64. But it's not the thing that I didn't create Retro 64 for this program. What I wanted to do is really to program in assembly language, because that's where you can really take advantage of a computer, and you really need to use assembly when you need to take advantage of it. So here we have a very simple program, a little bit more complicated because there are some special things in it. And I'm going to use .NET Watch again. And it's going to similarly open a new window. Things are not super exciting. It's a very small program in assembly, and assembly language can be very verbose. But what you can do is that you can command the code here. So it's recompiling, and you can see that I can change the border color almost immediately, and I see the change in stream. I can command this line, and then I'm back to the screen. For this, in assembly, I have implemented a soft reset of the machine, so that you can see that I don't restart the machine entirely. I just restore some states, seed register, and so on, to be able to reboot my program more quickly. And of course, I can modify some properties here to create some effects. I know full effect. It's not really nice. And similarly, I can comment things. So here, for example, I'm not going to do it on the border, or actually it's nicer to do it on the border. We can see the text. And that's all that simple, like live coding in assembly language from Visual Studio with the emulator. So now let's try something a little bit more like advanced. It's hello sprites. Let's look at what we can do with sprites. So if I run this program, it's going to show a few sprites on the screen. Up. And it's 8 sprites here. And what is really cool is that the code is actually implemented. So where is it actually? Where is it? I missed it here. It's actually implemented with this code here, where I'm using actually Skia Sharp to draw the sprites directly in memory. And I forgot to copy this line, so I'm going to need to copy it from that place. Sorry for the misstep in the demo. But what I can do is that I can reprogram the sprite directly from C#, and it will change them on screen immediately. And all of this code is running like the Skia Sharp library that is used by .NET MAUI, for example. And you can like comment code here and change things, and you have like this combination. Or I could also decide to also combine with this, or maybe even comment the middle and have a combination of this setup. And you can see that at the bottom, I'm storing the sprites in memory, and then after, of course, there is some code like to make it happen in assembly language, but it's quite straightforward. Now, I talked about the music, and of course, you can also program a music. So what I have in my project is here a music that is made by, this one is made by Linus Åkesson. It's a beautiful little music. And if I run it here, same, we are going to hear some music in the screen. I think that you should hear it a little bit. I made the sound. Low. I could increase the sound, and you can hear it a little bit more. But I'm going to lower it after. And so let me lower it. What is very cool here is that we can load the seed file. Relocate it in memory, instantiate the player, initialize it, and play it. It's that simple. And what is very cool with the integration of C# and all the things that we can do within C#, so we don't need a makefile, we don't need a C program file separate, is that I can take the data that is coming directly from the seed file and display it on the screen. So here I'm reading the author, the name, and the release date of this music, and I can put it straight on the screen. And lastly, it's something that I made specially for this event. I made a demo actually. So it's a very small demo. I'm not like a Commodore specialist, and so bear with me. Like it's just a small demo for this event. But so of course, what we can do here is that, we can just have a clear screen. It's not going to be interesting, but it will give me time a little bit to show you a little bit the different parts. Okay, we have a white screen here. We could, I think, change it here. We could put the character 0, and you would recompile everything. Character A, you put A. Okay, that's not really interesting. But the first part, it's not the first part of the demo, but just like to show you that we can change things. I've made the logo for the .NET Conf. The logo is at the bottom of this file. Actually, you can see it here if I dezoom, and you can see that like it's highlighted here. And it's just like a copy of a character in memory. I'm going to copy to the screen. And then I have sprites that you just saw before. Difference here is that I'm going to animate them. And what is very nice with this setup is that I can actually create all the sine and cosine tables directly from the code here, integrated in the same source code where I have all the assembly language that is moving these sprites on the screen. And then the full demo that I can launch here, where I have an additional small effect. Let me just stop. So this is the demo with all the parts. And I've just added a small effect, a typical demo effect in the demo, to show that we can really create some very cool stuff in assembly language. The code is including with all the data and all the setup to make it live, etc. is just like 600 lines of code. It's not that much actually. And yeah, it's super cool, right? So one of the biggest cool thing also that I wanted to show you today is the debugger. Because here we can set breakpoints. I'm in Visual Studio Code. And I can press F5. And the demo is paused. You can see it on the screen. Oops, no, that's the wrong screen, sorry. And here you can see that I'm in the Visual Studio Code debugger, and I can see the accumulator, the register, the CPU flags. I can even inspect the VIC registers, the 0 page even, like I can see that, oh, the C player is taking these variables and all of that. I can step in. I can inspect the changes here of the registers. I can even go to the disassembly view. Where am I? It's the same code that I have here. And I have also access to the memory of the 64 that is running in the emulator here, directly straight from VS Code. I can play and go to there is also the data watch that is working, and I won't show it. But you can do everything here from VS Code. You can pause. It's going to pause at some place. You can continue, and it's going to work now. And that's it for the demo. So let's come back to the end of the slides. I have 4 minutes left. So the SDK is organized around 4 main packages. The main package that contains the app layer that manages the lifecycle of the build, .NET Watch, and the live sync with the emulator. There is a debugger that connects to the Vice emulator through the remote interface. There's a core package that contains all the core functionality that I said earlier, the basic, the assembler, the loader, packers, graphics, music, and all of that. We have the assembler, the 6502 and 10 assembler. There is even an emulator inside it. I developed an emulator, especially a CPU emulator, because for the seed relocation, I had to port the code from Linux Cashmore to be able to relocate seed files to a different memory allocation. And finally, we have the Vice package that is able to connect to the Vice monitor that is running the emulate, that is running the C# program, the C64 program. Sorry. So I would like to zoom just on the debugger because I think that it was a really interesting challenge and I learned a lot from it. So in particular, I discovered the debug adapter protocol, a protocol that lets IDE to talk through the common interface without needing to know which one works internally. So when you create a Retro64 application, there is actually a debug adapter inside it. I lied earlier, it's not a real debugger. The debugger is actually in the VI simulator. And when VS Code connects to the VI simulator, it uses the DAP to communicate with that adapter inside the Retro64. And the adapter then proxies all the calls to the VICE monitor and also enriches them with information only that the Retro64 runtime knows, like variable names or source mapping, so that the DAP protocol can feedback that to the VS Code. And of course, to make all of this work, I had to implement dozens of callback functions. It feels like a mountain of work at first, but it turned out to be totally manageable, actually, because in our case, we only have one thread. We have one frame in the call stack. So lots of things are actually much simpler than, let's say, creating a debugger for C#. And honestly, I found it very cool that adding full debugger support in C# to this project was ultimately very straightforward. So as I said, what's coming next? First, I need to add a fast loader. The assembly code has been ported, but it's actually not finished, so it's not completely finished yet. I need to add ZX0 depacker. I have created the packing system in C# entirely, but I need the depacker. It's a small amount of work, but it still needs to be done. The SDK doesn't support also multi-part demos yet. That's what the fast loader and the ZX0 depacker are going to enable. Documentation, and actually, since I create these slides, I have actually a surprise to share. So actually, I have some documentation. Graphics, because, for example, I just made the sprites for this demo, but I don't have anything related to bitmaps or converting from real images or making the process conversion easier with differing and things like that. And then a bunch of little tiny things. And of course, contributors are going to be super welcome in this project if you are interested. So thank you for watching. Here is the website. I can actually show you the website just a little bit here. You can connect with this address. There is like the front page. There is actually some documentation with the getting started, what you need to install, the overview that we just saw before, a little bit more details about the assembler, some details about graphics, musics, helpers, all the names that are in the registers and so on, and some documentation about debugging. So that's super nice that I was able to finish that for this event. And of course, happy coding. Don't forget to maybe buy, if you have the chance to buy the Commodore 64 Ultimate that is going to be released like this month or next month. It will help to grow the community, and maybe you will be able to enjoy programming with Retro C64 in .NET, in C#. Probably most likely I haven't tried in F# and even in Visual Basic to program the Commodore 64. Thank you for watching.
That was great. So I put the link to the repo and the documentation in the chat. Yeah, it looks like Commodore 64 is still out there on pre-order. I remember watching the story about them reviving it and like re-releasing like the classic beige boxes.
Yeah.
This is
it's really cool to be able to enjoy, to have a feeling of a retro machine in modern times without having to deal with transistors that are burning and things like that. So you have like real new hardware running the old stuff, and you can even run faster with more features as well if you want. And you can plug it on your regular monitor with HDMI. So it's very, I mean, it should be very nice. I'm really looking forward to it.
Well, really cool demo, really great stuff. Really cool seeing that. So thank you.
Yeah. Thank you, Chris.
All right. So we're going to keep rolling with our schedule. Next up, we're going to be talking with Yulia about OpenTelemetry and observability and monitoring. Hi, Yulia. How you doing?
Hi. Good afternoon. All doing well. Thank you.
Great. Where are you joining us today from? Or joining us from today? Yeah, words.
So I'm actually in the office, and I work for Datadog, and we do have a big office in Paris. And it just turns out that I have a business trip. So yeah, I'm joining you from the capital of France.
Awesome. Yeah, I've been to Paris once, maybe twice. Lovely city. And observability, OpenTelemetry, like this is just such a hot topic. Everyone, I think, needs to know more about this, especially when we talk about resiliency and like the status of our applications. So I'm really looking forward to your session.
Yeah, no, thank you very much. And also, I want to demystify a few words such as monitoring observability. It does feel like it's a buzzword. It's used interchangeably, but it's not the same.
Awesome. Well, I will turn it over to you. Have a great session, and thank you for joining us today.
Super. Thank you very much. Let me set the scene. It is early. The user is just waking up. And like almost all of us, the first thing they want to do is to check their phones. They tap their app and it loads, or maybe it doesn't. And this tiny delay, like a failed API call, like a problem with the release, can get the user very frustrated. And they didn't have their coffee yet. Now let's flip to another side. Engineers, product owners, support, they're all trying to understand what went wrong. And without the observability, you're just guessing. Was it a network issue? Was it a backend issue? Or maybe it's a third-party dependency. Yeah, my name is Yulia. As I mentioned, I work as a pre-sales engineer in Datadog. I have a background in software engineering, and the last 5 years, I'm in more monitoring and observability space. So let's go back to our example. Currently, like all the applications that are modern are very complex because there could be lots of microservices, third-party APIs. The teams are very distributed, and there could be lots of things that go wrong. And at the same time, the customer, if something goes wrong, they don't complain, they just leave. And hence the business starts losing like the revenue and also user trust. And this is where monitoring and observability becomes super important. As I mentioned, monitoring and observability often used interchangeably, but they are not the same. So monitoring is about watching the things, the signals you know. Signals such as CPU, memory, error rates. So basically what you do, you set up thresholds and then you put in alerts, and then when something goes wrong, you get notified. I do really like this analogy, like as these speed cameras, because when you put the speed cameras, you put it on specific area. You you check which speed you want to be alerted on. But if somebody speed it speed it up outside of these cameras, basically you wouldn't know. So hence the monitoring works only for kind of knowns. And this is where observability comes into place. So basically, observability doesn't replace monitoring. Observability is kind of extra layer. And with observability, what you do, you take all the different telemetry that the application is producing, logs, metrics, traces, and this helps you to answer the question, why is this happening? So if we look at this iceberg, so the monitoring will be on top. So basically we can monitor for CPU usage, errors, any additional parameters, and the observability will be beneath. So like monitoring, so basically you can see that monitoring and observability come in hand into hand. And observability is very critical when you're dealing with complex system, when you can't just set thresholds for the known issues. So what is the OpenTelemetry and why it is such a hot topic? And OpenTelemetry basically is a summary of all these things. So first of all is a collection of APIs and SDKs. It's also set semantic convention and that defines how telemetry should look like. And also it's collection of tools such as OpenTelemetry Collector and Operator to manage and route that telemetry. Also, it's important to remember that OpenTelemetry is vendor neutral, and this is how it is increasing the popularity because it doesn't matter which backend you're using. Are you sending the data to Prometheus, to Datadog, to New Relic? It's all vendor agnostic. At the same time, I just want to highlight that OpenTelemetry is not just like a nice, fancy idea. It is one of the fastest growing open source projects. And you can see that it's almost on par with Kubernetes. And what it means that lots of companies, vendors, and individuals are actively contributing and improving this project, because the pain is real. It's fragmented telemetry, and by having everything in one place with consistent telemetry, it just makes everything easier to troubleshoot, to understand the health, performance, and reliability. Here, just a few slides. You can see that there is a lot of active contributor to OpenTelemetry project, and at the same time, it's not just individuals. You can see that these big companies are interested in help promoting this project and help with standardization as well. So it's OpenTelemetry is a huge focus. And OpenTelemetry, or you can say OTel for short, basically it focuses on four things. First is to generate the telemetry, then to collect, manage, and export telemetry. And it is important to understand that OpenTelemetry is not a backend. It's just a pipeline, and you can use any backend for the OpenTelemetry. So OpenTelemetry, it will not store or visualize your data. So why OpenTelemetry is so popular? And the first one, the first one is. Sorry, I'm just why OpenTelemetry? Yeah, so I think we covered this, and the reasons is data portability. The main reason is data portability, data flexibility, and open source as a cultural choice. So basically, what you can do, you can with OpenTelemetry, for example, you use one backend and you decide to switch it, so there is no vendor lock-in. At the same time, what you can do is, let's say, send logs to one backend and send metrics to another backend. So again, you have this flexibility. And of course, open source is popular. So OpenTelemetry could be a natural choice for this reason as well. And what are the types that OpenTelemetry produce? So this is the same data types that you would be familiar with. So first one is the traces. So the trace help you to track your request from track your request through different services. And with the help of the trace, you can quickly understand where was the problem, where was this slowdown. And at the same time, you can see which service was affected as well. And each part of the trace is called spans. So spans will be like a small part of the trace. Another signal that is collected is called metrics, and basically what metrics is quantitative measurement recorded at the runtime. So it could be like a counter, it can be gorgeous, a histogram. All of these types are supported with OTel. And it is really great. Metrics are really great to track historical behavior over time and see how particular metric was was behaving over, let's say, a few months or a few days as well. At the same time, logs, I guess, it's the type of telemetry data that most of us are the most familiar with, and at the same time, logs are the most detailed. So OpenTelemetry can collect logs as well. And the latest addition is profiling. And what profiling does is able to show which functions at the runtime, which functions using the most CPU, the most memory, and which methods are blocking each other. So basically, it's kind of like one more step down with the profiling. And this is the case with the profiler. Some companies, they have donated some of the instrumentations to OpenTelemetry as well. Okay, so you would ask me so how do we start using it? Which languages is supported? How widely OpenTelemetry is being instrumented? And as you can see, lots of languages are supported. And today we're talking about .NET, and great news for the .NET. The .NET Tracer is in really in quite mature state. You can see that traces, metrics, and logs are all stable. So this means that you can start using OpenTelemetry. It's production ready. It will not have that many major changes, and basically it's ready to be used. Okay, so the next question would be, now we understand the importance of the observability and monitoring. We understand the what's the difference between them. We understand how OpenTelemetry is important, and then the next logical step would be to start using OpenTelemetry and start the instrumentation. So there are few ways how you can start the how you can do the instrumentation. First one is the manual, then with libraries instrumentation, and then there is a zero-code instrumentation. And of course, there is bonuses, benefits, and also the trades off for each of them. So the first one is manual instrumentation, and this is where you can get all the control of what you want to capture. You decide what spans to create, what attributes you want to attach. And basically, it just gives you full control, and it is very intentional. And here I just put a simple, simple example how you can start doing the manual setup. The second way is to do instrumentation with the libraries, and like there is literally like lots of different libraries that are available. It was like more than 100 for the .NET, and you can see on these screenshots some very common libraries that you can just start using them and get this get the output straight away without like writing the code. So there is another option. And there is a third option, and the third option is just zero code instrumentation. And basically, it's really good for getting started because you will just need to write one command and have like environment variables, and basically that's it. You don't need to change your code. And it's very easy to start with the this zero code instrumentation. So here is a quick example. All this example actually I took from documentation. So if you go in to hotel main website, it has lots of very thorough documentation, and at the same time it has also like a lab that I would recommend to try as well. And the lab basically it's lots of microservices in different languages, so it's just a really good way to kind of get your hands dirty with with OpenTelemetry. Okay, and the most impressive thing here is also that you can use zero code instrumentation to instrument application at scale. So, for example, if you like in a enterprise company, you don't want to ask like every team to follow the guidance. What you can do, you can just do it on like +1 level and have the automatic injection of OpenTelemetry, and you can have like developer-free setup, and just to make sure that everything is just to make sure, and it will guarantee that everything is instrumented as needed. Okay, so here I just put a few examples of the dashboard. What maybe like the first step could look like, what metrics you want to start pulling from your environment, and this was done basically this was done with like all out of the box stuff. But at the same time, we understand that, okay, out of the box is good, is easy to start, is easy to instrument, but it might not give you this like visibility and granularity that you need. For example, if you work for e-commerce shop, perhaps you might want to keep monitoring like the amount that the customer put in basket, or what is the total revenue of the website in a day, etc. So all of this metrics will not come out of the box. So what you need to do is to do the custom instrumentation. So for example, here we have instrumented what was like the payment currency, what are the types of like different payment, etc., etc. So basically what I'm saying that you don't need to choose either one or another. What you can do is to combine, let's say, start as out of the box and then instrument like a few additional bits that is valuable for your team or your company. Okay, now just wanted to walk you quickly through like OpenTelemetry components, and the first one is OpenTelemetry collector. And what it is a vendor agnostic way to receive, process, and export telemetry data. And what we see here is that you export the the metrics, logs, and like traces all the data from the application. You send it to OpenTelemetry collector, and then it will send it to any backend of your choice. And here again is important. The backend could be anything. So you are not basically you can choose just whatever works for you and your team. At the same time, if we look a bit deeper into collector, we can see the three main functions that collector can do. First, it receives the data, then it processes the data, and then it is able to export the data to this observability backend. So it is quite smart and functional. And it can receive the data from different sources, whether it is like API calls, databases, containers, any request. So it has ability to grab the data from all the different data sources. At the same time, once you have all the data, what you want to do, you might want to filter, modify, enrich, or sanitize this information. For example, for the logs, you might want to remove some sensitive data from the logs before you send it over. Or I have seen customers with OpenTelemetry, they might want to use the batching before they send it further away. Okay, and the exported is the last one that helps to send the information to different backends. And as I mentioned, you can send, let's say, logs to one place, metrics to another place, or you can split, for example, split the logs that have different types to different systems. It's all very customizable, and it's all possible. It's all possible as well. Okay, it can get even more complex. So you can have different pipelines for different types of data, and do the data more granularly. So again, there is Hotel Collector has ability to do so as well. Okay, and this is like the full this is the full picture. So Open Collector will sit in between the application and the backend, and it's very powerful to receive the information, to pre-process and export it further. And what the companies were doing before the OpenTelemetry, or what are the other options if, for example, your company is not ready for OpenTelemetry. So there are quite a few commercial solutions, and we usually Gartner, who is publishing Magic Quadrant every year, is putting this solution across this across this diagram. So if, for example, OpenTelemetry, you're not ready for it, or it doesn't fulfill your needs, there's quite a lot of commercial solutions as well. But at the same time, commercial solutions started to understand that OpenTelemetry is a big focus, and it's a choice for many companies, especially going forward. So many of the vendors, what they do, they support OpenTelemetry, and they also treat OpenTelemetry as a first-class citizen. So what it means that wherever you are using the collector from the vendor, or you use OpenTelemetry, you will have the same experience inside the tool. So basically, at the same time, you don't need to choose. Why not have it all together? Okay, and just looking, I think it's my last slide. Perfect. Cool. So let me just check. sharing. Okay, Chris, over to you.
Great job, Yulia. I love that you covered the whole spectrum of things with observability, and I have some friends that will definitely point out if there was a space anywhere, any spot you might have had OpenTelemetry with that space, because we know it all goes together. Let me see if there's any questions that have popped up during the discussion. No, nobody had any questions. Is there anything you want to add or leave us with before you finish wrapping up?
Yeah, I think like theory is good, but the practice is better. So I will just encourage you to go to OpenTelemetry website and try the lab that they have with like different languages, different microservices, and all this theory will like shine once you see it. Once you see it for yourself.
And for the people looking at kind of having a service, like, there's always that build versus buy when they're looking at monitoring services. Are there any things, like, I know you covered some of them in your talk, but specific things they might want to keep in mind or look for as they kind of look at that consideration?
Yeah, that's a very good question, and I feel like at least the vendors with whom I was working, what they let's say if we were talking like 3 years ago, 4 years ago, like it would be more beneficial to use the vendor's agent, because of course they spend lots of time developing, etc., and OpenTelemetry was not as mature. Now it's becoming more mature, but still not as strong as the vendor's agent. So that's why I feel like sometimes for like bigger enterprise, having OpenTelemetry and an agent as well working together might be like a good, it's like a way to sit on both chairs. So yeah. It's like it might be like a good way to start the journey.
Well, thank you very much. I really appreciate, and everyone here at .NET Conf appreciate you coming and presenting. Have a good rest of your day.
Thank you. Thanks everyone for listening, and thanks Chris for having me.
Of course.
Thank you.
All right, so now we're almost ready for our next presenter, Alex. I'm gonna go ahead and bring him on. Hi, Alex. How you doing?
Pretty good. Yourself?
Very well. Where are you connecting from today?
So I'm based in the UK, in Reading, not far out from London.
Oh, great. I'll be up there next year for NDC London in the London area. Nice. So today you're talking a little bit about Aspire and service dependencies, one of my favorite technologies. I speak about it a lot. How long have you been working with Aspire and kind of diving into this new paradigm?
Yeah, I've been working with Aspire for quite a while, so I think I started using it. I think it first came out at what's the March conference you have?
Build. It was Build last year, but it was a little bit before that.
Yeah, so I think it was about a year and a half ago when it first came on the scene. So I've been working on it since the 8.0 days. So
yeah,
started having a play around. I'll tell a bit more in my presentation in a sec about some of the problems we're trying to solve, and it's working really well. And I got stupid enough to start contributing to it, and it just snowballed from there.
Yeah, now we're up to 13.
Yup. It's come along in leaps and bounds. It's still got some quirks, but everywhere I use it, it gets me further than I would have got otherwise.
Yeah, I am a huge fan of the whole team's work, and it's wonderful that you're a contributor as well. So thank you for that. We've got another minute or two, but if you want, we could probably get started. Or is there something you'd like to share? Or I know there's a little bit of overlap from the previous session on OpenTelemetry. I love that Aspire helps encourage that as well.
Yeah, I think the local dashboard. So one of the challenges we've been working with OpenTelemetry for a while, but it's this thing that doesn't appear until you go into production. And I think people didn't really know what to do with it, or you just ended up with just console logs and structured logging, which, don't get me wrong, is a great thing, but there's so much more to OpenTelemetry than just the structured logging and getting that dashboard locally and making the data accessible. And also as well, even if you went through all the trouble of setting up Grafana, Prometheus locally, they're a little hard to use locally when you've got one request a second. The Aspire view is really well optimized for that local dev scenario, show me things in real time, which, to be honest, locally, unless you're doing some kind of load test, that's exactly what you want.
You don't want to just console write line and pipe it to a text file and search in that, or
well, the first part is easy. It's when you want to actually come and use it, things get complicated.
Well, I don't want to take up any more of your time, so let me go ahead and let you dive right into things. I don't want to steal your thunder. So thank you again for coming and presenting, and I'm really looking forward to this session.
Awesome, cool. Yes, so hi everyone, I am Alex. My name's Alex. I am a software engineer on the developer experience team at Trayport. We build trading solutions for the energy market, and for our core trading platform, we have a little bit of a problem for our local development setup. We have a monolithic local deployment. We have over 100 different services and configurations of those services we're deploying as sort of Windows services or iOS apps. It's slow, it's brittle, there's a lot of duplication in the deployment. It's a real pain when we get new devs on board to get them started. We have this, what we call the JD challenge, when people just come in. The idea is, can you get your local development set up and essentially get as far as making a trade on it? It's very problematic. Not everyone ends up being able to manage to complete it, or they spend a lot of time troubleshooting dependencies that they would actually never touch in their entire career again at the company. Some of our more modern applications are built as, most of them are built as containers, and for many of them we've been using Docker Compose for their local development setup. That works reasonably well. It's definitely a massive improvement on the older monolithic deployment, but there's still, we have the same things being copy and pasted all over the place, the same problems being solved again and again, slightly differently as well, just to make troubleshooting even more fun. There was also a little bit of a problem when we want to start trying to communicate between the new and the old worlds. That sort of originally led to some of the more modern applications have to maintain a deployment in both the new and the old worlds. But then when you've got that instance in the old world, trying to inject the local development environment into that setup can be rather complicated, because you've got to stop it, you've got to reuse the exact same port, everything else is being bound to, etc. So we're thinking there has to be a better way to do all of this. And our goal was, could we get something, or we could simply clone a repo and just .NET run, Rust up, npm dev, or whatever the language idiomatic thing for a repo is. So then about a year and a half, we came across Aspire. What we really liked was the patterns Aspire implemented that sort of encapsulated and abstracted away a lot of the complexities. If you want a Redis, it is simply an add Redis call, and you get a working Redis instance. There are a bunch of additional configuration you can do for some more complex scenarios, but again, those things are still mostly abstracted away for you. I don't care how the data volume is implemented. I just want persistence. So give me that data volume for persistence. So based on that, we thought that pattern looks awesome. Could we do the same thing ourselves for our components? And the answer was yes. So I want to take you through a basic example of our accounts component. So accounts is what we use for our login and authentication stack. It does token issuance, OpenID Connect, all of that good stuff. It's a web application. It is containerized. It was in the Docker Compose setup previously, but it's one of the core dependencies almost everything relies on. And for some of those cases, particularly the service-to-service cases, potentially we could mock it out, but they're still, particularly for the user interaction flows, things often need to be able to have an option at the very least of running the accounts component. So to start with our integration, we start by defining a class to define the resource. This isn't strictly necessary, but it will become useful when we want to create the extension method specifically on this resource. So in this case, accounts resource is a container resource. We're now going to create our add method. So the add method is an extension method on distributed application builder. We create our resource, we add it to the model, and then we configure it. So we configure the Docker image, the container registry, the tag, and we also configure a bunch of environment variables. So for this example, we're simply configuring the environment to be development. You can imagine there could be a richer involvement of that. Now we have that, we can start building sort of our helper enrichment extension methods. So for this example, let's say we have a way we can create a set of fake users via a JSON file. We can take that file as an argument to our with mock users method, bind mount that into the container to a well-known path, and then tell the accounts application to read the fake users from that path. So right now, at this point, we have got a very basic integration. We simply create our builder from Aspire. That's just the standard way you create your application builder. And then we call add accounts with mock users. Let's sort of take that a little bit further. So as in the previous session, we would like our OpenTelemetry. When you add something as a project in Aspire, Aspire will automatically add the OpenTelemetry environment variables for you. In a container, you have to tell it to do that. So that's what we'll do. We also, as I said, accounts was a web application. So that means we need to expose a port in order to make it be useful. So we can tell Aspire that we have a port 8080 in the container. And we want the container to listen on that port, the target port, and we'll tell the application what port to listen on by passing it as the ASP.NET Core HTTP ports environment variable. With that, when you then run this thing through Aspire, Aspire will allocate a port on the host, a dynamic port to avoid port conflicts, in this case 57814, and that will map to port 8080 in the container. We can take this a little bit further. We know that our accounts component has a health check endpoint on health. We can configure a HTTP health check. So this means Aspire will keep probing this path. If the health check returns success, it will mark the resource as healthy, as in the first example in the screenshot. Otherwise, it will mark the resource as unhealthy. Where this becomes useful is it becomes useful in waiting scenarios, but it also is really helpful in testing scenarios. So we can create a distributed application builder from the Aspire hosting testing library from NuGet, configure the logging, we add our accounts resource to the graph, and then we build our application, start it, and wait to make sure our accounts resource goes healthy with a timeout on the test so that if it fails to start or anything, our test will eventually fail. The reason we have this test is this integration. We are putting this integration as a project alongside the component itself. So in our CI pipeline, we publish the application and the Aspire integration concurrently. The way we do this, we have some golden templates that we use company-wide across a Lotte company. The way we do that, we essentially just call .NET pack on the solution, and that will pack our NuGet packages, and we then push them. Convention we use just to make sure we don't push too many things is we turn off packing in the directory build props, and then in the individual packages that we want to package. So in this case, simply the Aspire hosting component, we turn is packable on. We also, in our build scripts, use artifact path layout. It just makes our process a little easier because everything is pushed and published under a single artifacts pack or artifacts published directory, which is just easier to automate the publishing from and packing from in our pipeline. Similarly, for the publishing side, we use the .NET SDK container publishing capabilities. Take a look at Chet Husk's demo yesterday on that for more details. But we simply call .NET publish with the publish container target, configure the registry and tag, and just like with his packable, we use that same approach where we turn his publishable off in the directory build props and then opt in the individual things we want to publish. So that's one integration we've built. we want to build a set of these, and at some point we want to make them work with each other and have to deal with dependencies. So how do we deal with dependencies in Aspire? We sort of, by convention, we sort of have two ways in which we can do this. We can either have include a dependency on the add method on the distributed application builder, or we can define a with whatever extension method on the resource itself. The convention we tend to follow is if a dependency is something that's sort of mandatory and required, we put it on the add method. That way you can't forget it. And users are going to fall into the pit of success and not end up with creating a component which doesn't work because they forgot to call, or they didn't know to call the magic with database argument, with method. So an example of that might be a database your app requires on startup. Say you've got an optional dependency. So for accounts, say the SMTP server for sending your forgot password emails. You don't need that most of the time. So that is a great example of something that can be an optional with SMTP server. Or again, you could have, say, maybe you have a view count database or something that your app just gracefully, if the view counts aren't there, it just silent. You can just configure it to not log those view counts or something like that. In those cases, we'd use an extension method. So how do we reference endpoints on other resources? So endpoints are what Aspire used to expose ports and things like that. You can get an endpoint from a dependency via the getEndpoint method. So in this case, we'll get the HTTP endpoint. We can then pass that through as either an environment variable or with arguments. If you want to do something a little bit more involved and just not get the URL but get constituent parts, you can get that via the property method. One gotcha to be aware of here, there is a property on the endpoint for host, port, and all these various variables, but you don't want to use them here. The reason for that is at this point in your builder, when you're calling these methods, you haven't actually built and started the application. So these ports, hosts haven't all been calculated and evaluated. So we need to pass what Aspire calls a reference expression, which is what those property things are. These reference expressions are a reference to the host and the port, which will then be evaluated later on. Another complexity of the host is, depending on whether you're talking container to container, host to host, host to container, etc., those same endpoints can resolve differently. Local host, host Docker internal, container name. And that's another reason to pass those references. You can as well, if you want to combine those things, you can combine different constituent parts in a interpolated string-like format. However, do be slightly careful. There's a little gotcha there in that you want to make sure the following two examples here, you would think via substitution they're the same thing, but actually they're not. The reason for that is in the middle example, that URL will be evaluated as a string at builder time rather than at runtime. If you need to do that kind of advanced combination in a separate fit property like that, you'll need to explicitly use reference expression create on the interpolated string, or you can use reference expression builder if you want a string builder like API. So if we have connection strings, so we've got a database rather than endpoints, we can use a lot of the resource types will expose properties for those various values. So this example here is a Postgres database. We pass the server host, port, username, password as parameters from the server, the database name from the database. And depending on the resource type, there may be some more useful combination properties like the connection string expression, which will format all of these into a .NET style connection string, or the JDBC connection string, which will give you a JDBC connection string. The other thing we may want to do with dependencies is waiting. So there are two ways we can wait. We can either wait for a resource to go healthy, or we can wait for it to go completion. So an example of waiting for healthy would be you've got an app, you will need to wait for the database to be there before you can start it. So you want to make sure the database is healthy, because otherwise your app will try to connect to the database on startup and fail catastrophically if it isn't there. Other times you may have another process to wait for. So migrations, job type things, seeding activities. If you've got to seed some sample data into your app before your app for something your app has to read on startup, again, you may want to wait for completion for those migrations to be done. A little bit of a pit you can fall into here. Just be careful of putting weights in too many places, because each weight can suddenly start to add up. If your app depends on something else, which in turn depends on B, which in turn depends on C, you can end up with quite a long wait before your app starts. Whereas maybe you can move all of those weights, and maybe you can just have your end system under test app essentially just start all the other things concurrently and then wait for them all in one go. If you're working with containers, though, there's a great way to work around these kinds of problems, which is you can use persistent container lifetime. Persistent container is one that will start up, and then if you restart your app host, the container will continue to live and will get picked up again. So you don't have to pay the startup cost again and again and again. This is particularly useful for slow starting containers. SQL Server, Cosmos DB are really good examples where this can be really valuable. Another thing, if you have some older applications where if you can pass configuration file environments and environment variables and command line arguments, things are really easy with Aspire. If though you need to pass them via either means, say you've got config files or heaven forbid the registry, you're going to have to do some additional configuration. So a good place to do this kind of thing is to hook into the onBefore resource started event. This basically gives you a callback in which you can write some code, and that will run and to completion before the resource starts. So in this case, one gotcha though, you have to be slightly careful if you want anything where Aspire would give you a sort of reference expression for endpoint connection strings. You'll need to make sure you're doing the appropriate weighting just to make sure you're not going to try and use that value before it's available. So here we're waiting for the endpoint to be available before putting the URL in the file we're writing, similar for the connection string. In a more real-world example, you're probably going to do this with XML or JSON rather than a raw string formatted string like this. This is just easier for the demonstration. Another very powerful pattern you can use is sort of the creation of sub-resources. So on all of the resource builders, there is an application builder property, which will give you the original iDistributed application builder. So you can essentially use this to create additional resources to add to the model. So in this case, this is an example of database migrations. If you want a better example of database migrations, go and look at Damien and David's talk yesterday. That's got a much richer and goes into this in more detail. But for the purposes of this talk, the important thing is we can just we're using .NET EF tools to run a database migration. We have the accounts resource. We create a whole separate executable resource to do our migrations. We reconfigure the accounts resource to wait for those migrations to complete. So the .NET EF tool waits for the database to be ready before running, and then the accounts waits for the migrations to be completed. We also configure a parent relationship so that the migrations show underneath the database. One problem you have here, if you're using sort of the builder pattern of Aspire to create these resources, is now you've got two resources. What do you return? Do you return the inner resource you've created, or do you return the original resource you are working on? Generally, you want to return the original resource you are working on so you can continue the chain. Otherwise, you're going to break the chain. You can only from that point onwards run extension methods on the inner resource type. But then the problem there is you can't actually provide any way to configure that inner resource if you want to. If that's a scenario you have, the typical way you can do that is take a configure delegate. And that's a callback that can be run to allow others to configure that inner resource. We also found as we're doing this, there are a whole bunch of common patterns and problems people were solving again and again. So we actually were able to use the eventing framework in Aspire to wire these up in a way that we can solve these in a common way and just let all of our developers just reuse all of those extensions, and also provides a way to add new capabilities as new things come up. And again, this simply works by us building an extension method on distributed application builder. So we call it our with trayport default method. So our callers import the library into their app host, call with trayport defaults, and we do a bunch of things to just try and make things work with our internal infrastructure. So the two examples I'm going to show here are registry mirrors and certificates. For container registries, we have a little bit of a common gotcha insofar as on developer workstations, the files are a lot more permissive. So you can often pull containers from the Microsoft Container Registry or Docker Hub or things like that. Then they go to our build servers, which have got a far more restrictive firewall, and everything that works locally just fails and blows up spectacularly. So for that scenario, we have an internal mirror which we use to store these registry images. So what we can do, we can hook into, to just solve this problem, just so developers most of the time just don't even know we've solved it for them. We can hook into the before start event in Aspire, which gives us back the resource model. We can iterate over that. And for every resource with a container image annotation, we can fix that annotation so it points to our mirror registry. So if it points to Docker.io, we correct it to point to our mirror registry, and then we prefix cache Docker.io to the path it pulls that from. Our actual examples are a little bit more complex. We have a few more registries we handle. We'd have a bit of logging, etc. But this does the job for the slides on the demo. We also internally, we have a number of internal certificate authorities which we use for internal websites, and trusting those within a container is a little bit of a pain. So we want to make sure all those certificate authorities are trusted within our containers. Prior to Aspire 13, this was a whole bunch of horrible stuff. You can find a blog post by Anthony Simmons on this. Whereas now in Aspire 13, there's a really nice method to simply say, trust or take all the trusted certificates from the host and trust those on the container. The one gotcha here is in the event, we get a collection of resources, not a collection of resource builders, and the extension methods tend to be on the resource builders. However, there's a method to create resource builder that allows you to take a resource and convert it to a resource builder, which then allows us to call that extension method. We also have a convention where if we have a prod image, it goes to one registry, a non-prod image and a test image, it goes to another, and we differentiate based on whether the tag has a Semver pre-release component. We just create a nice little helper method to encode that behavior. So how did it work? How are we doing? We're now up internally to about 33 different integrations internally, and that number is rising. And we can use that to build a lot of really powerful applications now. So this example is one of my colleagues put together a couple of weeks ago for the automated trading platform. Each of these circles is a component that's essentially a NuGet package. He was able to just pull these in, compose them all together, and we have a working solution. That's really awesome. It's not all sunshine and rainbows, though. We have a few challenges. Keeping containers up to date is a bit of a pain. We've got 3 options, all of which have pros and cons. Refer to the latest tag is the sort of simple, obvious thing. Works most of the time. The one gotcha is when you run the latest image, if you already have an image tag latest locally, Docker will use that and not put a new version. That means potentially in a horrible worst case, someone could end up with a 1-year-old version of the dependency. All the devs on your team are probably going to end up with a different version of that, which could cause some fun differences between developer machines. Although you can work around that by just running Docker pull regularly. You can combine that with image pull policy always. That will guarantee Docker pulls the latest container. However, if for any reason your network is unavailable, Docker will just completely throw its hand up in the air and refuse to start the container. The other option, because we publish a lot of these integrations alongside the application, we get a new version of the integration every time we release a new version of the application. So we can use something for a stable tag. So, for example, we can get the assembly version and use that as our image tag. This does guarantee we get stable dependency versions between developers who've checked out the same code, but it also has a similar drawback in that developers will not pull image updates unless they pull the NuGet updates to the NuGet package, although things like Dependabot can help with that. None of these are perfect. They've all got their pros and cons. We also have a whole bunch of non-containerizable executables. The beauty of containers in Aspire is the containers handle not just running the container, but also acquiring the container. Whereas with executables, we have to handle that acquisition. Start off with cheated, and our monolithic deployment deployed a bunch of executables to well-known paths, so we can cheat to start off with and just use that path. We're exploring, and I've got some proof of concept that's not quite ready to show yet, of using .NET Tool to share these around, and also using there's some new capability in .NET 10 that can help out with this. So .NET Tool Exec allows you to install a tool and run it in one go. It's also got some native tooling capabilities for AOT apps, and we think we might be able to smuggle non.NET tools into .NET packages like that. Projects, we also have a little bit of a challenge in that we build our integrations as containers, but locally for debugging, projects are much better. We can do some horrible stuff. This is almost this would be an entire 20-30 minute session by itself, so I'm not going to go into too much detail, but we can essentially take the resource out of the model, put a new one in its place with the same name, a little bit of fix-ups in order to run the container as a project without having to maintain two completely duplicate branches of code. How we want to go forward in the future, more integrations. The way we started our integrations up, is that we've got a massive improvement on the 100 dependencies we potentially had previously. We've still got perhaps more dependencies than we'd like to have. Can we mock some of those up? Can we make some of those more optional? Things like that. Can we use things like the deployment capabilities of Aspire to build ephemeral environments? So you've got a PR, someone wants to do some exploratory testing on it. Can we just have a simple deploy this and you get a Kubernetes environment within a couple of minutes? Are there other things we can do with testing? Chaos testing would be very interesting if we've got all this model. What happens if we take our database down? Does our app fall back to a reduced capabilities mode as we'd expect? Thank you very much. Hope that was useful. If you have any questions, let us know in the chat or join the Aspire Discord. I'll be around there to answer questions. And if you have any feedback, there's a QR code on screen.
That was great, Alex. Thank you for sharing. I really love how you showed some of the work you've been doing and how it applied. Let's see if we have any questions popping up. No questions at the moment. So just wanted to say thank you again for sharing on .NET Conf. I'm going to go. Anything you want to add before we say goodbye?
No. So yeah, this has been a very interesting journey building up these internal integrations. A little slow to get started because we had to reach a certain critical mass. There are certain sort of core dependencies that, until they were Aspire-fied, everything else was being blocked behind them. I think we've probably only recently, in the last month or two, hit that sort of critical mass. And yeah, we're able to get going really well now. I think one of the other things as well is I think it's interesting how this Aspire has been useful not just for developers and testers, but our application security team actually have started using it. It provides them a really nice way to get things started. They love the OpenTelemetry view of just giving them a sort of, they come in often knowing very little about the application, just be able to see something. That's really awesome for them.
Yeah, we even internally, as we raise security standards, we're able to have extension methods that we add into like how we generate our bicep or how we deploy it out, just to like lock down individual components very easily that work great locally, and then we have them secure when we deploy. So
that's awesome.
Thank you, Alex. Really appreciate it. Have a good rest of your day. You
too. Enjoy the rest of .NET Conf, everyone. Bye.
Thank you. I'm going to go ahead and turn things over to one of my friends, Sam. Sam, how's it going, man?
Whoa, I'm live. Things are going well. Thank you. So Chris and me are both on East Coast time today. I was a little slow to get started. So Chris, I appreciate you taking the first shift. But here we are. Hopefully everyone's enjoying .NET Conf. Yeah. I was actually around for day one in the studio. So had to make the journey back to the real time zone that matters, East Coast. Now that's where you and me are.
I'm going to sign off from Tampa, Florida. So, we had that cold front coming down all the way down south. So it was in the 30s down here, setting like a 133-year-old record. So where are you joining today from?
I'm from Pennsylvania, just a little up north, a little bit more used to cold than you.
Yep. Well, I will turn it over to you. Have a great day.
Absolutely. Thank you, Chris. All right, folks. Hope you're having fun. To me, like .NET Conf, day 1 and day 2 are all of the big, announcements from the .NET teams. But day 3 is kind of where the rubber hits the, road. This is the community day where we get to hear from so many passionate .NET developers all around the world. So without further ado, let's bring on our next speaker, Chad, if I'm going to add you in. There you are, Chad. How are you?
Hey, Sam. How goes it?
It's all good.
I'm representing Pennsylvania here as well, coming in from
there you go.
Philadelphia.
There you go. Yeah, so good afternoon, good evening to everyone else tuning in from different parts of the world. So Chad, you are a security specialist. Like with all of this new .NET, like I just want to start building my apps, but you are making us pause and think about security a little bit.
Well, we're hoping we don't need you to pause. We're just going to be right there alongside you as you build. So
sounds good.
That'll be part of our demos today to show you.
Yeah. All right. So why don't I bring up your screen, and the stage is all yours. Take it away.
Awesome. Thank you, Sam. So welcome back here. .NET Conf Day 3 Community Day. This session is Security First .NET. Basically all things application security you can do with .NET and C# using GitHub. So if you read the session description, you can tell that was generated by my good friend Copilot, notably by the usage of all the M dashes there. But I did do a search and see there's 17 other M dashes in the content as well. So kudos for all the presenters for working smarter, not harder. As mentioned, I'm Chad Bentz. I've worked for GitHub for about the past 4 years. My title just means I get to work with you and our customers, trying out all of our new application security features in GitHub. I still identify as a .NET developer, but I've been focused on application security for about the past 15 years as well. So really happy to be here and excited to give back to the .NET community. Been to so many sessions, and it's been a really great conference so far. Just a quick intro here of what we're going to be talking about. We'll talk about GitHub, C#, the state of AppSec, what's going on here. We're going to talk about insecure dependencies, what you can do to remediate and prevent them from continuing to get into your backlog, how easy and costly it is to accidentally ship a secret, and what GitHub offers to protect you here. And then we'll wrap up with how you can prevent, detect, respond to vulnerabilities in the code that you are writing. And then hopefully have some time at the end, we'll do some Q&A so that we can answer your questions. So we'll jump right in, just talk about the GitHub platform. So GitHub just continues to be the home of open source development and now AI-powered development as well. We just wrapped up our annual developer conference, GitHub Universe, at the end of October. And as part of that, we deliver our annual Octoverse report that gives us stats on all of our platform. Some of the highlights from the report, .NET usage is continuing to grow at impressive rates. So C# continues to be in the top 5 used programming languages, just year over year there. The headline really is that .NET usage stays strong. C# repos grew 10% year over year, which is consistent with enterprise and gaming and other tooling ecosystems. But that also suggests that AI features are being integrated into .NET workflows, and we're not stagnating there. We're gaining new contributors, over 130,000 new developers this year, putting us near 1 million developers active in .NET on the GitHub platform month over month. But what about application security? So we've kind of seen this momentum. We're shifting from like a notify me to let's just patch things automatically within guardrails. We've seen repositories that define dependabot behavior in a dependabot.yaml more than doubled this year alone. So 846,000 total repos have that dependabot.yaml, and that's increased 137% year over year. Broken access control overcame injection attacks to become the top CodeQL alert overall, flagged in over 151,000 repos. For C# specifically, though, we continue to see security logging and monitoring failures take the top spot for CodeQL alerts. We're also seeing faster fix times. So in 2025, We saw 30% faster fixes for critical vulnerabilities, with 26% fewer repos having critical alerts. This acceleration is pretty much happening at scale too. So the average fix time shrinking from 37 days down to 26 days in total. And to be really transparent with y'all, like this is the clear remediation trend that GitHub is after. Like for too long, application security tooling has always been really painful for developers, adding additional work and stress to your jobs. But the clear message we have for you is that if we find something in GitHub, we're going to give you a solution, the fix. It'll be right there along with the issue. So it's really exciting to see that come to fruition and just be represented in the numbers we're showing you here. Let's just jump right into some demos. We're done with the slides now. You can follow along or watch back here to enable some of these features. I'm just forking public repos. I'll link to the repos I'm using at the end as well here. We're going to start out just digging into insecure dependencies. These will be like vulnerabilities, not in your code explicitly, but ones that are pulled in from your third-party dependencies. Let me open up my Visual Studio. You may have noticed your NuGet CLI, NuGet.org, Visual Studio. Anytime you pull in a dependency that has a vulnerability, you might have seen this yellow banner that comes across your Solution Explorer here. If you're navigating the dependency view, you can see we're getting alerted to vulnerabilities. If you go down to your error list, those same vulnerabilities are shown to you front and center. So we're trying to give you all this information right in your IDE as you're developing. But let me take you over to GitHub and show you how GitHub can really be that last line of defense, prevent pull requests coming in. Maybe not everybody's using the same IDEs, and how we can use our code review process to get those things front and center as well. So I have a repo here with some intentionally vulnerable dependencies, as it's named. I forked it from a public repo. I'm going to take you right into the insights view. So this is where we have what we call our dependency graph. Just going to click this big green button to enable it. It's not enabled by default there. What it's going to do, after I refresh my screen here, is it's going to walk all the manifest files we have in the repo. So in the case of .NET, we've got NuGet manifests in our CS proj files, package JSONs. We've got our central package management, directory props JSONs. And in this repo, we also have some GitHub actions. So all that inventory of what we're seeing in the repo is listed here. The caveat is this isn't the full picture, right? When we do a NuGet restore, a lot of extra dependency information comes down when we run a build, the exact version we use, all the transitive dependencies we use. So you can see this big old hint here, GitHub saying, you've got more to do here. So you as a repo owner can go to the settings tab and then scroll down to advanced security. These are where all of our security features live. So, well, number one, if you're an open source developer, turn on private vulnerability reporting. Click enable here. That's all you have to do. This would allow a security researcher, if they find a vulnerability in your application, to basically reach out to you privately, report that. You can work on a fix with them. And when you're ready to disclose it responsibly, you can do that with a fix with the support of GitHub. We're here to help you there. So definitely recommend you turn that on. The next one we were just talking about, detecting those transitive build time dependencies. One button clicked here to enable that. What that's going to do is every time you touch one of your manifests in those CS projects, it's going to run a build, run a NuGet restore, and report that full dependency graph for all your directs and transitives. Next, for Dependabot, this really gives us a few different features here. I'm going to suggest you go right down to grouped security updates and you click enable. So what that's going to do is it's going to turn on Dependabot alerts. So vulnerability reporting for everything we see in the graph. It's going to give you security updates, which would bump you through a pull request to the next non-vulnerable version of all those packages. And then group them together, meaning we'll just send you one big pull request with all the fixes right there for you. Run your unit tests, run your integration tests, make sure everything's working, and just merge that pull request in. All your vulnerabilities from your third-party code is gone. So it should be that easy. Lastly, there's one other feature here, Dependabot version updates. To enable this, you just need that dependabot.yaml file we talked about earlier in your repo. The idea here is this is more centric around just keeping all of your dependencies up to date, even if they're not vulnerable, just as kind of a best practice. You just need to suggest the ecosystem to run this on, NPM or NuGet or all the other ecosystems that might be in this repo. You can list them out in this YAML. All kinds of different settings you have control over. Head to the docs here that's linked, and that will give you all the settings. Commit that to your main or master, whatever your default branch is, and that will basically fire off Dependabot to keep you up to date. All right, So now that we turned on that submission, let's head to GitHub Actions, because it runs an action every time we make a change. I just made a change, so you can see actions running there. So I'm going to head to the first one that ran when we turned it on. Remember, we said this is going to run a NuGet restore. So if I go all the way down to, right, it's getting the code for the repo into this GitHub action, and it's running a restore on all of our projects with a solution if it's here. End result of that is we have all of the dependencies that were used on disk here, and you can see the number of dependencies that were explicitly referenced in our project, 14. But total of components found is 118. So the vast majority of the dependencies you're using, even in .NET, are all coming transitively down through NuGet. So without that information, doing vulnerability reporting is not giving you the full picture here. So let's head back to the Insights tab, go to our dependency graph. And now remember, we had like 20 or so here before. We now have 181 total, both direct and transitive. You can see NuGet packages, the name, the version you're using. If it does say a transitive on it, you can hit these. Actually, given this big hint here, you can view transitive paths. Okay, I got it. You can click show paths, and this will show you the dependency that pulled in the transitive. And more importantly, if there is a vulnerability on that, you can click here and see, oh, there's a Dependabot alert. So we can click into that. This will take you to our security tab. This might be new for you if you've never seen this. And it will take you into the Dependabot view, filtered down to that package we were just looking at. So this is kind of the anatomy of a Dependabot alert. So what the alert is, the package we found it in which project, it's a transitive, here's that graph. More importantly, what versions are vulnerable. All this information is curated by our GitHub security lab team in what we call the GitHub advisory database. So the advisory database is all about curating actionable information, which packages are impacted, which version fixes it, give you all the details, the severity, predictability score of if it might be exploited in the next 30 days, pulling forward CVE information. And of course, if something's wrong with this data, click here to send us a pull request, right? We're open to fixing this information if it's not accurate or up to date. If you want to fix it, click this big green button to fire off a Dependabot security update. We're running that grouped update in the background, so that would be spinning as well here. So we probably wouldn't want to do this a one-off. What we might want to do, though, is go take a look at our backlog. So here's the backlog. In this repo, we've got 12 Dependabot vulnerabilities. That's not a ton. I've seen thousands. I've seen tens of thousands. So if you do want to get drilled down and maybe the more important packages you want to focus on, there are some filters here. You can filter down to the scope. If it's a dev dependency that's only like impacting your IDE versus if it's a runtime dependency, would be the opposite. Like this is a package you're deploying out into your production. You can filter down to that. And then that same EPSS score we mentioned, the predictability score, if it's going to be potentially exploited, we can maybe filter down to say, if it's got a greater than a 2% chance of being exploited, give me the list of alerts. So there you've taken that list from 12 down to 3. These are probably your most important ones that you'd want to go patch faster than the other ones if you needed to do that more as a one-off, if you've got a really large backlog. So that's really awesome to view your backlog, but like how would we prevent these from getting into our repo as new vulnerabilities? So while this repo continues to spin, I'm going to head back to the repo I forked from because I've got already a pull request out here where I've added a vulnerable dependency. So now I'm a project maintainer. Imagine somebody sending me a pull request and they're updating my package manifest to pull on a dependency. So I go look at the files change here to do a code review, and like this just like makes my eyes gloss over with all the information here. I want to show you a really cool button to click. Go to the manifest and click this display the rich diff. What that does is gives you a visual view of all that diff on the manifest, the packages. It gives you green if it's added, yellow if it's modified, red if it's being deleted, the version, when it was released, the number of usages, the license types, and then more importantly here for our security discussion, if there's any known vulnerabilities. So just pulling in this one dependency's got 2 high severities, a medium severity, a moderate severity. So all that information is visible to you here. What you can also do as a project owner is you can turn on a feature we call dependency review. So it uses that same diff and just looks to see if anything in the diff there is vulnerable or if there's any license types, and you can then set up a policy. If it doesn't meet your policy, we can put these red X's here and tell you it's failing to meet your policy. drops right into your pull request here, puts a comment. If it does find a vulnerability, it gives you information about what the vuln is. Let's go peek at this one real quick. This is, again, taking you right to our GitHub advisory database. This is a really nice one because the REST-Sharp team had a vulnerability, and how this got reported to them was through that private vulnerability reporting we were talking about earlier. So I'm going to click this link and go right to the REST-Sharp repo. And on that repo security tab, you can see they've published an advisory, which package is vulnerable, what the fix is, and you can see they worked with some security researchers. We give them credit. We want to encourage this behavior to do responsible vulnerability disclosure. They worked together. Whenever the patch was ready, they asked GitHub to create the CVE and roll this out to anyone using Dependabot that was dependent on any of these versions, less than 107 of REST-Sharp in this scenario, would have then got that Dependabot alert basically in real time if they had the usage there. So that kind of just highlights how that rolls up. And we were talking about dependency review. So that is done through GitHub Actions today. You can see the GitHub action ran as a check task, and it failed because it didn't meet our policy. In this case, the policy out of the box is just if there's any vulnerability, fail. In this case, we had a moderate. But if we go look at the workflow file for this one, the GitHub action, just a YAML that basically runs on any pull request, and it's a one-liner. And then you can set a policy in this case. Put the comment on the pull request. What severities do you want to fail on? What license types do you want to allow or deny? And then remember, we were doing that automatic submission of the transitive dependencies through what we call a snapshot, so a point-in-time snapshot of the build. This basically says, hey, wait for that, because that takes a few seconds to run and do the NuGet restore and publish it up to the graph. This will basically spin wait for as many seconds as you describe here for that snapshot to come in, and then use that in the diff. So that's a really awesome way that you can set this up. The easy button to get this set up is if you go to the security tab, you go to code scanning, there's an add tool button, and we have what is like a curated security marketplace. Dependency, search for dependency. There's a marketplace item out here called dependency review. You click configure, it'll write that YAML file for you for dependency review. Just commit this to your repo, and then again, put whatever your policy is down here, and then you're good to go. Before we wrap up here for dependency management, I'll just show you what one of those grouped updates ends up looking like since this repo has been enabled here for a few months. You can see this update is bumping 7 packages in one pull request. So again, it's trying to go to the next non-vulnerable version if it can. This uses NuGet under the covers, so it can bump parent dependencies, it can bump child dependencies, and if it can't, it will just pin the versions, so it will make sure that transitive that's used is not vulnerable. You can see that Dependabot PR here is updating this directory packages props XML here using central package management on this repo. So that's fully supported now by Dependabot and a really awesome feature. So go turn that one on. All right, let's shift gears a little bit and talk about secret leaks. So this is like when you're accidentally leaking API keys, tokens, and other secrets. This risks security breaches, reputation damage, legal liability at a pretty mind-boggling scale when we're talking about GitHub. So at GitHub, we were detecting more than a dozen accidental leaks every minute since 2024. GitHub Secret Protection is a feature that was created basically to combat this head-on. GitHub has partnered now with over 150 plus, I think we're up to 186 providers currently, that we work with them to understand over 415 different secret patterns and tokens. And when we detect those in public repos as a leak, we do notify those partners through a partner program. So if you are minting tokens as part of a product you're working on and you have a very specific format, reach out to GitHub. You can join our partner program here. So if we do find a token, we'd reach out to you and let you either revoke it or alert your users. The majority of folks would just revoke these things because something had to be done here, right? Malicious users are basically scraping these credentials off of GitHub faster than you could even use them in your application. So back in 2023, we allowed our users to opt into a feature called push protection. And think of push protection as like a Git pre-receive server-side hook. It actually runs in a quarantine phase before pre-receive. And that just means that GitHub can detect secrets coming in to github.com, block the commit. We'll look at the commit for any secret and then allow the users to basically revoke that commit before it even gets leaked publicly into GitHub. So back in February of 2024, we actually turned that on by default for all users. So let me do a quick demo just to show you what that ends up looking like so you're not surprised by it. I was working on a feature in my application. I'll show you here in a minute. I wanted to basically integrate with Slack. So I set up a Slack webhook URL. I created a Slack channel for it. I copied this secret. As you can see, it's like a URL with Slack webhook here, but it's got a token kind of in the URL format. So Slack is one of our partners. We understand what that token format is. I'm going to take you down into a new application here, a different one from the one we were just looking at. But it does some integration with other social networks, and now it's integrating Slack. I asked my buddy Copilot to help me integrate and introduce this feature to turn on Slack integration. I gave it my webhook URL because I needed to test that. You can see Copilot in the ID here was giving me some hints that like, hey, this isn't really right. You shouldn't be doing this. There's a hard-coded credential here. You should probably move this to a secret score for production. So Copilot gives you some gentle hints that you shouldn't be doing what we're doing here ultimately. But either, I got distracted, I forgot, or maybe I accidentally go and try to actually commit this code. As you can see in my app settings development JSON, I've got that webhook URL here locally in my commit history here. So if I go and I try to push that secret up to GitHub, as soon as I do that push, you can see the push failed to the remote repository. So we sent the commit up, but before it got anywhere publicly leaked on GitHub, we failed the push. So you see as in the output window here, the source control Git window, GitHub push protection failed the push. The push cannot contain secrets. We have a link to the docs. You can learn more. We detected that Slack URL in this commit in this file on line number 9. And if you really, really needed to get the secret pushed out to your repo, you can click this link and you can basically, as a developer, self-bypass push protection. Maybe you've already revoked it and it's just going to be a sample. Whatever your reason is, we allow you to get that in there. 9 times out of 10, though, that's not what you want to do, though. Just put like a sample token and not a real token instead. But you can now go to your Git history. I'm inside Visual Studio 2026 here. You go to Git, View Branch History. You can see here's my latest commit that I just tried to push up there. But since it's not there, we just go to the commit before it and choose Reset, but keep our changes. So that will take the commit, roll it back. I guess if you go here and do a refresh, you can now see that commit is gone. And now I can go back here and instead of hard coding this kind of in a public settings file, we could put this into an environment variable or a key vault or somewhere more secure than the Git history for a repo. So yeah, that's really awesome. It's as I said, like on by default, and you don't need to do anything to get that. But just to give you some hints there on what it would look like if you do get a push block. Let's shift gears one more time here and talk about vulnerabilities in the .NET code you write. So I'm going to head to that same repo we were just looking at, but I'm going to go to the GitHub view of it. You can see it's a pretty big mono repo. It's got a mobile MAUI app, a web Blazor app, a control web API here in .NET Core, and a shared NuGet library that I published out to NuGet. So we're going to head back to our settings on our repo and go back to advanced security. Scroll down a little bit below Dependabot, and you'll see code scanning. So this is where you can configure CodeQL to do static analysis on your repo. Choose setup, choose default. This is our easy button. We basically are detecting which languages are in the repo we can scan. We'll give you a choice of which queries you can run. I'll click this link and show you the docs in a second. This is going to run on every push and pull request to your default and your protected branches and on a weekly cron job. I'm just going to click this green enable button and send it off to work. To give you a little more description about what's going on when I click that button here. So it's running a GitHub action right now, but I'm going to dive into the docs here for C# analysis that we do with CodeQL. So CodeQL is GitHub's first-party semantic static analysis engine to look for vulnerabilities in the code you're writing. The way it works, you see we're talking about queries here. So we actually turn your code into data. So as we see every file in your repo, we extract those files out into a database. That database contains the abstract syntax tree, control flows, data flows, and we bundle that all up into a DB. and then we take our security queries, we execute them back against the database of your code. The result of that is vulnerabilities. So this doc page shows you all the queries we run, which CWEs they relate to. If they're in that default suite, we also have an extended suite, which have lower severity vulnerabilities, lower precision, and then which queries we will suggest fixes for, which is pretty much all of them at this point. So we can head back to that repo. We can go to GitHub Actions. We can see CodeQL is still running here. It should just take a couple minutes to run. Again, it's detected all the languages in our repo, but within a couple minutes, it will scan all of these for vulnerabilities. Let's head back to the repo I forked from, because this one has actually completed. And let's maybe just open a pull request and see what this would look like as new PRs are added into your application. So I've had, again, my friend Copilot open up some intentional vulnerabilities here as a pull request. It does it with some additional hints that's saying, hey, you did ask me to introduce a vulnerability. Do not use this for production. But it's really nice that Copilot can kind of be a little bit of a red teamer here with you if you're doing some vulnerability research. I personally use Copilot for that all the time. But you can see here, if we keep scrolling down, the files that Copilot introduced here knowingly introduced some vulnerabilities. And now that we're running CodeQL, like we set up that default setup, it's running on the pull request, we can see that it's detected some vulnerabilities. These vulnerabilities are of high confidence because we can see these coming in from a user-provided value. This is our API tier on a controller coming in from the path variable from the query. If we click Show Paths, we can see where it comes from, the source. We can see how it flows into the sink. In this case, the sink is a logger call, taking user data unsanitized and jamming it right into our logs. Like I mentioned, when we find things, we want to fix them. So we're giving you a Copilot autofix hint here that says, hey, you should be escaping user input, not allowing them to do log forging, injecting of new lines and returns into that log, because they could kind of simulate their own logs being injected there. And we'll give you a fix. What we're suggesting to do, sanitize that user input before you call the log. If you like that, you can just take it, commit it right to this PR branch. If you need to make some changes, click the edit button. That'll let you edit things. Or you can always kind of do this and apply this commit into your local IDE. Take the diffs that we're suggesting here and test it out locally as well. Another vulnerability, uncontrolled data in a path expression. We've got the same kind of paradigm here. Data flowing in, you can see flowing into a file read all text. Kind of same idea. Maybe that's not the best thing to do. We should probably be doing some consideration of not allowing .. coming in. Even the fix is suggesting we should be looking in a specific folder and then sanitizing that input. So you can see that the Copilot autofix is kind of giving you this information here right in the PR. Again, you can fail the pull request if that fails for CodeQL, and it'll give you that information that you've got vulnerabilities coming in that we want you to fix. That's all great for new vulnerabilities, but let's go take a look at the backlog. Actually, let's go back to our other one that I think if we check now, we can see this one's finished. This is my fork. 1 minute ago, we've detected 6 vulnerabilities in our backlog here from that initial scan. You can see it's the same log forging issue where user data coming in is not sanitized when it calls the logger. This one's a little deeper of a data flow, but you can see we give the developer all kinds of information about the vulnerabilities and what they are, links to the OWASP top 10, severity scores. But I've got a lot of these. I can go and I can click Copilot here to generate an individual fix, which is very similar to what we saw in the PR there. But since we have 6 of these, maybe the right thing to do is head back over into our IDE and let's ask Copilot to fix these for us. So one of the really cool things you can do is turn on the GitHub MCP remote server here. And this does support code scanning as a tool that you can use to either get or list the code scanning alerts. To do that, go to your MCP.Json and just opt into the tool for code security or Dependabot or secret protection, or just choose the all tool set in the API URL. So here we can just ask it to list me all the injection vulns in this repo, and it will go out and use that remote MCP call to call the GitHub API for all of the vulnerabilities that apply here. And it's going to pull forward all that context, all the vulnerabilities, the files, the line numbers, all the data flows from source to sink. That's going to pull all that data back here into my IDE, And now my Copilot context is really, really good here. So maybe the right way to fix this would be like, let's implement this in my shared project as a common injection sanitizer and fix it everywhere. So we can either ask Copilot to do that or use agent mode and just do it. But in this case, like, it's now got all that context that it can go iterate through all of those vulnerabilities and come up with a really solid fix. Again, you can see all the files that we know those vulnerabilities exist in already, coming from that prior scan we did in GitHub.com, now pulled forward into this context. And you can see it's found my shared library, my NuGet package, and it's implemented a class called log sanitizer, a method called clean that's, again, doing that return new line injection, preventing tabs. You know, you might want to prevent whatever if you're logging as JSON as your logger. Maybe you don't allow JSON. And then it's going out to every file and sanitizing that input. So that's what I wanted to show you. That's it for me. Go out and implement this on all your GitHub .NET repos and stay safe and secure out there. This link at the bottom is has all the information about the repos I was at, links to GitHub docs, GitHub blogs, all about these features. So take a look at that if you have a chance.
All right, Chad, I snuck in as you were wrapping up. This is really cool stuff, and so many guardrails in place because, you know, we devs love to shoot ourselves in the foot, right? So it's really nice to see all of this, you know, kind of done and defaults for us. Lots of chatter in the chat room. A lot of our friends are showing up, and I think you are speaking to a lot of us because, like, if I highlight a couple of things, like we check in stuff that we should not, and you know, like you were saying, like keys, they are abused very quickly. So it's really nice to see like those, you know, sanity checks where GitHub will just not even let you, you know, push something that has sensitive stuff. So a lot of info here, really good stuff, Chad. Appreciate that. And what can folks find at that URL?
That's just actually a link to my GitHub repo that I've got all the content that basically I presented here in this presentation, links to those repos I was using, and then just links to the GitHub docs if you get lost to turn on some of those features. So
awesome. Wonderful. Thank you, Chad, so much. I am going to bring your screen down and just, you know, appreciate your time joining us here at .NET Conf.
Thank you.
All right, Chad. Bye for now. All right, so folks, we are going to keep rolling. It's kind of getting midday over here in the East Coast, and we are ready to bring on our next two speakers. If you are ready. Hello, Emma. And
hey.
Hello, Lotte. How are you too?
Hello. Good. Super
thanks.
excited.
Where are you joining us from?
Two different places. I'm here in Denmark.
Okay.
I'm in London. So Europe represented.
It's late afternoon for you folks, and it's just the magic of tech. We are all on one screen, and you two are both at Umbraco.
Indeed, we are.
Yeah, yes. Love it. Lotte, I saw you a couple of weeks back at a booth right next to us in Europe.
Oh.
So yeah.
Yeah, in the Netherlands. Nice to see you again, Sam.
Yeah, absolutely. All right, so for the sake of time, I'm going to bring up your screen here. Frameworks to Friendliness. Stage is all yours, so take it away, please.
Thank you so much, Sam. Hi. So we're going to talk to you a little bit about going from frameworks to friendliness and how we believe you can build really, really welcoming open source in .NET. So I'm the one on the left. That's me, Emma Burstow, and I'm the VP of Developer Relations at Umbraco.
And I'm Lotte Pitcher, the one who's going to try and click slides when she's meant to. I'm also in DevRel at Umbraco, and we're both Microsoft DevTech MVPs.
I'm super happy about that too. So we're going to go through some of the things that we're going to talk about today, just so that you know what to expect from today's session. The first thing we're going to cover is the technology. We're going to look at the ways that your tech choices contribute to making a truly friendly open source project. I'm going to talk about stability and how it might sound a little bit dull, but it's a really key part of making your project very contributor friendly. Then we're going to go into communities and belonging, because we know that the people are really the things behind the tech that we want to look after. A little bit about empowerment and how we make life easiest for our contributors, and then into governance and how that really sets the groundwork for that community contribution. Sorry, Lotte, I'm seeing you're clicking slides and I'm just not noticing. So why are we here to talk about it today? So as we said, Sam, we're from Umbraco. Umbraco is a 20-year-old open source project. We just celebrated a birthday in February. And that's really, really cool in this industry. We started out with a single maintainer, as many, many open source projects do and continue to be. We're now 160 people here at the company. We're a .NET open source CMS platform, and our origin story is super cool. But the really cool part is why we call ourselves Friendly, why it's all over our branding, and it actually didn't come from us. So it came from somebody all the way 19 years ago who said that everything about Umbraco is friendly. It's the UX, the community, and the pricing. And we loved that. And we really haven't been able to shake that tagline. It's baked into everything that we do. And we want to make sure that this is a super friendly place for contributors to enjoy themselves and to continue to innovate with us.
Yeah, so let's get started talking about the tech side of things. In case you don't know that much more about our project, Umbraco, it's just a bit of UI on top of ASP.NET MVC. This is a quote from our VP of Engineering. I think perhaps as a bit of a throwaway quote because it's a little reductive for the flexible, extensible, wonderful platform that it is. But it is also kind of true. It's how we want .NET developers to feel when they're working with Umbraco, that it is just a bit on top. When you run .NET New Umbraco, you get a content management platform running on ASP.NET. You can add your own C# code, or you can install packages, which is our word for plugins, add-ons. You can use Umbraco to render your front-end website or work with it headlessly. And I say website, it's quite often not a website. It's been Umbraco's powered smart devices in hotels and big screens in music festivals. This is an example of a website being edited in the back office, which is the term we give to the restricted admin area that editors use to manage content. All the tools are there out the box to make the editing experience as friendly as you can for your users. And then if Umbraco is serving your front end, when a request for a URL comes in, such as blog/community, the default Umbraco controller finds that node in the content tree, creates a C# model with the node's properties, and passes that model to a Razor view to render the page. And that's the friendliest, shortest way I can think of to describe Umbraco to a .NET developer audience. So, unless there's a really good reason why you can't, always try to follow the standard .NET way of doing things, such as naming conventions, existing patterns like the MVC one I just showed, and dependency injection. When you install Umbraco, this is the program.cs that you get, and that will just look familiar to anyone who works with ASP.NET websites. You will feel at home when you see a code base that starts looking like this. So, don't get in the way is something else we believe in. In Umbraco, you can do anything. You can do in a standard .NET web application, register your own routes, use custom database tables, inject your own dependencies. As I say, we give you out of the box the tools you need to build the editing experience, but from that point on, build sites in the way that you want to build them, because that's what we believe is key in building friendly software. Don't get in people's way. Also, don't ask people to learn legacy technologies. We at Umbraco have been guilty of this one for quite a few years with a long-standing dependency on Angular.js, which was a discontinued JavaScript framework, different to actual Angular, that no one had any interest in learning in the last few years. I'm delighted to say it's been removed a couple of versions now ago in Umbraco. It's all web components now. Use technologies that are actually useful for someone new to the world of web development to invest their time in to learn.
And that brings us really nicely onto the topic of stability, which is not like the funnest of words that we're going to discuss here, but stability is actually really, really crucial in creating a project that people want to contribute to. So we took this quote from the book Grit by Angela Duckworth, which is a fantastic read. And what she says is that consistency of effort over the long run is everything. And we're great believers in that. You're not going to get everything right immediately, but consistency is going to help you in the longer term. So we believe, and this is something that we really, really practice, that your release cadence is actually a contract. Creating that kind of certainty allows for people to plan. It really helps adoption. It completely removes friction, and it brings people along for the ride. So the .NET release cadence, this is how it looks. You'll be super familiar with this. It's their standard term support, or STS, and their long-term support, or LTS. So we've aligned our LTS to their LTS. So when we release a new version, we're actually leveraging the features of .NET as they are made available to developers. We actually have 2 major releases a year, though, so we're not completely in line. We have release one. We release next to .NET, and we usually go anywhere between a couple of days or 2 weeks after .NET release their major, and then we also have our STS versioning too.
Yeah, so our STS has actually come out twice a year, so we release majors twice a year. So yes, as Emma says, we're not completely doing it the way Microsoft does it. We follow Semver, so of course you can only introduce breaking changes in a major, and we want to be able to do that twice a year if we need to. We don't always, but we quite often do need to. It enables us to advance the software in the best way whilst minimizing technical debt. We encourage people to go from LTS to LTS, or if you use the STS versions, then continually upgrade those until you get to the next LTS.
And it really comes back to this whole thing, trying to balance innovation with stability, but it is possible to balance the two. I think as developers, sometimes we can get really lost in the race to innovate and forget that there should be a focus on stability too. But it is key in keeping your contributors engaged. In the early stages, absolutely. And then as you have more of a stable project, it becomes a little bit more difficult for people to find ways to contribute that are obvious to them. So there's much less low-hanging fruit. But if you want to keep your contributor ecosystem thriving, then you are going to need to find new avenues for them. So engaging them in changes really early. For our part, we get people involved in our RFC, or request for comments process, so that people actually have some input around architectural decisions before we have built the big features. So we really try to bring people along for the ride with us. And it also, on the plus side, just makes our software better when we do that. A really big win for us was in 2021, we released Umbraco 9, and that was our move to .NET Core, which was a huge disruption to our entire ecosystem because whole new framework. And we actually managed to engage community people from the get-go, 2 years before we even launched our version. They were involved in the RFC process, they were involved in the planning, they were involved in the writing. So when we went live with that launch, we actually had over 1,000 PRs from community contributors and 121 contributors outside of our engineering teams. And I know that was a long list because I read it out live on air when we did a launch, and it took me forever just to get through. Super proud of that.
So now we're going to talk about people a bit more, the communities that build up and around open source projects. Glyn Moody, who's been thinking and writing about open source for over 20 years, made this observation. While open source companies can be bought, open source communities cannot. Read the words. Which means if you've been successful enough to build up a large community, if they don't agree in the direction you're going in, they may not come with you. Another way I like to think of it is you can fork a repo, but you can't fork its community. But before we go much further, I do want to acknowledge that we at Umbraco are talking from now a position of privilege. We've built up a commercial enterprise around the free CMS. So we have 20 odd people who work full time on the open source code base. We're big enough to have a developer relations team that Emma and I are in. But this project started life with a single maintainer, as Emma said, Niels Hartvig, who decided all those years ago that he wanted to release the code with an MIT license, which we still use today. and see what happens. So whilst you might think that some of what we're talking about is only applicable to the bigger commercially backed projects like ours, we hope you'll find inspiration from this talk in whatever way you work with open source. So what do we mean by community? Well, we believe it's the people who go one step beyond just using the software because they were told to do so. There are many ways to do that. It includes people who engage online in forums, asking questions and answering the questions, talking on Discord, contributing to code, contributing to the documentation. Love those people. Commenting on discussions, as Emma said, RFCs, going to events, sharing packages themselves, releasing their own open source add-ons, recording YouTube videos. So we would say that anyone who is watching .NET Conf now or shared on Mastodon that they're excited about C#14, you are all part of the .NET community. So we'd like to set you a little challenge, which is if you haven't already, please find your local .NET user group. I'm a big fan of meetups being like the grassroots of joining communities, working out where the people are who you will enjoy spending time with and learning from. So if you go to the .NET Foundation's homepage on meetup.com, you will find an awful lot of .NET user groups all around the world. And why does community matter? Well, it isn't just finding free labor for writing code.
No.
As a community grows, you see the multiplier effect. When community members help inspire each other, it's really the only sustainable way that your community is going to grow, that your product is going to grow. And having a visibly active community builds confidence in your project and in its future.
So then we get on to a rather fluffy word, to be honest, and that's belonging. But this is super, super important because people are not going to contribute if they do not feel as though they belong. I chose this quote from somebody who is now a friend of mine. Her name's Yulia, and she's not actually a developer. She's been in the Umbraco community for a good 6 years now, and her contributions have been vast. And the reason that I chose to highlight her was because she said what we have heard variations of so many times. I came for the software, but I stayed for the people. Now, if you're able to welcome community members like Yulia, you will see the impact that it has. But in order for you to do that, you need to give people a sense of belonging. And the way that we start is actually by taking care of our newbies. I cannot stress this enough, but the first 15 minutes really, really matter. What does somebody encounter when they encounter your project, whether it's on GitHub or if it's at a meetup? What are the first 15 minutes like? Think about that time, because we do not stick around as developers or otherwise if the first 15 minutes actually kind of suck. Documentation is really, really important, whether that's your user manual or your contributing.md. Keep things up to date. Make sure that that first touch point is one of quality. Be really open with the mistakes that you make. We're fortunate enough to have made loads. We've been around for 20 years. But when I first started contributing to open source, I was terrified. I was really, really frightened of working in public and getting something catastrophically wrong. You know, everyone would point and laugh at me. And what really enabled me to feel free in contributing and to give my contributions was seeing people that I regarded as community legends really own their mistakes, really kind of show up and say, got this wrong. And not just say I got this wrong, but then show us how they fixed it. That was super empowering for me. You're going to want to get really good at saying thank you. So obviously, I'm a Microsoft MVP, so is my friend Lotte here. And we also have Umbraco MVPs. And these big awards are fantastic, but we mustn't underestimate the value of smaller thank yous. So if you're an open source maintainer and somebody's created a great contribution and you've merged it, feel free to reach out to them and let them know in a private message. Remember the value of shout outs on social media. They really, really land. And then I'm a sucker for a handwritten note. I cannot tell you the value of receiving a handwritten note, and it costs the price of a stamp and a little bit of time. It's actually the only thing that I've got framed on my desk is a handwritten note, not a picture of my kids.
You'd be surprised at the cost of a stamp in the UK now, but never mind.
Yeah.
Next slide, sorry.
And then I want you to think about the fact that representation really matters. And it matters at every single stage of the journey, whether we're talking about speakers, bloggers, or people that are submitting PRs. Try to highlight when interesting contributions come from an unexpected place. Really, really work to make space for different people, because it's that drives innovation. Creates a sense of safety across your entire community. And if we see people like us contributing, we are so much more likely to contribute, and you really wouldn't want to be without that vast range of contributions. We don't want the same 10 guys building our software.
So when you've got your community of people and they feel like they belong, it's then time to ensure that they feel empowered to achieve and contribute so that they keep doing it. Rizzle Scarlett of blackgirlbytes.dev wrote a wonderfully honest blog about her experience of contributing first to open source, not our project, I should add. And she said that gaining support from the maintainers and feeling embraced by the community empowered me. And I really relate to this quote. For over 10 years, I was a community contributor to Embraco before making it my day job. I got an awful lot of support and encouragement to do things in our world. And whenever I heard that people had found use in what I'd created and shared, whether it was a blog post or a NuGet package, it was incredibly empowering. That was the word I always used to use. The contributions that I made were valuable, and that made me want to do more of them. The two factors of empowerment, well, you've got the resources that you need to share so that people can participate. So that's, as we've talked about a lot, documentation, a forum for people to communicate through, and Discord perhaps for that real-time chat and community building. And then you need the pathways for people to find the resources that you are having. And remember that you've got text and non-text. Yoka is a wonderful example in our community of a non-dev who's made a real difference to our ecosystem. So don't just think about the devs who are arriving, think about the other people as well. Oh, look, documentation again. Documentation should be empowering. So contribution guides that don't assume too much domain knowledge, or use video walkthroughs as well as the written word, because a lot of people prefer to watch a video to learn how to do something than to read about it. If you can create a tool to automate a job, then do that. Create tooling to do the heavy lifting. We have a .NET new template for creating customs extensions in the back office with this new, in quotes, way of doing it that end up as web components to help our community learn and focus on what they need to do. I had a lot of help from someone in creating a package for Embraco and publishing it to NuGet, so I distilled all of that into a .NET template and released it to make it a lot easier for all the other people to learn what I'd learnt. I think it's called passing it forward. Probably one of my favourite phrases in the open source community. And remember that empowerment, as I think Emma said already, it leads to innovation. So at Embraco, we've recently released a Embraco MCP server, or a few months ago, who knows where the year's gone. This was an innovation started and developed by a couple of our most active community members, who since have worked with us closely, but it came from them first originally. We have a weekly newsletter, FYI, it's called FYI, that aggregates content from all around the world in terms of different social media platforms and blog posts, and consolidates it all into one weekly newsletter that people can get in their mailboxes. Again, written by someone in their spare time, because they knew it would be valuable and they had that itch that they really, really wanted to scratch, and they knew it was worth scratching. And you can make a space where people want to scratch their itches, and indeed do, if you provide good governance. And again, I get all the unfun words in this presentation, but let's talk a little bit about what governance looks like. So when we're talking about governance, we're talking about really having clear and transparent decision-making processes. Things like a code of conduct are also really, really helpful. Security vulnerability processes that people can see and people can read. And then things like the contribution license agreements. I've been bold enough to quote myself here because I couldn't find a fun enough quote around governance, but
It's a good quote, so I'll go with it. Governance isn't the paperwork that you add when you're done. It shouldn't be added at the end. You begin at the beginning. It's the playground you build so that others can play.
I want to see this quote in other people's presentations now.
That would be fab. Let's get it out there. So I think it's best to start as you mean to go on. We don't do this because we were big. We did this when we were small and it had fantastic results. Create a culture really early. It is never too early to have your merge processes public, your contributor guidelines out there, or a code of conduct. These things are going to save you so much time in the long run, and you can adjust and adapt them as you go. Collaborate with your community on governance. Don't just create rules for your contributors without speaking to your contributors. In the early phases, that's about talking to the most active people on your repo. And then when you're 20 years down the line and you've got a much bigger community, the way that you can do it is something like our community teams initiative, where we have people that are working on specific projects who work with us here at HQ. We've got one on security and privacy, one on sustainability, and I could go on, but we do it because we know that we're not the experts on everything, and that it's great to create things for people with people. The outside expertise is invaluable to us. And one of the other things that we do too is we have a team of people who look at incoming pull requests on our core repository, and they're able to approve or ask for changes on all of those pull requests. And true story, they even have merge rights. So it's something that we've made work in the early phases and in the later phases, and it's been really, really valuable. Think about prioritizing clarity. You don't need a ton of rules, but just be really clear with what you want in place and what you have in place. Make public your decision-making processes around things like merge rights, who can merge, who can release, when these things are going to happen. We were thinking, we were talking when we were planning this about the trust paradox. And this is the idea that clear rules can actually increase trust. And if you increase trust, you actually increase contribution and engagement too. And then finally, explain your thinking. The core team says no is not very helpful to the people that are trying to raise issues or create pull requests or request features or build features. Don't become the benevolent dictator who isn't actually benevolent. Like, invisible decision-making is really, really unappealing. So it's cool to say no. You should say no. At the end of the day, we govern. It's our project. But explaining your thinking really allows people to really understand what the processes are and actually to contribute elsewhere or to contribute in another way.
Yeah, so time to close. And we want to acknowledge that just like bug reports, which are a gift themselves if they're done well. When they're done well, we love a bug report. Mistakes are a gift too. Across the last 20 years, we've got plenty of things wrong. There's no doubt about it. We started small, we've got bigger, we've learned along the way. We definitely advocate progress over perfection. Software is built by people, so we want to take care of our people, and then the code will take care of itself.
Really, really work hard to keep your contributors close. Whatever phase of your project you're in, work hard to keep them close. Involve them in your decision-making when you can, and this really will create a thriving ecosystem. We have some discussions on our RFCs that are so long, they are intimidating, but so much valuable information in there. And then for our part, we believe that if you're ever really worried about the health of your contributor ecosystem, just return to the one real metric, which for us is, are people still excited to contribute after their first PR? And are they still excited to contribute after their 10th?
Which leaves us to say thank you and apologies. We forgot to do the bit where we say where you can find us and find out more. But Emma and I are both on LinkedIn with our names.
You know our names now, so you should be able to find us.
And Sam's back. Hey, Sam.
I am back, and I am blown away. Like, You two speak from experience. Such wise words here. Thank you so much. And as we all work in open source, these are all very real things. And we see this all the time, where big .NET open source, repositories with commercial businesses built on top of it. How do you keep your base, invigorated? So such, gems of, wisdom that you have dropped. Active chatter in the chat room from a lot of our friends. User groups, meetups, they're great. They're, grassroots, and they help, build that community. And I love that, comment where you said you cannot fork a community. Like you have to, bring people along for the ride. Lots of good comments, kind of piggybacking off what some of you, some of the things you said, gratitude and rewards. I love the fact about you mentioned the handwritten notes. You find those effective?
Really effective.
Yeah.
It's, in an age where so little is authentic and everything could be a ChatGPT answer, the handwritten note goes a really long way.
Yeah. I loved your thoughts on empowerment as well. It's people are contributing their time, their precious time, to help a project. How do you empower them? If I may ask another question, like how do you, like on a new thing that, let's say you're working on, potentially maybe a breaking change, like how do you incentivize more contributions?
Lotte, your turn.
Incentivizing new, I guess it's all about making it clear that all contributions are welcome, all opinions are welcome, and having a long enough time for people to give their opinions. One thing we have in our community is a very, very vocal community who are never shy at telling us what they really think, which sometimes hurts a bit, but it is always coming from a place of passion and loyalty to the product, which we are so grateful for. So you get over the initial and then you realize that there's so much positive intent because we all want to win. We're in this together. We've got some people who've invested a lot around our product, and together is the way we want to keep moving forward.
Sorry.
Very, very nice words here. So I'm going to take down your screen here for a second and just bring up Code with Sean, our friend, is pointing to your next release. You said this is coming up soon.
Yep, that's 2 weeks' time. That's coming out. So we were 2 days. We're actually live last year doing our 15 release, but we're a whole 2 weeks later, so we don't have the exciting.
Yeah, we can't release live this time.
Yeah.
No.
But it means that we have time for Azure to roll out .NET 10 to all the various regions. Then we have time to test in our cloud platform and then release, which is always a nice way to do these things. Thanks for the person putting the URL in there, though. Sorry, we weren't very good at doing those.
Yeah.
No.
Yeah, and lots of more comments, thanking you folks in the chat room, appreciating all of your kind words. So, from .NET and Microsoft and all of our communities, we want to thank you too for taking the time to come and share your wisdom. And
thank you for having us, Sam.
Yep. All right. So I will wave my goodbye, let you folks go, and bring up our next speaker. All right, let's see. Erik, you ready? How are you, sir?
Yes, I'm fine, thanks. And thanks for having me on the live stream, Sam.
Yeah, absolutely. All right, so it is the age of AI, but MCP can bring context, and I guess that's what you're talking about. So if you're ready, I am going to bring up your screen.
Yes. So.
All right, stage is yours.
Yes, thanks a lot, Sam. So in this session, we're going to look at how you can take some of your own existing tools, or maybe even a new one that you're planning to create, your existing .NET tool, and improve the usability and the audience for that by making it into an MCP, a local MCP server. I will use the one I have done myself as an example, but hopefully you will go away from this and be ready to also do this for your own tools. So we'll go through quickly go through what and why MCP servers are, I guess there has been some talk about this already during this event, so we'll just do it briefly. And then we will show what it takes to add an MCP server feature to our current CLI app. And secondly, what can we do to publish it as an MCP server to NuGet? And we'll look at some additional improvements that the .NET team has made to make the ecosystem around MCP servers and tooling around it, in particular for local MCP servers, better in the .NET 10 release. So let's just have a quick recap of the model context protocol. We have some MCP clients, which is usually GitHub inside either Visual Studio Code or Visual Studio, or you can actually also create your own agent with the new Microsoft agent framework. And then on the other side, we have an MCP server, which exposes various tools. And it can be a remote server where you communicate over HTTP protocol, but it can also be a local tool that you invoke via standard I/O. And in this example, it's going to be the last thing I mentioned, invoking the tool via standard I/O. So let's look at what it takes to take an existing console app and convert it into an MCP server. So I have a tool here called SQL Analyzer, CLI, and it's a tool that's published on NuGet as a command line tool. So as a .NET tool, which is basically a command line tool that is installable with .NET tool install, as you can see here on the screen. And that tool provides analysis of bad patterns in T-SQL object creation scripts. So if you are in a folder with some T-SQL object creation files, you can basically just run the tool and it will run analysis on those files against more than 140 analysis rules and report any findings back as warnings in this case. And it's also, there was a syntax error in one of the files, so it's reported back as an error. So it's a standard command line tool, and you install it with a .NET tool install. And the installation actually means that it's being downloaded to your NuGet cache, and on top of that, it's also being registered with a shortcut somewhere else on your disk. So that's what the installation means, and you can also have local installations. Global means global for me as a user. It doesn't mean global for all users on this machine or server. So given that we have this command line tool, which is a standard command line tool, console app, and it passes command line options. I'm using the command line library to do that, and then I run my class library for actually doing the analysis of whatever is supplied to it. So it can take a list of script files or just a single one, or it can even take a piece of text, which is SQL script, and then analyze that and return the results. So right now, this is just a plain old school, whatever you want to say, .NET tool. And what in order to make a command line tool, a .NET tool, more or less all you need to do is, of course, do some package metadata, add some package metadata in your project file, and then you add this pack as tool property group to your project, and then when you pack it, it will be packed as a NuGet package that wraps your command line tool for you. So in order to make it MCP server, first we need to add a reference to a library that enables us to do this without too much effort, and it's called, where is it? Here. So it's called Model Context Protocol. it implements a model context protocol standard way of interacting with MCP servers for .NET. And I think it was originally created by a community contributor, but now it's also maintained by Microsoft together with that community contributor. You can see it's not Microsoft something, it's just model context protocol. So it's a .NET library that enables you to add model context protocol functionality to your app. That's the first step you need to take. And then secondly, you need to add a class that exposes the tools in your MCP server. And I have already a class ready here. So let's just include this in the project. And it will reference the model control protocol namespace up here. And it will say that this, what we're exposing here in this class, is an MCP server tool type. And this particular method here is a specific MCP server tool, which has a description. So adding a good description is really good for the AI agent to be able to understand what value this MCP server actually adds. And then, of course, you have to implement your actual tool functionality. So I have called my tool Find SQL Script Problems, which is also kind of relatively describing of what the tool actually does. And then there's another description of the actual tool. So you can have multiple tools. In this case, I have just implemented a single tool. So an MCP server can have multiple tools and do multiple things. But this simple MCP server here actually only does one thing, which is find SQL script problems. So it takes a string, which represents a SQL script, and it returns the result basically just as text. I think in the newer versions of the library, there's options to make the results more strongly typed, more structured, but it actually works quite well by just returning text. The important thing is that everything, even if there's errors happening, it's important to not return those errors, because imagine that you're actually interacting with something that the AI agent is reading, so it should be like human readable text, not necessarily technical error messages. And finally, the last bit of plumbing you need to do is adding the tool to your main program. And of course, there's different approaches for doing that depending on how your program is already implemented. So, but one approach to it is, so I already supported being called without any parameters. So I had to add an additional parameter to say now I want my tool to run as an MCP server, and it will use the Windows host builder to basically create a continuously running app that will then listen to whatever text you send to it. Initially, when you start your communication, or when an agent starts its communication with a MCP server, it will get a list of the tools that the MCP server provides, and then it will know about those individual tools and make them available to the end user of the AI agent. We'll get a demo of the actual interaction with the Copilot in a little while. So it's important to notice that we use the add MCP server method, which comes from the model context protocol, and then we specify what type of transport we're using. So it can be either HTTP server transport or standard I/O server transport. So standard I/O is basically just whatever appears in at the command line going back and forth. And then you can have several methods. There's several methods to register your tools. So this one will basically just scan this analyzer tools class for any methods decorated with the MCP server tool attribute, and then make those tools available. I think there's also a way to just scan everything in your library. An important thing to notice is that you should make sure that you're not accidentally outputting stuff to the console that is could be confusing to the MCP server. So that's why it was suggested by whatever example I used to do this, to only add trace level errors to the console, so it doesn't get polluted with error messages. So it's only the only communication that happens on the console is actual textual message exchange between the method and the AI agent. And then you run the method, run the host, and it will then continue to run and wait for requests from the AI agent and respond as needed when it receives text data to the tool that is being called, because that's how we decorated this method with a string parameter. So now we have an MCP server that we can install and run. One of the challenges with this approach until the .NET 10 was that you actually had to then ask the user to install the tool. As you can see here, even if they wanted to use it as an MCP server, they had to first do the .NET tool install dance, and then register it as an MCP server. So in order to register as an MCP server, you can either add this to your MCP JSON file with the command line parameters. You can see I have this additional flag here to indicate we're running an MCP mode to our tool. There's also possible to make simpler installations now with some sort of hyperlinks that adds this configuration either to Visual Studio Code or Visual Studio. So you can go into my repo and see how this is done. So basically, it's sending the config as a URL encoded string, so it will get injected into Visual Studio Code or Visual Studio with these special URLs. You can see, maybe you can see at the bottom, but you can go into my repo and see what the exact syntax is to do that. So next step, of course, for .NET 10 is that you actually don't need to install the tool. You can just refer to it with this syntax, which is new in .NET 10. So instead of the actual command from the install tool, you can use a new .NET 10 command called dnx, which has the ability to execute your .NET tool package directly from the web. Of course, it will initially download it to your NuGet cache, but then basically it will execute your tool from the NuGet cache. So as you can see, I have published it and NuGet realizes that this is actually an MCP server. And if you go into package search in NuGet, you can actually filter and do a search for only MCP servers on NuGet.org. So how did I publish this packet with all this additional information about the fact that it is an MCP server, including the arguments? Let's have a closer look at that. So first of all, you need to add a metadata file called server.json, which basically is the basis for this server.json part fragment that's shown here. It's a little more verbose than that, so it's basically like I'm thinking a little bit of it like a new spec for MCP tools. So it's like a standard thing. I don't know why there's squiggles here. Okay, I have some typo somewhere. No. So you need to specify a number of things, basically like publishing a NuGet packet. Like the command arguments has to be this funny syntax, and the name has to be this inverted domain name and some things like that. So basically, this will make it available as a tool, and in order to do that, you have to first author this file, and then add an additional property to your project, which is this new package type, which is added in .NET 10, called MCP Server. So basically, you're telling the NuGet pack command that this is a special type of tool that is an MCP server, and that then it becomes published as an MCP server. The last thing you need to do is to actually make sure that you add the MCP file, similar to adding a README file. You can do that with this syntax here at the bottom. Again, have a closer look in my repo, but basically you need to include this MCP server file inside your NuGet package, and this is how it's done. So with all that, let's just have a quick look at what the tool does. So I'm over here now in another solution where I have a SQL script. It looks actually okay. It's from the from the Chinook database. But let's see what GitHub Copilot can help us with in terms of making sure that we're following best practices when we're designing this table. So I'm running GitHub Copilot in agent mode, which will enable it to use various tools. And I have installed the tool with a shortcut. So you still need to install the tool. Maybe in the future, Copilot will be able to browse a registry of MCP tools somewhere and find relevant tools based on the questions that you're asking. I don't think we're quite there yet, but you have to kind of consent to having the tool installed. So it also the issue of doing that the right way. So you have to activate the tool, so you can see I have a SQL Analyzer MCP, and then I have my Find SQL Script Problems tool here that is activated. And then I'm asking Copilot to check this script that's currently on the screen. It's asking me, do you really want to run this tool? And I will allow it to run in this session. So it's not running tools without my knowledge. So only run trusted tools, and then it will actually tell me what the bad practices were in this file here, and I can get a link to more documentation about the bad practice and see what I can do to fix it. So a quick recap. So we added the model context protocol package. We can add and inject an MCP service, as you saw in Program CS and in the Analyzer Tools class I had implemented. And then, of course, we enable it to be called somehow from our main Program CS file in our command line tool. And then in order to publish it as an MCP server, we need to make it a package type of MCP server. We need to author the MCP/server.json file. And then we need to add the MCP server JSON file to the package. That's all these 6 steps. That's all you need to do to get started by making your command line tool useful as an MCP server. We also had a quick look at some other features like the one-shot execution. So I'm just going to do a quick demo of that. Time is permitting us. Yes. So I'm in Visual Studio and I'm in Developer PowerShell 7 in Visual Studio 2026. So basically I can run this command with any tool that's published on NuGet.org, and I can also add, as you saw on on the website. I can also add a specific version. But if I don't add a specific version on my command line, I just sorry, yeah, I'll go back here. I will just get the latest version, and then I say yes, because otherwise I do have to do some confirmation that I actually want to do this. So this will be the same as running the tool that was already installed, but now it's not installed, so to speak. It's quickly downloaded and then run from our NuGet local NuGet cache folder. So this fact that it's downloaded and run for our NuGet folder adds some interesting perspectives on how you are designing your tool. We will not have time to deep dive into that, but basically you have to think about a couple of things that are now more relevant than ever, because you want your MCP server to be responsive and installed quickly. So the way to get it installed quickly is, of course, to make sure that the size of your package is as small as possible. And you can do that. One approach to that is actually you can split your right now when you pack your tool, it's packed in a single NuGet package. So the whole NuGet package will have to be downloaded. But if you have a lot of unmanaged dependencies, you can actually split your package into multiple packages, and only the package that is relevant for your platform will then be downloaded. But your mileage may vary if you don't have a lot of unmanaged dependencies like C++ DLLs or C DLLs or whatever that are platform specific. It's of less importance, but it's definitely something that you should consider depending on what your tool does. There's also the possibility to pack your tool as an AOT with AOT compilation. Again, your mileage may vary, and maybe you are using some dependencies that don't allow being packed or being compiled as AOT. And the third option, you can also do trimming. Again, maybe some of the libraries you are using are not trimmable, and then you will have to work around that or switch libraries or whatever. But that's also an option. So the goal is to make your download as smart as little as download size small as possible, and then make your app launch as quickly as possible to get the best experience for the end user when they're using your tool as an MCP server. Yeah, we saw this. Another thing that maybe will come is a little bit of future thing is a CLI introspection, the ability to expose structured information about your commands and the parameters of them with a CLI schema, which it has been built into the .NET command already. And you can also, for example, with a tool like spectre.cli, console.cli, you can actually add it to your own app. So you can expose metadata about how your parameters are and what data types they are and so on, what the values are, and so on. So that could be used by tools like AI agents in the future. Yeah, go and get .NET 10 and start playing with it. And thank you very much. I'm a little bit over time, Sam. I hope you'll forgive me.
No, you're all good. You're all good. Thank you. Thank you for this.
You're welcome.
All right, so this is really good stuff here, Erik. In the age of AI, I think we could all use, context. So I can bring your screen down here.
Thanks.
Without context, we are letting the AI agents sometimes guess, and that's not healthy. So MCP, I love it because it helps us bring whatever is the context. You are known for your expertise with entity framework and SQL Server. Could be SQL Server in the cloud, under your table, doesn't matter. Just
Could
bring
be
it.
anything. Yeah.
Could be anything.
Could be anything.
So I really like, I don't know if you have used anything in the Node world where they have always had NPX. So I'm so glad to see .NET get.
So So if you followed the design of this, there was a lot of talk about NPX, and I actually didn't know at the time what it was. So I had a closer look. So it's like, instead of doing like this multiple process where you first do a gesture to install and then a gesture to execute, it's basically install if it's not there and then execute it right away.
Yeah, makes it super easy.
One-shot execution makes and it's really, really helpful for scenarios like MCP servers to make it as frictionless as possible.
Yeah, and another thing, and I saw you were using the C#, MCP SDK. That's been worked on. I think it's nice to see how quickly the industry, like we all realize the need for this standard, and everybody is contributing to make the MCP standard. Like all of the big tech, Anthropic, Microsoft, Google, they're all working together. It's nice to see the progress with the C# SDK. I think something that was talked on day one was adding, authentication and authorization to your MCP if your service needs that. And then that's good for, things like Slack or GitHub or any of the things where they need to know who you are before the agents can execute something.
So my tool is basically just a local knowledge base that you can take advantage of. There's nothing.
Yeah, absolutely. But it's good to see everything around the MCP developing so quickly. So it's so easy to make MCP servers and tools.
Yeah. Cool. I'm sharing my my repo with all this in my speaker profile.
So go check that out, people.
Go check that out.
All right, Erik.
Of course, feel free to ping me if you have any questions on the repo.
Absolutely. So Erik, thank you so much for sharing your expertise, with us and, helping us see the light with MCP. So hope you have a great rest of your day. Thanks for joining us here at .NET Conf.
Thanks a lot, and thanks for having me.
Yeah. All right. Bye now, Erik. All right, folks, we are rolling right along, 4.5 hours in. This is a 12-hour or even more of a stream for day 3 of .NET Conf Community Edition. I am ready, and I see our next speaker is ready as well. So I'm going to bring on Ryan. Hello.
Hey, Sam. How you doing?
I am doing great. So, how are you, and where are you joining us from?
I'm joining from Atlanta, Georgia. I'm out here for KubeCon, and the folks at the Microsoft campus here have set me up in a nice room, and I'm ready to present.
Beautiful. KubeCon, Kubernetes, load balancing, all the difficult stuff. So I hear you're going to make it easy for us. So I'm going to bring up...
I'm going to make it possible.
There you go. I'm going to bring up your screen here, and you're all set, ready to roll. The stage is yours.
All right, great. Welcome, everyone. We're going to take a look at using YARP, which is a reverse proxy, and customizing it to handle multiple Kubernetes clusters and more, but you're going to have to wait and see what that more is. What you won't have to wait for is the takeaway from the talk. Now, YARP is a reverse proxy toolkit. It's built in C#, and it expects that you're going to extend or rewrite components of the implementation. And so it makes that an easy process to do. Standard reverse proxy functionality that you'd expect from Nginx or HA proxy is available for you, and you only need to extend the parts that you require for your use case. So there's a lot of great content that's available already for setting up YARP as a standard load balancer, but I really want to highlight how easily it can be customized when you have a need that arises. So we'll set the stage with the scenario that was causing us problems with the off-the-shelf solutions. We'll look at the standard Kubernetes load balancing and why it fell short, and then see how we designed a system using YARP to enable our multi-cluster load balancing. And finally, we'll see how we were able to utilize this beyond Kubernetes. So my name is Ryan. I am a software architect at Blizzard Entertainment, And the team that I work on mostly builds internal tooling for support, localization, game integrations, as well as external services like the player support site and self-service options. I actually recently hit 20 years at Blizzard, and that gets you a helm, which I think is pretty cool. Additionally, for about 19 of those 20 years, I've worked with the same team, and it turns out that gets you something as well, which is a vast catalog of systems that you need to continue operating and maintaining as the business evolves. And so that was our driving challenge that we had. And we really want to standardize as much as possible everything that we do to lower the burden on our team to maintain all of these systems. And these are varied systems in what they do and in when they have load. Some are during the workday in the United States. Some of them are used around the world. Some of them are used in times when players are online. And so we standardized our hosting for these services using Kubernetes, and specifically using a small number of clusters that host all of the systems on them, as opposed to having separate systems, separate clusters for each system. This reduces the operational work. It also prevents the clusters from specializing for each specific system, thus increasing the complexity of trying to manage them. In addition, we run redundant clusters. That means that a workload is going to run on multiple 2 or more clusters at any time in an active-active setup. And this allows us to run upgrades or other maintenance operations without needing to find a off-peak time, which is difficult with the varied systems that we run. And so we can take down a cluster and do an upgrade while we still have active clusters that are servicing traffic. This greatly reduces the risk and allows us to update more frequently, which also means we have smaller updates that get made, which further decreases the risk. And we also, as a standard procedure, do our upgrades by tearing down a cluster and recreating a new one, which also exercises the ability for us to do that should the need arise, because that is our standard operating procedure. So we get benefits from those multiple clusters, but there are also some challenges that that introduces. And the one we're going to look at today is multi-cluster load balancing, or getting clients to these workloads across multiple clusters that can be created or destroyed at any time. So multi-cluster load balancing isn't a common scenario right now, and it certainly wasn't very common in 2020 when we started our journey of looking for a solution to this. If we look at standard Kubernetes load balancing, you will have your cluster that's running pods. These are your workloads that you want requests to ultimately get to. And in a public cloud, there are managed offerings for creating a load balancer that will allow requests to come in. And the general pattern is that they will run a pool of layer 7 proxies, which are able to look at HTTP requests, find out the host name, the path, headers, other things about the request itself, and determine which service it should go to, and then pick one of the workloads to send the request to. And the cloud will run multiple instances of that layer 7 proxy for availability and to allow it to handle higher scale if needed. So then the layer 4 proxy or routing will expose a single IP address that clients are able to contact, and it will forward to one of those layer 7 proxies, which looks at the request and forwards it onto the workload. Now, that layer 7 proxy needs to know how to look at a request and determine what service to route it to. And that configuration gets pulled by a Kubernetes controller, which is just a process that runs usually in the cluster, and it's going to look at various resources in the cluster, like service resources, ingress, gateway, as well as others that we don't have time to get into. But ultimately, it's looking for what services should be exposed, and what workloads are providing that service. And the controller, when it sees changes in that, will create configuration that gets applied to the layer 7 proxy. And this is available in essentially every Kubernetes cluster in some form, but it does assume that there's a single Kubernetes cluster that is being used to create that configuration for the proxy. And in our case, we want to have this work with multiple Kubernetes clusters that we're running. So if we imagine what we would like to happen is we have these multiple Kubernetes clusters that are each running the same workloads. So a service gets deployed, it runs pods in both of the clusters, and they're going to be running their controllers to discover these services and pods that are running. And we want to somehow combine these portions of configuration from each cluster into a single config that we can then apply to the layer 7 proxy. And then the proxy is able to route to the back end in either of the clusters that we've shown here, since both of them run workloads for that service. And a solution like this doesn't exactly exist. And so we were looking at options that were available. I'm going to squish down the diagram here just to save some space. This is the same picture. We've got multiple clusters that are running, and we want that configuration to somehow get merged. Now, I will mention there are some multi-cluster service ingress and gateway options that do exist, and we have tried using them, but for various reasons, they weren't applicable for us. One of them is that most of them are specific to one public cloud, and we do run across multiple clouds. And so that runs against our desire for a standardization, which would require that we have separate solutions for different clouds. Also, some of the clouds we run in don't have multi-cluster options. A second reason is that many of those multi-cluster options are only working with external load balancers. The majority of the services that we expose are internal, and so that also meant that it wasn't an ideal solution for us to use those existing solutions. And so we were trying options, and eventually around 2022, we heard about this product called YARP, which is the reverse proxy toolkit. And we were eventually able to come up with a solution that follows a very similar pattern and uses a discovery controller that we wrote and uses YARP that we run and manage as our layer 7 proxy into our clusters. And we haven't got time to look at the C# discovery controller, but if you are interested, the YARP repository does have an implementation of a Kubernetes controller that provides ingress, and you can see what resources need to get watched, how to use the .NET Kubernetes API client in order to watch those resources. So you can check that out to see what that portion of it entails. The reason we don't use that controller is because it as well assumes that it's working with one cluster that's configuring the YARP proxies. And so what we needed was a way to get these multiple config pieces and somehow get them merged together into the proxy. And so we use an intermediary of object storage, which is available in any of the public clouds as a place to store these config portions. And then in YARP, we need to collect all of those and merge them together before we apply them to the proxy. And so in order to handle writing the config without overwriting, we use this layout and object storage. A gateway is a naming we use for a pool of YARP proxies. In this instance, Gateway US are our internal facing services in the US region. Gateway External US are our external facing services and they each have their own pool of YARP proxies that expose them. The second segment is the source, which in this case is the Kubernetes cluster, and then the service name, and it ultimately stores JSON that is used to define the routing and the set of backends that a specific cluster has for that service. And so this allows us to have cluster 1 and cluster 2 write their own config portions without overwriting each other. And you can imagine if cluster 3 is spun up, it's going to discover and write out to cluster 3 in object storage. So this allows us to write our config in a way that each cluster has its own separate portion. For then the merge process, what we logically want to happen is the YARP proxy is configured for one specific gateway, and it will pull all of the objects that start with that gateway name. So the gateway US is going to pull those first 2 objects. It's going to ignore the source because it doesn't care where it's from. It just needs to get the information. And then it's going to get the distinct services across all of those. So in this case, just service A. And then it will aggregate all of the backend pods or the backend workloads from all of the different sources. So if cluster 1 has 2 pods running, cluster 2 has 3 pods running, it will create a single collection of all 5 of those pods as the backend workloads. So logically, that's what we want to do, but we still need to get YARP to do that logic that we want. So if we look at how YARP is integrated, it is a NuGet package that integrates into the standard ASP.NET Core pipeline. And this has benefits because you can utilize the policies for rate limiting and cores and auth in your YARP routes. And you also get distributed tracing out of the box because the REST requests come in through a standard ASP.NET Core pipeline, and they get forwarded as HTTP client calls, which is already instrumented. And then YARP itself integrates in as an endpoint routing registration, and it has its own pipeline, which we see coming off to the right here, with various components that implement the standard behavior of reverse proxies. But each of these is designed to be able to be removed, replaced with your own implementation, or even to have you add and extend your own entries into this pipeline. So we're going to look today at how we've customized the configuration portion. But in addition to this, we also have our own implementations for health checks, for request transforms, and session affinity to fill other needs that we have with our proxies. Also, since mapping the reverse proxy just registers in the standard endpoint routing, you can still have controllers and razor pages and minimal APIs that are registered alongside in the proxy to add even more functionality, such as showing the config that a specific proxy is using, along with backends and their health status on the proxy itself to help with visibility into what's going on. Now, with these components being available with standard implementations, we have the C# available for what's being implemented. And so if you want to see what the functionality is, you have the code available and you can look and see how it's been implemented. And the code is always the best documentation. So for actually setting this up, there's very little that needs to gets put into place. As I mentioned, YARP is available as a NuGet package. So we add the reference to that in the web application builder. We set up the reverse proxy dependencies in the service collection with the add reverse proxy. And then at the second arrow is where we map that reverse proxy into the endpoint routing so that it's able to handle requests that match its routing config. And then the last piece we have is the configuration. And if we look at the commented line here, That's how typically YARP is configured. And this is going to pull from the .NET configuration system, which is your app settings.json or wherever else it is you're pulling your configuration from. And that's typical for a static or a manually created config that would be similar to creating a configuration for an Nginx or an HA proxy. But in our case, we have our own custom logic where we want to pull from object storage and do this merge operation before it gets applied. So we have our own object storage config provider that implements the iProxy config provider interface, and we register that with dependency injection, and YARP will use that to create its config when it needs it. And so I mentioned that we have the code for the standard implementations, which can be a great starting point to how you write your own behavior. And in this case, there is an iMemory config provider that YARP ships with, and it provides the iProxy config provider interface, which has a get config method. This is what YARP will use to get a snapshot of the configuration, as well as a change token that can be used to signal updates. Then the in-memory config provider adds an update method where you can call it with a new set of configuration. It will apply that internally to the provider and trigger the change token that will get YARP to pull a new snapshot of the config, and it will have that available for the next request that comes through. So we use this and we copy pasted the in-memory config provider for our object storage based one. We made the update private, and then we started a task that runs in a loop that periodically pulls the config portions from object storage. It runs the merge operation and then calls update to let YARP know that there's new config that's available. And we're actually not going to look into that code because it's in the end pretty uninteresting. It uses .NET clients to pull from object storage that all of the cloud providers have. It does a distinct to get the services that are available and a select many to get the destinations. And that simplicity of the logic is kind of the point here. We've seen very little code to add our own implementation, and the logic that we want to run is also relatively easy to express in C# code. And because YARP was set up to allow customization easily, this is a very straightforward process for a .NET developer to see. So if we look at how this lifecycle works, if we deploy a new service to a cluster, the deployment system is going to create the pods and for the workloads and create a service with the annotations that describe how the routing should be configured. And our discovery controller monitors those resources. And as they change, it will write out config for that cluster and that service. And all of those clusters will do the same. At this point, the discovery portion's done. And then YARP is going to periodically pull those object storage objects and merge them together. If the configuration is different from what's currently applied, then it will call update, which will trigger YARP to pull that new configuration and start using that. And so at this point, we've now done no manual work, and our new service is available for routing through the YARP proxies. And as those pods get created and deleted through the normal Kubernetes lifecycles, then it will update YARP with the new backends and the new services that are there. And then finally, we had used object storage as a way to simplify and reduce complexity in the implementation. The YARP proxy itself doesn't need to know about Kubernetes, and the Kubernetes discovery component doesn't need to know how to update the YARP proxies. They just have a shared location where that config is written. And that ended up being very beneficial for us as we looked at some of our services that are not running in Kubernetes. So we had services that exposed APIs and web pages before we were using Kubernetes. And those are running on Linux containers that were just VMs that we managed, as well as .NET Framework services on shared IaaS hosts. And we were able to add manual config in YARP to allow those to be proxied through a standard YARP interface, which gave us good distributed tracing and allowed us to remove other infrastructure that was running HA proxy and going through hardware load balancers that we had, which did not have the same visibility that we get using YARP. We eventually moved the Linux containers into Kubernetes hosting, so those went away. And for our .NET Framework services that still existed, we ran those. We run those now on auto-scaling VMs that have Docker installed, running as Windows containers. With them being auto-scaling, we can't use a manual config anymore. We have to have something dynamic. And what we did there is we wrote a self-discovery component that runs inside each of those Windows container processes. And when they start up, they discover themselves and they write out a config portion of just that one services on that one machine. So the target's the VM and the service is the name of the container that's running. And with that in place, YARP just does what it was doing before, and it pulls in the config portions, merges them together, and it's now exposing our .NET Framework services. And as the VMs scale up and down, those routes and backends will update on the YARP proxy, and our services are now available through the same framework with the same observability with a very standard C# .NET process that the entire team is familiar with operating and maintaining. And so, again, the specific implementation of our use case isn't the point of this. The point is that YARP is designed to be easily customized for use cases where the off-the-shelf reverse proxies don't fill the need. It's a common language and framework for C# developers to customize and to operate. And if you can write the code, then YARP can do it. So I've included the link here to the GitHub repository for YARP, where all the code is available, as well as the NuGet package for incorporating this into your systems. And I hope this has inspired you to consider YARP when you need a customized or a consistent proxy to get your job done. Well, thank you so much for coming out.
All right, Ryan, this is good stuff, very good stuff. And you clearly speak from experience of having done this. Can I ask a few curious questions of my own?
Certainly.
Because you mentioned a few things in the slides. So the configurations, like, is that, what is it written in, and can AI help us write it?
The configuration itself, I would not personally look at at AI for that. It's relatively deterministic. YARP has a notion of routes and clusters, which are the routes is if the request looks like this, and then the clusters are, then send it to these. And that's pretty deterministic. It's relatively straightforward to get that information. It's really that merging logic that is just not something that there are existing solutions for.
Yeah, okay, I understand. And then in one of your slides, you had mentioned health checks. Like, how do you do that?
Mm-hmm. So health checks are available out of the box with YARP. You can configure an active health check, which we match up with the readiness endpoint that we pull from Kubernetes. There's also passive health checks, which look at responses, and you can set a threshold. If this instance is returning so many 500s over a time period, it will have a circuit breaker pull that out for a portion. The changes we made were looking at some header values for specific services to ensure that we were getting the responses that we were looking for. But otherwise, the out of the box health checking is just a configuration when you set up those routes.
I see. So like a couple of things you mentioned, like towards the end with the self-discovery, like you could combine that potentially with the health checks, like if this happens, do this type of a logic.
Yeah, the health checks do still happen through there. As far as YARP's concerned, it's an IP address and a port. And as long as the HTTP server gives it back a 200, it's happy. It doesn't much care what's going on there. The self-discovery was really, like, the other option would be we have some centralized discovery service that looks at, somehow can look up the VMs that are running. I suppose, look at some label on them that identifies them as a Docker host, and then has credentials to be able to get on and look in Docker to see what's running and pull out the one. Like, it could have been done that way, but it was very simple to have something that it's just a background service that runs, start up the app, it writes out config for itself, and eventually it TTLs out of object storage, and it gets pulled out of the config when that service is gone.
Yeah, makes sense. All right, Ryan, so I don't want to keep you for much longer. Thank you for your time and sharing your knowledge and expertise and experiences here with all of us at .NET Conf. I am going to bring down your screen, and you mentioned you were headed to KubeCon. So
Yep. I think I can make one more session.
There you go. Have fun there. All right. Thank you so much, Ryan. We'll let you go from here. So bye for now. All right, folks. It is almost the top of the hour, and I think we're ready. Chat room is ready, has been asking for the next session. So I'm going to bring up our next speaker and my good friend, Jérôme. How are you?
Hey, Sam. How you doing?
I'm good. I am good. Full disclosure here, Jérôme and I actually work together. So chat room has noticed my Uno shirt. So it's been fun. A busy morning. Lots and lots of great .NET content. So Jérôme, where are you joining us from?
I'm joining from Montreal. I'm joining from Montreal. It's a snowy weather here in Montreal for the past few days. It's been interesting. 20 centimeters at once.
Oh wow. Okay. Well, you're here. You're going to bring some warmth here in terms of app development.
Yes.
Modern .NET deserves to be cross-platform, and over the years, you and the team have built up a lot of tooling to help developers be more productive. But I hear you got a few more tricks up your sleeve in this age of AI.
Indeed.
I am going to bring up your screen, and without further ado, give you the floor, and have fun.
Thank you very much. So welcome, everyone. Thanks for joining for the Uno platform with the AI session. This is going to be very interesting. So my name is Jérôme Laban. I'm the CTO of Uno platform. And, we've been amazed at what AI has been doing ourselves. It's been very interesting. And we've introduced Uno Platform Studio 2.0 a few days ago. And so we're going to talk about all of this and have some interesting demos about it. But before we start, let's talk about what Uno is. So Uno is giving you the ability to build native web, mobile, desktop applications using C# and XAML. It's a cross-platform. It runs everywhere .NET runs. It's free and open source. And this year, we're adding AI features on everything else that we've been adding for since 2018 for Uno platform. So let's talk about what we've been adding. So Uno Platform Studio is our set of tooling that sit on top of the core of Uno platform that bring productivity enhancements to users. And traditionally, there's been two ways to write code. There's the IDE where you write and type your code directly, and that goes directly into your files and then into your app. There's also Hot Design that we've introduced last year, which allows to visually design your app and get a WYSIWYG type of experience. This year, we're adding agent compatibility with three pieces. The first one is a documentation and scaffolding MCP that gets the latest and greatest information from Uno platform so that the agent doesn't go too far off. There's an app MCP that pretty much gives the ability for the agents to have eyes and hands, pretty much, giving it superpowers to be able to interact with the running app. And that's pretty important. And then there's the Hot Design agent, which is a new piece that's integrated to Hot Design that allows for designing screens and go back and forth and dialogue with an agent to design screens inside of the app. Running app, that's the important part, running app. So all of that is very interesting. And all of this is sitting on top of Hot Reload. And Hot Reload is a critical part of all of this. Hot Design and your app is able to use it, new ID is able to use it, but it's particularly important for MCPs and the flow of agents that are using the app MCP to give them the ability to modify the app while they're editing it. So we're going to talk about that. On the other things that the features that Uno provides for Hot Design, you can edit your app. This is the running app, so you can see here the ability to select elements in the tree, modify their content directly, adapt your UI, as it goes, and use your running app, particularly if you have APIs that are calling in. It's not like a standard designer. You can edit really your running application. We're introducing the Hot Design agent, which is an agent pretty much like the others, but the idea here is that it gives you the ability to preview the content without applying it. So I'm going to show you that a little bit later. The MCP servers we're introducing are compatible with a lot of IDEs and agents, of course, VS and VS Code, but also Cursor, Cloud Code, Open Codex CLI, and GitHub Copilot CLI. And that's all that kind of integration that makes it super cool to see in action. And we're going to see those a little bit later. And finally, so Hot Reload, I was just talking about it, but the things that we can do with it, like Xbind supported, you can Hot Reload in WebAssembly on mobile applications, and supporting. We have the best in class for the .NET experience, it allows for having the dev loop go a lot faster when you're developing without having to restart your app, particularly if you're in that 10th page of your workflow and you want to edit that page. It takes a while to get there. So that's why we insist a lot on Hot Reload. So without going too far into the details, I want to get to also design to code. So we have a tool that allows to take Figma designs that are in Figma, the website and design surface, and export those designs into XAML that's pixel perfect, that you can integrate directly into your app, and basically start off from what the Figma design is. But we have a demo that will enhance that experience just at the end of this session. So demo time. I mean, who doesn't want to see code running inside that kind of session? So the first one that I want to show you is basically create an application with Uno Platform, how to do that. If you haven't done that already, you can use Visual Studio, you can use .nu and others, but I'm going to be using Visual Studio. You can install our extension. I'm going to be creating a .NET Conf app. And this is going to start our wizard, which allows you to select your platforms, your frameworks, your presentation, your markup, and a host of other features that Uno is providing. And it's allowing you to view quickly what's available and what you can use in your apps. Optionally, you can choose with whichever target you want. So let's create that app. And first, what I'm going to do is let the app, I'm just going to let the app start up by itself. And we're just going to head directly into the app. And I'm going to come back to Visual Studio to explain a little bit more of what we're doing here with Uno. So the app has been created. You can see that it's a single project. I'm just going to be waiting a little bit for everything to settle. We're going to be testing specifically for desktop because it's easier right now, but you can do that with other targets. So the app is building. What we're going to do is head it directly into Hot Design. And to do this, once the app is started, you can expand. So you can take a look at our Hot Design status at the top, and you can click on the flame here, which is going to bring you into the Hot Design. And what you can see now with the newest version is that we have the agent mode here that allows you to basically type and interact with your page here. So what I'm going to do here is paste a prompt that will allow to make an inspiration login page. So we're going to click on generate, let it run for a few, then come back and take a look at the results. So in Visual Studio, the first thing to note is that the application is a single page application. You can configure features here. All of that has been set up automatically by the wizard, but you can add and remove as needed. No NuGet packages to add. That's something that was complex before. We removed that, and other people are happy with this. You have your platform-specific code here. So basically, anything that you want to customize can be put in there. It can be custom XAML, can be custom C#, or it can be inline in the rest of the project. We also have the presentation layers and services. So those are just placeholders for you to add your content in there, and that's what the rest of the tooling can use. So that's what you can see here. And let's go back to the running application to see if it's not finished. No, it's still not finished. So you can see that in here we've been selecting portions of the content. So in here I have a small design here that gives me what the application and the models has been trying to figure out about my application. So it knows about the context, it knows about the pages that I have in my app, it knows about the name, it sees that it figured out that it's a .NET Conf app, so it kind of figured out a tagline to put there. But I can see here that there's something interesting because my section on there here is at the top, so I don't want to do that. I'd like to move that a little bit down. So let's center vertically the right side of the page. So we're going to send that over, and we're going to say improve that particular design and make it better. So we're going to click that again, and we're going to go back to Visual Studio to discuss a few more things. So one of the important parts when you're getting to Uno is to use the Uno Studio app, which is for you giving you the ability to determine what features you have. Note that the MCP features that we're going to talk about a bit before are split in two. The interactivity parts are free to use. You just create an account and you can use them. Hot design, the agent, hot design, and some parts of the MCPs are part of the pro features, but you can get started very easily with the community features. On the other pieces that we've implemented Uno is the icon that's on the bottom right here, which is also included in Rider and VS Code, which is called the Uno platform status, and it's something that will give you hints about what the environment to develop Uno apps is. So if you're restoring your solution, Visual Studio restoring your solution, if you have installed everything, all those workloads that need to be installed, if they're installed the right way, Uno check will check for that, making sure that the dev server, which is our connection between the app and the running app and Visual Studio or the IDE, is running properly. So that's kind of changes that you can see here to make sure that the environment is running properly. Let's go back to the app again to see if we have something that's been updated. So let's see if it's done the right thing here. So we can see that the model has adjusted vertically. So our login page is actually going down a little bit, and we can go and apply that page once we're done, and we can iterate with the agent a few more times to get to a point where we can integrate that app, that design properly in the app, and that's pretty cool to see being able to interact with this. So we've been having a lot of fun with it, creating some very fancy designs, and we hope you're going to be able to experience that for yourself. So that's it. That's where we are for the agent. Let's go and head into some more features. So I have a few demos that I've been recording here for speed purposes, because it's sometimes it takes a bit of time to get all things together, and there's a lot to add for that session. So what you see here is Visual Studio Code, and we're going to be asking the agent to design a weather app using an open weather open API definition, and try to see where it goes. So what we need to set up first is the Uno MCP server, so that the documentation is readily available. We have a snippet, a prompt that can be used to create the app. In here, we have basically initialized an Uno platform creation expert, and we're going to paste it in a prompt that will provide some instruction on how to create the app, what visually it looks like, if it's a clean mobile UI, things like that. And we're also going to paste in an open weather API implementation. So we're going to be asking it to connect to the open weather API with Kyoto directly to in the live app. So what you can see here is that the model is, the agent is asking a few questions there about, how to create .NET apps, how to run Uno check, which is running right now. You can see that it's there, so I didn't run it because on this particular machine it was there. But if your setup is not there, it will run properly. You can see that it's asking about the options to create a new Uno app and figuring out what should be used to create the app. So you can see here that it's determining the options to do that. You can see it's using Toolkit, it's using desktop because I just wanted to see the desktop app at that point. It's using XAML and everything like that, so you can see Kyoto. Now it's creating the app, and you can see that it's filling up here. Now, I'm just going to be moving forward a little bit faster because there's a few things that are not particularly useful just as a detail. So you can see it's setting up Kyoto, asking questions about how to run Kyoto properly. Now it's analyzing the current structure of the app to determine what it should be adding. And after it's done, you can see that you will be able to see that it's so it's importing OpenAPI. It's generating the endpoints. So you can see here that it's generating all sorts of calls that are related to OpenWeather. This is not something that we had to do. Just the model figured it out by itself using the documentation at its own knowledge. That's pretty cool to see. It's all, so now it's going to be detailing a plan that's it's going to be implementing. It's going to ask us, is it the right thing to do? So you can say, just go ahead or just make adjustments. In our case, we're just going to say, go ahead. That's what we want. It's going to ask for us for an OpenWeather API key. So that's the API key. It's going to figure out where to put it. It's going to figure out that it needs to be probably in an app settings JSON file somewhere in there. So that's defined. See, so it modified and placed the API key directly in there. Now, it's going to be making all sorts of modifications, adding API service configuration classes. It's going to be adding all the surfaces that are needed. So we can see it's creating the models, the weather service, the models for the data access. You can see that some of the generations are incorrect. So for instance, that client data is not right. It's not using the right API. And we're going to see that the model is going to be able to determine that it's not correct, and it's going to be adjusting itself to generate the right API calls. As you can see here, the namespaces are not right yet. So it's modifying the models. It's creating custom styles also because our app needs to have a very distinctive UI design. So we're going to be modifying this. Now it's updating the make page. So creating all the sections that are needed to show our weather app. You can see that there's a progress ring that's integrated as well, making sure that you're showing a proper loading wheel. Now it's built the app the first time, and we can see that there's some namespaces issues in the main view model. So it's going to try to figure those out. It says, I need to fix this. Added the right namespaces in the right place. It's building again, and you can see that for the client data call that was there, that was incorrect. So it knows that it needs to change something based on what's inside the app, and it knows that it should be the 3.0 calls instead of having an indexer. But what's interesting is that there's an obsolete warning there because the call for get async is not the right one. So it knows about that, and then calls get as one call, get response async, which is the right call. So now it's updated. It's continuing to make additional modifications to the services, making sure that it's running appropriately, and that it's using the right binding. So it determines that some of the bindings that it wrote are not the right ones. It's trying to try to replace the bindings so that they behave the right way. So it's updating this. Now, again, in the bindings, and it's going to try to build the app again. So you can see that the app is now building properly. And now it's going to try to start the app. So before that, we need to restart Visual Studio. That's something when you create an app using the agent this way, Visual Studio needs to be restarted properly for the extensions to work properly. And you can see at the bottom now that there are the Uno icons showing up that were not there before. Now we can continue. And now it's going to start the app using hot reload. So it determined that the command was not the right one, modified it a bit, and now you can see that the app is starting. It's not showing the right content because probably the API key is not set up properly. So it's going to figure out by taking a screenshot. It said, it looks good, but it's not loaded. So it's trying to figure out the configuration. And it determined that the configuration was not loaded properly. So for that, we needed to restart the app. And there we go. We have an app that has all the information showing up. And there we can see that it took a few screenshots. And also there are calls that can be made to the MCP. So those are provided by the MCP. So run uno app get screenshot, and all of that is information that our MCPs, the app MCP, is able to provide for the running app, so that the models can react off of this. So you have the uptime, you have the process name and things like that. And the agents are able to figure out a lot based off of that. And now that the screenshot has been taken, it's also taking a snapshot of the content. So you can see that it's figuring out the details of the running app, being able to see all the items and their reference, so they can be interacted on directly. And it's finalized the screenshot, and you see that it's taking a screenshot and determined that the temperature is the right one. At the time I made the video yesterday, it was 2 degrees Celsius, and it's interpreted the right things. So it's read and interpreted the image that was returned by the app screenshot. So now we're done with the app. Let's make it cool. A lot cooler, actually. Or actually, cooler and retro, to say it like this. So now I have my app again, and I'm going to ask the model to do something super nice. What about if we made the app look like Windows 3.11 styling? So this is, we're changing the app so that you're asking the model to change the app so that it reuses the iconic classic gray interface that was there before. So this is the palette, and it's so we're going to be let it run a little bit, and the app is making modifications to the color palette. You're going to be able to see that it's modifying a lot of things here, and then it's going to be restarting the app once just to apply the content properly, and changing the inner borders and the visual aspects of the app. And then it's going to restart the app very quickly. And then that's it. It looks like a weather app that's coming from 1990. So that's super cool. Also, one of the things that we could do is that in Uno 6.4, we added the ability to extend in the title bar. This is a feature that Martin Zickman has been working on really hard for the past few weeks, and it's working super nicely. We can see that the agent is asking questions about how to integrate that, and you can see that it's set up drag rectangles and able to determine that. The application is just going to be restarting very quickly to set that up. And you're going to see that the application is going to look exactly like it should, which is a weather app with the extension into the title bar and with the style that's coming from the Windows 3.11. So that's the demo and the retro thing. It's super cool to see that. And the models are pretty nice on that kind of things. Now, the next demo is all about running Claude on the command line. We're going to take the same thing, but this time it's designed to code. And we're going to take a Figma design that's coming from the actual Figma. We're going to take a link that's coming from it, and then we're going to paste that into Claude Code CLI. And this is running on Linux, by the way, so that you can run on macOS and Linux, which is always interesting. And we're going to see here that the model is going to figure out that it needs to take the design that's coming from the weather app on Figma, take screenshots from that app in Figma, and then those designs in Figma, and then download some assets, figure out what to do with the content, and design some mock data just from the design. So it's figuring out classes and implementation details and everything else just by looking at the design from Figma. The original app didn't have anything. So it's creating converters, it's building the app in the background, starting the app, and there you go. This is the app started from Claude Code that built this. And you can see on the side that the two lists are not exactly right. There are a few things that are not right for the icon. So we're going to ask the AI to adjust the icon. So we're going to give it, it's asking a few questions about which icons should be modified. So we're saying to it that the agent that it should be changing a few things. So it's modifying in the background using hot reload. You can see that the icons from the top list has changed, and same thing just for the down list, for the bottom list, made some updates, and now it's updated properly. So it's super cool to see on Linux, just no UI. I've just put the UI for VS Code just for you to see the files being modified. And another part that's interesting is that you can get into hot design from there. The app on Linux is just another app. It has our dev server and tooling that's running properly, and you can view the app, modify the app, change some content in there, edit templates, modify the visibility, change zoom in, zoom out, and things like that. So all the features that are provided by hot design to edit your app from Linux, all from a design to code using Cloud Code CLI. That's Cloud Code CLI. That's super nice to see. And finally, the last demo, it's something pretty interesting. So a very long time ago, 5 years ago, Paul Thurrott created a demo of a WPF app. He wanted to see what could be done with this, and created that simple .NET pad. What we decided to do is give that source, that repository that's on GitHub, and ask the AI, can you translate or really migrate this application that's in WPF and make it an Uno app? And it actually did. So let's go take a look at what it did. So in here, what we do is we have a migrate prompt. It will analyze the content. We have the legacy application that's in that folder, and the new application that's basically just an empty app from Uno. And we can see that the agent is going to be analyzing the app that's the WPF app that's in the legacy WPF folder. It's going to be analyzing a lot of things like the about box, the font dialog, the input box, and it's going to create a migration plan. And you can see here, now it's at the bottom using the latest Visual Studio Code update. And it's going to create settings infrastructure, modify the input box, creating font dialog, analyzing all the settings that were there in the original application, determining what should be updated, and fixing and translating updates as it goes. The interesting thing is that it translates by finding the right APIs to call based off of the interaction with the environment, but also will be able to interact with the app while it is running afterwards. So let's move forward a little bit. So it's modifying the font dialog, creating some interesting content there. So let's skip some portions there. So it's creating all the font dialogues. It's a big one. We got the I'm just going to drop a little bit more. There we go. So it's searching about refining some operation with content related to menu bars and accelerators and things like that. And let's move forward a little bit more. So this is about creating the app itself, and now it's building the app, finding that there are a few things that don't work. For instance, that listbox cannot be used, but it should be using listview, which Uno does. And then the app successfully built in the end. And now it's starting the app. And it's interesting to see because it's pretty much looking like the original one, except for the fact that there are a few things like the underscores and the menus. So that's the kind of things that we are able to ask the agent to figure out. You can see that it's able to type inside the app. It's able to click on menus, open them, take screenshots, determine that it's actually doing what it should be doing. You can see that the About menu is actually a changed version of it, where you can see that there's Uno platform version instead of WPF version inside. So it's making all those modifications. And in the end, you're going to notice that we're going to be asking it to make some changes because the underscore should not be there. So what we're going to be doing is asking it to remove them so that they're properly supported. And you can see the hot reload kicked in and modified all the menus at once so that they can react properly for the application and look better. But the rest is looking properly. Oh, and you may not have seen, but the agent actually took a screenshot of this and reacted to the fact that the content was the right one. For instance, here, it started the app. Let me see here. In here, you had said it reads the content of the app and it's able to make all sorts of modification in there. So it's pretty interesting to see. It's mind-blowing in many cases where the agent is able to understand what the app is doing by interacting with it. So it's pretty cool to see. So that's it for the demos. It's those sessions are going so fast and we have so much to show every year. But just to give you a very small recap on this, we're introducing those MCPs for documentation and being able to give you access to give the agent access to your running app, and also the hot design agent that's giving you access to creating designs directly in hot design. And all of that is using hot reload to make it super fast for you to develop your apps and make sure that the agents are behaving properly. So I hope you enjoyed that session. Give it a try. Let us know what you can do with it. It's amazing to see what the AI agents have been able to do lately, and have some fun and let us know. Happy end of .NET Conf.
Well, for you, Jérôme, but this is mind-blowing stuff. Like, thanks for making me obsolete. But this is super fun, and we are back to our deja vu again, like me and Jérôme together. But it's not our team's call. This is .NET Conf. This is really amazing stuff, because you are essentially giving AI and agents like eyes and hands to look at our stuff as it's building.
Exactly. That's super fun.
Yeah, so it's iterative. So while the agent is doing stuff, like I could pause and I could look at things in hot design, like you said, and it's running app live data, so I can edit things as I go along.
That's correct. You can edit the apps while it's going, and that's where it's super cool. It's just not the same design surface that was there before, the WPF designers and things like that, where you had to do mock data or design time things and everything like that. That's not needed in that context. This is just the running app, and you can interact with the generating UI directly, whether it's using the agent or the design mode. It's working the same way.
Yeah, wonderful. And how do people get these tools? Like run UnoCheck to get all of them set up?
Yeah, exactly. So you go to platform.uno, get started, set yourself up with the extensions or agents that you want to have, create an account to get the community license, and then off you go. You should be able to have a trial for those pieces for the agent, but also have free access to the MCP tools for your agents.
All right, wonderful. All right, well, my mind's just spinning, but thank you so much, Jérôme, for all the goodness here. You somehow managed to make Montreal cooler with the retro weather app design. So,
yes.
Thank you for that.
So cool to see. Thank you, Sam.
All right. Hold on one second. My AirPods are running out of battery because I've been doing this for a while. So I'm going to do a switch up here. All right. And thank you so much, Jérôme.
Thank you, Sam.
We are, for the sake of time, bring down your screen here. And thanks for joining us and showing us amazing things about modern .NET cross-platform, where things can be.
Have a great day.
All right. Thanks, Jérôme. We'll let you go for now. And and bring on my next speaker, who is a dear, dear friend of mine, Sarah.
Hi, Sam.
Hello. How are you?
It's
going great. It's going great. So, Sarah, where are you joining us from?
I am joining from near Akron, Ohio, here in the U.S.
All right, wonderful. We are not that far apart. I'm in Northwest Pennsylvania. I've known Sarah for years. So welcome to .NET Conf, and let's get you rolling. I'm coming into a new company, new code base, and often we are like, where do I even start? What are these decisions? How do I know what happened before me? So you have some ways to help us out. So I'm going to bring up your screen here.
Sweet.
And often, running you go. I'm going to step out and let you have the stage.
Awesome. Thanks. As Sam said, I am Sarah Dukevich. I also am known as Saduki, and I'm here today to talk about decision records. With Sam just joining Uno, I'm sure he's getting into code bases that he's like, what in the world is going on here? Why did they make these decisions? If there's a collection of decision records, that can answer those whys. But not many of us are lucky enough to be dropped into a system that has records or documentation of any sort. So today I'm going to show you how you can document these decisions to be better for people onboarding into your app and even to future you. So what are we waiting for? Let's go. So we just got assigned a project, but it's legacy code and it needs some updates. This is the story of my career. I do a lot of legacy code work. So let's go. Why did they choose a front-end technology? Did they do a distributed monolith? Why does this code look so complex? And what were they thinking about when they built this? This could have been better if they had decision records. So let's talk about what are decision records. So decision records, they capture why a decision was made. The template I'm going to show you right now is called NIGARD's template. So NIGARD is somebody who has gone through talking about decisions and understanding what needs to be captured for somebody to understand what's going on. So the first thing you want is a title. Typically, the title is going to have something like an identifier and maybe a short description, very short, because it's the title. And we'll have the status, and the status indicates what this decision's current state is. So is it a draft? Is this something that we have to go through a formal process, and now this is a proposed decision, and accepted and superseded and obsoleted? The things I'm going to show today may have some formalities to it, but the formality doesn't have to be there. This is going to be a your mileage may vary situation, because some orgs are small enough that the developers and the architects and their stakeholders are all like, these are the decisions we make. Some have a more formal process with a committee that has to review all the decisions. The context, why do we need to make this decision? What prompted us to have to do this decision? The decision is, what did we decide on? And what's the justification for it? The consequences, there are always trade-offs. For every decision we make, there are trade-offs. And so we want to capture those, at least the trade-offs that we can acknowledge. And then the additional notes. So it could be things from compliance guidance. So how do we make this decision and ensure it gets carried out appropriately, to additional supporting information. Now, I want to stress that these are general recommendations. You're going to want to evolve your template for organization's needs. A decision record will look something like this. So we'll see the ADR format from the fundamentals of software architecture, where there's a title, there's your status. So this is a written document. We'll talk about where and how here in a little bit. There's the decision, the consequences. Compliance is another one that they call out separately. But again, the template's going to depend on what you prefer for your company, what makes sense. So what is a decision record? It's going to capture the decision that was made, plus as much information to understand the why behind it and what triggered it as well. So who are decision records for? Well, they're anyone who's onboarding into a code base, like Sam and Uno platform, for example. We have some new folks joining our project, so they would want to look at our ADRs as well. I call them ADRs. ADR is architectural decision record, but in reality, you're going to hear me call them just decision records. I dropped the architectural for a reason, and that's because we get too wrapped up in the architectural decisions. I'll explain it here in a little bit. But anyone who's onboarding, that they need decision records. Stakeholders need to understand what's going on. Decision makers, well, we're decision makers today, but we might not be in all of the decisions. And so we kind of need to know what happened, why, what was considered. And for those of you who are like, but I am a solo dev. There's nobody else here in my room. There's nobody else on my project. Maybe you're even a solopreneur, so you're a consultant. Document this stuff for future you, because the context you have today, you will not have as strong at the end of the day, and it will continue to fade over time. So then in a few months, when you have to go back and look at your code, like, why did I even make this decision? You'll have it caught in the decision record. As someone who's done solo consulting a lot in my past, I've learned to document for future me because that context is easily lost. Now, this is where it gets tricky. So which decisions should be captured? Well, some people are going to be like, why not capture all of them? Well, to what degree? It does feel like it's going to be a bit too much. So when we talk about capturing our decisions and which decisions, the thing I want to think about is a term called architectural significance. And so the architectural significance will help you to figure out what you need to include in your decision record. So you might have decisions that are about structure. We're going to go look at some details about that here shortly. Your architectural characteristics, that is your abilities, that is your things like performance and security, maintainability, reliability, availability, scalability, things like that. Dependencies. So if you have explicit dependencies you need to know about, capture that. Interfaces and construction. I'm going to stress construction when we get to the examples because and this is why I dropped the architectural part and just call them decision records, is because the architectural significance, people will argue that the construction gets into implementation details, which isn't architectural, to which I said enough of the nuances and the semantics. You're documenting decisions that are important to understand, and the construction does count. Okay, so first let's talk about structure. So when you're looking at a decision and the architectural significance of that decision, when it comes to structure, these are the decisions that impact the patterns or styles of architecture. For example, are you looking at modular monoliths or clean architecture, vertical slices? Maybe you're looking at a modular monolith and at the modules. Maybe you're looking at bounded contexts and microservices. These kind of decisions are considered structural architectural significance decisions. Later on today, you're going to see a demo from Ardalis as he talks about clean architecture in ASP.NET Core 10. So you'll have some more insight on that clean architecture part. But again, this is all structure. Now with architectural characteristics, so this is where we call them architectural characteristics or abilities. Some people call them non-functional. I don't agree with the non-functional part, and that's just because sometimes it's actually the functional matters as well. The architectural significance includes things like security, performance, maintainability, scalability, auditability, usability. They're not all abilities, so that's why I call them architectural characteristics. And I do have an example of one for security here in a little bit. The next point for architectural significance, if you're not sure if a decision should be documented, it could be a dependency. So they're coupling between components that you need to worry about. Are you dealing with database access versus accessing the database directly versus an ORM? Shared libraries, down the API design and sync versus async. So these are some of the things you need to think about. If you have decisions around these, document them. Interfaces. So interfaces are another part of architectural significance. And this is going to impact how the services and components are accessed. And so now we're looking at like protocol level. gRPC versus HTTP, for example. Bench streaming, REST versus GraphQL. Maybe you're dealing with sensors, and so MQTT. These things need to be documented so you understand why you made the choice of using a particular protocol. And construction. This one I need to stress, people get cranky with construction because they're like, this gets into implementation and not just architectural. And I'm like, hold up, but they're still decisions. Examples are platforms, frameworks, tools, and processes. You're going to see a demo that I have of a decision record from a project that I've been on for a while, debating the .NET framework that we use. .NET Framework 8 was the thing at the time because it wasn't .NET Conf time yet. But .NET 9 was also a thing, and then .NET 10 was not off our radar. It was something that we were like, well, how do we consider it? With it in preview bits and this being in a production environment, eventually, we want to make sure timing is right. We documented that. So if you're working on particular platforms, if you're working on different frameworks, maybe you're dealing with a migration from, oh man, if you have to deal with a .NET Framework 4.8 to .NET 10, document it all as to why you're going like that, and so on. So that's the which decision is if it meets any of those architectural significance. The other one that I don't mention is business strategy decisions. If there's a business strategy decision that impacts your architectural decisions or impacts your technical decisions, capture those as well. All right, so when should these decisions be captured? Well, first and foremost is when you have the context. Because when you have that context present, you're not going to be missing the details as much. You can capture this in a decision record before the decision is made. That's what that status of draft is for. That's what the status of proposed will eventually be for. Do this while the decision is being discussed. This is something that I stress whether I'm doing decision records or any other kind of documentation is document as you go while you have that fresh context, while you have the fresh screenshots. Everything, it just goes a lot easier. Or you could do decision records after the decision is made. Should have asterisked this one because after the decision is made, if you're doing it immediately after, you still have that context. But what if you've inherited a code base and nobody else is there? Except maybe that one person who's been on this project for 10 years and they understand it all and they have all that knowledge. Then you have that conversation with them. And you capture the decision with as much context as you can, but also make note that this documented decision was documented after the fact. So it was documented with somebody who was working on this 10 years ago. And so we might be missing some of the context. Is it beneficial to capture it that late in the game? Yes, because if somebody is still there with that knowledge, you want to get it while you have them there. Having been that person on a project who's been on a project for a long time, and I'm getting ready to change onto another project, I love being that person who's like, okay, ask me the questions and let's document them. If I haven't already documented them. Usually I document them as I go. Now, who should be the one writing these decision records? Well, software architects can, software developers can, project managers can. Ideally, you want someone who is good at documentation to be able to take that decision, analyze it, fit it to your template, and then publish it wherever it needs to be. Now, that said, I have worked on teams where I've been that one person who does the documentation. And it gets boring and tiring after a while. So I'm going to let you in on a little secret. Sometimes you just want to find someone who's good with AI. And I've got a demo that'll show you why AI should be considered as well. Where should the decisions be stored? So you can store them in a document store. You can store them in a formal document control system. So I used to work in a manufacturing facility, and they had a formal document control system. And so any of the decisions that we made based off of the software that we were supporting there, if it was something that internally we made a decision for, we would make sure to talk with our document control manager to get it all documented and captured in a format that they need. Your decision records can be in a folder on an intranet, especially if it's an internal-only project. It could be in a wiki. It could be in SharePoint. Honestly, you want them in a place where all who are impacted can review the decision records. So let me be explicit on that. I'm on a project where we keep our decision records with our code. But those of us who are impacted by the decision records also are the ones who are in the code. Now, the minute we have non-technical stakeholders, we will want to move those documents into a spot where everybody can access them. And I don't want to scare away our business stakeholders by putting them in a Git interface. So now we have to then think of, okay, the document stores or folders or wikis, things like that. All right, how should these be captured? And when I say how, I gave you an idea of some of the templates that are out there, but how should they be captured? Well, first, identify that decision that needs to be made. Then you want to gather the relevant info with a stress on relevant, because I know many of us will see all of the info and might end up down rabbit holes chasing some of the info. We have to remember, avoid scope creep. Stay focused at the data at hand. We only want the stuff that's relevant for our decision. Justify the decision. Why did you make that decision? document the decision, communicate the decision, which is key because you want to make sure that everybody who's impacted understands that this decision was made. But then most of all, execute on the decision. We can make decisions and say, okay, you know what? I think about regular decisions in life in general. Where do you want to go out to eat? Well, I want to go to restaurant A. Okay, we've communicated a decision, and let's actually go there. Execution is key. All right, so let's look at examples of decision records. The first one I want to show is security with multi-factor authentication options. And the reason why I want to show this is because this is one of the many formats that I use. And I'm going to use the Zoom, so don't panic if you're like, oh, little text. So this is an example of an architectural characteristic. This is security. So we have our title. We have I usually include a date because it makes sense. The status is active. We're working on an application that has some sensitive data, so we really want multi-factor authentication available. And I'm going to say we want at least 2 factors for all accounts. Now, if there's anything you know about me with multi-factor authentication, I get really ranty when email and SMS are used because those are easier to compromise, as you can see in the rationale here with the security risks of email and SMS. I want stronger authentication, so I'm going to usually push for something like option 3 with the MFA with biometrics, authenticator apps, or time-based one-time use passwords, and passkeys. So we talk about the options considered. This is important to capture because then people understand, okay, did they look at this option? Did they have this option? Because the thing is, if we're looking at the options today, maybe in the future we get better security options. And so then we can revisit this. Note that we're capturing the document, the decision for today, but it can always be superseded. It can always be obsoleted. The rationale, so this is allowing whoever looks at my documents to understand this is where my train of thought was. The consequences, this is trade-offs. There's positive ones and negative ones. So understanding your trade-offs. I usually call it trade-offs rather than consequences just to be a little more clear. And then we talk about any open issues. So how do we help our users to come on board with MFA, for example? Or how do we teach them to use passkeys? So this particular decision record, the main things to note is that we're capturing the context. We're capturing the decision. We're capturing the rationale and the options that were considered. These are all important so that future me knows what did we look at when we considered this decision. Another one's modular monolith versus clean architecture. In this particular application, we had no idea the context that we were getting into domain-wise. And so we chose to implement clean architecture. And again, that's just because we understood that we wanted to have our code maintainable and easy to work with. However, we didn't feel comfortable enough to go the modular route because we didn't understand the domain we were getting into. None of us had worked in that domain prior to this project. So again, this is using the simple format of here's your title. This numbering is going to be up to you and your system. And then again, there's always a status, a context, a decision, consequences, and additional notes. And of course, you'll learn about clean architecture because Ardalis is doing a presentation here later today about that. All right, let's talk about an example of containerization strategies. So this was another one. Again, this is going toward the architectural significance of structure and talking about containerizing our app. And especially since we already knew we had C# and Blazor as part of our project. And this was prior to .NET Conf with the documentation, so it does say .NET Aspire, but we do know now that they are just Aspire. They dropped the .NET part. But we did start with Aspire so that we could distribute or work with distributed applications locally in our development environment. We continue to use it. It's awesome. But again, there's our status, the context. What did we think about and how did we get there? This is the one I mentioned earlier about the .NET version. This one is following the same pattern 2 ago, where again, we're getting into the context. Some places go with the problem statement to kind of capture their issue in one line. And you can see here our decision. So we started at .NET 9. Now that .NET 10 is available, we can start to consider that. And if we consider that and start to update, guess what we need to do? We need to update this decision record. So what's going to happen is this decision we made back in July, we're going to have to come back here and say that it is obsoleted. And then, or we could say superseded and point it at the new one where we say, okay, .NET 10 is out and we're ready to go. And you can see, how did we consider it? With this particular one, this is my documentation, so you can see that I was looking at dates and making sure it was clear so that we knew this is the timeline we were working with. We knew that we had to go live of a certain date, and we weren't sure where that was going to be with the .NET 10 release. So we captured as many details as we could. This particular thing is done in Markdown, and so you're seeing my Visual Studio Code. I don't do dark mode because it's hard on my eyes, but I also don't do light mode because it's hard on my eyes. So this is solarized. All right, one last one to show, and that is handling domain events in C#. And the reason why I'm doing this one is I want to show you how I use AI. So you can use AI to generate your decision records, but there's two things that I want to stress about when I deal with this. One is smart quotes and two is M dashes. No, just kidding. When you're using AI to generate your decision records, you need to be explicit with your prompts. The more clear you are with your prompts, the better the output's going to be. So when you're using AI to generate decision records, you need to tell it the headings in a particular order so that it knows to generate it in that order, and specify the format that you need. This one is a little bit of a battle because it doesn't matter which model I use. It doesn't matter if I'm using ChatGPT or if I'm using one of the Copilots or in Web UI, Open Web UI. Doesn't matter. You have to be clear on, I want this, in like a Markdown code fence or a rich text format. Once you have the format of the ADR, then you can walk it through your decision. Find a model that has the ability to summarize and that also has the ability to categorize or classify. Because if you have those, they do a better job. But talk through your decision and let it organize into the desired format. Now, this quick demo that I show, so this is using Open Web UI with Ollama, running it locally. I wanted to show you this part here first, which is being very explicit in what kind of format I need. If I am telling H1 and H2, no, at that point, I'm done with fighting with the AI and trying to be very explicit. And then here's the case of all the things we were considering for our domain events. Now in this demo, you see me copy and paste. Honestly, this option here with the microphone and talking to AI and then letting AI hear what you have to say has worked really well for me as well. Because there are days where my hands are giving me a hard time. And so I'm just like, all right, voice prompts it is. All right. So you can use AI. Now that said, don't blindly trust what it writes. Review that, because there are going to be times where it's going to make its own assumptions and you don't want those to go into your docs. You want to make sure your docs are clear. So then what that generates is something like this. Now I clean my format a little bit more, putting the draft status underneath, but this is close enough and I didn't have to write it. I just had to tell AI what I needed. All right, if you want to get started with decision records today, this QR code will go to a gist with the resource links. The gist is Markdown, so it's got the links for you. You can just click on them and go straight to the site. And then make sure you document your decisions today. Thanks for tuning in. Again, my name is Sarah Dukevich, and I'm a senior trainer at NimblePros. You can reach me at sarah.dukevich@nimblepros.com, or you can ping me on LinkedIn at /in/Saduki.
All right, and I am back. Well done, Saduki. This was awesome. Yeah, thank you for reminding us for the need to document these things, because otherwise you're going to be very lost. And I love the part where you said you're doing it for yourself, because you won't remember. Okay, so this has been, .NET Conf Day 3 has been, so amazing to see all these ideas and all the amazing content from passionate .NET, developers all around the world. And I just had an idea, just thinking through what you were saying. How about a decision records MCP, where it just sits there and we just tell our AI agent to say, document this, and here's a markdown file. This is the format I want. Just go put it wherever you want.
Yeah, I mean, if that MCP's got access to put it where it needs to be, then that makes life even easier.
Yeah. There's always things we can improve, right? And people love you. Reading things from the chat room. There's been some good banter as well. All right. So this is all great. So thank you, Sarah, for all that you do, and for bringing content like this to .NET Conf. We love you.
Thank you for having me. This has been great.
Yeah. All right. So any parting thoughts, Sarah? We got, I think, 1 more minute before we have to let you go.
I mean, whether you're doing AI-related projects or non-AI-related projects, they all should be documented. So as you're making decisions, capture those, make the docs so that future you goes, oh, that's why I decided on it.
Yeah, and then there's also the readability part. So, our friends in the chat room are weighing in. So as long as you make it friendly and you make everyone know in the organization that we are documenting things and make that a part of your process and your workflow, then it becomes more natural and people know where to go look.
Yeah, that goes back to the slide where we talk about the different steps and making sure that you communicate that those decisions are there. Sometimes, like I see the Fuel Snapple's comment there about fearing no one will read nor follow them. Reading them means that we have to communicate that those things even exist, because if they don't even know they exist, that's a part of the problem. And then following them, it depends on who's in charge of enforcing those decisions. I mean, you could do architectural tests if it's something that can be covered by those. You can have those kind of things there. But making sure that people know of those locations, that's key to make sure that your documents get read.
Yeah. Well said. All right. So for the sake of time, I know you can keep talking forever. You're passionate about this, but again, thank you for taking a little bit of time out of your busy day to come and do this. And keep doing what you're doing, Sarah. We love you, and I know our Dallas is coming on later on today, so tune in. Stay tuned for that. Yeah,
that's gonna be an awesome presentation.
Yeah. All right. Thank you, Saduki. Yeah. Bye for now. All right. How are we doing, chat room? We are live and rolling for about 6 hours now that we had started day 3 of .NET Conf. This is the community day where we get to hear from all of you all around the world about things you're doing with .NET. So we're going to keep going, and I'm going to bring up our next speaker, who I see in the green room, if you're ready. And another deja vu. Andres, how are you?
I'm doing pretty good. How are you, Sam?
I am good. So people in the chat room have noticed, like, I have the Uno shirt, and we had Jérôme a while back, like, we're just not on a Teams call. We just happen to be on .NET Conf. Yeah. All right. So you were talking about bringing the cool back in command line, which never left. It has always been cool. So if you're ready.
Exactly. Yeah, I'm ready. You can share the screen, and we can start. I don't have a separate screen, so if there's anything that you want to let me know. Yeah.
All right. So we see your screen. Everything is all set. I'll give you the stage, and have fun.
Thank you, Sam. Thank you, team. Thank you, everyone. I was taking notes, as Sarah mentioned. Document your decisions, and there was one decision that I just took right when I was making that, at least in Sarah's presentation. Say, okay, I'm gonna start, and here I was taking notes of everything. Yeah, so follow what Sarah just mentioned, and we should all be right. So thank you .NET, thank you Microsoft, thank you Sam for the opportunity to bring this topic. This topic is very inspired on things that I've been seeing around, because we all developers, we know command line or text-based applications are a thing, but most of the time we just see those applications as a way for us to try new things. Whenever you're testing, you .NET, you create the console application and then you test it and you never use it again. But we all got to admit that every time you go to Costco or you go to a supermarket or you go into a bank, we see applications like this. You see people that are attending you or doing something for you, they have these type of applications. And these applications have been around for many years now, and they're still used, and that might be a good reason. We will be discussing what are the best reasons, but the thing is that terminal-based applications can be CLIs, command line interfaces, or TUIs, which is the topic that we're going to be discussing, which is terminal user interface, are still very relevant in our day-to-day. And the reason why they're relevant is because they provide performance, they provide reliability. So as a .NET developer that we might be using only those terminal applications only for testing, I want to show you some cool tools and tips how we can get the best out our console application, and we can create beautiful applications, with good architecture. You know, we .NET developers, we love architectures. So all the .NET console application doesn't need to be a script. And so that's what I'm going to be discussing, creating modern CLIs and terminal user interfaces with applications with .NET, and you see everything .NET. My name is Andres Pineda. I'm a senior developer, and I'm also part of the Uno Platform core developer team. So as I mentioned, we have been working together. The same, if you saw the presentation from Jérôme, if you just joining now, if you didn't see it, just roll back after this, or you can watch it later. With presentation from Jérôme, co-host of the .NET Dominican meetup. This is a user group where we just bring the beautiful of .NET into the Dominican Republic, and this is my socials. The agenda is just pretty much the evolution of the user interface, CLIs versus TUIs, getting started with the TUIs on .NET, tools that are available for us to use beyond UI, like what are the architectural decisions that we can take for TUIs, and just a final conclusion. So evolution of the interfaces, we back in the days, probably most of the people that are in this call never have to deal with the punch card, but the first output application had computers were in punch card or paper trails, either or. That was back at the beginning. Then we started seeing text-based interfaces. So the same thing that we started talking about, things that are still relevant in our day-to-day were things that were invented in the 60s. So they're not new. This is not a new trend. It's just things that exist and will continue existing. Then we move from the test base that was mainly commands, and you remember all the things that you wanted to do, F2, F5, combination with controls, and then we move to graphical interfaces. Graphical interfaces, mainly this case desktop. So in this case, we started using more the pointers, the mouse, and the trackpads and all that kind of stuff. And it's nice, but we went really far. And I say far because if you take the example as an example, there are so many options. There are so many things to the point that you get into one application like this, and I know this is not a problem of the desktop. This is a problem of the type of applications, the type of problem that this desktop application is trying to solve. But still, I mean, whenever it has to use any kind of this software that has so many buttons, you get lost. But that's what it is. Graphical interfaces, you use the mouse, but by using the mouse, you keep changing context because the mouse make you a little bit slower. Then we move from the desktop into the web so that we can use that interface that allows for us to connect to different server, different applications, regardless where they are. So we didn't have any more the restriction that the desktop application has, that you needed to be in front of that computer that has that desktop application installed, that now you can launch applications like Figma in this case, and any browser will be able to handle it. And then the evolution continue from the web, then came the mobile, and from the mobile, there's even interfaces when there's not even script. So now with this Alexa style, Siri styles, where you can just send a voice command and the application will do something for you. So usually, buy this, what the weather, do calculations. So in these situations, we see more of this happening in our day life. But still, regardless of the evolution that we just saw, there's still these type of applications that are relevant. And as I mentioned, the reason why they are relevant is because they are reliable and they are fast. They are really, really fast. Things that applications on the web, you can see that we go very far in terms of performance, but still there are situations when you need more, or you will require a higher computers with higher processors and resources, when an application like this one would not require a lot. And before getting started into the main topic, I want to make the distinction between what is one thing, which is CLIs, or command line interfaces, versus the TUIs, the terminal user interfaces. So CLI, both of them are test-based, both of them run on the console, but the CLI is most seen like a command base. So basically you have an application like, for example, the GitHub client or the Git client, that you call a command, you call the utility, you pass a command, you pass on flags, and you will do something for you. So yeah, the GitHub CLI is a very good sample for this. Also, the Git CLI is another good sample for that. There are many. Developers, we use many tools that are still based on the CLI. And a cool one that we can take an example is the UnoCheck. If you saw your own presentation, the UnoCheck CLI is this nice tool that we made available for everyone, so that you can install it and then you can configure your environment with all the tools that you need in order to create cross-platform applications. Because cross-platform developing is nice until you have to configure your computer to be able to develop for all those different platforms that cross-platform technology has set. So the UnoCheck, you install it, you run, and you can pass some flags, and it will make sure that you have your Android dependencies, your iOS dependencies, your Windows dependencies, your Linux dependencies, and everything runs. So this is a nice tool that if you haven't used it, or you're using Uno platform, I would invite you to go ahead and use it. But on the other side, when we're talking about terminal UIs, this is mostly referring to applications that also use a test-based environment, but instead of being a command-based, they have a more structured layout. So they look more like a desktop application, but it's all from the terminal. So taking back the UnoCheck application, imagine that instead of you running UnoCheck and passing parameters and you run everything, is you just launch an app and you can click and select things that you want to configure, and then you click on run, and you will have this little console application that will give you the output of that utility. That'd be really nice, right? So that's the difference. One is more based on commands. The other one is more based on the layout looks more polished, so we want to say in a way. It's more organized. So NeoVim, for example, is one of those applications. NeoVim is this editor that you can basically, it's a co-editor or text editor that you can run from the terminal. It's a good sample for this. So now that we know the difference between one and the other, it's time for us to get into how we can get started building CLIs and TUIs from .NET. Probably we all know that because creating a console application is probably the first things that you did when you were learning .NET. Console applications is the main starting point because they will run on the console. But besides from the tools that we get directly from Microsoft, that they are good and they keep improving. For example, .NET 10, I know that they included the single file project that you can just create a hello world.cs and you just .NET run hello world.cs and you don't need a project anymore. That is what .NET and Microsoft keep doing to make this whole developer environment more rounded, better, I would say. And I know as well that the system command line, there's a new package or new namespace in the console that system command line would allow you to do more with the parsing of the parameters. We know that every time we're talking about command lines, at some point you will need to parse parameters, and with the tools that we had before .NET 10, it was not as good. I mean, part of the .NET, because we know that we have libraries, external libraries, and one of those libraries is Spectre Console. So from now on, we're going to be talking about the different libraries that we have available in order to build terminal and command line applications. So Spectre Console might be, if you have ever needed to do something more than just it's very simple script, you might be using already Spectre Console. This is a .NET library that makes life easier for all .NET developers to create beautiful console applications. Basically, with this library, has different parts because it has the beautiful that you can put colors like errors, warning, you can use icons and symbols and stuff, but also they have some sort of for prompting, for capturing, there are some widgets that you can include as part of your applications. Getting started with this is just a package. So once you install, once you create your .NET console application, you just need to .NET add package, and you just install the package, and from there you can start doing things. I want to jump really quick on the source code. Let me see, where's my console, my terminal. So as I say, it's just a console. I'm not even going to create a console application because I think most of you already know. So I'm going to start from an application that I already created. This is a to-do application that it's part that is basically just a console application, and I made sure to include the Spectre console. Let me click this out. There's a lot of things happening here, and I'm just gonna guide you through really quick because it's not the how we do it, but what we are getting. The most important part. This is very basic. We have a record that is gonna represent our task, and we have the actual application. That is the one that is going to be handling the capturing, the printing, and the handling the errors. So we have the async console, the prompt. We have methods from Spectre to clear our UI and to write tests to the console. Here we can make any choice. We can add choices that are going to be available through the keyboard. And then these are the CRUD operations to deal with tasks. All this is happening in memory, but through the presentations later, when in another topic, I'm going to be showing how we can enhance this application to make it like a real application. So we're going to be going from using memory to using local-based SQLite database, and then we're gonna replace that SQLite database by using a MongoDB database that is connected somewhere in the outside, and it's an atlas, right? And also the final version is how we modify to use, dependency injection and inversion of control, so that we can change our implementation whenever we want a SQLite or we want the Mongo. But for now, let's continue seeing the CRUD. This is toggle. It's not that important. So now the program, the actual program that we run, if you see, everything is in a single file. Later, also, we're going to be changing this and making it more robust. So we run the application, we just create an instance, and we click on run. So if we run this application from the console, I got it here, and let me make sure that I'm in the right place. Okay, .NET run. And this is going to launch to do application that I can run from the console. Basically, you see, it's very basic. I can view my task. I don't have any task. I can add a new task. Listen to .NET Conf talks, and then I can toggle the task. Right now, it is in a state, so it now is completed, and they have a table. It have a state. It have a beautiful colors. All this comes from Spectre console. So all these capabilities that Spectre provides are amazing, and I understand why Spectre console is the go-to library whenever we want to create CLIs and TUIs applications. So this is nice, and but I want to continue talking about all the tools that are available. So Spectre Console is there, is open source. You can use it in your projects as of now. But there's well, that was the demo that we just saw really quick, so we're gonna come back later. There's another one that have been catching my eyes, catching my attention, because of it's very well written. Well, and the approach is different. Not because Spectre Console is also nice, but the approach is different. This is more like a toolkit for building rich console applications. It's a cross-platform. And the name cross-platform, I work for a cross-platform technology. That's why it's so amazing. This library, one of the maintainer is Miguel de Casa. If you know Miguel de Casa from back in the days, creator of one of the creator of Xamarin and the many things that we all love about the cross-platform.net. So this one is the way, because why it is so captivating is because it treats everything. So from the start, everything is, you have a window, you have views, you have events, right? You have in a command line, you will have events that you can subscribe, you listen to events, you have the click, you have the completed, all the things. So think of it as if you are working with a WinUI desktop application and you're building UI for the desktop, or you're working with Uno platform, right? But instead of you be rendering in one of the targets for Uno platform, you're gonna be rendering on the console. But the whole structure of the application is so nice and so well written that's why I chose this one of the applications that I wanted to show. So this one, Terminal GUI, also cross-platform. You have two ways to work with this application. Basically, you have a way that it is by installing a template. They provide a template that you can install. Terminal GUI that templates, and then you can create an application with that template. I think I already have installed it. .NET new install terminal templates. Yes, they are in version 2.0 right now, which is still in alpha. But you can use it. It's solid so far. So I'm gonna enter into that directory. Let me use version 2 because I was using both applications. So from here, if we want to see the code, I create an application. So yeah, basically the template asks you .NET new TUI. So instead of using console, you use TUI and then -n, which is going to be the name of your console application, of your terminal GUI application, and you pass the name and it will immediately create this project. So this project that you have here, what is this? I think it is this one. Oh, this is the version 1. Okay, I can open a new one and hold it anytime. So I'm gonna do code and I'm gonna open a new one. Okay, so this is the application. This is what it creates. Don't look at the code that is commented. It's something that I'm gonna show you later. So this is the fine new project, and if you see, there is a view, and there's a view designer. And both of them, you see, are generated code, and you might wonder what is this that generated. It's because the terminal GUI also includes includes a tool that you can use. The tool is called Terminal GUI Designer. So yes, you will have a designer that you can use. Let me go sample design .cs. You will have a designer in the console that you can use to create applications. So let me, I don't remember, I think it's to do at TUI GUI. I don't remember, but it doesn't matter. So this is a designer that is a canvas, is in the console, and from here you can start adding components. What components they have available? They have a lot. They have, for example, a button that you can, you select the button and you can drag and drop the button where you want it to be. And then you can continue doing this. For example, text field. They got it somewhere. Text field. Let me get that label. Let me get .NET .NET Conf 2025, and then also I'll put it here. So once you're done, you can configure, you can click F4, and then you can change the arrangement. You can focus. You see, the API looks a lot like WinUI API, or also on the Uno Conf, on the Uno platform. You can change the alignment of the task if it is visible, the width, if it is the dimension is automatic, that means it's gonna grow or not. So yeah, as you can see, many of the properties that are available for this are things that basically you have available also when working with Uno or when working with WinUI. So once you're done with the designer, you can just click on escape, you save it, and your file with the designer created is going to be part of your project. So I call it, what was the name? Was my dialog? Yeah, sample design. Okay, this is the one I created. And basically this is the C# code that it generated once you completed the putting together the things that you needed. This is really nice. Once you run this application, then you're gonna have an application that just .NET Run. Let me do Ctrl+C, .NET Run. You're gonna have an application that's running locally on the console, and we will have the good things about Terminal GUI is that it just takes everything as it's just a window, so you have context of everything, not only a script that is part of running. So you have all the stuff, but you don't need necessarily to have the designer. You can create controls with C#, and this is the thing that I wanted to show you. So I'm gonna comment this out really quick, and this is coming from an example that I created, example window. So I created this. It's like a login button, a login page, and if we run again, we're gonna have again a TUI application, but now with a UI that is more to things that So we didn't use the designer for this. Basically, what I wanted to say, you have options to click. You have options to click also in this list view that you have at the bottom, so that we can continue and times give us the opportunity. The last tool that I want to display is Racer Console. This one is, I just learned about this like a week and a half ago, probably 2 weeks. So imagine that you can use Racer syntax, and you can create that Racer syntax can create terminal application. This is what basically Racer Console is just use Racer syntax on top of the Spectre console, and then you use Racer to create your applications. This is also a .NET package. So you create your application, and then all you need to do is make sure that you include that package on your side. So you have, this is a very simple application. And let me Command Shift B so I can hide this, and Command B. Basically here you have a Racer page control, and then here you have the code, and you have access to run the application by just doing the host. It's very simple, very straightforward. But the good thing about this is that you can, if you're a web developer doing .NET ROM, if you're a web developer doing Racer or Blazor, you already know the Racer syntax, and you want to build terminal applications that looks nice, you just basically use this. You see, you have the click event that you are listening, and you are incrementing the console, incrementing the counter with this event. All right, so I'm about to run out of time, but I want to show something is that how we deal with things that are outside of the terminal, outside of the UI. How about architecture? How about things that are gonna make my application to be easier to work with, and also easier to orchestrate. That's why architecture are for. So let's say that I want to add a local persistence. So the same applications that we have first for the database, now we added, it was already included. So now we added a repository, basically, that we have the capability to save our to-dos into tables. So if we do .NET run, I'm gonna run it from here, so it's faster. If we do a .NET run, then we are gonna be able to persist those information at new task, .NET Conf, and view tasks. We have one, we exit. It says that are not saved, but they are actually saved. That was actually an error. So if we run again and we say the view task, we see that the task is there because we are persisting that information on tables. And the same way that we deal with that, we can also include MongoDB that it's actually implemented, but I won't be able because we don't have as much time available. And also, if you want your terminal applications to connect to APIs, nothing stop you from that. The goal for this presentation is not that all your applications from now on you're gonna do terminal applications, but for you to understand that the same power that you get on desktop application, mobile applications, web applications, everywhere where .NET runs, you can get the same power and the same features in an application that's going to run in the terminal. Not all applications might not need to be in the terminal, but the ones that need it, you don't need to create something on the web just because it is the viewport that you know the most or that people use the most. Terminal-based applications are good, are powerful, and I invite you to learn about this tools and put it in practice. And if you have questions, please let me know. And thank you very much for hosting me this evening.
All right, this is very cool, Andres, and very retro. Thank you for bringing back some, lots of memories. Chat room has been having some good banter. Maybe we can bring back, 6-bit retros. Why not? And
why not? Yeah.
Like you said, I think terminal GUI, a lot of us have, memories of that. So, and it's nice to see that you can, impact, modern app stacks with, all of the architecture to build, TUIs, which are much more structured than CLIs, like you said. So,
yep.
Yeah, this is very good stuff. Any other parting thoughts, Andres, before we let you go? I'm going to bring your screen down.
Oh, no, nothing else. I think this is perfect. My last presentation at .NET Conf was about CLIs and .NET and the .NET CLI. And so you can see that evolution. I'm looking forward to get most. We at Uno, we build a lot of tools and things internally and also externally. And so I understand the power of the CLI and have given me the opportunity to talk about those things. So I appreciate that. Thank you very much for anyone that saw the presentation. My socials are there if you have questions or want to connect. And Sam, thank you for hosting me.
Yeah, absolutely. And to answer this question, these are exactly the libraries that Andres talked through. So we have some good ammunition to build, modern terminal GUIs. Good stuff. Good stuff. All right, Andres, we're going to let you go for now. Hope you enjoy the conference that you are in, and thanks for taking the time to come and share your expertise with us. All right, bye for now. All right, folks, we are 6.5 hours in .NET Conf Day 3. I'm going to bring back a friend that I haven't seen in a very, very long time. He's doing some time travel. Maybe I'm doing some time travel because Mr. Jeff Fritz is back. Mr. Fritz,
hey Sam. Hello. Good to see you.
You're back in the studios. How did I end up at home?
We're closing things up, wrapping things up, getting stuff ready for tomorrow even.
Yeah.
As we continue rolling through .NET Conf Day 3 Community Day. Oh, thank you so much for hosting.
And it's been so awesome. We had Chris Ayers as a host, and in 6.5 hours, we have covered so much of awesome content, like my head spinning with ideas. So I
love seeing the text UI stuff from Andres. There's so much I want to do with that now. Coupled with Copilot at the command line, I'm itching to do some things.
Yeah. So without further ado, let's bring out our next speaker who's hanging out in the green room with us. Mr. Kevin Griffin.
Hey.
This is like a Tech Bash reunion. We were just together last week for Tech
I
Bash
know.
in Pennsylvania.
And Andres as well. Like we were all together.
Right. The magic of tech. All right. So Kevin is going to talk about all things, .NET Foundation and taking .NET open source forward. I'm going to bail and go have some lunch. And you're in the hands of Mr. Fritz and everyone else at the studio. So thank you.
Excellent.
All righty.
Sam. Mr. Fritz.
All the best to you. And let's bring things up and I'll step out.
All right. Thank you, sir. So I'm like the smooth jazz part of .NET Conf. You're all over the excitement. You just need to take a little nap. Now's the time. Sit back, relax. And let's talk about the state of the .NET Foundation. So hello, everyone. So if you've been paying attention to .NET Conf like I have, it's no better time to be a .NET developer. And there's not just the stuff that Microsoft is doing and the great work the team has been putting out there. There's also all the things that the community have been doing as well. And that's what I like to talk to you about today is the community. So everyone out there who doesn't know who I am, I'm Kevin Griffin. I'm the current president of the .NET Foundation. I'm a longtime Microsoft MVP. I love .NET. I love the .NET community. And all this stuff just, jives with me. If you like, talk to me afterwards. My socials are up on the screen. I'm also on LinkedIn. I'd love to communicate with you. Those of you out there who aren't familiar with the .NET Foundation, let me just kind of give you a quick little introduction about who we are and kind of what we try to do. So the formal answer to what the .NET Foundation is that we're a 501c6 nonprofit, basically established to support a commercially friendly open source platform around .NET. The 501c6, and those of you who are based in the States know that 501 is typically a nonprofit. A C6 means we're a membership-based nonprofit. So still a nonprofit, we're just slightly different in the letter of the law. Just a couple things you should know about the .NET Foundation is that we're 100% board of directors, volunteer board of directors, elected by membership. So if you're a .NET Foundation member, you are allowed to vote in the elections and you choose who guides the .NET Foundation. To preface that a little bit, we're 100% non-Microsoft board. That's hasn't always been the case with the .NET Foundation, but as of today, since I've been on the board of directors, it's been 100% non-Microsoft. I do put a slight asterisk next to that, but we'll talk about that in a moment. And every member of the board of directors serves a 3-year term. We recently made a change from 2 years to 3 years just because we wanted to make sure any one person who joined the board of directors had the chance to really try to get some changes into motion. And we found that 2 years was typically not enough to get some of that work done. So we increased it to 3 years. Now, your current board of directors, you have me, Kevin Griffin. I'm joined by our vice president, Mitchell Sellers, and the rest of our board of directors, Mr. Glenn Watson, Ms. Lou Creamers, Mr. Chris Woodruff, and Mr. Kendall Miller, all serve as your elected board of directors. Then we have Mr. Chris Stefanos, who is our founding member. And remember that asterisk I just mentioned a moment ago. I said we're 100% non-Microsoft board, but Mr. Chris Stefanos is from Microsoft, and he is a board member who just helps support some of the things that we're trying to get done. And he's amazing at his job. Chris is one of my favorite people. I love everyone on the board of directors. Recently, we had an election and we brought on 2 new board members who haven't started their terms yet, but will at the beginning of January, Mr. Jay Tower and Miss Irina Demente. I'm looking forward to serving with both of them with my time left on the board. And I've already had some conversations. I know there are a lot of big ideas coming down the line. So what does the .NET Foundation do? This is the $1 million question. If you ask Reddit, we do absolutely nothing. But we're not talking to Reddit today. We're talking to the great people of .NET Conf. I break what we do up into 2 categories. We have projects, and then we have people. So first, let's talk about projects, because this is ultimately what everyone looks for the .NET Foundation to talk about. We support over 130 open source projects in the .NET community. Some are Microsoft, but the majority of them are just community projects. And there's a lot of different ways that we support open source. I'm just going to kind of highlight the big overarching themes. The first one is project guidance. So if you're a .NET Foundation project, you are just part of the community. There's other project maintainers who come in, you ask for or you offer mentoring to these projects, you answer questions. If you're just a person coming in looking to get involved in helping maintain a project, we can assist with that sort of stuff. If you're asking questions about best practices around, say, CLAs or doing releases or code signing, we can help in a lot of different ways, just because through all of our projects, we have dozens and dozens and dozens of years of just technical knowledge. We also support legal services for different projects. This is not something we talk about too much publicly because no one really likes talking publicly about legal issues. But if you're a project under the .NET Foundation and you have a legal problem that needs to be taken care of or addressed, the .NET Foundation has legal services available to it that can assist you in these cases. And sometimes we have to go talk to our lawyer, and we have a great lawyer who is knowledgeable in open source and can help us through a lot of these issues. I think marketing is kind of the big one that I wish I could devote way more time to, but a lot of the projects I talk to on a somewhat regular basis, we ask, what can we do to help you as a project? Now, obviously, the first thing they say is, well, pay me. Help us get money and funding. The second thing they talk about is marketing. Can you help people just know that we exist? How many times have you looked for a solution to a problem you're having in any project and realize, oh, someone has already solved that problem with a library. Oh, it's been up on NuGet for 4 or 5 years. I'm just going to pull that down and start using it. Now, we're just trying to help people know what projects exist out there, and we do that through a variety of different ways, through social media, through our newsletter, and some other things I'll talk about towards the end. CLA management is other big thing that we offer to a lot of projects. If you're accepting contributors, you want to have a CLA with them and make sure that everything is legal. We provide the resources for you to be able to do that, to get a list of who has signed licenses with your project. It helps from a legal standpoint. And we've had a couple projects come back to us where we've had to pull a list of licensed contributors because something was happening. Some projects we offer limited infrastructure, which like the easiest way to describe this is just Azure. So if you're an open source project and you need some Azure resources like Key Vault or hosting, we do have resources available to us to provide that to our projects. So when I say limited infrastructure, it's basically, it's Azure in the simplest terms. And then a lot of projects take advantage of the code signing resources that we have. If you've ever gone through a code signing process in your environment, you know it can be time intensive. It can also be costly depending on the type of signing that you're trying to get done. Any project that comes into the .NET Foundation is eligible for code signing, which helps a ton with just promoting your project, because some businesses require that all the binaries are signed before they are shipped. So if you're a project with the foundation, you get access to code signing, businesses are more likely to take advantage of your project in their infrastructure. Now, I had a long list of all the new projects that we had recently brought into the .NET Foundation, and I would love to talk about all of them at length. But just for the sake of time, I'm going to touch on just a couple that we have recently brought in, just to give them a little bit of visibility so you can go check them out afterwards. The first is FlowTide. So if you're doing a high-performance SQL and you need a streaming data processing engine, FlowTide recently joined the .NET Foundation. If you're looking for a cloud-native cloud streaming tool, Cloud Streams, recently joined the .NET Foundation. I'm sure there's a lot of Avalonia users out there in .NET Conf, but if you're looking for an enterprise UI library, we recently brought in Ursa Avalonia to provide you some UI tools. And any friends out there who have worked with SignalR, which is one of my favorite libraries in .NET, you are aware of MessagePack, and MessagePack recently joined the .NET Foundation as well. Now, there's dozens and dozens more I would love to talk about, but I can't. And not every project that applies to join the .NET Foundation is brought in. Sometimes projects are not at the maturity level that the project committee is looking for. And they look at a variety of different things like the number of commits, the number of maintainers, stars, just general who's using the project. If it's a fresh project that someone started 2 weeks ago, it's likely not to get added to the .NET Foundation. If it's coming along, but it's not quite where the project committee would like to see that project be, they will typically suggest that project comes in as what we call a C project. This was recently added by the board of directors in the past year or two because we wanted to provide some resources to up and coming projects, but they might not necessarily be able to take advantage of all the resources that we have. So the seed category means we're going to keep an eye on them. We're going to offer them a little bit of mentorship and help to just build awareness and check back on that project in a couple months and see where it's progressed. And there's a handful of projects that we have moved into that category that we are watching, and I see them being talked about on social media. So it's very likely that when the project committee meets again and they review these seed projects, many of these projects will be fully moved into the .NET Foundation over the next couple months. Now, I have a whole drawn out set of slides on just controversy of the .NET Foundation. I joked about Reddit a little bit earlier. There's a lot of people have a poor taste of the .NET Foundation because of actions of the foundation many, many years ago. I do not have time to go into detail on any of those things, but what I'd like to talk about is just the foundation is trying to rebuild trust. And the big thing that we do, that we've changed since controversy many, many years ago, is that we bring all of our projects in under contribution-based licenses. The .NET Foundation does not own any new project coming into our ecosystem. We are merely here to provide resources. We do take a copyright license on the project for different legal reasons, but we don't ever own the project. We've also made changes to limit the board of directors, the Microsoft, non-Microsoft volunteers, members of the community. And that's simply because we have read so many messages out there on the internet that when the foundation makes a decision, they put it under the umbrella of Microsoft is doing this, Microsoft is doing that. And it's not Microsoft. It's a volunteer board of directors of your peers, people made up in the community. We used to have a executive director position for the board of directors that did a lot of the heavy lifting. That position has been eliminated. So any decision that comes from the .NET Foundation is agreed on by quorum of the board of directors. We also try to be fully transparent about anything that happens. So if there's a project that goes commercial, for example, we try to talk about why they are leaving the foundation and the decision up to that point. And our overall goal is that the .NET Foundation wants to help projects. We do not want to own projects. And there's a lot of people who think we own every project that's under our umbrella. And that's not true. So I hope if you're out there and you're listening and you have this poor opinion of us in the past, you take a moment and maybe reassess how you feel, because we made a lot of changes over the past several years. All right, back to dividing up between projects and people. Let's talk about the people now, the you, everyone out there watching .NET Conf. It is very likely that in your backyard, you have access to a .NET user group or a .NET meetup. We support through the .NET Foundation over 231 meetups via our Meetup Pro sponsorship. If you've used Meetup as an organizer, Meetup is expensive. It is also the place that a lot of folks go to by default when they're looking for a community to get involved in. So if you're a community organizer trying to serve up a meetup, it can be a little bit limiting to try to put that on Meetup if you don't have the assistance. .NET Foundation has come in and we've supported 231 meetups. We used to have more, but COVID killed a lot of them, so they are no longer in the program. But our goal is to support the people out there that are helping promote .NET. Now, through those meetups, we've hosted over the past 3 months 19,000 events, which I think, hands to you all, because that's the community doing the work. That's not the foundation. That's not Microsoft. That's the community doing the work to teach everyone about .NET. Now, through these meetups, we have 337,000 meetup members, and that's across 45 countries. So if I show the map of all the meetups that we support, it's a little broad over in Asia, but if you're in the States or in Europe, you're probably close to a .NET meetup that you could go to. Now, I'd love to see more dots up on this list. If you are running a meetup or thinking about starting a meetup and there's not a dot near you, we should talk, because I would love to give you the resources to accomplish that. Just start a meetup and see if people come. Now, kind of wrapping things up, I'll talk about what the .NET Foundation is, what we try to do, the people that we try to help, what's the current state of the .NET Foundation, because we've made a lot of changes over the past couple of years. The question I ask myself every time I'm talking about the .NET Foundation, every time the board of directors comes together, I say, how can we be better stewards of .NET open source? Now, I'm not perfect. I'm not a maintainer either. I'm just a guy in the community who has a vested interest in .NET succeeding. I don't want to go learn anything else. I like .NET. It would kill me right now if I had to go learn Go or Rust or something like that. I want to stay in .NET. So what can I do to help .NET be better? What can we do to keep .NET better? So if you're in the foundation and you're a foundation project, we're trying to start a couple new initiatives. We're trying to start town hall meetings with our projects just to keep them up to date of what's going on with the foundation, and also let them bring questions to us that we can go get answers to. And this is an upcoming initiative. We've also recently kicked off our .NET Foundation Buddies program, where every project in the foundation should have a contact on the board of directors, where if you have a problem, you can reach out to your board member, and that board member will bring it to the rest of the foundation to try to get a resolution. We're actively talking to our projects to promote their updates. If you're planning a new release, we want to know about it, because we want to put that out on our newsletter. We want to put that out on social media. We want to send that out to our meetups. We want to tell everyone about the good work that you're doing in your project. Big part of that, we also do a project spotlight. So instead of just listing all of our projects, we'll pick one every month, and that project will get a full spread of what it's about, the people who are maintaining it, because we want to tell people about the projects. And it is people doing this work. So in addition to our project spotlight, we're doing member spotlights. So pick a member of the .NET Foundation community, and let's talk more about that person doing the good work. I mentioned earlier that we had removed our executive director. A big part of that process was the .NET Foundation had to relearn how to be an organization. And so much was lost when the executive director went away. We reduced our overhead immensely during that process, but we had to learn how to do things. So the .NET Foundation is redefining how the .NET Foundation operates. So we do that through a series of SOPs. I know it's businessy words again, but standard operating procedures of how we do our work. From a boring funding standpoint, the the .NET Foundation was hemorrhaging money. When I had come onto the board of directors, this was already seen as a problem, and steps were being taken to fix that. Right now, I can say the board of directors, we've eliminated 80% of our overhead as an organization. This was money that was not going to projects. It was not going to people. It was just being thrown away. And we were able to eliminate a lot of that. So everything that we spend money now on should be directly impacting projects and people. We're also actively trying to partner with new folks out there in the community to be able to better promote our projects and people. So if you are a company looking to get out to the .NET community, we'd love to talk to you. So ultimately, this comes back to how can we be better stewards of .NET open source? It's all for the people. It's all for the projects. So yeah, if you're interested in sponsoring, we'd love to talk to you. Contact at .NETFoundation.org. And just wrapping things up, and then if there are any questions, I would love to chat with you in the chat. So the big thing, get involved in a project. If there's a project out there, even if it's not in the foundation, go contribute. We've talked to a lot of maintainers who are looking for not code help per se, but maybe help with documentation, help with samples, help with getting started guides. There's a lot of opportunity to contribute to a project, and we'll help you find one if you're just looking around. Sponsor a project. So a lot of projects out there don't get a lot of sponsorship dollars. It's folks just like you and me giving their free time to support these things that are basically making your lives easier. So if you're not sponsoring a project, take a moment to go see if they could accept a couple bucks a month. I'm currently working through it right now. It's the open source maintainers fee project to see what projects, what libraries we use to make sure that maybe let's give a couple bucks to them every month and make sure our projects don't die, or make sure we don't have to do significant work if a project goes dead. So sponsor a project. You can also become a member of the .NET Foundation. We'd love to have you. Anyone's eligible. It's 100% free. It used to be a paid fee. You have to pay contributor dues, but that's gone. It's now 100% free to join. When you join, you get voting rights. So you can vote in, say, our upcoming election in the next couple of months. We have another 3 members that will be rolling off, myself included. You can take my place. And yeah, you get to vote in that. You also get the opportunity to participate in any committee meeting that you are interested in, be it our projects committee, our membership committee, or we also have an outreach committee. And our Discord is filled with amazing humans that you can talk about all the open source that you want. And wrapping things up, if you don't want to do any of that, just go to a meetup. Meetups would love your support so much. Just showing up is the easiest thing you can do. And if that's all you can do, yeah, go to a meetup. There's a lot of them out there. We do have election season coming up soon. Go run for the board of directors if you're a member. But last things last, if you're out there, you talk about .NET open source, maybe mention the .NET Foundation, say nice things about us, because we're doing a lot of good work, and the volunteers of the .NET Foundation are working really hard. But with all that said, thank you all so much for hanging out with me here at .NET Conf. I hope you enjoy the rest of .NET Conf. And I think I have a couple minutes for questions if there are any. Mr. Fritz, you are muted.
I'm muted. That's weird. I don't see any questions coming in right now on chat, but I do have a couple questions myself for you.
All right.
So as we're looking at that group of meetups, and you talked a little bit about how there's some meetups that are out there that folks can go and find, and they saw on the map. If we wanted to start a new meetup at I don't know, DoverDelaware.net, and we wanted to start a new one, what's that process look like?
Well, you could go to meetup.com yourself, start it, and then they would eventually ask you for money. What I would suggest is, if you're interested in starting that meetup, reach out to us. So I had the email address up there earlier, contact@netfoundation.org. just say, I'm interested in starting a meetup at in Dover, Delaware. And we'll have a conversation with you about, all right, is there no other meetup in the area? Let's make sure we're not competing with ourselves. And if there's not, we'll give you a special code that will let you set up the meetup profile, and it won't cost you anything. And it will automatically add you to our meetup network. So you'll show up on that little map. And I can also help you find speakers, virtual and in person. Like Dover, Delaware, I could fill your calendar in 10 minutes with speakers within a 3-4 hour radius.
Yeah, right. There's a lot of folks in the Philadelphia area, New Jersey, and of course Delaware that can make it down there. So it's a great process. It's a great way to grow the community. So many of us that you see on .NET Conf, we came up through the community.
Yeah,
we started speaking.
You and I met through the community, Jeff.
Yeah. I started speaking at my local Philadelphia user group, and things went on from there.
Yep.
It's really good stuff. And of course, all the packages that are out there. There's so many good libraries. And I love what you're saying about, hey, let's get out there and sponsor them. If your company has a match program, or maybe they want to spend some money to help fund their supply chain, the things that they're dependent on, it's real easy to justify and say, hey, we need to give a couple bucks over to .NET Foundation to sponsor some of these projects that we want to see continue to grow.
It really isn't much at the end of the month. I think I'm doing the math right now, and I'm looking at about $100 a month for the client-side support, which makes millions of dollars a year. Just to throw a couple extra bucks at the projects that I use. And that's not just in the NuGet ecosystem, that's also NPM. So any project I rely on, I want to toss some money to, because I like to see it succeed.
Absolutely. I throw a couple bucks at a couple open source projects myself every month. There's so many things that we depend on, and we got to continue to help those creators grow.
Yes, sir.
Thank you so much, Kevin. It's been a pleasure talking to you, and I will see you soon, my friend.
Yes, sir. All right. Thank you, .NET.
Take care, Kevin. All right. .NET Conf rolls on here. We are on Community Day. There is so many good things that are happening. Make sure you check out the sponsors for the event, .NETconf.net. There's a bunch of logos down at the bottom. We've still got our swag giveaway. You can sign up and participate in the Secret Decoder Challenge and so much more. We've got links there to help you download .NET 10 and Visual Studio 2026, both announced and released on Tuesday during day one of the event. Now, let's get ready. I've got Benjamin here to join us, and let me bring him on. There we go. Hey, Benjamin.
Hey, everyone.
So I understand you're going to talk to us about turning CI failures into focused debugging. I struggle with CI failures. I'm one of those folks that has about a dozen commits in GitHub that says, trying to fix this, didn't fix it right the last time, trying again, right? And there's a way through this that we can improve, huh?
That is the whole hope, and that's the goal, and what I'm bringing to us today.
All righty. Let me bring up your slides, and the stage is yours.
Fantastic. Thank you for the introduction there. So, hey, everyone. I am so excited to be here with you today. I'm going to paint a familiar picture for you. You run maybe hundreds or thousands of tests, and a handful of them fail. Whether this is locally or in your CI pipeline, you now have to figure out which tests failed, why they failed, and how to fix them. You open up the CI logs, you start scrolling through the pages and pages of test results, trying to find the failures among the noise. What you really want to do, though, is focus on just the failing tests, ideally locally, ideally in Visual Studio, where you can just debug them and get to work. So I'm Benjamin Michaelis. I'm a software engineer at Intelitect. I'm the co-author of Essential C#, which is also a free learning resource going through Essential C#, beginning to expert, wherever you need to be, just hop in. And that's available at essentialcsharp.com. And I also built this small tool that I call the TRX to VS playlist. It's a .NET tool that improved how my team handles failed tests. So now when our CI pipelines fail, instead of sifting through the thousands and thousands and thousands of test results, we now automatically convert those results into a Visual Studio playlist that then lets us just download it and focus on just the tests that are failing locally in minutes. And this all started just as a little weekend experiment and has now turned into something that actually saves us time every week. So today I want to show us the journey of building this developer tool. We'll explore how this thing actually works, how you can actually use this tool to take a CI test failure and turn it into something you can actually debug in Visual Studio immediately. This is the actual workflow from something failed to let's actually debug here. Secondly, I want to talk about what I think is really the most interesting part, which is how I actually figured out how to build this tool. I had never worked with playlist files before. I had no idea what the XML format looked like. But with GitHub Copilot helping me navigate the way and walk around some decompiled code, I went from nothing to a working tool that could solve my problems in not much more than a weekend. So we'll walk through some actual moments where AI helped me out, some of the lessons I learned along the way. And more importantly, the last thing I kind of want to cover is what this all represents. This idea that we can just take annoying parts of our workflow and just fix them. We can build a small tool that makes our lives better, and how AI is making that actually more easily accessible to more of us. By the end, hopefully you'll see the code, see this tool, see how it was built, and hopefully you'll walk away thinking I could actually build something just like this for my own pain points. So if all of that sounds good, let's dive in. The beginning of this journey starts with the Visual Studio playlist. If you haven't seen these before, they're pretty cool. Normally, if you haven't added any traits or done any tweaking, you view all of your tests in your Test Explorer, and it looks maybe something like this. It's kind of just a wall of tests. However, if I want to just focus on a subset of those tests, I can use the playlist file to group together related features or ideas into logical subsets based on categories, anything you want. And because it has this grouping ability, we can use this ourselves. In case you haven't experienced what this playlist file looks like before, I'm just going to show you how to make one quickly. So here I have the Essential C# samples. So this is actually a tool that we use for our Essential C# repo. And I'm going to open up one of the chapters, and we can select a specific test. We can select a namespace. We can select a different project. And I'm going to right-click, select Add to Playlist here. That is visible. And I'm going to select New Playlist. This has brought me out into this little playlist window where I now have a subset of all the tests. So instead of viewing all, what did I have? 1,300 tests, and we actually have multiple target frameworks. So we're targeting .NET 8, .NET 9, .NET 10 simultaneously to make sure everything works. I can focus on just a subset of these tests. This file I can actually go and save. So I could commit this into my repo if my team wanted to use this repeatedly, or I just want to save on my desktop because I'm going to come back to this over the next couple of days as I'm building something out. But now that we know that we can save a playlist file, and I can also reopen that back up to get to this exact same view, that means that this playlist file, which is an XML format, actually stores the data I need to be able to create a grouping in a subset of our tests. So this is the first part of the problem of how are we actually going to solve this. So instead of manually creating this file, we want to generate it automatically. But how do we do this? The next piece of this all is a TRX file. This is Visual Studio's test result format. They're very common, whether you knew that you've interacted them or not, but they're very common because they're the output from test runners and is commonly used with a lot of tooling that integrates with your test results. So every time that you run .NET test and specify a logger of TRX, you're going to get one of these. It's another XML format document that contains everything about your test run. Which test failed, which test passed, error messages, stack traces, timing info, anything you could possibly imagine. Let's open one of these up in Visual Studio just to kind of get a glimpse. So I have selected one off of my desktop, and it actually opens up in Visual Studio. And this gives us a nice look, instead of having to look at XML, of what is contained in that TRX file. It shows me which test passed, which test fails, even error messages, stack traces, a slew of abundance of information, when I ran the test, how long it took. The key part, though, is that it knows which test passed and which test failed. That's the piece that we want to use for our solution. When we focus on this, and we take together the TRX format that we now have that can determine which test failed in our run, and we're now able to generate a playlist file, we could now theoretically put these pieces together. So how does this actually fit together in practice? This is what our workflow kind of looks like. We start with a CI pipeline wherever you run your automated tests. Some tests are going to fail in your pipeline, and the pipeline generates the TRX file automatically. This is something that .NET already does. Our tool then will convert the TRX file to a Visual Studio playlist, filtering just on those failures. We don't really care about all the tests. We just want to focus on the failures. The playlist then gets uploaded as a build artifact. So all we functionally have to do is see, oh, the CI pipeline failed, download the build artifact, open up in Visual Studio, and boom, we're actively debugging just the subset of failed tests that we're interested in. Let me show you what this actually looks like in a real pipeline. So I'm going to go open up the Essential C# repo, and I have a workflow file here. This is GitHub Actions, but this would be the same concept if you were in Azure DevOps or Jenkins, whatever you're using, the same concepts apply. When I scroll down here, you'll notice that I do some setup for the .NET environment. Hidden in here is where I'm going to do like my .NET build, my restore. And then I do this .NET test. The key parts of this is I run my .NET test, standard. I specify my logger as a TRX. And then, just out of view, I specify my results directory, just so I know where to expect this TRX file to show up, so it's not out lost in the ether and I'm hunting for it. I then have loaded this all into a GitHub action. So this GitHub action, all it's doing is wrapping that .NET global tool that we've built just to have a nice facade on the top, a nice layer to interact with in GitHub. But all it needs is a TRX file path. Where do I actually go find those TRX files? The test results from our testing. And I'm only going to run this in the failure case just because why do that extra work of filtering through to the failure tests, even though it only takes about 10 seconds on my pipeline when I don't need to. So let's actually do this. So here's an actual failed test run I have. I could start scrolling. This is maybe the normal flow. I could start scrolling through this, looking for the test failures. Oh, I see I have a test failure here. I can try to go find the name. Where's the name of my test? Somewhere the name of my test. Keep searching, keep searching. All in all, this is taking me time, and this is being difficult. Here we go. Here's a failed one. Equals given same reference. So I could copy this identifier. I could go find it in my test explorer window, and then I could fix that test. But there's more failures here. In this case, coincidentally, because I caused the failures, there's about 30 failures. So what can I do to improve this? So using this tool, I can now click on Summary. I can scroll down to the bottom, and we automatically produced a build artifact called test_results.playlist. I can now download this to my machine, as I have already done, and I will now open this up. Let's close the fake playlist that we made already. Let's just snap our window back into place here. We can click on this little button here in our test explorer called Open Playlist File. We can select the file. In this case, we called it merge.playlist. And instead of now looking at all 1,300 of our tests, we are now focused only on the tests that were actually failing. So let's run these all, and let's make sure that we actually are able to reproduce our failures that were on the CI pipeline and reproduce those locally. They're running. Great. Now, this is maybe one of the coolest parts. This just came out in Visual Studio 2026, which just released a couple days ago now. This is maybe my favorite feature in Visual Studio that has come out recently. If you right-click on your failed test here, you can select this Debug with Copilot button. When I click this button, it's going to open up a, let's just snap this here so we can take a look at the Copilot window. Copilot is actually starting to go look at the test, and it's acting in agent mode where it has context of the full workflow, of all my code context, of everything in my project. But now because it's in this debug mode, not just simply the agent mode, is actually able to go set breakpoints, and it's able to view values, do all the things that we would do, and it's able to do that on my behalf now. In this case, we have an event firing, and it looks like there's an exception, and so it thinks the property name is wrong. If we go look at the property name ourselves and try to get ahead, see if we can figure out what the problem is. Oh, there we go. It said it. So in our code, we referenced it as name1, the property itself. So here's the property. It's called name. We referenced it as name1. Oopsies. That's a bug. GitHub Copilot has gone and renamed it properly to be name of name. And it will continue on. Has it fixed it? It'll run it again. See it launching. And it has actually rerun my test after it fixed it. So now we have a passing test. So that's the whole tool in action. Pretty straightforward. But we just went from CI failures to actively debugging, and in fact, GitHub Copilot debugging and solving our problems in what, less than 2 minutes? Obviously, your mileage may vary, as this bug was a little bit maybe more simple. Yours may be a little more complex. But the point is that we went from a wall of noise to focused debugging in under a minute. So that's the tool in action. Pretty straightforward. Parse some XML, generate some XML, all the things. This, I think, is what makes it interesting, though, is the point I maybe mentioned at the beginning, that I had no idea how a playlist file worked at the beginning. I'd never parsed a TRX file. I'd never parsed a playlist file. So how did I figure all this out? We started, in my case, with the Visual Studio playlist file, like we looked at. And I wanted to know not just what could Visual Studio make at this moment in time. I can see obviously an example of a playlist file, but what does the actual schema look like? There's no public documentation to understand the Visual Studio playlist format. So I decompiled some assembly to see how the files actually worked. If we open up this window, here's a normal VS Code instance, as you might expect. And I can ask GitHub Copilot, tell me about the decompiled code you see. And it says, I have no idea. There doesn't seem to be any decompiled code. So it only has context of what is actually in my workspace. What I'm actually doing now is, instead of just doing what's in my workspace, I'm using the extension for ILSpy. So here's the ILSpy extension. And ILSpy is a tool on its own that I'm going to utilize here that allows me to investigate decompiled code or compiled code and decompile the IL. It gives me a guess as to what the actual C# code may look like. Now I use a little hack here. When I ask GitHub Copilot and I say, hey, can you help me figure out what is going on here? Because I don't actually have the decompiled code ready, I can double click on the files in my ILSpy extension. I can view the decompiled code here, but I want to give it to AI to help me with the context. So I'm able to go select one of these files. Let me just clear these out. And I'm able to select the Boolean rule kind file, and I'm able to add the file into GitHub Copilot's context, even though this file is located elsewhere on my system. Now that it is loaded into the context of GitHub Copilot, I can now ask it questions like, can you help me understand what the schema looks like? And after I see the schema, I can further prompt it, can you tell me everything about the specific attribute of it? And it'll give me all those things. The really sweet part is I didn't really know what I was doing all along. And AI was able to help me understand the core parts of a TRX file. AI amplifies your understanding. AI amplifies whatever you're trying to bring to it. If you know what you're trying to figure out, AI can help you navigate unfamiliar code. But if you're just guessing, I think AI can sometimes amplify confusion. And so we can use AI to actually help us understand the core principles. Instead of me blindly going and trying to create this tool, not understanding the intricacies of a playlist file, I may have been lost and my tool would have been a bust, but it actually works. And AI helped me with that understanding and helped me iterate on that process faster than I could have by myself. The next piece to this is a common practice that we have done in development for a long time. Test-driven development. Why does this sound familiar? It's because this principle existed before AI. Test-driven development is not new. We write a test, we make it pass, we repeat. What does this look like in the age of AI building this tool? Well, I gave GitHub Copilot some actual code, some actual examples of a playlist file that I had. So if we go open up our tool, this is the actual code. Let's close down the test results file that we had before. Here is a playlist file that I actually found on GitHub, so I had a real example. And I would go ask GitHub Copilot, hey, could you go make me a test, let's say that make sure that we can parse the rules of match not. And it would go actually write that test for me. You go input it, write the test for me. But I found there was a strategy that worked really well for me. Giving GitHub Copilot actual playlist files for my build, not abstract just descriptions, really helped it actually produce real and accurate results. I iterated in small chunks. Each test covered just maybe one parsing scenario or one result type, one edge case. And because I kept that context narrow, it wasn't like I was dumping my entire code base into the chat and saying, figure this out, build my whole tool. I kept it isolating. Can you help me parse this XML structure? Can you extract these fields? Because I was also operating off of real data, I was also able to catch when AI was making mistakes faster. When Copilot generated code that misunderstood the XML schema, the test immediately failed. So I think through this all, the tighter that we can make our feedback loops, the faster we can understand and catch when AI may be actually misunderstanding the problem. Next thing is just keeping it simple. I fall into this all the time, and maybe you relate to this as well, where I overcomplicate things. I want to make the most extravagant engineering tool I can, and it is maybe overkill for what is at hand. When I first open up a playlist file, it looks something like this. This is like exactly out of the file that we saved from what I showed you earlier about how to make a playlist file manually in Visual Studio. If I save one of those, this is what it looks like. There's a lot going on here. But I noticed something key about this. There's a version 2 indicator here. Makes me wonder, is there a version 1? How can I figure that out though? I could either start installing old versions of Visual Studio, hoping that I stumble upon a version that still generates the version 1 format, or I can use everyone's favorite tool, and I can use GitHub. So in GitHub, I can actually go use a search syntax that I have here. And this is advanced search syntax to allow me to search for a path extension, the extension of a file. So I want a file ending in .playlist as Visual Studio produces. And so I don't grab version 2 files. Let's see if version 1 exists. Just the way that it said version 2 on that version 2 one. I'm just going to make a blind guess that version 1 might be a good guess. Upon searching, I can find that these actually exist. Here's one from the Power Platform team. When I look a little closer at this looks simpler. If we can see what's actually happening here, it's an add block that has just the test name, the fully qualified identifier. In my mind, that is a whole lot simpler than what is going on here. Maybe not as powerful, but simpler. Way simpler. So I downloaded it, loaded up into Visual Studio, and it turns out it handles it just fine. The trap that I almost fell into there is I almost went and built the complex version 2 format first because that's what Visual Studio generates now. What I actually ended up doing was starting with version 1 because it was just simpler. It met my needs, and I could later add version 2 support once the core of the tool is working. So figuring out the simplest piece first, I built that, and then I only added complexity once I needed it. Once again, none of these ideas are revolutionary, but I think even in the age of AI, these core principles still stand true, they still are applicable, and they still are valuable. The last piece, kind of dovetailing off of that last make it simple practice, is working code first, perfect code second. Standard engineering practice, but worth emphasizing with AI. I got the tool working first, ugly code, quick and dirty, then I refactored. Why does this matter with AI though? If you ask AI to make it perfect while building, I find I do the same thing, but it does it as well, where it gets caught in the complexity spiral where it's happily generating elaborate patterns I maybe don't need yet. There's a saying, I think back in the Unix, old Unix blogs or something like that I've read before, that says, make it right, make it work, make it right, and then make it fast. And it turns out that AI can help you through all these three of these steps. Making it work, the basic parsing of the V1 playlist format, AI helped me go fast here. It helped me write tests quickly, helped me understand the schema, the full scope of the schema, not just what I could observe with my eyes from the decompiled code. From there, it could help me make it right. It helped me understand and refactor once I understand the shape and the architecture I'm looking for, whether this will meet the design and guidelines I want. And only then, I didn't even have to make it fast. In my case, this tool doesn't really need to go that fast yet, but AI could help me optimize with the context of real usage. There's actually tools now built into Visual Studio with the performance, GitHub Copilot and similar. I think those are the profiler. Those are really cool. But working code first, elegant code went second, and AI accelerated both phases. I just found that it's best to do them separately. Let's take a step back though. What did we actually just do here? We took a real pain point, scrolling through CI logs, hunting for failures, and we fixed them in a weekend with tools that are freely available to all of us. And here's what I want you to notice about that journey. The problem wasn't how do I rewrite our entire test infrastructure, it was how do I stop wasting 20 minutes every time CI failed. The solution wasn't building some massive enterprise system, it was simply parsing an XML file and generating another XML file. The accelerator in this all wasn't knowing everything about a playlist format beforehand, it was using AI to navigate the unknown parts quickly. And I think this represents something much bigger than just test playlists. There's been this shift happening, and maybe you've noticed it too in the past couple of years, where building small tools to fix our daily annoyances has gone from this big project I have to take on to sometimes it can just be a weekend experiment. Not because the problems have gotten easier, but because AI lets us navigate the unknown parts faster. So here's what I want you to walk away thinking. What's your annoying thing? Not what system needs rewriting, what small daily friction could you smooth out? The thing where you think, ugh, I just wish this could work differently, and then you just keep doing it the old way because there's nothing to fix your problem yet. What if you spent your next Saturday afternoon building a fix for that thing? This tool is just a small tool that I built in a weekend that actually on Essential C# we use all the time. It is built into our pipelines. We use it all the time. Love it. I love it. I love it. I love it. And I use it all the time. And if you go build a tool on a weekend, you might get it working, you might not, but you'll leave with something. You'll have learned something, and the next Saturday after, it'll get even easier. So feel free to go try this tool, go clone it, break it, make it yours. Because I think that's the real lesson here. We can fix our workflows now. We no longer have to wait for someone else to build us the perfect tool. And AI doesn't completely write the code for us yet, but it is making me be able to ask the question like, I wonder if I could build that a little bit more often. I'm thinking that question a little bit more. Can I build that thing than I may be used to? Because AI it helps me speed that up, iterate on that process. So with that all, here's a link to all my links. There are some blog posts walking through a bit more of the nuances of this specific tool. And I would love to hear your feedback, whether on the talk or the tool itself. There's a link in there for that as well. Everything I showed you is on GitHub in that link, and I'm excited to see what else gets built. Back over to you.
Thank you, Benjamin. Really appreciate that insight. What a simple little tool that really does solve that problem that so many of us run into. How do I get those tests isolated and running again inside of Visual Studio? I love the approach also of, you know what? Let's just generate a little bit of code that's going to solve this problem for us.
Yeah. Doesn't take much sometimes.
No. And I also like your approach of, hey, you know what? This is becoming a little bit of a nuisance. Let's let Copilot go and address that for us.
Yes, 100%. And it definitely was a help all along the way. I couldn't let it go build the whole thing, unfortunately, but it did help me kind of iterate and figure out the things I didn't know and solve the problems much faster than if I did it on my own. Like the fact I could build something like this in 2 weeks, like a TRX parser, a playlist parser, and it's actually half decent, isn't because AI could go do the whole thing, but it could help me understand and dive in a lot quicker than I could have otherwise.
It really speaks towards the things that we're curious about that are beyond our knowledge. Like you were saying, the AI now makes those accessible to us so that we can solve those problems.
100%.
There were a couple comments from folks on the YouTube chat around the amount of content that you're making visible to Copilot. Is that something that you see folks in enterprises have concerns about, the intellectual property concerns around that because of how you're interacting with some of those things?
Totally. I think it's always good to be careful. Like, obviously, you don't want to go sharing proprietary information. I'm not a lawyer. I'm not an expert on this. I know with GitHub, one of the beautiful things that I've noticed is they have policies and at least with our company, policies of, hey, we're not going to log or use your data. And so that's kind of a guarantee that we like to be able to keep in the pocket and know and trust in that. But at the end of the day, be careful. It's not like I'm going to go be putting in a bunch of personal information into it. I'm maybe avoiding that. And so I think there's just some common practices of, hey, deobfuscate things as needed. Be careful, be aware. But I don't think it's anything new. I think we've always had to be careful that we could go throw stuff into Google. It's now just a little bit easier. It's a little closer to our fingertips. But the same principles, I feel like, apply.
Absolutely. Well, thank you so much. We really appreciate your session here as part of .NET Conf, and I hope you have a great rest of your day.
Thank you. It's a pleasure being here.
All righty. And I will let Benjamin go. So we continue on here, day 3 of .NET Conf. We started with announcements all about .NET 10, Visual Studio 2026. It's so much great content. We're learning different ways that we can build little utilities and solve problems and make continuous integration easier from Benjamin. We've seen some other things throughout the day today, including how to work with a Commodore 64. It's been tremendous. We've got many more sessions throughout the day today. We've got a premiere track on YouTube that's going to air overnight. And we've even got some content coming tomorrow as part of Education Day for folks that are young in their career and are ready to get started and take a dive into some .NET content. But I think it's time to bring on our next speaker, and he has been a tremendous presence as part of .NET Conf and our community days. I got to bring in my friend Ardalis here. Hello.
Hey, how's it going, Jeff?
It's going well. It looks like we might have a camera resolution issue here. You look a little
stretchy, doesn't it?
You look a little skinny.
That's all right. We're gonna be just in the code here in a second anyway, so I'm not gonna mess with it.
Fantastic, then. All right, and today we've got. Let me bring up your slides. Clean architecture. Oh man, you are the person that I tune into when I want to just get that review on how my architecture practices are. I'm really eager to hear what you have for us this year.
Cool.
All righty, the stage is yours.
All right, thanks. Hey everybody, I am Ardalis. Go by that name online because Steve Smith, my real name, is really hard to get. Today we're going to talk about clean architecture with ASP.NET Core 10. I've been talking about clean architecture for quite a while, many years now. But every year there are some new things that I learn and new features that come out with .NET Core and ASP.NET. So I like to give this presentation whenever I have the opportunity and hopefully help some people learn how to structure their applications in a way that's appropriate for that application. Now, if you have seen some of this from me before, I do want to let you know I have some new stuff. So stay tuned till the end. And I do apologize. I only have like 29 minutes, so I'm going to go pretty quick, but it will be on YouTube later, and you can always slow it down or repeat it there. And one new feature that's in .NET 10, if you haven't seen it yet, is this cool feature where you can use DNX to run stuff. So I made a little business card that you can run at DNX-Y Ardalis card, as you can see on the screen. So check that out if you want to learn more from me in the short term. All right, so let's talk about architecture. And the very first rule of architecture is that everything in software architecture is a trade-off. And this comes from the very good book, Fundamentals of Software Architecture. And I've found it to be certainly true in all the different choices that you have when it comes to how you design your system and what type of architecture you're going to use. And clean architecture is no different. Now, this law is basically a fancy way of saying it depends. And it depends is, something that every consultant should probably readily say to most questions that they're asked. And the reason why it depends and the importance of this answer is what the context is. What is the things that are variables that it depends on, right? Because context is really king here. And your application's architecture should be designed for the kind of application and the kind of organization that you're building and that's building it. So, questions like, what are you building and who are the users and how many will there be? And things like, what's the performance that you'll need? How much data will there be? What does your team know? And what's their experience level? And many, many more. Now, in that book, the authors talk about a lot of different capabilities of different types of architectures. And so these are the things that you kind of trade between one architecture and the next. So these are things like how modular is it? What's the overall cost to build it? How complex or simple is it? Is it particularly testable? Is it great at scalability, or is it good for performance? And all of these things can be trade-offs when you're choosing an architecture. So there's a little bit of background that leads into clean architecture that I want to share, because I know a lot of our developers today weren't around necessarily when some of us more experienced developers started their careers. And so let's talk about what was the context that kind of made clean architecture a thing. And I want to start with the 90s, because that's when I first started writing professional software in the 1990s, in a different century. And the primary way that enterprise software was being written at the time was an architecture called client-server architecture. And generally, the client was an application that you were building, and the server was a database server. And databases were these big, expensive things. They were expensive to purchase, to deploy on expensive hardware, and to maintain and back up. And as a result, a lot of organizations, they didn't have a lot of these things lying around, right? They had a database server, at least, a production database server. And so typically you would see most applications in an organization, even a large organization, would write applications to talk to the same database server. In fact, in many cases, they would be talking to the same database. Now, this did have a positive effect of being able to say that anytime one of those applications makes a change, like they update the customer's phone number, that all the other applications can see that change for free. But there are other trade-offs here, because again, everything is a trade-off, and having a big shared database that all the applications depend on is a trade-off in a number of ways. And one of them is that if any of those applications has a change they want to make to that database schema, they are really restricted, because they know that all the other programs in the company are also depending on that schema, or at least some of the main tables. And so if you've ever seen a big database that's been around for a long time in an organization, and you look at one of the main tables that everything uses, it's like the customers table or the users table or whatever, you might notice that the first 10 or 15 columns in that table, they're not null, they're required, they have, really understandable purpose for being there. And then there's like 50 or 100 more columns have been added on over the years. Every one of them is nullable, because some application wanted to store something sometimes. And so they added that for their needs. That is not great, right? And so we would rather be able to have a database that has just the data that is modeled and suited for the application that you're building. But we'll get to that more in just a minute. So in the 90s, coming into the 2000s, this is kind of the go-to architecture that most apps are using. And the really fancy architecture that comes along is layered architecture, sometimes called N-tier architecture, right? And so this basically just meant that you take all your code, and instead of having it in one script or C# DLL or Java, whatever, you would split it out into separate logical and sometimes even physical layers or tiers. And the most common breakdown would be the UI, the business logic, and the data access. But the problem with this approach, when it was first implemented, is that it almost invariably meant that all of these dependencies, which are transitive, would go to the database. And so the business logic would all depend on the database at the end of the day, and the user interface would as well. And so this made it really difficult for you to do testing of just the business logic in isolation, or just your web layer in isolation. You always had to have a test database. Now, around this time in the early 2000s, testing was starting to become a thing. And Kent Beck published this test-driven development by example book in 2002. And testing in general and unit testing were really starting to take off. It was something I was a big fan of, and I was learning how to do, and I was trying to write these tests for my applications. And I felt like the database sometimes was causing problems for me, right? And as I was writing these tests, I would be able to write some of them, and then I would hit the database, and it would just, everything would break because I didn't have a database. And instead of being able to test this method that does this thing, it would blow up and say, I couldn't find this database, the database connection timed out or whatever. And that was frustrating, right? And so there was a lot of, old man yells at database when we're really just trying to build the software. Maybe we're starting to use continuous integration around that same time. So now even if I do have a database on my dev machine, when I run that on cruise control on a separate machine that's going to be by build server, right, it maybe doesn't have a database, or it needs a shared database. And so these were, common problems as folks were trying to really embrace automated testing and unit testing in particular. The database was a problem in that it was this dependency you couldn't easily get around without certain techniques. And remember, at the same time, C# development and web development was ASP.NET Web Forms. So another constraint was that we didn't really have a whole lot of dependency injection, and solid principles weren't really widespread at that point. So that also entered into this. But we're getting ahead of ourselves a little bit. So shortly after all the testing books came out from Kent Beck, we also had this idea of this domain-centric way of building software. And Eric Evans introduced this in his book in 2003, which is about 22 years ago. And the idea with this was that instead of having the database be the center of the universe for our applications, we would write applications that were more loosely coupled to the infrastructure concerns that they had. Where what I mean by infrastructure is anything that's outside of the process of your running application. All right, and so we would build applications following DDD that would have dependencies on other web services or on the database or maybe the file system, but those would all be kind of, at arm's length, going through some type of an adapter or an anti-corruption layer, DDD would call it, in order to keep it from messing with or corrupting our beautiful domain model of the system that we were trying to build. And this, started to gain popularity here in this time. Now, along with this, it enabled us to build many applications that had their own smaller database because we were no longer trying to have one database to rule them all, that every application talked to and became, the way that they communicated. Instead, this is kind of like leading toward service-oriented architecture and microservices and other things that would come later, because this idea is that every application is its own independent construct that is not tightly coupled to any other application or to shared infrastructure like a shared common database. All right, so a couple years go by after this book's been published, and the first of the domain-centric architectures really start to come on the scene. And the first of these was hexagonal architecture. And hexagonal architecture, as you can see, has a hexagonal shape, right? Because the author originally decided to use a hexagon for the center of this architecture, and so that's where the name came from. A better name for it, which you can also see on here, is ports and adapters. So you can see around the outside of that center hexagon, we have a persistence port, and we can plug in an adapter that then is able to talk to a database. We could plug in a different adapter that talks to an XML file or a JSON document or whatever. And there are other ports for other things that you could talk to. But the key point here is that they're all kind of plugging in to our application services and the domain model that we have at the center of the application. And I misspoke. The application services, I should say, are kind of acting as a bridge between our user interface and that core domain logic that's in the center. You can see that up in the upper left. Okay, so hexagonal architecture comes along, and one of the key benefits of this is that it's really easy to test all that business logic and your domain model, which means that if you're building complex systems and they have lots of business rules, you've got pricing rules, you've got systems to say whether or not someone is eligible for this insurance or whatever large complex key concerns that your business has as a differentiator. Now we have a way to test all of that stuff in isolation from the infrastructure, which means those tests can run really quickly and all the time. And that really makes things a lot better in terms of writing software that doesn't have quite as many bugs. All right, so if we look at this timeline that's leading up to clean architecture, we've got client server in the 90s, then we've got testing really starts to take off along with continuous integration and some of the other extreme programming practices that Kent Beck and others were professing. Eric Evans comes out with domain-driven design. We've got hexagonal from Alistair Coburn. And then a little bit later, we have onion architecture from Jeffrey Palermo, which is kind of geared toward ASP.NET MVC, not ASP.NET Core, but the original ASP.NET MVC. And then in 2011, the first article on clean architecture is written. And in 2017, the book with the same name comes out. And so that's this, kind of 20-year period where this was evolving. And you just have to remember that the main thing that we were trying to solve with these architectures was how do we isolate our business logic from all these infrastructure concerns that make testing difficult and make it harder to refactor that domain model as new features come in or as our understanding of the domain grows. All right, so to my experience, this is fairly in line with domain-driven design, although you don't have to practice domain-driven design to use any of these architectures. All right, so then talking about clean architecture specifically, the first rule of clean architecture is called the dependency rule. And the dependency rule basically says that dependencies should flow toward the core project or layer where the domain model is and not toward infrastructure, right? And so there are a few ways that we can implement this, right? If you're a fan of strong types and compile time checks like any good C# developer, you'll see the wisdom of constructing your application in such a way that this rule is enforced by the compiler. And one of the ways that we can easily do that is because of the fact that you can't have circular references in your .NET projects. So what that means is if you have project A and it depends on project B, and then you decide later on you need project B to reference something in project A, the compiler is going to jump in and just say, nope, sorry, can't do that. All right, and so we can take advantage of this to build out a set of projects that will enforce the rules that I just described, the dependency rule. All right, so we're going to start at the bottom. We're going to have this core domain project, and in there we're going to put all of our business logic stuff, our domain model if we're doing DDD. This is going to have our entities. It might have value objects and aggregates and other DDD stuff, but it's going to have just pure C# code, pure goodness that we can unit test with no dependencies. And unit testing is easy because we don't have databases and web services and files and all the other stuff getting in the way. Now, on top of that, we're going to add our application layer, which is usually called use cases in this case. And that's because we can implement that using commands and queries and follow command query responsibility segregation, CQRS. And it's going to kind of work with the domain on individual use cases like add an item to the cart or checkout or things like that. Some of them are going to sound very much like CRUD, like create, read, update, delete operations, but others could be more business logic or in the business domain terminologies. Right, but a use case is going to generally correspond to an action a user might take when working with the application. Now, we want to make sure neither one of these depends on external concerns. So we're going to put all the external concern stuff inside an infrastructure project. And we're going to have that project depend on these other two projects. And that's going to ensure that it is impossible for either the use cases or the core project to depend on infrastructure. And then on top of that, we're going to add our web front end. And what that's going to do is it's going to make it so we can have this process boundary between our application and anything that's out of process, the file system, database, whatever. And the only thing that knows how to talk to those things or is allowed to talk to those out of process concerns is the infrastructure project. Those adapters that implement interfaces defined in the other projects are the way that we're going to communicate outside of our application. And on the other side, our ASP.NET Core app is going to be the only thing that talks over HTTP to the front end, right? To the user, to an API client that's hitting our APIs, whatever it might be. All right. And so this is like clean architecture on one slide. Now, if you want to see all the different files and types and things that might go into each of these, I do cover that in other talks and in my previous, .NET Conf talks from previous years. But I wanted to spend more time here on this and then just get into the code. So with that, let's look at some code. We're going to show you some templates. So I've got a .NET New template here that you could run. I just updated it like less than an hour ago to be on .NET 10 and have a bunch of new features. So I'm going to bring up my thing here and just show .NET New Clean Arc dash, did I say question mark? Yeah. So here is the details on this. And if you want to create one, I've already done it. So we're going to use the Nimble Pros .NET Conf 2 one. But yeah, we can show, like, you just say .NET New Clean Arc and then -O, and you can say, whatever you want. And it runs in an instant, right? Boom, it's done, right? And now it's created that solution for you. So you don't have to worry about how to create all those projects and folders and dependencies and all that. It just does it for you. All right. And what does that look like? Well, it looks like this. So we've got Aspire in here. We've got the core infrastructure, use cases, and web projects. And we can go ahead and run this. And I probably need to point it at a different browser. I want it to be this browser. That browser. All right, let's go there. Cool. All right, so while it's running, it's spinning up. It's got SQL Server. That's all great. Let's look around and see what is in here. So this is a template. It is not a sample app. So it does not have a ton of stuff in here, but it has a few little things just to kind of show you some patterns. So there's a contributor aggregate, and it's basically just an entity. It's been marked with this iAggregate root marker, which means that only aggregate roots can be used with the repository pattern that I'm using. And so if it had child entities, you wouldn't be able to work with those. You notice that the types here are strongly typed. They're not primitives. So I'm not using strings. I'm not using ints for things. I've got strong types here. That's because I've defined these as their own value objects. And I'm using this library called VOGen, or Value Object Generator, to handle that. And then inside of infrastructure, I've got all my data access stuff using Entity Framework. And there's some VOGen stuff in here that wires those things up so that Entity Framework knows how that works. So when I have the, let's say this name here, I can just say it has a VOGen conversion, and Entity Framework will now translate that back and forth to that strong type. This also has some stuff for email, which I'll show you in a second. And the repository stuff is super tiny, right? And you almost never need to touch it. So that is this EF repository right here. And it's coming from this Ardalis specification library. And so this is basically all you have to do. You don't have to ever edit it. You're not having to have a repository per entity, which is kind of an anti-pattern. Instead, we're going to use specifications, and those specifications are defined in your core project, and they look something like this. They're really small, and they have this little bit of link in them that you would have written if you were just talking to the DB context directly, but now you can use a specification instead, and you can reuse these and test them, and they have a name and lots of good reasons to use them. All right, so the app should be running now. So if we come down to the web project, I have a, where is it? The web project, I have an API right here, and we can check and see if it's working. So we'll list all the contributors, and they're right there. And then I'm going to just update a contributor here and say send request. All right, and then what does that do? Well, we're going to come over here. We're going to look at two things. We're going to look at our structured logs, and we're going to scroll down here and see right about here, we're executing the command. This is the handling one, right? So we're handling this event. let's see, I don't see the other thing I was looking for, but that's fine. And we sent this email. So what does that mean? Well, we actually really did send an email, and I have set up a Papercut Docker container inside of Spire. And what Papercut is it's just a Docker container you can pull from this source right here. It's not part of this application. It's just something I'm using in Aspire. It's literally just defined in the Aspire app host. And it comes with a port 25 listener and a helper here that has an inbox and will show you that, hey, you know, a minute ago, contributor 3 updated their name, right? So if you ever want to be able to test emails, this is something you can just drop right into Aspire, and it works great. So I include that inside of there, inside the template. Okay, so here is, you know, clean architecture. We've got the web, we've got the use cases for things. So contributors, you can do create and all these other things. Then that leans into infrastructure, and that leverages the use cases leverage this core domain. But there's a frequent criticism of clean architecture from folks that prefer architectures like vertical slice architecture, which you may have heard. And vertical slice architecture is basically a rebranding of feature folders, which were real popular when we were building MVC apps 10 years ago. And the problem that is rightly described here is that if I want to add another thing for a contributor, let's say I want to, I don't know, subscribe them to something, right? So I create a subscribe endpoint here in the web project, and then I have to go into use cases and I have to create a subscribe folder, let's say, which has a command and a handler. And then I don't have to do anything in infrastructure because I already told you my repository takes care of all that. But in core, I might have to come in here and add some stuff to core as well to mark them as subscribed or something, right? And so the issue is that I'm jumping around between all these different projects, and I don't like that. I'd rather just be able to work in one place and not have to be moving all over the place in my solution. And so there's a way that you can do that. And historically, the problem with that, my problem with that has been that if you switch to that approach, which looks something like this, and this has a different domain, but you can see it's kind of shopping cart related. It's got, you know, products, and it's got shopping cart stuff. But all these things are just in folders, right? And so now I've got infrastructure with all my data, with all my AppDB context. It's just here in a folder. There's really nothing that would prevent someone from going into one of these features and just directly depending on this DB context. And I don't want that. Like that kind of breaks all the dependency rule of clean architecture. And so fortunately, there's this cool little tool that I found. It's been around for a while, but I only recently discovered it, that lets you make sure that you don't have those problems inside your application, right? So let's just go into something that's in this domain project. Here's this cart, and it's got some code in here. We can say var, db equals new app db context right there. And the thing that you should notice right away is that I'm getting an error here. And that's one reason I'm getting the error. But the other is that there is a tool in here that prevents this thing from doing this. And I think I forgot to update the domain name on it. So let me just fix one thing here. So in this config, yep, there it is. In this config, ns-depcop, which stands for namespace dependency cop, you can tell it which namespace references from one to the other are not allowed, right? And let's see, do I care about that one? No, I don't care about that. So let's just get rid of those, right? And then rebuild. And what this ought to do, if it's working now, is come in here and there it is. All right, so now I've got the error, right? So ignore the null error, but look, I've got an ns-depcop01 error telling me this is an illegal namespace from the cart aggregate to the data namespace, right? And so by using ns-depcop, you can have your cake and eat it too. You can have a vertical slice architecture where everything is organized by feature. And inside a feature, we're going to have all the things, right? We're going to have the request, we're going to have the endpoint, we're going to have, you know, the handler, whatever. You might want to have additional handlers in here. So if you're using mediator, right, we've got a separate command with a separate handler. This can be nice because it can make it so that you can use behaviors for your cross-cutting concerns. But you get it all in this one folder instead of having to have all those different projects. All right. So I'm just about out of time. Let's see if we have any questions. I'm going to throw up before we get done with this. So I had another demo, which was the minimal clean. This is our Dallas minimal clean template. And then I've got these resources for you. The one on the left is for feedback. The one on the right is all the links from this presentation, which I'll update shortly with a few more once this is done. But the other link you can use is this rdallas.com .NETConf25-clean-arch, and that'll get you to these resources as well if you don't want to pull out your phone. All right, and that is all I've got. What have we got in the way of comments or questions, Fritz?
Hey, how you doing? Oh my gosh, always something great to learn from your sessions here. There were a number of folks. Thank you for putting. I'm going to leave these. There they are. I'm going to leave these up for a little bit. There were folks asking, how do I get the templates? How do I get the resources? Thank you so much for putting together those QR codes and links for our friends. We'll copy them down and put them in with the resources for the event as well. So if you're watching on the recording on YouTube, we'll have the links available for you there as well. I've been trying to keep up with some of the discussion here on YouTube chat. There was a question about why not architectural tests?
That's a good question. So in fact, I had those in last year's presentation. They're not a terrible way to do it. But if you have the choice between a compile time check and a test time check, you should always prefer the compile time check, because your devs may not run those tests, right? Or they might just ignore them, or Copilot might say, hey, this test is failing. I know how to fix it. Ignore, right? It's harder to do that with a compile time check. And the NSDepCop approach is a compile time check. So it gives you the squiggle, the red underline in Visual Studio or your IDE of choice. And it also just won't let you build. So it's a much nicer way to enforce it.
Sure. Well, thank you so much. Right, you're right. Chock full of content there, right at the limit here. Really appreciate you taking the time for us, Steve. And I hope you have a fantastic rest of your event.
Thanks.
All
See
right.
you later.
We'll see you. And I'll bop him out. Thank you so much. Lots more still to come. We've got a few more hours here today as part of day 3. My friend Javier is going to be coming over to join us, hosting in a little bit. We've got a couple more sessions to come. And of course, tomorrow is Education Day. It's the Education Zone where we're going to have sessions that are great for folks who are early in career and want to get started with .NET. So you've got those friends and family that you want to tell that might be interested in getting started with .NET. Tomorrow's a great time to tune in for those folks early in career. So let me get ready for our next session here. I've got Russ Harding he's going to be joining us to talk about efficient onboarding, accelerating new engineer productivity. Let me grab Russ here. Hey there, Russ.
How you doing?
Oh, man. Doing great. There's so much happening. I love the excitement, and I can't wait to hear your perspective on efficient onboarding here.
No, I love the last presenter too. That NSCOP. I'm going to be taking a look at that as soon as I hang up from here. So that's fantastic. I 100% agree. If we can get the compiler to do the work for me, I'm thrilled to do it.
Yeah.
So I'm going to go ahead and jump in because I think I'm between the slide deck and the demo. I think I'm going to use the full half hour. So
the stage is yours then.
All right. So thank you, everybody, and welcome. My name is Russ Harding. I am VP of Engineering at EQ Engineered, a strategic digital consultancy out of New Hampshire in the United States of America. What I wanted to talk about today is basically the idea that as a new software engineer coming onto our teams, we generally, what I've experienced, I should say, is that as new engineers come in, they're handed a laptop, it's got nothing on it. And they're expected to go from that laptop to being a productive member of the engineering team in a fairly quick amount of time. So how do they do that? Well, my experience over the years has been a somewhat painful process. There's a bunch of documentation that is never maintained. And your team leads are getting constantly bombarded. And the rest of the team is kind of being disrupted by this new person, at least for the first couple of days, while they're trying to just get everything installed. And I can't connect to my database, and I can't, it doesn't compile, it doesn't compile, it doesn't compile, right? So how can we improve that, manual onboarding problem that we have and actually move us into a position where potentially I can, hopefully during this demo, I can take us from a bare metal machine, which I have set up, and I'll jump over to and get started here, to a running demo app, the eShop from the Aspire project, just to kind of show that, you know, we can go from bare metal to a running application in hopefully 30 minutes. We'll be really close, but I think we can get there. All right, so what I'm going to do is I'm going to kick over here, and the first thing I want to talk about is kind of two major technologies that we're going to lean into. We've heard a lot about a .NET Aspire over the course of .NET Conference, and it's an amazing tool. I've been using it for the last 2 years, almost since it came out. But I also want to talk a little bit before that in talking about Winget. And I don't know how many of you might be familiar with Winget, but it is a tool, and I'll kind of pull up a little bit better screen, and I'll show you on Visual Studio Code here in a minute. But basically, it's a tool from Microsoft that allows you to script your software installation. So as you can see here, kind of in the screenshot that I have here, I have scripted out, you know, Visual Studio to be installed, web deploy, Git, Tortoise SVN, Postman, and a few other pieces of software. So I'm going to go ahead and jump over to my desktop application here, and I have none of those things, right? If I go search for Visual Studio, right, it doesn't know anything about it. It seems to know something about these things, but it's just going to take me out to the internet and say, hey, do you want to go ahead and install these things? So it doesn't actually know about any of these. None of this stuff has been installed yet. So what I'm going to do is I'm going to start actually running some of these, and then I'll go back to the slide deck and talk a little bit about this. But what I'm going to do is I have a Winget configuration file, which I'll show everybody, and we'll talk through it a little bit. And I'm just basically going to say, hey, Winget import, right, and install. And all of the files that those are showing you in that slide deck, everything is configured in this JSON file. Now, you can use it one at a time and install individual pieces of software. But if you have a new engineer and somebody new, doesn't have to be an engineer, it can be anybody on the team, and you want to just very quickly say, hey, here's a configuration file. I want you to just open up a terminal and run this command. Just do this, and it'll just install all the things that you need to install. So I'm going to run this. We'll go through a couple of very quick reboots because we're going to install a lot of software, and then you'll see that over the course of this conversation, we'll be up and running. So I'm going to go ahead and hit OK on this. You see that it's going to get started, and it's going to look at all the files that I think that I have told it that I want it to install. I'm accepting all my package agreements and all my source agreements. So it's going to go ahead and get started, and it's going to start with Visual Studio Code. So I'm going to jump back over to the slide deck while it's doing a little bit of that work, and you know, we'll go through and we'll talk about a little bit more about this. So, like I said, so we've got Winget, we've got these configuration files. There's a couple of different alternative ways that you can use this. Like I was starting to say, you can manage your software. So what you see here in a couple of these slides here is that I have a configuration file, which I'll show here in a minute. But if I don't know a software package that I want to install, there is a search functionality. So here in the top right-hand corner of my slide deck here, you can see that I can go to my command terminal. I can say Winget search, and I can say, well, it's Visual Studio or it's Git or something like that. And then it comes back and it tells me all of the different SKUs that Winget knows about, so that I could potentially script out any single one of these. All right, Visual Studio 2017, 2019, Enterprise, Professional, Community, right? Visual Studio 2026. So you could set up all of these things. And if you don't know what they are, you can search for them. If you aren't sure if a package is available, you can search for it. There's a lot of stuff that's available. In the bottom screenshot that I took here, right, I'm also exporting all of the software that is potentially installed on my machine. So I want to go ahead and say, show me everything that's already here, right? So you can see, oh, I got IIS 10, I've got .NET 10, I've got Visual Studio installed, SQL Server 2025, right? And all of these things, and you can see kind of toward the bottom, I've got OneDrive, and I've got Microsoft Edge here kind of in the middle, and Outlook for Windows. So my point is it knows about a lot of software. So there's a lot of things that you can very quickly script out and just hand to a new engineer. I like to think about this as a little akin to your infrastructure as code. It's not quite as advanced as some organizations that'll give us an image for a machine or something to that tune. But every single project has its own custom configurations. And you can take this and I'll pull over Visual Studio Code real quick while this continues to run. And so let me see if I can put this over here and have it dock. No, not well. All right, we're making this worse. That was nice. There we go. So I'm going to pull this back up. Wherever that went to. Demo effect, right? So we're going to pull this back up, and I don't need any of these widgets. Thank you very much, machine behind me. We'll ignore that, and we'll let that keep running. And so I've got Visual Studio Code here. And so I've got my Winget configuration, and let me close everything else so we can just focus on this one thing. Close others, and close, close, close. And we're going to look at this. So you see this configuration is really pretty straightforward. It's a nice, simple JSON file. You can take this, you can put this into your source control. You can have some quick documentations that you can share with the team about how it is. But you can source control this so that everybody that's coming in, if you have to make changes to your software package structure, you add new requirements that developers need to put on their machines, you can use this. And you can very quickly just define, right, Visual Studio package ID, Visual Studio Professional, right, MVM for Node, Visual Studio Code, Web Deploy, Git, Tortoise, Postman. We're going to go ahead and I got Postman in here twice. We're going to install WSL. We're going to install Podman, Notepad, right? All of these things we're going to have installed, and you can still kind of see it's cranking away in the background. And I'm installing Node LTS right now, so it's almost done. So it's at WSL, and it'll install these couple others. We'll have to, like I said, we'll jump through a couple of quick reboots, and then we'll at that point be able to have this. We'll be at the point where we'll be able to clone down this code for the eShop, and we'll be able to get ready to actually open up Visual Studio. So as this is finishing up here, actually that finished up, so that was really great. So now so the next step here is I'm going to want to try and run Podman. Now it's going to tell me no, and that Podman needs to install a couple of extra things on its own, but that's okay. Machine and net. So it's going to tell me that Podman right? So it's going to pull down a blob for Podman. It's going to tell me that it needs to install a couple of things and that it needs to do a reboot. So we'll do that real quick, right? And we'll let it do its thing. And then we'll flip back over to the slide deck while it's doing a quick reboot. This will only take a moment. So while that is happening, I'll jump back over to our slide deck, and we will jump down to the next step, which is going to be .NET Aspire, which we're going to get to here pretty quick once we get this machine back up and running. And in .NET Aspire, there's a lot of functionality. I think that we've probably heard a lot about it. It's a fantastic tool for your different teams, right? And what I want to kind of emphasize, and I think we hear a lot about what a fantastic tool it is and how it's a great tool for your development environment and how it interacts with building cloud and distributed systems and your orchestration and your availability. But I also want to kind of stress that it is also a fantastic tool for your non-cloud environments as well. I'm going to keep talking about this, but this machine is back up, so I want to keep the demo portion of this going because I want to see if we can get this completely ready by the end of this half hour. Let's see if I can type my password in correctly. Yes, no. And let me check my password, and that looks correct. And there we go. Much better. So we'll come back in here and we'll finish up with Podman real quick, and then we'll continue talking a little bit about .NET Aspire while we finish these quick steps up. And I'll pull my Visual Studio Code off to the side here so that I have my notes. And so we're going to finish installing Podman. We're going to go ahead and Podman machine start. So all of those pieces of software that we just watched the Winget config go and install, they're all here, they're all running, right? We have the WSL in the background, and I'm not going to spend a lot of time configuring Podman, so I'm just going to go with the quick and easy versions, but it's running. So, you know, I've been able to do all of that. So now what I'm going to go ahead and do is I'm going to go ahead and git clone eShop from GitHub, right? So we saw that I installed Git. And so I'm going to go ahead and do that. That's going to come down here pretty quick. And we're going to CD into it. And I'm going to go ahead and open Visual Studio. All right. So I've got actual Visual Studio 2026 here. We'll skip all of this and we'll start Visual Studio. And we'll go to the eShop project and we'll open this up. And you're going to see that, you know, I don't have all the workloads installed. So that is, that's something that it doesn't do. It installs the base software. But as soon as you go and open Visual Studio and I open up the eShop solution, so what's going to happen is Visual Studio is going to take a look at that solution and it's going to say, you don't have what you need installed. So we're going to go ahead and let Visual Studio install that for us. So this will only take a couple of moments to finish up itself. So I'll jump back to the slide deck again, and I want to talk can keep talking a little bit about .NET Aspire, and I use it quite frequently, and my teams are using it quite frequently in an on-premises kind of environment, right? So we're still using that strong orchestration, that strong configuration. We are using all of the observability, the logging. We use it very tight, very extensively for any kind of custom operations that we might need in order to kind of maintain our environment. So there are some CLIs that we've built, some other tools that we've built that help us maintain our database structures and other functionality that we use both in the Aspire dashboard, but we are using the Aspire dashboard as kind of an analog for our pipeline experience as well. So all of these things are in our Aspire dashboard, are also in our development pipelines, really making it a lot easier for anybody on the development team, not just one of the software engineers, but your QAs or your project managers or VAs or anybody else out there, to be able to execute on certain functionality. Say, an application needs to be redeployed, or database needs to be re-imported, or we need to create scripts to be able to hand off to somebody in the security team. All of those things that we have, created processes for in the different projects, they can be exposed both through Aspire as custom actions, as well as in our pipelines. So we just kind of, again, using it, sort of like our QA automation. So as we're using Playwright, right? We've built Playwright into the Aspire. So you have all of these different processes and devices and dependencies, and to the point here as well is that when and if we decide we want to go to the cloud, we're in a pretty good place because we have all of this information kind of ready to go. So I'm going to take that. Let's take a peek at our Visual Studio installation. So it is almost done, and we are 15 minutes in. So I want to just kind of say again, the goal here is to take a brand new machine, bare metal, a brand new engineer, without having to kind of hold their hands through the process, and onboard them in the morning and have them show up to stand up and be able to say, I have my machine up and running, the code downloaded, and the project runs on my machine. Now, they're going to have questions about, the business logic, and that's a bigger conversation on education, as everybody knows as they come in. But we've taken all of the noise away from that process by being able to make sure that the software is installed quickly, the application is easy to stand up through .NET Aspire, and there's and I'll even talk a little bit about standardizing Visual Studio here in a minute once we have this up and running. But I want to show us that we're finishing up here, we're optimizing the .NET assemblies, and in a moment we'll be able to just fire this project up, and you'll see the same messages that we typically see when installation is complete. So you'll see all the same messages you get when you have a brand new installation of .NET 10, which I'm sure that we've all seen, right? It's going to ask about your certificates and all of that. So, we'll be able to kind of take a look at all of that stuff. So I'm going to jump over here to the Solution Explorer and make sure that the app host is set as my startup project. I'm just going to go ahead and hit F5 on this. And we've been at this for about 17 minutes, so I think we'll beat my testing and have this maybe up and running in about 20 minutes. So that's kind of my my intention here, again, to be able to kind of show all of these different tools. And we'll have this going. We're going to start to get asked a bunch of questions here in a minute about certificates, and I'm just going to click through them really quickly because we've all seen them a bunch of times, and it's the first time that you do any kind of system setup. But I just want to stop and show everybody that they're there, pulling all this down. eShop is still using the RC1. That's okay. And I think it's also using the previous version of Aspire. So you'll see the warning at the top saying that it should be updated to 13. And I'm sure that somebody is probably getting real close to pushing that up there. Right, so this is project configured. These are all your default certificates the first time that you set up a new machine. And I'm not going to linger on these. Project is starting up. Yes, I trust it with all of my heart. First time I've run this browser. So we're going to just skip all of this. And you'll see the application is starting. And I'll just jump onto one of these guys here. And if you haven't seen it, right, these are all going to be Docker containers. I'm using Podman, the open source version of Docker. It's the same thing at the end of the day. It's pulling all of these Docker containers down, and it's going to start this application up. And we're going to have this up and running here pretty fast. So if I come back over here, where all of these containers have been pulled down, and the ordering API, payment processor, and let's see, which one of these is the front end? Catalog API, I think it is this one, web app. We'll see, there it is. So from bare metal to my application works using Winget to script the actual tools that you need, like your Visual Studio, your Gits, your NVMs if you're running a node and you need to switch versions of node because maybe the engineer is going to work on different projects, your Notepad++, maybe your Outlooks, your Microsoft Teams, whatever it happens to be, all of these things can be scripted out, handed to a new individual with a single command line. I just need you to run this, and they're off to the races, as you can see. And we've gone from bare metal, 20 minutes, we're up and running. So one other thing I wanted to have a little bit of a honorable mention to, as well as in this process, is Visual Studio's import and export settings wizard. So if you have a new engineer on the team and you have either a complex setup in your environment, or in Visual Studio's got a few settings or configuration settings, so you've got somebody that's just struggling for some reason and their configuration settings have managed to get themselves in an unhelpful state, or if you just want to have this as a standard setup, and this is how we configure Visual Studio, and you could have can have this as a side-by-side with your Winget config as well. So again, if I kind of go back to our demo project, and I'll just kind of draw everybody's attention to this. Inside of Visual Studio, you can import and export your settings. So I'm just going to go ahead and I'll export my settings. It'll ask me where I want to put them. They're all standard settings because this is a brand new system, and I'll just keep track of where we're going to put this, and I'll open it up, right? And it'll create a VS settings file for you. I'll finish this, and then we'll go take a quick look at this file in Notepad. Oh, maybe Notepad++ because we have it installed. Right. So we'll have this, and we can just go ahead and open this up, and we'll be able to see this is the configuration setting, and it's XML. It's a little tough to read, but the point is, and I won't linger on this. The point is that you can export these settings. You can make it very easy for any configuration settings that you might have on your machine to be, or as a standard baseline that you might have for your project or your team. You can export that information, and you can very easily just share that again with any of your team members. They can come in here, instead of exporting it, they can import the selected environment settings, or they can reset their settings, or whatever it happens to be. So 22 minutes up and running. I'll jump back to the slide deck. Again, honorable mention. This is definitely very handy as well, to be able to import and export your template settings, your fonts, your colors, your menu bars, your Windows layout, all of those things, so that it's very easy for somebody coming in on the team to just, here's kind of how we do things, this is how everything looks. Here's a place for you to begin. And again, very handy for your new engineers. This is here. So with that, I'm just going to jump over here and say, we're really kind of looking to be able to empower teams to go from setup to deployment in a matter of minutes. And as you just watched, that's entirely possible. Different teams are going to have different requirements when you start talking about your custom NPM sources or NuGet sources, things like that. Those will be additional steps, but most of those are fairly well and easily understood, scripted and documented processes where you may need to create some sort of SSH key or some sort of OAuth authentication, depending on what it is. But that's not going to really detract too much from this 0 to fully runnable and set up in a matter of minutes. So with that, I think I actually have time for questions, which I didn't think that I was going to have much of. So Jeff, I don't know if there are any questions that we could take.
So there is one, and I'm actually switching out with Jeff because he is starving, and this is the half the fun of .NET Conf.
Unbelievable. How you doing, Javier?
Great to see you, Rez, and it's awesome to see you for the tech check now over here where we have it. So I'm going to switch it to more of this camera. Yeah. And there's a really good question here, and I'm going to try to show is that Sakwir, I can't pronounce their name. It says Winget is only for Windows, right? What if the project could be only developed for Linux and Mac OS? Have you tried anything like that?
Yeah, that's a good question. So Winget itself is a Windows only platform, but if you're looking for your Mac OSs, they have something similar. I didn't do a lot of research because most of my teams are Windows, but if you want to take a look at something called Homebrew or Mac Parts, that's a place to probably take a look and get started. It's going to give you a very similar type of package management, centralized package management experience to Winget.
Absolutely. It's funny you say that because that is, I'm a consultant, right? So, and one of the things that I always struggled with is not getting up to speed, but making sure that, hey, we're all consistent in the tooling, right? Yeah. Because there's a fine line between my license as a consultant and the company's license.
Absolutely.
Right? So trying to standardize that way where we can all work together. So we just want to be efficient. Like, that's what every single person wants to just go in there and get their work done. And what you showed here is perfect for that. Like we're talking to Visual Studio settings.
Yes.
We've done that with every single team, right? It's like, okay, we're going to standardize to X.
and then we're going to export it. We're going to put it in a share or something. Everybody can import it and go that way.
Yep, absolutely, 100%. Yeah, the standardization against teams and projects, and if you are a consultant and you're working on multiple clients, being able to jump back and forth and make sure that you have everything that you need quickly is extremely handy. And that consistency and auditability, be able to just kind of look at source control and say, these are the tools that we're using. There's at least as a baseline, right? There's nothing necessarily stopping people from installing other software, but as a baseline, it's a good place to begin to make sure that we're using the right tooling from the right locations and the right software. Yes.
Absolutely. And actually, sorry, Jeremy, I just saw that you had your question up there. So our good friend, Jeremy Sinclair asked, is like, are you using solution like Stepbox for your team as well? What do you do if you're using contractors as well? So
yeah, so that's a fantastic question, and we typically, at least in my world, we're using what our clients generally prefer us to use.
Right.
In our case, they are, at least the projects that I'm working on right now, we're going ahead and we're issuing everybody laptops from our systems. Sure. And we're making sure that those laptops meet certain criteria. And then there's a zero trust kind of configuration. As far as the dev boxes are concerned, we've definitely looked at them, and they are a viable option. We just have not gone down that path.
Right. And it's funny you say that, because more often than not, I've seen clients moved to more straight up VDI through the Azure or AWS.
Yep.
And the downside of those things is not the setup; it's just the horsepower, right? Because
that's exactly it.
It's brutal to do anything once you get everything installed, right?
Yeah.
So,
no, that was exactly it. One of our clients was using something somewhat similar to DevBox, and the performance was devastating. And by moving to physical machines that we have we have quite a bit of control over, but they're still physical machines, has made a world of difference in performance.
yeah. Also, the one thing I've noticed and I know we're kind of just going back and forth with this, is that if you I have my own hardware where I would want to plug in my own USB hub because I have my monitors and everything else plugged in. Every couple weeks, I have a different security audit that gets like, hey, you've been flagged for this, and this.
Yeah, exactly.
Storage account or USB something plugged in. There's like, no, it's just my hub that I reported 3 weeks ago.
Right. Yep. But it's good too if you have if you have clients that issue you different machines too. So you can hot switch and use these tools to make sure everything's set up consistently with them. Yeah.
Well, Russ, I really appreciate it. Thank you so much for taking the time to volunteer your time and knowledge for our conference. This is what makes Community Day so awesome.
Yeah. No, I appreciate you having me. Thank you very much, Javier. And I look forward to continuing to be on the community and definitely enjoying the content that's been out there.
Perfect. Thank you so much. I really appreciate it. All right. I'm going to remove you here from the stream, my friend. And I'm going to bring up our next presenter. Jay, how's it going, my friend?
Hey, Javier. Great to see you. It's going well. Thank you.
Likewise. I hope I've been following you on Facebook and glad you were able to wrap up your trip so you can talk to us about MCPs and our APIs.
Yeah, that's right. I've been catching little tidbits of .NET Conf from out in the backcountry. So just got back from a vacation.
Very awesome. And funny enough, I consider .NET Conf as my vacation that I'm working all the time. So it's a work. But it's all for the community and everyone for out there to enjoy. You want to go ahead and share your screen when you get a second?
Yeah,
I can add that here.
All right. All right, great.
Oh, sweet. All right, adding you there, and take it away, Jay.
All right. Thanks, Javier, for the introduction. So for the next half hour here, we're going to be talking about APIs and MCP, specifically how to take existing REST APIs that you've written in .NET and to add MCP capabilities to that. If you're not familiar with MCP, we'll be talking about what that is and what it allows you to do. As Javier said, I'm Jonathan Tower. I go by Jay for short. And I've got my contact info here. I'll show that again at the end. I'd be happy to connect with anybody who has any questions today from the content that we're talking about. So just to start out with kind of the inspiration for this talk. At Trailhead, the consulting company that I helped found and currently work for, we have a lot of clients that are that have existing APIs, usually REST APIs, in the sense of that we do a lot of .NET. A lot of these are .NET REST APIs, ASP.NET, and those things are allowing other systems to talk to each other. They're allowing front ends to talk to back ends, whether that's mobile or desktop or web applications. All of those things right now exist out there, and a lot of our clients already have this. But now a lot of them are really trying to figure out how they can AI enable the technology stacks that they already have without kind of reinventing everything. And so that's kind of the inspiration for this talk is how can you take these APIs that you already have your front-end applications talking to and allowing you to then to access other back-end systems and databases and things, and kind of add just sort of a bolt-on to those APIs that gets you from 0 to 100 really quick on being able to give AIs, whether that's agentic AIs or just the classic chat AIs that we've all been using for a couple of years now, to give those access into that same data and functionality that your other applications are able to get through those APIs that you already have. So that's kind of the inspiration for this. If you're like me and you kind of need examples to understand some abstract concept like this, here's a few that I just threw together that I think are very realistic scenarios that are happening today. Some of these are the types of things that we're helping our clients unlock right now. So imagine you're creating a sales assistant that's helping you update data in your CRM and scheduling follow-ups automatically and updating you with reports and briefs and things on your sales process and your contacts. Maybe a chatbot that's helping you run reports or collect data from around your organization and give you different key performance indicators about how things are going, and maybe even proactively reaching out to you to say, hey, have you looked at this key performance indicator? I think there's a problem going on right now. As an owner of a consulting company, I really feel this one. We're always trying to keep an eye on certain key performance indicators, how happy our clients are, how much of our time we're billing. All of those things are really important to keep an eye on. How useful would it be if that data was just basically, accessible to like an agent, and that agent was coming to me and telling me proactively to take some action because some KPI is out of whack. Customer support Copilot, this is a really popular one right now. So customers, calling in, and something like 80% of those calls or those chats that are coming in are the same few things, telling them to reboot their router or asking, questions about orders and shipping dates and all of those kinds of things. And if you could hook into some of those underlying systems and answer a lot of those questions without the need for human interaction, that would be huge savings and also make things easier and more pleasant for your users. Document generation, maybe you're taking templates and then data from different systems and merging that data into those templates. That's something that agents and chatbots are really good at doing. Procurement flows, so it's time to reorder this stuff, creating POs automatically, double checking budgets and routing approvals to the correct people. And then obviously things like scheduling are a really natural fit for AIs to do for us, coordinating calendars, proposing times, sending out invites, etc. So these are all the types of things that you could unlock, and thousands of other examples if you need examples to kind of wrap your head around it. So in our time together, I want to do basically 4 things. I want to talk, first of all, about what MCP is. Probably a lot of you are already at least somewhat familiar with this. Maybe you've seen some of the other talks earlier today or the last couple of days here about MCP. But we're just going to kind of make sure everyone's on the same page about that before we move on. Then I want to talk a little bit about how MCP and REST are similar, but also different from each other. So if you're already familiar with RESTful APIs, you might be already thinking like, isn't MCP just like REST for AIs? We're going to talk about that and answer that question, which of course the answer is yes and no, or it depends, like any good engineer would say. Then we want to move on to the main tool that you're going to use to actually create your own MCP server, which is the MCP C# SDK, which has been out for a little while now and releasing new versions, but is releasing a new version here along with .NET 10. And then I want, of course, show you a demo of all of this good stuff happening in kind of a realistic application. So that's the plan for today. This is me again. Here's some contact information for me if you're looking to connect with me. Also got this QR code and bit.ly link if you want to just reach out a simple way, put some time on my calendar. And then the last thing on this slide, which I will show again at the end, is just a place that you can find all the code and slides that we're looking at in this talk on my GitHub. All right, so to start out with, just a quick introduction to MCP. So this is a definition you'll find of MCP on the internet, various places. Of course, what does it stand for? Well, MCP stands for the Model Context Protocol. And this is actually important to know that it's an open source standard. So 2 important things there. Number 1, it's open source. That means this doesn't belong to any one company. Nobody can like pull the rug out from under you if you implement MCP and suddenly say you have to pay for it. This is something that's out there in the community. And then it's a standard. It's just basically a protocol that allows all kinds of different systems from all kinds of different companies and backgrounds and creators to speak with each other. And this was introduced by Anthropic about a year ago at this time. And it was introduced as a way for connecting AIs, and that could be chatbots or LLMs or agentic AIs, to external systems. So that could be any kind of underlying system. What does that look like? Well, if you go to the modelcontextprotocol.io, which is the website for the spec, you can see this diagram here where they kind of lay out some examples of what this looks like. So on the left side, you've got here all kinds of different AIs. This could be ChatGPT, or it could be Claude, or it could be an agent, or it could be just an LLM, or it could be a development tool like VS Code, all kinds of different things over here on the left. And then in the middle is this protocol that allows all of those things to speak with all the things on the right. And you'll notice that this MCP standardized protocol is bidirectional, meaning that information can flow in both directions, from the underlying systems to the LLMs and other AIs, or from the AIs back into the systems, can make updates basically. And then what are they connecting to? Well, basically anything that you can write an MCP server for. So that could be underlying data systems like file storage or databases. It could be different development tools or SaaS products like GitHub. It could also be various productivity tools. You could imagine a scenario where in the future all of the airlines and hotels have MCP servers, and you can just ask your LLM to go find the best deal at a place that meets certain criteria that you're looking for. Maybe you want to have free parking or free breakfast or something like that, and you want to keep the price under a certain amount. And it'll go find a place, and maybe even it'll be able to connect to some of your membership information and say, oh, you're a member here and you have these rewards, and maybe you should, I'll book this one for you because of all of those things matching. So that's kind of what MCP is for here. It's for connecting these AIs to these underlying systems and to have that data flow in both directions. So how does that data flow? Well, it flows 2 different ways, but kind of potentially 3 different ways. So let's talk about what those transports are. The first and best one when you're in a local scenario is standard IO, just the standard in and standard out. That's available on basically any process that's running on basically any modern operating system from a command line or a console. And those standard in and standard outs allow you to have really fast inter-process communication. And so if you are running an AI on a particular box or virtual box, and you want to be able to connect to a system, and an MCP server that's running on the same virtual machine or machine, you can do that through standard IO, and it's going to be really fast and really secure because it's not going over the network at all. And that's really a great option for those scenarios. But a lot of scenarios are going to be not on the same machine. And so that's what the streamable HTTP transport is for. So this has a couple of different methods that it uses in HTTP. Number one, it's using posts to send data in to those external systems. And then it's using server-side event streams to get data out. So basically long HTTP GET requests, and then it's doing server-side events through those GET requests back to the client. So that allows streaming to work. So this is what you're going to want to do for any remote scenario. And this is also something that, because it's HTTP, it works really well with all of the auth stuff that you might already have that's HTTP compatible. Also works with any kind of proxies or, traversing different networks. And then the last one I'll just mention, the spec actually leaves room for there to be custom implementations of transports. It doesn't specify anything about those. And so, that's kind of up to you if you want to create your own custom one for a certain implementation, maybe a proprietary thing for your particular organization or something. But the spec does leave room for that. It just doesn't specify any other details. So the main thing you're going to use is that standard IO and streamable HTTP. So let's just kind of compare and contrast REST and MCP a little bit, because at this point, if you're familiar with RESTful APIs already, you might be thinking, isn't MCP just basically REST for AIs? And you're not totally wrong, but you're also not quite right. And let's talk about how those are different if you're thinking that way. So first of all, it's just the audience that these are for. So a REST API, if you think about it, it's basically programmers that are using this, right? You would not probably send this to your non-technical coworkers or your non-technical family members and say, here's a REST API that you can call. They're not going to know how to do that. So it's really service integrations of other developers. That's the audience that you're thinking of here. MCP, this is meant for LLMs. It's meant for humans, agents, AI agents to use. So it's really meant for a slightly more AI-oriented and non-technical audience. It should be pretty easy to set up. And of course, as the technology evolves, it's only going to get easier to basically just click on a link and say, I want to add this MCP server to my tool. As far as discoverability goes, you might be lucky enough that you've used REST APIs that have implementation of the OpenAPI standard, something formerly known as Swagger. This is a great way to kind of statically document what is existing currently in the different endpoints of an API, but it's not required to have a REST API. You do not need to have OpenAPI documentation. But for MCP, it is required, and it's actually runtime discoverable, and it allows the tools that are the AIs that are calling the tools to get a list of all the tools and resources and prompts that are actually provided from that MCP server, which is cool because it kind of versions itself. So you don't have to do anything special to update all of the AI clients that are using a particular MCP server. When they make a call to that MCP server, they will automatically find out about any tools that have been added or removed or changed in the meantime. The other one is contracts. So when you talk to a REST API, you're going to be using the contract of what's the particular URL endpoint that you're hitting, what HTTP verbs are you using, and then of course those status codes that come back are going to give you information about what actually happened. With MCP, it's particular named tools, and then there's kind of well-known JSON schemas and structured results that you can expect back from them. The invocation and transport of a REST call is going to be over HTTP always, whereas MCP, like I mentioned before, can be either standard IO or streamable HTTP or a custom transport implementation. When you're trying to orchestrate data from a bunch of different systems, you have to basically, custom write that code. Another reason why REST APIs are meant for developers, not non-technical humans, because you have to kind of stitch together all those multiple calls. So maybe you make one call and that gives you an ID. You use that ID in your next call, and so on and so forth. And you're kind of stringing together a bunch of things to make decisions and decide what other APIs to call and what data to send to them. MCP, that can actually be done for you, particularly if you're thinking about like an agentic AI that's calling potentially multiple tools, maybe multiple endpoints in one server and multiple endpoints in several other servers, and has the ability to do some human-like reasoning to decide which of those to call, and based on the response, what other things to call and what to send to each of those. And you don't really have to do anything other than document them well, the tools that is, to get those things to work together. The AI is going to do a lot of that wiring up for you. Streaming, very uncommon in a REST API. It's a first-class citizen in MCP because so much of agentic and AI stuff happens slowly and gradually. You want to be able to get that stuff as it becomes available, all the response data as it becomes available. It's obviously built into REST APIs to do authentication because it's over HTTP. On the MCP side, that kind of depends on your transport. So if you're HTTP, like if you're using streamable HTTP as your transport, then yes, of course, you have auth available to you as well. And so if you think about like the best use, REST is really meant to be the back end for front ends or for integrations as APIs. And then MCP is really meant to be a tool that you can add to an AI that allows it to call into back-end systems. So some similarities and some differences, as you can see. So now let's talk about the MCP C# SDK, which is the library that you would actually use to implement your own server or client, MCP client in C#. So this has all kinds of great tools in it. You've got the ability to do clients and servers, as I mentioned. It's got attribute-based discovery. So if you have tools or prompts that you want to expose, you just put an attribute in front of them and they're automatically discovered by your code. It integrates with the Microsoft Extensions AI stuff natively, so it just works. Transports are all included, so standard I/O and HTTP. If you're doing a client and you want to integrate this into certain chats or agents, you can do that very easily with this framework. And then last, I'll just mention that it works with any MCP server because MCP is a standard and this follows that standard. So what's new in .NET 10 with C# SDK for MCP? There's improvements to the auth protocols, so you can do more modern authentication. Allows now what's called elicitation, which basically allows the server to request information from the client. Better structured output from your tools. The ability to include resource links. Some schema and metadata improvements to make things a little more human readable, and then some simplified APIs. As the tool and SDK is improved, the APIs get simpler and easier to use. All right, so with all that said, now we're going to jump into the real meat here, which is the demo. We want to actually see this in action. So I've got a real simple API project here. You can see I've got top-level statements, program CS here. And it's just setting up a web application at localhost 5555. And I'm setting up my Swagger endpoints. And then right here is where I actually start to set up MCP. So you can see I'm adding an MCP server. I'm adding that HTTP transport. So I'm using HTTP streaming, not standard I/O. And then I'm also telling it to scan the current assembly for any tools that are registered in there. We'll see what that means in just a moment. And then for my app, I'm again setting up the endpoints in the pipeline for Swagger. Then you can see where I'm actually mapping my MCP server, which is under the /MCP root path. And then I've got some kind of custom code here that's doing minimal APIs. And we'll look at that in just a moment. And you can see I'm mapping all my endpoints right here and then running the application. So let's start with mapping the endpoints. What's that actually doing? Well, if I look at this extension method, you can see here, this is where my mapping endpoints method comes from here. It's a extension method on the iEndpoint route builder. And you can see what it's basically doing is it's looking through the current assembly and it's looking for anything that inherits or implements the iEndpoint interface. And then if it finds those, it's basically creating an instance of them and then creating a list of those. So then it loops over that list, and for each one of those, it calls its map endpoints and passes in that endpoints method. So right here, we can see that I've got one endpoint implemented. So here you can see to do endpoints, which implements the iEndpoint interface. And this is got the map endpoints method in it, so that makes it actually implement the interface. And here's where the app gets passed in. And here I'm basically setting up 4 endpoints under the /API root path, and then to-dos. And you can see I've got a get, a post, and 2 patches in there. And then those are basically mapped each to a private static method below that is kind of each of those endpoints and is doing those things. And mostly you can see it's using this to-do store. And that to-do store is kind of like a business logic layer or a repository layer that's basically going out and doing these actions to the database. So, getting all of the things, adding a particular to-do, and so on. So that's kind of the program. Now let's look at this in Swagger and see how this actually works. And then we'll look at the MCP configuration. So I'll go ahead and run this, and then we'll open up the browser. So here we are on our Swagger endpoint. And if I just go here to the to-dos endpoint and say I want to try it out and execute, you can see I get back an empty response, just empty brackets there. So I could create a new one here by doing this post method here and say I want to insert one. We'll call it demo at .NET Conf. And by default, let's make sure we spell that right. And then by default, I would want this to not be completed. I want it to be an incomplete task. So we'll put that as false. And I don't really need to specify an ID. It'll do that for me. And so when I execute that, I get back, okay, it assigned an ID of 1, and you can see that it's in there. Now, if I call this get method again, I should get back a single item in my response. So great, my REST endpoints work as expected. Now let's actually look at how I can expose these with just a simple bolt-on to this API. So you remember in my program CS here, I've got the add MCP server, and then it's saying with tools from assembly. So what that's going to do is basically scan for those attributes I was talking about earlier. So if we look at this to do MCP tools CS file, you can see it's got an MCP server tool type attribute on it. And then each of my methods in here has the MCP server tool, and then it has a description. So what each of these do is, first of all, this tells the logic that's scanning through here that this class has tools defined in it. And then each of these methods is a tool, and it's being marked that way. These descriptions are also really important. This is actually how the LLM interprets what these particular tools do and what data needs to be passed into them and what data will come back out of them. So the more descriptive and specific you can be in these, the better it'll work with your various large language models. And you'll notice even the attributes or the parameters that are coming in to these particular tools have a description on them. So this is complete, which is a nullable Boolean, and it defaults to null. You can see it's saying filter by completed status, true for completed items, false for incompleted items, or omit to get all items. So we're being very explicit there about how this works and what it should do to, pass in different values there to get different results. And if we kind of just look through this, each of these is just basically doing the same things that each of the API endpoints are doing, but they have a little bit different inputs and outputs. And, maybe I want to apply different business rules in these. So this is a great place to kind of do these separately, but because I might not want to expose all of them. And so I've basically picked and choose which ones I want to do here. And then I can go through and describe each of the parameters and the return types and what each method does. So that's what's going on here. And then the last thing I want to show you is how I can actually call that. So I'm going to go over here to Claude, which I have running locally on my computer. And first thing I'm going to just ask it is, do I have anything to do right now? And it's already been configured to have my MCP tool. So you can see that it's saying, from what I've asked, it's saying, oh, I need to look at your to-do list, and it's calling my get to-dos. And it says, yes, you have one incompleted to do, which is demo at .NET Conf. Would you like me to mark it as completed once you finished it? And I can say, yes, please do that. I'm just finishing the demo now. And it's going to go ahead and update that through the API that does updates. And so you can see it calling that, and I can actually see the response. And then it says it's done. Now, if we go ahead and execute again here in the API, you'll remember this was incomplete false before, and now it's is complete true. So it basically did that update for me through the MCP server from the AI. And now I can say, do I have anything else to do? And it's going to go call that get endpoint again. It's going to pass in the, only show me the non-completed items and says, nope, your to-do list is clear. So I've now basically unlocked all of the functionality that these REST endpoints already had. And I've basically made it so that I can now do those same things from MCP server or from a large language model, chat, or agent like this. Last thing I'll just mention before I answer some questions is that if you are hosting your REST APIs in Azure, you can also use Azure API Management to basically create wrappers around different endpoints as MCP servers without having to write any code. So if that's the level that you'd really like to do this at, and you don't care about kind of changing the business logic, but just basically handpicking different verbs and endpoints that you want to allow, you can actually do that right in Azure API Management without any coding whatsoever. So with that, I'll just use the last couple minutes for any questions.
We do not have any questions from the viewers, but I love this. This is awesome. That as a developer, you're always trying to struggle. How do I get on this AI bandwagon? Right? Because it's to quote SNL, like President Caveman Lawyer, it all frightens and confuses me. Because it's all over the place, right? You don't know where to begin. And I've been looking into NCPs and everything else, and like even agents, and like, okay, now I can actually take the skill set that I have outside of Copilots or those sort of things, right? And be able to enhance what I'm already doing, right? Yeah. And heck, even as developers, like you can create an NCP server. Remember back in the day when we had like CI/CD tools were like, hey, the build broke or something like that in emails, you can create NCP servers for your own infrastructure.
That's right. Yep.
Right. Use Copilot. Like, hey, what is the status of this build or what's going on?
Yeah. You could tell it to go look at the code. Was there some check-in that just happened? Is that what broke it? If so, what changed and who's to blame for it and who should be alerted and told, hey, don't do a check-in like that on Friday afternoon, right?
Exactly. Not only because it's Friday, kind of all wonderful things. No, but that's awesome. I really love the way you explained it. The demo you're showing, here's the REST API, here's the MCP endpoint, here's how it works. And I think the next loop and the next level here is some of the, like, ChatGPT is not the easiest way to get that NCP server configured. I'm sure Claude's a little bit better. But even for like Microsoft Copilot, it is not straightforward to just like, here's my NCP server, right?
That's right.
Because you have to create an agent. You have to go down these other things to get it working. So
yeah, this is basically a 1-year-old technology, which, in AI makes it very old. And yet it takes a long time for those things to all update and standardize and for everyone to kind of decide how do we want these UIs to look when we're adding MCP servers so that, somebody who isn't technical could be able to figure it out. And I think a year from now, we'll be looking at those tools and they will all have it be very simple and built 100%. In.
I agree. Well, Jay, thank you so much for taking the time to present. I really appreciate it. And I'm sure I'll see you later.
All right. Thanks, Javier.
All right. I'm going to move Jay from the stream here, and I'm going to bring on my other good friend, Sean Walker. How you doing, sir?
Good. How are you?
I'm doing great. By the way, I love the title of your session. A perfect 10. Next year, when you upgrade to 11, it says .NET goes to 11.
Yeah, perfect 10 just fits so perfectly from a language perspective. I don't know. I don't know if it can get better than 10, but we'll find out.
It's perfect. I love it. Well, I'm going to bring you on here with the stage and take it away, my friend.
All right. As you mentioned, my session today is titled .NET Scores a Perfect 10, and I'll explain in a minute why I titled it that way. So I'm Sean Walker, the founder of DevEssence Inc., which is a boutique consulting company that kind of specializes in Microsoft technology. I'm an MVP. I've been an MVP, I think it's been 17 years now, so it's been a long time. I'm the creator of a couple of popular open source projects. The first one that I released way back, like this really dates me, more than 20 years ago, was .NET Nuke, that some folks are familiar with. And then more recently, I'm working on a new open source project called Octane. I've also been a volunteer with the .NET Foundation for a long time. Actually, ever since it started back in 2014, I've served in different roles, always as a volunteer. And I definitely appreciate the opportunity of being part of the foundation. So my title of my session is, .NET 10 Scores a Perfect 10, is going to be focused on migrating a large-scale enterprise Blazor application to .NET 10. And I've kind of gone through this effort and got through the other side and really had a successful migration. And I think what a lot of folks, when a new release of .NET comes out, they might be a bit hesitant to do the upgrade because they don't really know what they're going to encounter on that journey. And hopefully I'm going to uncover some of those things so that when you go through this exercise yourself, you're going to be better equipped. And so the application that I'm going to be showcasing is Octane, which is a content management system and application framework that was developed on .NET Core using Blazor and .NET MAUI for the different kind of client interfaces. The tagline for Octane is build applications, not infrastructure, because it really allows you to accelerate the development of your applications that you're building in Blazor. So in terms of product features, Octane offers a lot. So one of the main features it has is multi-tenancy. So it allows you to have an installation that you can have multiple clients that are hosted within the same installation so that you can really maximize your infrastructure. And also, there's capabilities to keep the data for the different clients or tenants separate from one another. So it's got a lot of powerful features there. It's completely modular and a dynamic framework, meaning so the whole user interface is composited at runtime using Blazor components. It's extensible, meaning people can build extensions for it using Razor class libraries. And then those libraries can be integrated tightly with the framework at runtime to create like a full application with a lot of different custom extensions. It's open source, and it also supports localization. So all of the UIs that are part of Octane are localized, and there's quite a number of different translations that have been created in various languages so that people can interact with the application in their native language. Octane uses EF Core. And it is multi-database, so it does support SQL Server, MySQL, SQLite, and Postgres right out of the box. And in fact, within the same installation, different tenants within that installation can use different types of databases, even if they so desire. So you can imagine sort of the level of sophistication that's required in order to support that. And then the last thing is Octane supports all of the Blazor render modes and hosting models. So it's a framework. And so we know that developers, have their preferences on how they would like to configure Blazor. And so if you're using Octane, you can have multiple sites that are part of it. And each of those sites can, in fact, use their own preference when it comes to render mode and hosting model. So some sites might want to use static Blazor, if they're building more of a website. Others might want to use interactive rendering for like globally for that whole site. Supports that. It supports Blazor Server, supports Blazor WebAssembly for interactivity. And it also supports Blazor Hybrid. So if you want to host the Octane application within .NET MAUI, within sort of the .NET MAUI shell using Blazor Hybrid, you can do that as well. So it supports all these different capabilities. And so when I approach a new major .NET release and I think of all of these, features and functionality that need to be supported, it's a little bit scary at first, but then you kind of work through the process. and I'm going to talk a little bit about that. Octane has quite a lot of adoption because it's been around for quite some time now. I've been lucky enough to attract 57 different contributors to the framework over time. That's got over 2,000 stars, over 7,000 commits, and over 3,000 pull requests at this point. The project is available on GitHub like most open source projects, so you can check it out and get involved if you're interested. It's had a lot of different releases. So initially, I created the initial POC for Octane back in 2018, and this was at the time that Blazor was still in a preview stage. It actually had just, I think, joined with .NET Core at that point. It was .NET Core 3.1, but it was still tagged as a preview then. Octane 1.0 came out in 2020, and that was based on .NET Core 3.2. And then since then, every major release of .NET, we've had a major release of Octane. And so that brings us up to this week where, of course, .NET 10 was released. And we've actually decided with .NET 10 that we're sort of jumping version numbers, and we're going to align the Octane version number with .NET going forward. It just is a lot more intuitive, makes more sense, so that someone knows that if they're using Octane 10, that it was released with .NET 10. So that is kind of the goal. As far as application size, Octane has grown quite substantially over time. So at this point, it's about 160,000 lines of code, has more than 200 Razor components, has more than 50 APIs, 50 database tables. So it's quite a substantial application. And so an application of this size requires a fair bit of effort to migrate to new versions. So in terms of getting into the migration steps, when you're going to migrate to a new version of, like a new major version of .NET, you want to try to get involved, I guess, as early as possible. Microsoft does a great job of releasing previews of the new .NET releases. In my case, I downloaded the RC1 as my sort of starting point for attempting the migration. Of course, I could have started earlier with the preview releases, but it's sort of a matter of like time to try and figure out when the right time might be. Sometimes in the earlier previews, there's breaking changes and things that you might encounter that you might spin your wheels on a bit. But really feeding all of that feedback back to Microsoft earlier really helps them create a more mature and stable final release. So I started with RC1 and then migrated to RC2. In order to use .NET 10 and you had to download Visual Studio 2026 Insiders because .NET 10 was not compatible with Visual Studio 2022. So that was just something you had to install in order to work with the new bits. I updated the target framework from .NET 9 to .NET 10. Octane uses the directory.build.props file so that it's stored in one place within the overall solution. So I only actually had to update that target framework in one location. Updated all the package references to .NET 10, updated third-party package references where they were available to newer versions. Because often when it comes to third-party package references, is this where it might sometimes hold you back when you're doing a migration as you're waiting for a dependency of yours to update to a newer version as well. I didn't run into that problem in terms of .NET 10. I had to update all references to .NET 9.0 to .NET 10.0. This was typically in some of the new spec files. And then I also scaffolded a new Blazor web application project in .NET 10 so that I could do a comparison, like source code comparison of the various sort of more critical files, like project files, program CS, app.razor, to see if there were any significant differences that I could identify between versions. And then I could incorporate those changes into my application. Some of the compatibility issues that I did run into, these were not significant. One of them was, I guess, a new compiler message that will identify packages that perhaps, well, it basically says they won't be pruned because perhaps they're not even necessary parts of your project. And so I was able to actually remove a couple of dependencies because the compiler notified me that they probably weren't needed. Of course, you want to test after you remove them because they may be needed sometimes. There's also compiler warnings around iWebHost is obsolete. So iWebHost is an interface that's been around a long time in .NET applications. And in .NET 10, Microsoft has kind of suggested that you need to move forward and replace it with a suitable alternative. And so I migrated the Octane application to use web application.create builder. And as part of that, I guess in Octane, I think this goes way back to maybe .NET 6 or .NET 7 when there was a consolidation within .NET where you could put all of your your registrations for your services into program.cs and get rid of startup.cs. I had never done that in Octane, and of course it continued to work fine. But when this message came up about iWeb host being obsolete, it seemed like the perfect time to consolidate the Octane framework as well. And so I was able to kind of move logic into program.cs and get rid of the startup.cs class. And actually, those were the only changes that I needed to make in order to get Octane to run on .NET 10. And I'm going to show you now kind of Octane running on .NET 10. So first of all, I mean, this is the Octane solution. This is the latest code that's in the dev branch that's in GitHub right now. I'm planning on releasing Octane 10 probably tomorrow. And so that project is a standard sort of client-server Blazor project. And because it supports Blazor WebAssembly and it supports Blazor Hybrid, it has to be broken out into the separate projects, like true client-server architecture. The client project has all of the different components that are part of it, which are sort of in this modules area, and there's like a ton of different Razor components through various areas for the different features that it provides. There's also a server project, and that's where, of course, all of my my APIs reside, my repositories and things of that nature. And then the shared project follows the same model that Blazor followed originally, where the models are all identified in the shared project. We can see here that I've got the Octane server project file open, and we can see all of the references that have been updated to the 10.0.0 version number. And then some of the other dependencies that Octane has have been upgraded, but some of them, some of these projects haven't been upgraded to .NET 10 yet, but that doesn't matter because they're still compatible with .NET 10 because there haven't been breaking changes. If I go ahead and run this, we're going to see the Octane Blazor application spin up. I've already actually done the installation of it. And so this is like the standard template that is installed with Octane. I'm going to go ahead and I'm going to log in. I'm going to use the self-hosted authentication for a moment here. So I've got a username and password I can log in with. And now that I'm logged in, I've got some, additional capabilities. I can go into edit mode. I can see that there's various blocks on the page. I can do some very basic content management. This is using the Radzin text editor. So I can, if I'm not kind of a non-technical user, I can change the content, or I can flip into HTML mode and modify the content like that as well. We can also see if I go in the control panel, there's a whole lot of additional functionality that's included within the admin dashboard of Octane. So because it's multi-tenant, if we go into site management, as part of this install, we can see that there's one site, but then there's also an additional site. And if I browse to that site, we can see that this other site has a completely different look and feel than the original site that I was on. Each of these sites have, just completely separate content, completely separate set of users, security roles, files, like all the different functionality that you would expect is available in each of these sites. I can also maybe go into like user management, for example, and this is where you can set up all your various users. And if I go into the settings area, I have a lot of additional user settings. So for example, I can set up, very easily something like Microsoft Entra integration, or basically integration with any other open OIDC server, just by specifying, all of the different configuration options that are available. And then if let's say I want to log out and I'm going to log in again, I can see that I want to use Microsoft Entra, which I just show you the configuration for, and it's going to log me in as that user. So Octane has a lot of capabilities that are available so that you don't have to build things like a lot of plumbing yourself. because it offers a lot of that functionality for you out of the box. With that, I'm going to go back to the slides. All right. So one of the things that's important in an upgrade of a framework like Octane is there's basically sort of these different levels. So Octane, the framework that's in the middle here, is of course built on .NET itself using Blazor and .NET MAUI. And so we're always hopeful that there's no breaking changes within .NET. And we didn't really encounter any breaking changes in this version upgrade. So that was great. That didn't affect the Octane framework. But then other people, like developers, build Octane applications on top of the Octane framework. And so, of course, since there's no breaking changes in .NET, that means that they're going to be able to upgrade to the latest version of the Octane framework, which is going to be based on .NET 10, and they won't have to change their applications whatsoever, right? Those applications that may have been built on .NET 9 or .NET 8 or 7 or 6 or what have you will still work just fine if they upgrade to the latest version of the Octane framework, right? And this is the benefit of like using the framework model, is that you can get the benefits of the upgrade that was done to the framework itself. You don't have to change your applications until you're ready. And so that was an important consideration in upgrading a framework like Octane. Once we were able to, have a successful migration to .NET 10, just in terms of basic compatibility, then we started looking at what some of the additional improvements that are available in .NET 10 are. One of the issues that we had encountered in .NET 8 and .NET 9 is related to the navigation manager and navigate to method. For developers, it would throw an unhandled exception when they were using static render mode in the debugger in Visual Studio, and that would sometimes lead them to believe that there was a bug in Octane or there was a bug in a third-party module that they were using, when in fact it actually wasn't really a bug at all. But it could really cause some grief for people. So Microsoft has now fixed this in .NET 10. They've introduced a Blazor disable throw navigation exception property that you can put in the project file. And of course, we've done that in Octane to sort of get rid of those confusing exceptions that would be thrown sometimes when people are interacting with the application. Another issue that was part of .NET 8 and was still not addressed in .NET 9 was when it was in regards to the browser scroll position behavior in static Blazor. So as you were navigating from page to page, if you would have a lot of content on a page, when you navigated, you'd expect your browser scroll position to be reset to the top of the page. Sometimes that would not happen, so you'd end up with kind of weird behavior that you weren't used to, or at least your end users would encounter this behavior. This issue has been resolved in .NET 10. Octane had introduced some of its own custom JavaScript to address this problem in the past, and I'm happy that we were able to remove it and just rely on the default .NET 10 functionality here. Another opportunity that we took advantage of for .NET 10 was that actually in .NET 9, a new solution file format was introduced. The SLNX format, and it's based on XML, and it's a whole lot simpler than the legacy solution file format that was proprietary. And in .NET 10, an additional enhancement was added so that you could actually specify the default startup project, which really improves the usability for developers when they kind of open a new solution. The startup project will be automatically set if you set that property, the default startup property. And so we actually migrated fully away from the proprietary solution file format to the newer solution file format in .NET 10. Another improvement that was added in .NET 10 was around the navigation manager not found. So this is a new method that was introduced for .NET 10. And this was to address scenarios where perhaps someone through their browser was trying to access a route that does not exist, which should throw a 404. You don't always just want to throw a 404. You want to actually redirect the user to a friendly page so that they can see some friendly content. But you want the server to still send back a 404 error status, right? That's what crawlers expect when they're crawling your website, right? If there's a missing path, they expect a 404, not a 302 redirect. And so that sort of behavior that existed in prior versions of Blazor was a bit problematic when it came to SEO. And so it's great that Microsoft has now added this new method. And often that has to be used in conjunction with a middleware and maybe even some additional configuration. But there's some good examples now on how to do this. And so Octane is going to take advantage of this as well. The next thing I wanted to cover is passkeys. And so passkeys have become more and more popular over time. And passkeys are often referred to as passwordless authentication. And they utilize, the WebAuthn, which is a web standard that was developed by FIDO and the W3C. And the way it works is, of course, it provides authentication, but it uses a device's biometric features, such as fingerprinting, facial recognition, or even unlock methods such as PIN codes. So some of these methods are deemed or considered to be much more secure than just a standard username and password, because they're more closely tied to an individual's identity. And so that's why passkeys have become more and more popular. And I'm starting to see this on more and more websites where they're offering passkey authentication. Passkeys rely on navigator.credentials JavaScript API, which in fact has been widely available in modern browsers since September of 2019. So this isn't new. This has been around for a while and is quite mature. Both Windows 10 and Windows 11 both supported passkeys via Windows Hello. So most likely on your desktop or laptop, you probably set up a passkey where you just enter like a 4-digit code instead of entering a username and password. And that is passkey authentication. And so in .NET 10, Microsoft has included passkey support as part of the .NET Identity System. This includes both server-side APIs as well as UI components. And I'm going to talk a little bit about that in a minute. There's basically two kind of flows that you have to be aware of when it comes to passkey. So there's the registration flow when you are registering a user. And there's like sort of two different aspects to this. Obviously, these diagrams, they have the client in the middle, which would be your browser. The relying party is, in fact, the server, right, where your application's running. And then the authenticator, there's various types of authenticators, right? There are many different types, but the authenticator is what's, kind of verifying your identity. And this flow kind of flows between the server, the client, and the authenticator using public-private key combinations in order to kind of authenticate you. So there's the registration flow, the authentication flow, and they look similar in terms of what the flow is, but they sort of pass different credentials on these different flows. The .NET Identity passkey infrastructure, so focusing more on what's available out of the box in .NET 10 from .NET Identity. In order to take advantage of it, you need sort of to add a new database table to your existing database if you have an existing database. And as you can see on the right-hand side here in the diagram, you'll see all of the regular ASP.NET user tables, but there's also an ASP.NET user passkeys table that's available now. In order to get that scaffolded properly, you need to set a configuration option. And typically it's set in the add identity core declaration in the options.stores.schema version. And you can see it sets identity schema version 3. If you do not set that, then the passkey table is not going to be scaffolded in your database. And I kind of ran into that and was wondering why I couldn't get the new table to be scaffolded. And so you got to just be aware of that if you want to take advantage of passkeys. .NET Identity also provides some UI components. These are some examples of sort of the registration component, right? In your user profile, you can add a passkey, and the login. When you're authenticating, you can say log in with a passkey. I'm going to do a quick little demo on that. Actually, I'm going to skip that demo because I don't have a lot of time, but you can scaffold an application, a .NET 10 application yourself, and choose to add self-hosted authentication to it, and you will get to be able to experiment with the passkey support. The one thing I wanted to call out about the .NET Identity passkey implementation is that the way that it was implemented, just like the rest of the .NET Identity UI, is it uses static Razor components. So, if you have an interactive Blazor application that is using interactive Blazor components, it's a bit more challenging to integrate some of these passkey concepts. I'm going to explain how I had to do that. But first of all, I'm going to explain sort of how the .NET Identity passkey implementation actually works under the covers. And so there's a login, like for example, we're going to cover the login flow. So there's a login component, and that's on the left-hand side here. So the two boxes that are on the left-hand side would be client side. Things that are actually sort of running in the browser, and then on the right-hand side, the box is server side. So on the left-hand side, we've got the login component, and the login component has, a form in it where you can, choose to log in using a passkey. Within that component, it's got a passkey submit component within it. And that passkey submit component actually has a reference to a JavaScript web component. That's that passkey-submit reference. And so if we look over at the next box, that passkey submit.razor.js is a JavaScript web component. And you're probably wondering, well, why use a JavaScript web component? Well, the issue is in static Blazor, by default, it uses enhanced navigation. And so that doesn't make, well, enhanced navigation has some challenges when it comes to using JavaScript in a standard way. Like you can't just, make a reference to a JavaScript file on your page and expect it to be executed properly every time. Because as you navigate around, it's actually your requests are being intercepted, and only the sections of the DOM that are being changed are being updated, and JavaScript is not being re-executed every navigation. So because of that, one of the kind of workarounds to solve this problem is to use JavaScript web components. So there's a JavaScript web component that's been defined using a custom element. Within that JavaScript web component, it makes a web service call to the server using a post method. And you can see it's making a call to the passkey request options. It's getting back these options, and then it's using the the JavaScript or the native browser navigator.credentials.get method to deal with the public-private key. But then it's taking the credential and it's using JavaScript to insert it back into the form as a form field, and then it's going to later submit that form. It's kind of ingenious the way that this is done, but it's also kind of complicated to kind of follow what's actually happening here. And so and again, it's done this way because it needs to support static Blazor. This is not the way that you would write this if you were trying to implement passkeys using interactive Blazor. So now moving on to the Octane implementation of passkeys, I did have to make a change to use add identity core. So I had to use the onConfiguring method in the DB context because I couldn't get it to scaffold any other way. And so this is a way to get around that. Octane has its own UI for components that you can, so it basically has a much richer UI than what is available from the .NET Identity. And I do not have time for the demo, but obviously I'll post these, but the interactive method for dealing with passkeys, like especially using Blazor Server when you have a web socket and you need to refresh, the headers and the cookies. Not a lot of people know that this works, but what you can do is you can use JavaScript interop. And so they have a JavaScript interop method here called submit form, which I can call, and I can, I can set up, I can build basically a form dynamically, and then I post that form values to the server to a Razor page, which is going to be caught by that passkey.cshtml. And then it can use the .NET Identity methods to make the passkey request options, and then it's going to redirect the user back to the browser, and then it can again do the second part of the flow where it does the login. So I guess it is completely possible to use the .NET Identity Passkey functionality that's available in .NET 10 in interactive Blazor, but it requires a totally different implementation than what you'll find in the scaffolded .NET Identity. All right, and so with that, I want to thank you because I think I'm out of time.
Yes, we are. Man, that was pretty crazy. I love watching how Octane, I remember you and I talking about Octane years ago and kind of how his mic evolved over the years. And I like this kind of talk because you're showing like, here's some of the pain points, right? And hearing some of the ease of actually upgrading as you go across versions, because they are breaking changes and you're opting to do that when you go from version X to version Y.
Yeah, but at the same time, I've really been impressed with .NET over the years. I guess that, it always helps to be following along as closely as possible, so you don't have to make a big jump from so let's say if you're trying to move from .NET 6 to .NET 10 in one move, right? Yeah. That gets more challenging. But if you're keeping up with the regular major releases, Microsoft's done a great job of only having very small compatibility issues between each, and so it makes it much easier to move forward.
Yep. No, great. Well, Sean, thanks so much for taking the time to present to us. Really appreciate it. And I hope you have a wonderful day.
Thank you.
All right. Thank you. All right. I'm going to remove Sean here and I'm going to bring our next presenter, Mason Wheeler. How's it going, Mason?
Doing all right. A little bit nervous. I've never presented against a worldwide audience before.
Hey, you know what? You'll be fine. We're all here to support you. I can't wait to hear all the details about your session here. I'm going to bring your screen and go ahead and take it away. Go ahead and share your slides. There we go. Perfect. And I'll mute myself. Go ahead, Mason.
All right. So, hi everyone. I'm Mason Wheeler. I'm the creator of the PanSynchro project. PanSynchro is an ETL framework written in .NET that's used to create high-performance data pipelines. And a couple years ago, after seeing one too many data engineers complaining online about paying through the nose for data warehousing services, things like, oh, we're spending $100,000 a month on Snowflake, I thought to myself, well, I've already got about 20% of a SQL implementation working in the PanSynchro project. How hard could the rest of it be? That was a couple of years ago. Today, the project is almost complete and finally far enough along that I feel comfortable demoing it. So that hard. Data Mountain is a new data warehouse. It's a full SQL implementation written entirely in C#. Here I've got a simple console interface to a local instance. I've loaded up with ClickHouse's QuickBench dataset, and here's a query from QuickBench that I've got stored here. So I'll put it in here. And that was pretty quick considering that this is running over 100 million records. Now I've got ClickHouse loaded up also here. Let's see how fast that runs over there. I'm hoping this doesn't embarrass me because I have not actually done this recently. It's 0.35 seconds. Okay, so I know I said this was going to be faster, and it turns out a little bit slower. There's variation in these things. This is still running very quickly. ClickHouse is, as we see, it's a very fast database. It's written in C++, and I wanted to show that we can achieve similar performance in .NET. Still got a little bit of ways to go. I've been optimizing on this thing right up until about an hour ago. And I think with a few more days, I could get it under this, but let's move on. Thing about databases, they're commonly thought of as being in the realm of system languages. Well, you build them in stuff like C++ or Rust, but we've got some pretty significant cases for dealing with data that .NET is uniquely well suited to. The static compiled database code knows nothing about the structure and the queries that you're using to run it. So you've basically got two ways to deal with it. You can put everything in one unitype, box everything up into one value or one type value, and then anytime you need to deal with data, you have to box it into a unitype, you have to unbox it to do any processing on it. This is how Postgres works, and I'm not trying to throw any shade at Postgres. It's a great database, but it's designed for transactional workflows where it's dealing with small amounts of data at a time, so you don't really notice the overhead. The other solution is to statically generate statically typed code for your queries. This requires some sort of JIT. And guess what we've got built right into .NET? We've got, with other databases, they've got to build their own compilers. Typically, they'll use something like LLVM and build their own systems. Here we've got reflection.emit, we've got RuJIT right out of the box. And then if you want a higher level interface, we've got Roslyn. It's right there on NuGet for anyone to pull up. The .NET Unitype system already has object as a unitype, and the constraint-based generic system lets you insert all sorts of types into existing code and make them work with high performance. Anders famously said, a system should use static typing when possible, dynamic typing when needed, and Data Mountain exploits this capability to the fullest. Where some databases will conditionally use JIT compilation when they think it'll be useful, in Data Mountain, the C# compiler is an integral part of the entire process. Like with Pansyncro's PanSQL compiled scripts, the query gets translated into C# and then compiled, but with Data Mountain, this all happens in process. It adds a certain amount of overhead, but since this isn't designed for a transactional workflow, it's supposed to be a data warehouse that runs on heavy queries, and so we're assuming that the compilation overhead will be worth it almost all the time. Getting high-performance code in .NET is an interesting job. The .NET Core team has done a great job, and they continue to do a great job with every release, improving the performance of the JIT and the BCL. If you're attending this conference, you've probably seen Stephen Taub's annual performance increases blog posts. Talks every year about how they've done great work at improving the speed, and this project piggybacks on that to a certain extent, but there's always so far that what's built in can take you. For example, in Data Mountain, we don't use .NET strings. System.string is just too slow to work with. We start off with a custom UTF-8 string library. Well, custom is a UTF-8 string library you can find on GitHub called U8 string, and then made a few custom modifications to it to improve performance in ways that U8 doesn't really like because it's designed for general use, but that we can prove are safe, specifically in the context of the database. The nice thing about U8 string is that it's designed internally as basically a slice of a byte buffer, and so you can make other slices of an existing string practically for free. So there's no allocations, there's no GC pressure from that. Likewise, when we originally started out on this project, the SQL parser was written in Antler. Antler is very nice, it's very convenient, it's very slow. Even a simple query would take over 1/3 of a second to parse. So I kept the Antler Lexer because that's simple and pretty fast, and rewrote the parser as a simple handwritten recursive descent parser that took down about 95% of the parsing time, and about 70% of what remains is overhead from the Antler Lexer. If I really wanted to, I could rewrite that and squeeze out a bit more performance, but that's getting deep into diminishing returns territory. And we all know that the fastest code, of course, is code that never runs in the first place. Data Mountain uses aggressive filtering techniques to minimize the amount of data it ever has to look at. First, we've got simplification passes in the SQL compiler to turn more complicated expressions into simpler ones. This includes all your basic compiler stuff like constant folding and dead code elimination, with a bit of a SQL twist on the latter. If we can prove that a where condition will never run at all, then you can eliminate an entire filtering clause. If you can prove that something is false and it's chained together by an AND subclause with other conditions, then that entire AND chain can just be thrown away. Once the query is compiled, you want to run it while touching as little on-disk data as possible. Data is stored in a columnar form, which means that instead of writing out all the data as one row at a time, we've got a separate file for each column. Because data warehouses can get very, very large, the tables are partitioned into small chunks, so each of our current databases current benchmark database has 16 sets of each column file, each one containing a piece of the data. This lets the reads be parallelized across CPU cores or even distributed across multiple machines in a compute cluster. And within each file, the data is broken up into pages, which are a small set of a few kilobytes of data. Accompanying the database file is a mini index that tells the storage engine the location of each page within that file at the minimum and maximum values of all the data within the pages. This is incredibly helpful at filtering. If you can look at the index and prove that all the values are outside of the range you're looking for, you never have to load the data for that page into memory at all. And if you can prove that all of the values are outside the range, you never have to load the data into memory also. You just do a big add range on the list of row indices you're building. We've heard for a long time that getting high performance out of C# requires unsafe code. That's mostly not true anymore with all the work that's gone into performance optimizations and the advent of SPAN over the last few years. The need for unsafe code has diminished quite a bit, but there are still a few points where it's relevant. The one place in the database engine that dabbles in unsafe code is loading data pages into memory. We allocate a big block of native RAM and access it through a read-only span. And this way, all of these byte buffers stay off of the garbage collector's radar. This saves a few precious milliseconds, which can add up if you're reading enough databases or enough data pages. Then filter the columns themselves. Filtering on numeric values is done with vector-based operations to run the data the absolute fastest that the CPU can handle. The BCL's vector API ensures that this will run at the maximum possible speed for any given CPU. And it's very, very fast, except for this little block here, where I have to step outside of vector space. I've been poking Tanner Gooding from the .NET Runtime team for about 1.5 years now about a way to make this specific operation faster. And apparently it's a very, very difficult technical problem. And most CPUs, it's not even possible because they don't have the instruction sets for it. But this is somewhere where I'm watching very closely. And if anything better ever becomes available, I'm going to put it into this code as soon as I can get my hands on the bits. I want to give a big shout out to Tanner and all the members of the runtime team who hang out in the C# Discord channel. They've been a big, big help with all sorts of hairy details over the course of this project. Another thing that's crucial to high performance is locality. if you can run the same code on a bunch of data located close together, then you can keep a lot of it in the same CPU cache where everything is blazing fast. Everything that can be done in the columnar realm is done there. And at the core of the data retrieval is a method called filter and project that applies filtering to produce a list of row IDs, then projects those row IDs and a set of column IDs to produce a set of result tuples. Any filtering that can be done inside the columnar realm is pushed down into this method, and then afterwards, anything that requires you to, for example, compare one column with another column, you can't do that in a single column filter, so that happens after the projection. We try and make that happen on as little data as possible, so it's pushed to the end of this pipeline here. Once the data has been retrieved, if you're working with analytics, you usually need to aggregate it. That's what data analytics and data warehousing is all about, is producing aggregate reports of some kind. The original aggregate implementation was copied straight from the PanSynchro framework's PanSQL compiler, which is the script compiler that PanSynchro uses to build data pipelines. It has an aggregator object that's basically a wrapper around a dictionary with the aggregation logic built in. And the problem with that is that if you have more than one ag in the same query, you have a whole bunch of dictionaries doing a whole bunch of lookups over and over on the same data row. And the overhead on that, even though dictionary is pretty fast, the overhead on that will add up and get heavy quickly. So it's been rewritten, and this is going to be pushed back into the PanSynchro project very soon now. It's been rewritten into a code generation system where the aggregate logic gets created inside of the compilation process, and there's a state variable that contains all of your different ags for the row all at once. And so if you're computing multiple ags, then you would have multiple lines like this. Let's say you've got a min here or a max, using a custom hash table to save just a few percentage points of speed over dictionary. And this way you have your key lookup only once, and then you process whatever the data is, and you're done. Got it. This is about the state of the project right now. It runs the entire SQLite SQL logic test corpus, which is around 7 million SQL tests. Runs those successfully. It runs several hundred tests taken from the PostgreSQL database test corpus. So this is a working system. There are a few things that are still not working, but I expect to have this project up and running very soon now. The last few things to be done, the query overhead or the compilation overhead from Roslyn is enough to be noticeable. The earliest implementation of Data Mountain used direct IL generation with reflection.emit, but that got too complicated too quickly, so I rewrote the code generator to use C# as an intermediate step. Like Antler, Roslyn is designed for convenience rather than performance. It's fast enough for build servers and IDEs, but it's really not built with high performance computing in mind because that's just not its primary use case. So I'm debating looking at building a direct IL generator again. I'm also looking at building a CUDA generator for truly heavy data loads. Move everything off of the CPU into the GPU and see how much time that can save. Anyway, that's my presentation. And here's how to find me. Looks like we've got a time for a few questions if anyone wants to ask.
We do not have a lot of questions out there.
Okay.
But so if you want to go through a demo or kind of just talk more about that, kind of how the synthesis of the changes you've made, that'd be awesome too.
Well, I've gone over a lot of this. Where is my... Suppose I shouldn't have expected too many questions. This is a very highly technical project.
It's great content though, but it kind of shows, to me, when you cover this type of content in particular, like here's some of the technical and speed, like the pitfalls, like we're talking about fast versus slow. Here's a problem to solve and everything. Those are things that more often than not, us as developers sort of take for granted, right? So, for example, we make a call, we expect this thing to work, and we don't think too much about it, right? But the fact that you're making these changes and you're trying to figure out, okay, what are some of those performance optimizations? And it's always a trade-off, right? Performance over readability and usage of the API and everything that everybody has to make, right? And you're constantly doing that.
Oh yeah, that's always been the philosophy for PenSynchro. The idea is obsessive optimization, make things run as quickly as possible, because when you're running compute in the cloud, you're paying by the second. Time literally is money. So everything that I build with the PenSynchro project is designed to save end users as much money as possible.
Yeah. Well, it's funny you say that because, you brought up the fact, like when it's like, hey, the moment that the data has to be close to you, right? And that's one thing that you could easily fall into a situation where the data, especially in the cloud, could be in a different region altogether, right? So yeah, I'm making a call to it, but now I'm literally hitting wire to go to cross several time zones, several thousand miles to get to that data source.
Yeah, it's part of the architecture of the data files actually is that because it's columnar, it will only pull down the data files that it needs. Right. And the data files are compressed, so they'll spend less time on the wire, and then the time you save on the wire is several times more than the time you spend decompressing, especially if you're filtering out and not even looking at certain data pages within the file. So you only have to decompress what you need.
Yep. Now, the one thing you were talking about, and you were talking about making some of those performance enhances through the GPU. What are you seeing with that? I'm trying to make it work better that way, right? Because GPU is a totally different architecture altogether, right? So there's a lot more, I'll call it herding of cats, right? When it comes to the actual execution of the threads and everything that happens compared to like what you do in a CPU.
Okay. CUDA is on the to-do list. It is not something I've done extensive amounts of research into yet. And yeah, what you just said, there's a lot of squirrely things you have to deal with. It's honestly a little bit intimidating from what I have seen so far, but it is something I plan to bring myself up to speed on, because when you're dealing with truly huge data loads, just a CPU or even a cluster of CPUs isn't going to be enough.
Yep. Actually, we do have a question here. This is great. This is why I figure you and I chatting will get people to get interactive.
Sure, what are they asking?
And I'm going to bring it up here. So Zachware, it says, what are other challenges on your list of improvements in this direction? How can we help, in other words? So this is great, right? So it's like, you're not alone. This is what I think I love about the community is that we're always willing to lend that helping hand.
Oh, well, I have not released the source to this project yet. That's on the to-do list. It should be up on GitHub fairly soon. And there will be plenty to read through if you can stand to look at this highly optimized code and my idiosyncratic coding style.
Well, and the thing about it too, that's the cool part about a project, it's not necessarily just code, right? It's like, do you want samples, right? Here's documentation. Here is or issue tracking. How can we get people involved with it? It's not, because you are correct, and it's like reading someone else's code. That's for anybody takes a little bit of just a learning curve, right? Because you may take a different, you may say potato and I may say potato, right? But it's literally the same thing, right? So but trying to figure out how do I provide value to you outside of just coding, right? Because trust me, sometimes you may not want any of my code just because of I'm just special that way, but I could help in other ways.
Well, I put my email up in the last slide.
Yeah, go ahead and bring it up again so we can so I can bring it up here into the stream.
All right.
Excellent, sweet. I'm now adding that here. There we go.
And if okay.
Yep.
And if anyone wants to talk about this project, hit me up. I'd be happy to talk with you about it on here.
Yeah, so if anybody wants to help out Mason with all the work that he's doing with Data Mountain, like I said, here's his email, hit him up. And like he said, it's like he's ready to release the source code out on GitHub, which is awesome. Mason, thank you so much for...
Especially anyone who has experience with compiler engineering or with high performance computing. Any help I can get would be very appreciated.
Very awesome. Yeah. I'm sure, there our viewers, whether they're now or in the future here, once we get the video going, and ready to consume, we'll more than happy to reach out for you. So, but Mason, I want to thank you so much for taking the time to share your project, what your findings and everything with our community. It's because of people like you that make .NET an awesome community to be a part of.
Thanks.
Awesome. Well, thank you so much. I'm going to remove Mason here from the stream, and I'm going to bring our good friend of the show for many, many years, Mr. Ed Charbonneau.
Hey, I'm doing great. Hopefully you can hear me all right.
I can hear you perfect. It's like you're right next to me, right? So we got rid of Fritz because, Fritz, and you're all stuck with me until the end of the day. But here you go, Ed. We can start
needed a break.
A little bit. I'm going to bring in your slides here and take it away.
Awesome. Thank you so much. All right. So we are going to talk about designing first with natural language and Blazor for a better user experience. And I'm a big fan of natural language. And I feel that we are in this era of AI first, where mobile first was something that we were talking about ages ago. So I'm going to rewind for a minute and talk about mobile first. Do you remember back just a few years ago when we were all using our mobile phones and none of the apps and websites were built for mobile? They were all desktop. We had to pinch and zoom and it was a complete mess. And it took us a long time to get from that built for the desktop style over to the mobile responsive websites that we have today. And we were in that pinch and zoom mode for a really long time. I feel like that's where we are with AI first right now. We are in that pinch and zoom era, and we are trying to figure out what exactly AI first is and how do we get our existing applications to play with AI so people can be more productive. And one of the things I've seen a lot of is we have these blank canvases with a giant text box and a button, and users are supposed to understand and know what the application does. And really, it's hard to tell just from an empty text box and a button. And these AI-powered apps are typical of this. And users are really confused by it. Like, they don't know exactly where to start. They know they can maybe enter something in the box, generate some text, and so on. So there's a problem right now that we're all facing, and that is that developers have to know how to build these new AI-first applications. And then, of course, the users have to understand how to use these AI-first applications. And there's this big disconnect right now that we're all trying to figure out and be the first ones to get these apps just right. And I think one of the problems with AI in the whole conversation with developers is we see a lot of chat demos. We see a lot of chatting with AI. It's become the to-do list of AI application demos. And I think this is really selling the capabilities of large language models short, because one of the real gems here is natural language processing. And what that is the ability for us as humans to talk to and interact with software like humans. So I'm going to try to stray away from the typical chat demos when I talk about AI today. And let's start things off by talking about smart components. Smart components are AI-enabled user interface components that are an evolutionary step towards user experience rather than throwing away our entire application and presenting the user with a blank text box. And we saw some of these come out of Daniel Roth's team on the Blazor side with some examples of how AI might interact with some user interface components. And one of the better ones is this response, the autocomplete text box. And this is more than just your normal autocomplete. This is autocomplete that's contextually aware of our application, and it can help us fill in information that's pertinent to the app we're using. And then we can also do things like semantic search. So this is allowing us to do search rather than by a text, searching by specific literal text. We can search by semantic meaning of that text. So for example, if I wanted to search for dairy, I might return some things like milk and cheese. Or if I wanted to say, I want the opposite of milk, I might get something like hot sauce. So this is a very powerful search tool that we can use in our UI components that let users interact and search much more fluently and interact with them more in a human-like way. And large language models have a lot of capabilities that we can leverage in our user interfaces. We can transform and translate text. We can do language-to-language translation. We can talk with natural language. We can work alongside relational data. And code for large language models is just another language that it understands and can interpret. So try to keep some of those things in mind as we go along. So one of the things that I do is I work at Progress Software on the Telerik UI for Blazor components, and I was looking for a way that I could start moving some of our UI components into the AI space. And one of our most popular components is the Telerik data grid. And I thought, how can I let users do all of the functionality of the Telerik UI data grid, but use natural language? Right now, they can sort, group, filter, page, and do all sorts of things, but they have to understand where all of the user interfaces are to do all of these activities. And I thought about some of the challenges of how users could interact with AI and how AI could process the user interface that's on the screen. We could give the AI the entire web page and allow it to understand what that web page is and try to manage what the user's request is, but that's pretty complex. There's a lot of DOM rendering going on. There's HTML, there's CSS, there's JavaScript and events. So that didn't sound like a real potential solution. So I started looking at what is the lowest barrier to entry for getting AI to understand what our user interface is doing and how the user wants to interact with it. So when you think about large language models, keep in mind that all of the things that it can do are not mutually exclusive. So for example, we can feed it code and data schemas, text in any language, and give it unstructured data. And our outputs can be code, translated text, and structured data. And we can mix and match these as much as we want. So what I came up with was this control-based, state-based strategy. And I'm going to show that to you now. We're going to jump into some demos, but the idea behind it is I'm going to extract the metadata from my UI. I'm going to send that to AI and let users query that metadata and process commands against it. So let's jump over to Azure AI Foundry, and we're going to do a quick and fun demo here. So I have some prompts that I'm going to put in Azure AI Foundry. I'll take those off to the other screen for a minute, and we'll paste it over here. And what this prompt says is you are an AI assistant that helps the user query and JSON data. And you are a JSON parser. Sorry, I got a little piece messed up there. So we're going to give it a user query, and we're going to give it some JSON data. And we're going to say you are a JSON parser. You will use the user's query to modify values in JSON format. Only update the values in JSON data. Don't modify the properties. And there's another typo in there. Sorry about that. Do not modify properties. And that is our prompt. I think when I pasted it in, it kept the original text in the text box and kind of got stuck in the middle there. So we are telling the AI to only manipulate the data that is in a JSON schema. So the first thing I want to do is give it the JSON schema. So I'm going to say JSON data to identify that this is my JSON data, and it's going to have a data object that has a first name and a last name, and the property values are my first and last name. So let's give it that, and it's just going to echo that back to me. Now, what I'm going to do next is give it the user's query. So it has this first and last name properties here. I'm going to say go ahead and swap the first and last name. Let's see what it gives me back. So it is giving me back my last name now as my first name, and then my last name is Ed. So it has swapped the values for those two properties. So it's smart enough to understand that I wanted to swap the values and not the positions of those properties within the object. So let's give it another query, and we'll do something a little bit more interesting with it. I'm going to say, use the phonetic spelling of my name in Bulgarian. So now we're combining a couple things here. We're giving the AI data. You could say this is code. It is JSON. And we are now using another language here. I asked it to translate into Bulgarian the phonetic spelling for my first and last name. And you can see that it has done that. So I'm going to go ahead and reset the data here. And we're going to do something a little, actually, let's keep it the same. This might be a little bit more interesting. Let's use another language to translate this one more time. So I don't know how to speak German. I used a translation tool to get this, but I'm asking it again to use the phonetic spelling, but this time back to English, but I'm using German. And it's going to think, and we come back, and now I have Ed Charbonneau back. So now it has taken the German language command and reset the values in this JSON object back to English. This is a very powerful tool that we can use to our advantage. So we're going to take this concept and apply it at a broader scale. So in this state-based control strategy, what I'm going to do is extract the metadata of the teller data grid, give that to the AI as JSON data, and instruct it how to manipulate that data as if the user was interacting with that UI component. So let's take a look at what that would look like. So we are going to go to an application that is running using Aspire, and this is a Blazor application written using .NET 10, and it has a teller data grid on it. Now again, I can do all sorts of things with this user interface manually. I can sort, filter, and apply all kinds of ways to parse through this data. And as a novice user, I might not know where all of those things are. What I'd rather do is just talk to it. So I'm going to open my AI assistant here, and I'm going to say sort amount in descending order. Now, because I have speech to text here, I'm able to just speak the command, and I can press apply. And now when I hit submit, it has sorted the amount in descending order. I can also do things like group. And notice that in my user interface here, I have some predefined things for the users to just select from. And this is a nice way to do user experience with these AI tools, is to provide some easy prompting that they can click on and interact with. So we'll go ahead and hit apply here, and notice it has applied our grouping. So what this is doing is, behind the scenes, we're taking the state of this grid and we are giving that to the AI. So it has all of the metadata. What is the current columns being sorted? What are the current columns being grouped? And then when the user asks a question, it's able to manipulate that metadata. And when we get it back in our Blazor program, we just apply that state to the grid. And now it is working as if the user is manipulating it with their voice. So this is just one concept that we have with these natural language interfaces. Let's take a look at some other capabilities the application has. So we're going to go to the home page now. And we're going to start talking a little bit more about multimodal large language models. So what we can do with multimodal large language models is we can feed them things that are not only text, but images and voice and audio and all sorts of things. So this application is taking that idea that we used for the data grid and expanding it a bit further. And it's allowing me to control the actual application itself. So you'll see me hook deeply into the Blazor framework with this as well. So first of all, let's see what its capabilities are. So I'm going to press the speech to text button, and this is going to tell the application that I want to talk to it.
I'm here to help.
So hopefully the audience can hear you when you say you're here to help.
Yes, I'm here to help, and I hope the audience can hear me clearly. If there's anything you need assistance with, feel free to ask, and I'll do my best to provide the information you seek.
What capabilities do you have?
I can assist you with a variety of tasks, including providing information through basic chat, handling return merchandise authorization queries with the RMA Assistant, managing data grids with the Data Grid Assistant, and enabling voice input and output for easier interaction. If you have specific questions or need assistance with any feature, feel free to ask.
Okay, so somebody in the comments said it was loud, so I tried to turn it down. Hopefully that helps. So let's ask it to do something. It has an idea of what its capabilities are, and I'll tell you in a minute how it knows that. So let's ask it to do something like change its voice. Can you change your voice?
Yes, I can change my voice. If you'd like to select a different voice for the speech output, please let me know, and I can retrieve a list of available voices for you to choose from.
What voices do you have?
The available voices are Alloy, Echo, Fable, Onyx, Nova, Shimmer, and Ash. If you'd like to choose one of these voices, just let me know.
Sure. Can you change your voice to Ash, please?
I've successfully changed my voice to Ash. If there's anything else you need, just let me know.
All right. So it was able to change its voice just by me asking it to change its voice. And you'll also notice that it gave me a list of voices. When I asked it if it could change its voice, it said that it had several voices to choose from. And it said it could retrieve an available list of voices before it did that. So let's take a look at what it's doing behind the scenes. And sorry, I don't have a Jeff Fritz voice. Maybe 11 Labs and Jeff could collaborate on something and hook me up. All right, so the first thing that is happening here is the AI has a list of tools that it can operate. And on my main chat interface on that home screen, You can see that I'm using the Microsoft Extensions AI library, and I am giving the AI tools that it can run. One of the things that it can do is get voices. So if we look at get voices, it is going to call a method called get voices. And if we keep going in, we'll find that this is a text-to-speech service that I have running in the background. And this is using Azure AI services, and it's pulling in that list from Azure of available voices that I can use with my API key. And once it has that, it can relay that back to the large language model to form an answer on what voices are available. And the way this works is the tool is described with this description. It says this method gets a list of voices from a speech provider. And then it also has a tool that can set the voice for the application. So what this is going to do is when I ask it to change its voice, that voice will come in as a parameter, and it will call a method to set that selected voice. So that was what you just saw happen there. So I have tools that I can give this AI assistant that it can run and use code within my application. And this is basic tool calling. I know you've seen MCP mentioned a lot today. This is like a localized version of MCP. It's just running code and methods within my own application here. So let's see what else we can do with this. What can this application do?
This application provides various features, including voice input and output for interaction, a basic chat interface for asking questions.
So I'm going to interrupt it because it's going to go on and tell me all
I'm
the things
here
that
to
it
assist
can do.
you.
Oh,
If
my.
you have any questions or
It's getting a little bossy. There we go. Let's calm it down. All right. So it says it can manage the data grid. So it shows the data grid assistant that I showed you earlier, and it mentions an RMA assistant. So let's see if it can take us to that RMA assistant. Can you show me the RMA assistant, please? Notice I'm hands-free here, folks.
I've navigated you to the RMA
It did that
assistant.
automatically.
You can now explore options
Just
and
5
features related to return merchandise authorization. Let me know if you need further assistance.
So how did it navigate me just by using my voice? Well, once again, we have tools that we gave the AI. So we'll look back at our chat options here, and I have a voice settings tool, but I also have a navigation tool. And my navigation tool has a method called getRoutes. Now what getRoutes does is it goes through an array of routes that are available, and all of the routes that are in my Blazor application are described with a little bit of metadata. Now this isn't your normal metadata though, this part is, but what is attached to it is what makes this work so well. So what I've done is I've taken this main menu of data, and I also have a main menu vector data set. So the metadata that has all of the routing information and the names for those routes, the human language names for those routes, is stored in an in-memory vector store. So when I'm in the application and I ask it about a certain functionality in the app, it can do a semantic search to find the route that it needs to route me to that part of the application. And why that matters is people might not ask for the page that they're looking for in the exact terminology that it's listed in the route or even the description. But if I use semantic similarity, I can get pretty close just by using natural language. Now, once I use getRoutes, the AI has a tool called Navigate2, and I'm going to speak the query that I want. There's going to be a vector database search, and it's going to find the route that it needs to navigate to and pass it to the Navigate2 function. So the AI is doing the tool calling here to navigate the application. And this is actually just tied directly into Blazor's navigation manager. it's going to go get that URL and pass it in so it can route us directly to it. So that brings us to our RMA assistant. Now, the RMA assistant is another take on this state-based control strategy. And you'll see a little bit of the tool calling and some of the state that's passed back and forth in the debug window while we fill out this form. And this is a pattern that we can apply to existing forms and now enhance them with AI to make them easier. So I had an RMA form that was very manual, and I wanted the assistant to walk users through filling out that form. So now what we can do is we can just interact with this AI assistant, and it's asking me to get started and provide an RMA number. So again, I can use voice. I can say my RMA number is 1735B. And we'll go ahead and send that to the form, and it's going to fill in the correct field. Now it's asking me to provide my name. I can just go ahead and type that in. So we have multiple ways that we can input these values into our form, and we can easily and quickly walk through this with our AI assistant. Now it's asking me for my email address, and I'm going to try to throw it off a little bit. I'm going to say my email address is 555 Main Street. And it says it looks like I've provided an address. Can I clarify an email address? I've seen this actually do multiple behaviors. That's one thing that's really interesting about these live demos. Sometimes it will actually fill in the address knowing that that was an address and not an email address. And then it will invalidate the email and ask for it again. Let me try it one more time. There we go. So it's invalidating the email at least. So let's see what the tool calling is in the debug window. So it asked me if I wanted help filling out my form. And then when I replied with my RMA number, we sent some JSON data up to the AI. And it used an update form method and assigned that RMA number. And then it responded back on its status. The next time it asked me for data, I gave it my name, and it called the update form method again. And then when I mistakenly gave it the address, it asked me to clarify, and it made sure that the data I gave it didn't go into the email field because it was an address, not an email address. So it called the clear form tool to make sure that the email didn't get accidentally set with that mailing address. This is an interesting problem that I ran into when I was building this, is before I gave it dedicated tools that it could call for specific scenarios, when it would get bad data, it would completely kill the form. It would clear every bit of data from it. So it's important when you build these things to give them designated tools that they can use to do various tasks. So let's go ahead and continue filling this out. So we'll say ed@telerik.com is the email address. We'll give it our Main Street. Oh, doesn't seem to like that now. There we go. Took it that time. I'm going to try to quickly enter some data in here because there's something else I want to show with this demo. So we'll say this is a smart oven. Say it's a model AB. Enter some numbers for a serial number. Return reason defective. It doesn't like that. Broken. All right, so now it's going to ask me for a date. I have a date picker. I can also enter data using the AI assistant. And then I have a condition, we'll say used. And this is something I thought was really interesting here is now I have a drop-down box. It says repair, refund, store credit, or exchange. So let's say I want my money back. And let's see what it does. Okay, so it's invalidating that. And it says that it found something similar. I can ask for a refund. So what it actually understands the values that belong in this text box because it has the metadata for all of those values in here. So it's not going to set it to something that isn't in the dropdown. And it also has validation information too. So if I ask it to go ahead and submit the form, it can try that, but it's not valid, so it won't submit it. So, whoops, I asked it for a refund, and it figured out I wanted a refund. Now it's asking me if I'd like to submit the form. We'll go ahead and let it do that. So we'll say, sure, go ahead and submit the form. And you can see it has been submitted successfully. And in this tool call, you'll see every time I entered information, it's going back and updating my form using the tools that it has. And I'm going to ask it for a summary of that form. All right, so I have my email summary. And it says, here's the details from your RMA. I'm going to go over to Copilot. And I'm going to ask it to translate this for me. So I'm going to say, Copilot, translate this into another language. What's a good language here? We'll do Swedish. Okay, so I have my form data now in Swedish. I don't know Swedish. I can't really validate that that is actually what it says, but I'm going to go ahead and clear this entire thing out. And let's start again from scratch. This time, instead of going through the form step by step, I'm going to go ahead and just paste this entire thing in Swedish and hope that this works. So we'll go ahead and submit this. And the large language model is able to take all of the data that I just pasted in, even though all of the fields are written in another language than they are on the form. It can still form that semantic relationship between the form fields that are in the form and the ones that are in the text that I pasted. And it's going to go through and field by field insert those into my form for me. So what this means is a user could interact with this without having to know the native language of the UI that's being represented. So you could think of the data grid component that I showed you. You could interact with that using your voice in your native language, and it's just going to work. There's no extra work for the developer to make that happen. So this is all using Microsoft Extensions AI, giving the AI JSON data and describing to the AI how to process that data and asking for JSON data back. We get that JSON data back, and then we can apply it to objects within the application. So I see a lot of chatter in chat. I'm almost out of time, but I'll try to take a question if I can spot one here.
So funny enough, chatter is around. Can you do your voices?
So you're breaking up a little bit. I couldn't hear what you said.
The chatter is around. Can you do different voices?
I still can't hear you. I'm sorry. Your microphone is really breaking up bad. I don't know if it's my audio or your mic. I don't know if anybody in chat is getting that as well, but the audio is very choppy for me.
How about now?
It's a little bit better.
The chatter was. Can you use voices?
So I'm getting a lot of people like the voice recognition, voice output part of it. Yeah, folks saying that your microphone's bad. I'm so sorry. Yeah, so the homepage that interacts with voice, this is all using Azure services, and it is using the Azure speech-to-text service to generate the audio, and then Blazor is playing that audio when it receives it on the client side. There is also an animation that you probably have seen at the bottom when it does talk. We'll trigger that one more time.
I'm here to help.
So that's actually taking the audio that's playing and converting the waveform into into canvas animations, and that canvas animation is strobing behind the scenes. So the application's actually aware of this voice animation, how it was built. Can you show me how to do speech to text?
To use speech to text.
Gave it the wrong command.
Can you hear me now?
It seems there was a misunderstanding. I'm here to help.
Yeah, I think I can hear you.
It seems like you've used...
Sure.
Trying to get my application to stop listening to me. Yeah, so the entire application, let me pull up my slides real quick as we go. I know you've got another guest probably next. We'll put this up so people can get the links. Is this working? There we go. We'll just leave it like that. You can grab the grid bits at telerik.com. I also have an AI course coming on Dome Train, and if you grab the link there for Code Magazine, you can read about how this was all built. And the bits are up on the Telerik AI showcase on my GitHub if you want to download this and check it out yourself. There are a bunch of keys that you'll need for various services, but if you plug those in, you should be able to get it working.
Awesome. Thank you so much. I appreciate it.
All right, thank you. Goodbye, everybody. Hope you enjoyed .NET Conf.
All right. Hopefully you can all hear me now. I think there was an echo with what Ed had. I'm going to bring our next presenter, Paul. Can you hear me okay, Paul?
I certainly can.
Perfect. Welcome to Echo with trying to hear the demo from the interaction and so forth. So I'm glad it's all fixed. But anyway, without further ado, go ahead and take over, and can't wait to hear about it.
Thank you so much. Good morning, good afternoon, or good evening. And it's great to be part of this amazing conference. Now, my name is Paul Usher, and I'm a technical evangelist here at DevExpress. I've actually been using the DevExpress tooling for about 22 years to help create beautiful functional apps. So we're going to see a little bit of that in what we do today. But before we start, a little bit about my history. I started working on mobile apps back in 1991, which interestingly is when the same year that Tim Berners-Lee introduced the internet to the world. I've worked on everything from Psion handheld Series 2, Series 3, through early Windows devices, Nokias, and in fact, pretty much everything since then. So if it had a screen and crashed, I've probably worked on it. These days, of course, it's more about iOS and Android. And because there's the bring your own device concept in businesses, it brings a whole new set of problems and things that we have to overcome, particularly with Android. And there's, again, going to be a little bit more on that as we move forward. What I've found really helpful over the years is to actually understand some of the native languages that are being used on devices. So I was quite happy writing in Objective-C, Swift, SwiftUI, and Kotlin. That's helped as I moved into frameworks that supported the concept of write once and run everywhere. And of course, there's been a lot of different vendors over the years moving into that ideal of a single code base. Everything from Cordova, Ionic, Xamarin, Xamarin.Forms, we've had FireMonkey, Flutter, React Native, KMM, Uno, Avalon UI, and of course MAUI. A lot of frameworks attempt this process of write once, run everywhere. But one thing that I've learned with my 30+ years experience doing this is really it's write once and fix everywhere. And today we're going to have a look why. When you hear the term app developer or somebody says, oh, we want an app built, it's important to consider the different markets that are out there. And by that, I don't just mean devices and platforms, but specifically development differences, corporate versus personal. You're going to have cases where there are internal users inside an organization, or you might be building something which is B2C or B2B. And then there's the applications where you've got the worldwide consumers, the end users that you're never going to actually know or understand what devices, what operating systems they're running on. So I feel it's important to actually know the audience. See, internal users, they send friendly emails, whereas worldwide consumers, they tend to send 1-star reviews. Another pain point, regardless of platform, is devices. And you've got to consider when working through these as to what device you're going to be targeting. Are you going to be looking at just mobile? Are you going to be doing mobile and tablet, or maybe both? With that, there's some serious UI considerations. And what I found is it's okay to be bold. It's okay to have views and pages specific to a device type and then determine on the fly which one you're going to do. Don't try and cram everything onto one specific screen and think that just resizing is going to work. Another thing to consider is orientation. What happens to your app when the user decides to go between portrait and landscape? Now, early versions of Calculator, Apple did a great thing where it would switch between a traditional calculator and a scientific, which was a great use of that shift. These days, the user gets to choose whichever they want anyway, regardless, but I think it's lost that slight edge. And I know that inside MAUI, we've got a notification to say when that screen size or screen orientation has changed, but there can be some quirks, so be very careful if you're playing around with that. It can tend to be a little moody, but it gives your app an edge if you're doing something a little different when you play with orientation. Another quick tip here is to keep your libraries updated. Now, I'm going to recommend a minimum 6 months, absolute minimum of maximum of 6 months. And when I say updated, we're talking about keeping your frameworks and your libraries to the latest version and then republishing an update to the app stores. That can be done under the banner of bug fixes or internal updates, but it's important because if you get too far behind, what can happen, particularly iOS land, is you end up having to scramble to find fixes for things that have happened during your last major update. So it's really important. My recommendation there is make sure that you're doing a refresh every month to make sure you've got the latest libraries and frameworks updated. Now, this talk is based around my experience with business-based apps. So things like internal programs, B2B, B2C, and focusing on mobile first. And I understand that MAUI allows us to target the desktop apps, but what I typically use is MAUI for mobile, Blazor for web/desktop if it's cross-platform, and WinForms for pure Windows. What I also think is pretty cool when developers get together is to understand what their toolbox or what their arsenal actually looks like. So I've given you a quick slide here as to some of my setup and the things that I get into day to day. And I run off a 16-inch MacBook Pro, which is as spec as I could get. The benefit of that is the raw power and the fact that I don't spend time doing copious reboots or running out of resources. The pitfall, obviously, with that is the sheer price of having to do it. But it's definitely, as a professional developer, a tool that I think works well. My day-to-day stuff is based around Mac OS, so I tend to use JetBrains Rider for my main IDE. I run Parallels Desktop and Windows 11 with Visual Studio 2026 now for Windows development on that Mac. And we can see that it's important to have access to such things as Xcode, Android Studio. I've got my essential plugins, and I want to do a special call out here for .NET Meteor, which is a VS Code extension, really, really powerful for working alongside with your MAUI projects, allowing hot debugging, some great visual stats coming back. And if you use VS Code as your main IDE, it's a phenomenal thing in your toolkit. For debugging, Android Studio, Xcode, there's a couple of other JetBrains tools there. Console.WriteLine, I think, is one of the most underused things when diagnosing problems, especially if you're using it internally. And I've got some examples as to how I use that later on. Writing things back to database logs and actually embedding things like screen capture into the application can provide critical feedback when working with a particular problem or something that you've not encountered during your production. Everybody's talking AI, and I tend to use ChatGPT regularly in my sessions. And I actually asked ChatGPT this morning, what's the benefit of AI in development? And one of the things that I thought was interesting when it gave me the answer was the fact that AI isn't the answer. It's not going to replace me as a developer. It's not going to replace the experience or the design and the architecture skills that I've built up over the years, but it is there to be a great asset tool and take some of that pain away from me, which is really nice. My preference when working inside or my general mobile building is to work with the iOS operating system as opposed to Android, and then test everything on Android as I go. And the benefits I've found for that is with my setup, the simulator works really, really nicely. It works faster than the Android emulators. And I've got direct access to the file system while I'm doing my debugging, which is something that's a little bit more tricky when working with Android. The other cool thing as a side note is when I provision my iOS applications, there's a little tick box that allows you to say, I want to run this on Mac OS. So I can actually run it as a native app on Mac OS alongside. So let's get into things such as provisioning profiles. Now, when we're deploying an application to a device, we need a profile, be it Android or iOS. And typically, iOS can be a little bit more stubborn. You create a App Store profile, something that's going to get baked in. We can jump in and have a look at what the plist would be linked to here, and that's all well and good. But at that point, I'm limited as to the devices that I can run it on. Yes, I can run it through TestFlight, and that allows me to go through the pipeline through to release. Now, the benefit there is that I don't require any registered devices. But the pitfall is that if I want to get people on TestFlight that are not directly part of my dev team, it has to go through an external app review with Apple. So that can sometimes take 1 or 2 days. So if you want to get something out there for quick testing, it becomes a bit of a pain. What I tend to do in this scenario is create an additional profile for my registered devices. Therefore, just by changing my profile or bundle identifier to that of my test profile, I can quickly create an IPA that can be thrown up onto a website, and my registered devices can therefore be able to jump in and do what they want at that point. Android profiles, sideloading is becoming more and more difficult. Whereas in the past, you just tap a button 6 or 7 times, enable developer mode, off we go. Google are making it increasingly difficult to sideload apps in that sense. And in fact, coming into 2026, they're making it a lot more, or putting in a lot more strict rules around what we can and can't do for submission. Another thing with the Android ecosystem is there's still 32-bit devices running around. There are cheap model tablets, etc. You go to install your app and you find that, hey, it won't load. It tells you some weird message, and you find that you've got to go back into your IDE, change the devices that you're supporting, rebuild, and then try and test that again. Now, with that in mind, you've got to consider bloat on your actual APKs if you're doing it by this method. So there's some quirks around what you're going to use there. My preference when working with Android debugging on my device is Genymotion and using the emulators through that app, or Android Studio. I've just found Genymotion, the devices, to be more widely available, more generic, and provide us some better options when testing. Now, if we think about App Store submissions, there's a lot of pitfalls around this particular process. And what we need to consider when talking about submitting our app to Play Store or to Apple App Store is that the testers have got no idea what your application actually does or how to use it, and they approach it cold. And if you've had any interaction with them, you certainly feel that. You get things rejected for silly reasons, such as, oh, you didn't allow us to create an account. And if it's a B2B app where you know full well that the accounts are going to be present and that there's no extra setup required, it becomes a back and forth, back and forth. Unfortunately, what then happens in the terms of, say, Google, is you can be not only rejected, but have your app suspended where they won't allow you to submit any more updates. So if you're working with a closed network or you're working in a complex setup, it's worthwhile having a custom test server and your screens pre-configured so that when it goes through the testing process, they don't have to think. They are terrible at reading through instructions that you might send. And it's also helpful if you send a video of how to use the app or the app being used so that they've got something to compare against. The last thing you want is to get an email like this where the app is suspended, especially if you're a startup. And this email came through where this was the developer's first attempt at submitting to Google Play Store. They went 3 times with, this is what you need to do to get past that. This is what you need to do to get past that. And in the end, Google came back and said, your app's suspended. You've not actually done anything wrong other than we can't figure it out. And at that point, the app cannot be reapplied, or you can't submit a new app. You've got to create a whole new profile and go through that. The other downside as part of this was because there were no other apps on the App Store, the developer was then in danger of being suspended completely from Google Play Store because they didn't have an app and there was no activity going through. So it can be a little bit tricky in that sense. Pitfalls when actually working with mobile applications. And you've got to think, your user is using your application on their device, particularly a phone, and a phone call comes in. Well, your app's going to be moved to the background. You get very little warning inside your application other than it's going to be suspended. During that process, the operating system can decide, hey, we're getting rid of your app altogether. We're going to terminate it. And if you're in a B2B app, in particular, you've got data in there that the user was in the middle of working with, you want to make sure that gets saved. So it's imperative that you think about all the different interruptions or chaos that can happen in the life cycle of your app. And as good as MAUI is, there's times where if you're not writing at a low level, you're just working on that write once, run everywhere concept, that your application might not end up doing what you want. Other scenarios are that the user switches to another app, or that there's a low battery situation, or the user just presses the power button and puts the device in their pocket or their bag. It's up to you to ensure that the notification to say, hey, I'm going to be suspended, you do something critical. You store your data, you store your state, and get ready for the fact that your app might be opening cold from that, and you can then decide what you want to do with it. Other things that I've come across, and particularly more recently are things like visual inconsistencies. So if we switch over to Writer and make sure I'm in the right application, I had the case where I had a beautiful icon design, had a splash screen designed, and when it got shipped out to the devices, looked perfect on iOS, and on Android, it looked balked. It was, the splash screen was half cut off, the icon didn't look the same. I'm thinking the concept is that I just provide a file and it works. But the reality is, with the operating system changes, with different things, you can look at providing unique files per device. And it's as simple as, in this case, providing an Android SVG and an iOS SVG, and exactly the same process for the splash screens. Now, if we just jump over to Finder for a second, we can see that pretty much the two files are identical. There's only semantics inside the way that the SVG is created with sizing and boundaries. And exactly the same on the splash screen, where the core differences to actually make that work were minor, but they were enough that frustrated me when it came to actually seeing it on the device. So inside your project file, to implement something like that is simply creating an item group with a condition and nominating the framework. So .NET 10 Android, .NET 10 iOS, and actually providing the particular screen image that you want. And exactly the same for the actual app icon. Little thing, but it can make a difference, particularly if you're looking at presenting or running your app for the first time on real live devices. One thing that I came across was that this will create some interesting discussions backstage, but I've never been a big fan of Entity Framework and prefer to do the SQL work on my own. That aside, working with SQLite, which is the underlying database system on Android and iOS, that I came across, it wasn't thread safe. Now, for a number of applications, what would happen is I just read what I needed, wrote what I needed, everything was happy. And then I started to implement a background sync into an application. And when doing that, I started getting some strange results from the end user saying this message has come up or this isn't happening as it should. And on investigation, discovered that the actual SQLite database was becoming corrupt. More investigation, and yes, what was happening, because I had a background sync engine running, it was trying to do some reads and writes at the same time that the actual user was doing other things, causing some reads and writes, and boom, no messages, just the fact that the database ended up corrupt. So to get around that, it was a simple matter of implementing the semaphore slim, and then inside my async methods, actually making sure that the operation was going to be available, that there was nothing else used in that sense, and that the semaphore would take care and queue what was happening. So I could still just call my methods as I needed to, and the database would no longer end up with that particular issue, which was phenomenal and has been in place ever since and works well. Talking of the background threads and the way that works leads me into the whole idea of network fragility, and that you should design your applications as offline first. Yes, we've got access to internet, we've got access to VPNs and things, but not all the time and not necessarily when you need it. So in the case of having a background sync engine, I would need to check and say, is the internet available or is the network available? Yes, now do my process. So it's critical that when you're doing any of your design, you can't just expect that the online server or API that you're hitting is going to be there, and you've got to work through what you're going to do. Now, in this particular class, I run a simple thing of 2 HTTP handlers, which is created when the application starts up. I've got a client and a service, and passing through simple things like presetting the API key, as we can see here, and setting the time spans. A side note here is Android is less respectful of a timeout than iOS is. If iOS can't get to a particular server or a site, it tells you very, very quickly, hey, not happening. Android, I've seen cases where it can take up to 30 seconds or even more before it decides, oh, I'm giving up, and sending you back a message saying that that's no longer available. Because there could be a lot of traffic going on, you don't want to create your HTTP handler and then be disposing it, create, dispose, because I've seen issues where there's been memory resource problems with that. So instead, I opted for running two handlers. One that would do the background checks to see if whether the service was live, and one to actually handle the traffic. And even then, what I found is you can't just leave them hanging around all the time, because something happens in the background, one becomes stale, and you end up with other issues. So I found running a timer or checking once an hour, I actually recreate these handlers. Other than that, they get used, so they're not being recreated and disposed too regularly. But it's a great way to look and see what's happening. Now I'm going to jump into one of the simulators for a second and just give you an idea as to why that, or how that can become useful and helpful when you're running an application. I simply provide a support button here, which allows me to run some diagnostics, which is going to check and make sure that the API server is available, and also check that the internet's available. Because in situations where you're dealing with internal APIs or closed networks, you get users reporting things such as, oh, the data's not syncing, it's not working. And yes, I've got internet, I've got the little Wi-Fi symbol, you see up here, it works, it's connected. And then you find that they're on the wrong internal network, or that they're actually not connected to the VPN or the internet. So having a simple little diags page like this has saved a lot of time and effort, especially where you support people can then come back and say, hey, I want to do, well, it's not working, what do I need to do? The other thing to quickly mention while I'm here is this backup button. And this has saved me quite a few times as well. Simply whips through the file system on the device, zips it all up, and pushes it back to a server or back to Azure Blob Storage, where I can retrieve and have a look at the database directly off the device, where I've been creating those extra log items to. So whether it's just straight telemetry or specific items in the log that I'm wanting to see. And that's a great little thing to just include, tucked away somewhere that's in a support tool. I'm going to finish up with a key thing and the difference between emulators and real devices. Now, in this app here, when it launches, it checks to see if the user has actually registered the application, ready to do its data sync. It's a internal or B2B app, and the idea is the user simply puts their email, their custom PIN, and they can do a sync. Well, as you saw, when I opened the app, this little pop-up displayed beautifully. Won't let me out of there because it knows that this user has not been validated. One of the things that happened was everything looked great. Application goes on to the device for testing, iOS, perfect. Ran this into Android, and we found that the actual screen never showed. And it was like, why is that? It's the same bit of code. One of the things that happened was we're calling the onAppearing method, as we can see here, but we weren't actually running the setting of show user, which is the property that causes the pop-up to display inside its own dispatch queue. Cool, change that, and starts to work, works on the emulator, everybody's happy, let's ship. Look, on device, it still didn't work. And there was a key lesson, and the takeaway was that whilst it works on the emulator, you still can't go past testing it on device. Solution was simply to do a yield and then the dispatch call, everybody happy, another valuable lesson learned. And the other one there is that different Android devices will operate differently. I've had issues where a Samsung device operates differently to a Pixel device. So test, test, test. I'm looking down at my clock and cognizant of time. So we'll just check in with the team and see if we have any questions.
We do not have any questions right now, Paul. So pretty awesome.
Is that a good thing? Is that a good thing?
Well, no. So it's funny because like I've been trying to keep track of the Twitch sessions of the conversation on Twitch and on YouTube, and they're just talking about the demo, right? So it's not, and not necessarily that's a bad thing. It's just talking about what you were showing.
Cool. Well, we will honor the clock, and we can bring forth a quote, and that is: building cross-platform apps isn't about avoiding the problems, it's knowing where the bodies are buried.
That is pretty accurate based on everything you've showed thus far. So quick question, for that QR code that you have there, that is where people can download the samples that you had, right?
No, that one is for people to provide feedback. The samples, so the samples that I was showing were real live example codes of things. Okay. More than happy for people to reach out and talk to me about the usage of some of the control sets that we use, the beautiful UI stuff, and or the semaphoring in the database, anything that comes. When you're doing a session such as this one, which is about the things you've come across in the real life scenarios, obviously I didn't want to spend time or burn time just trying to come up with an app that broke. It's about sharing with people the sort of things that you're going to come up against, and how to start looking in terms of simplifying that debugging process and saving time.
Perfect. Awesome. No, like, great examples. Thank you so much for taking the time to share your talent and your time, obviously, with us. We really appreciate it. And thank you for making .NET Conf community today awesome.
Yeah, no problem at all. Thank you for everyone.
Thank you so much, Paul. All right, getting over here, I am bringing on our next presenters, Andy and Stacy. How's it going?
Hey, I'm Andy D. George. I am I work on .NET Docs, and this
Well, folks, this is the fun of doing live presentations. We're working on the technical issues over here. We had to swap out between desks, so please hold. Like I said on the YouTube chat, if you can provide a header of question and then a dash, then I'm monitoring those questions as well as I'm monitoring the ones on Twitch. I know there's a lot of great conversations, so I'll do my best to scroll up and down since you're having awesome conversations there, and we'll do our best with it. So one thing to, as we're waiting, I wanted to bring everybody up to speed that we are finishing up the community day, and starting at 5 p.m. today, we have a bunch of extra content, which is part of our YouTube premieres, that we will be running that content all the way to at least 3 a.m. Pacific time. And then starting tomorrow, we will have the student zones. So anybody who is brand new to the technology, to the platform, there's a lot of great content for you to have there. We have about 4.5 hours worth of content for you to check out, and for you to learn. Here in a bit, we will, towards the end of our last session, we will do our wrap up where we will be announcing the winners of our swag bag and the Coder Challenge. So I'm still waiting to hear back to if we can actually be ready for the team here. Also, worth noting that day 1, day 2 of .NET Conf is already out on YouTube. So if you go to the .NET YouTube channel, you can actually see the playlist, and you will also see the playlist for the premiere and for the student zone. Granted, they will not come on live until it's time for us to have that content ready at the time that I mentioned. But you can go check out all the content out there. You can see it all in continuity, or you can see each individual splice one. So if you just want to learn something about Copilot or Visual Studio and the MCP servers or all the other awesome content that we have out there, it's great for you to have out there and check it out. Now, because we're running a little bit late, we're gonna just sort of push this content out a little bit longer as we're figuring out those technical difficulties, and we should be good. The question, actually, so it's great. Someone had a question, is tomorrow the same setup? Absolutely. So the site will automatically cycle through those embedded, so you just tune in and you should be able to see it. The student zone does not start until 9 a.m. tomorrow, 9 a.m. Pacific, that is. So if you go to the website and you push play on the player, it will just have a countdown for you when the content will have there. So afterwards, we will have all the links available for you to have, and our team will be working to get all of the community day sessions out for you to view out in YouTube. So again, thank you so much for taking the time to spend with us in Community Day. This year, we opted to take something a little bit different. Instead of doing the 24 hours of .NET, we figured, okay, let's kind of focus more on the 12 hours, what's available for us to cover here at the conference, since Fritz and I and everybody else on the team is running around the clock, making sure that you all enjoy this awesome content that we have. We figured, hey, let's try something different. That's one of the things that I love about .NET Conf, is that we get to try something different every single year. And based on the feedback that we get from you all, whether it be via social media, Blue Sky, X, or Twitch or YouTube, we take all that information. We have our sit downs and our retros, and trying to figure out, okay, great, what can we make better for next year for all you to consume? So again, thank you so much for taking the time. What is my favorite recipe? Depends. What are we talking about, John? You know, my recipe, for example, I'm Mexican, so I love tacos, right? So anything that has a pretty good flavor to it, I'm game for. For example, Fritz and I had dinner last night over at one of the Mexican restaurants that is close to campus, because we finished up here, we wrapped up day 2, and then headed over to the .NET 10 launch party with all the product managers. Got to hang out there, have great conversations about everything that they're working on. Some people are already working on .NET 11, because guess what? next year around this time, .NET 11 will be launched. So it was great to talk about that, all the synergy that we built throughout the entire week. And then we went and had Mexican. That's essentially how luxurious our life really is here at the World of .NET Conf. There is not really a dull moment that we have. As I look through here, one thing to note is that we will be finishing up the day here, the community day, with the community toolkit roundup, where we will talking about the MAUI community toolkit and how you can contribute to that. And then starting at 5 p.m. Pacific, we will have the premieres kick off.
Javier, do you mind if I join you?
Please. Mr. Galloway, how's it going? Welcome to a live show.
I mean, it's one of those days. I had my internet was out most of the day. I was working tethered on my phone. It just came back, and I'm like, hey, I wanted to make at least a cameo at .NET Conf.
You know what? It would not be a .NET Conf without John Galloway. That's all I have to say.
Well, so I do want to, while we're just talking, we have some amazing stuff coming up. So that is they're YouTube premieres. So what that means is they're scheduled. They'll just kick off at the time, and we told all the speakers what time their session is at so that they can be in the live chat. If it works out for them, it's tough time zones are difficult, but we tried our best to kind of schedule that. So,
well, it's like you said, it's like the hardest part of .NET Conf when it comes to Community Day is trimming down all of the submissions, right? And to try to squeeze it into now the 12 hours, right? Because we're still having 30-minute sessions. Yeah. But we can't say no to all the awesome content. So that's why we reached out to some of our speakers this year. It's like, hey, would you like to pre-record?
It would, yeah. And it's great too with pre-record. Sometimes that works better for a variety of reasons. We have different time zones. Sometimes people need some editing. Like if you're doing an AI related thing, sometimes you need to cut the time out, you know what I mean? Or you need to be able to, so it works great. We had a fantastic one coming up from Mark Miller. I was just reviewing that one. He does amazing work with video editing.
Absolutely, yeah.
Yeah.
Well, and it's funny because the one thing that that has been consistent with all these conferences throughout the year is that we're wrangling chaos. And I mean that in a good way, right? Because of, like you said, there are times where, hey, we're sending out to emails to speakers who've committed over a month ago, and they have vacations because it's that time of the year where they're at in their globe, right? So it's like we have radio silence because rightfully so, they're on vacation. They're enjoying life outside of work. And then they come back and are like, oh my gosh, how do we get this? How do we do this tech check? How do we do these things? And it's great because we've built an awesome team behind it to support all of it.
Yep. Well, as you're saying that, I'm just remembering some of the great, because I've been in video editing land. We had people like turning in these sessions, been editing them, getting them already. So we have one from Bill Wagner on C#, and his is kind of on. We had one on day one, which is like what's new, and then we have from Bill. Bill's like doing these practical. Here's stuff you need to start using today, kind of stuff, So he's got a session there, and then we have another one on F# right after that. We have one state of RX.net. Lots of good stuff. So.
Yep. Well, let me check with the team over here. Give me 1 second. I'm going to mute for a second, and I will let you know. So,
okay. All right. Well, let me see. I can look at any kind of questions. Oh, I guess they're popping online right now. So you don't have to see me try and juggle. All right. I don't hear anything yet. I see them in the bottom of the screen. I see them making talking motions.
So what we're doing right now, welcome to the best way to describe .NET Conf, this is a straight telethon, right? Because we have the dancing dog that has to be right next to the person doing all the juggling, next to the person with the glasses and the water in the glasses and everything else. So what we're doing right now, we're literally switching audio from one machine to another because the video was working in that machine and it's not working in the other one. So we're literally trying to split the world. And you know what? It wouldn't be a dull moment in .NET Conf if we wouldn't have situations like this.
Well, I will say this is absolutely worth waiting for. I've been looking forward to this one.
Yes.
One of the top sessions. Godot is really cool. Game dev is amazing. And one of the top things a lot of people either do with C# or want to do with C#, you know?
Absolutely.
And Stacy just published a whole series, by the way, on Godot on the .NET YouTube channel. So fantastic content. I haven't watched it yet. I've been wanting to. So that is what I'm going to be doing over Thanksgiving.
Yeah, well, it's funny enough. You know, I mentioned this earlier when I was talking with Jay Tower was talking of adding NCP support to your APIs. That was one of the sessions we had earlier. And for myself as a developer, it's hard to know where do I want to dip my toes into AI first. And I think something like that is excellent for it. Are we almost ready? We're good. All right. So this is awesome, John. So they are ready. I'm gonna bring Stacy and Andy to talk about Godot. So give me 1 second.
All right.
There you are.
We're
Okay,
good.
take it away.
We're good.
Right.
Microphones are there and working. You can hear us. All right. Okay. I'm Andy DeGeorge. I am a senior content developer in the .NET Docs team, and I happen to be sitting next to my sister, Stacy.
Hi, I'm Stacy Hafner, and here at Microsoft, I'm the director of OSPO, officially. Unofficially, I love to teach game development whenever I can, and that's largely because of, well, you and games.
Yeah, I mean, like we grew up playing games together. And, you know, at that time, I was just a little bit older than you, so I'd start programming and
still are.
No, and so I would do programming and game development and stuff like that. And so then you sort of saw me doing game programming, and you know what looks more fun than making your own game?
Seriously, actually, there's really nothing more fun than making your own game.
Not even your kid.
Oh, okay.
Just kidding. Just kidding. No, it's fine.
More fun. Let's back that one up.
Back that one up. So yeah, so we made games.
Yeah, we did. So no, seriously, that piqued my interest. I loved watching you, and my dad too, or our dad too, made stuff. And so I eventually taught myself how to program and how to make games. And I did this through 3 techniques. The first was experimentation, which I think you're the same way.
I do the same way. Like I just want to open an app or anything and just dive in and mess with it and make it break and then get help.
It'll probably not work. Let's be honest. Most of the experiments don't. But that was one mechanism. And then my second actually was you literally calling you up and asking you for help.
Yep.
And then the third, because that didn't always work well, was Stack Overflow. But in searching online and trying to find the answer. And this whole process, it went really well, right? I'm a developer. I can proudly call myself a game dev at this point, but it took a long time to do. And about 6 months ago, I wanted to start learning Godot. And I also really wanted to play around with AI and see how far I could take that technology together. And well, if you can't tell, I have a child, so I don't really have a lot of time to spend like I did. And so I figured, hey, why not? Why not try and learn Godot, see if AI can help teach me and see how fast that could accelerate my learning. And it really did. It accelerated it. And I learned so much that I felt comfortable putting out a 9-part series on the .NET channel, teaching what I had learned from that whole process.
Yeah, with this talk, I did the same thing. I mean, we said, okay, let's do a talk on Godot and AI. And I said, I've never used Godot before. And so I used the techniques that we're going to basically show you in this video. And that I used this to learn Godot. I used AI to help me, to be my little learning buddy. Because just like when, we were growing up and you would ask me programming questions, it was nice to have somebody there that had experience or knowledge that you could rely on. And that's kind of like how I used AI. I turned it into my programming buddy who knows more than I do and can help guide me from the starting line to the finish line.
Yeah. And really this talk came about because, we many months apart kind of did the same thing.
Yeah.
And we started to figure out, okay, what's the commonalities in the things that we learned? And hey, let's go share this. So that's really what we're here to do, is walk through the different techniques and things that we learned to go and make a game. Yes.
Yeah.
But learn a new technology. And this applies to Godot. That's what we're walking through. But really these same techniques can work for anything. You want to learn MAUI or Blazor. Well, this all works.
Yeah. It helps you get there.
So with that, why don't we jump in?
Okay, so I have VS Code open, and I have GitHub Copilot, the Copilot open in VS Code, which is great. And it opens up by default now because it is a really useful tool. So if you haven't started using that, go do it. And I'm sure that we'll provide some links or something at the end to help people get started. But in this panel, we can see that there's a model selector. And so from here, we have a lot of different AI models we can choose from. LLMs, large language models. and then these have all been trained on different types of data, and then it builds that relationship in the backing model based on how it was trained with that. So when you run into a problem coding or designing something and you're using AI to help you, sometimes changing the model might get you a better result.
Yeah, and I do this a lot. A lot of times, I mean, if we're being perfectly honest, it's my fault with my bad prompting. But, you know, some models will handle my bad prompting a little better than the others.
Yeah.
There's actually a couple of other ways that you can, I guess, improve the output or the result from an LLM that you're working with. And one of those ways is through Model Context Protocol, or MCP Server. And these are really great because they allow you to connect your model to additional data or even capabilities. And so the data is really powerful because it lets you kind of, I guess, expand out the knowledge of your LLM without having to go through fine tuning and RAG and all of the lengthy training approaches. And
well, let's be honest too. Those are complex things. It takes a lot of time to learn all those things,
of data,
to training things and doing that all yourself. So MCP gives you that ability to expose more functionality, but also more resources for your LLM to rely on to get accurate information.
Yeah, and actually the other side of MCP that's really handy is you can expose additional capabilities. So it will get more access to like tools where it can actually perform different types of actions depending on what the point of that MCP is. So for this, I think we're setting up two.
Oh, we have one set up. We open up the command palette first in Visual Studio. So you can do our Visual Studio Code, push F1, and then type in MCP, and you can see all the different commands for MCP. And the first one is browse MCP servers. And we are going to add the Microsoft documentation as an MCP server because that's going to give us access to all the documentation Microsoft publishes, which would include like C#, .NET, the API surface of .NET would be in there. And then, you know, if you're working with other technologies, Azure or Windows Forms or anything like that, the documentation is going to be there for our AI model to ingest.
It's definitely not because Andy's doing a little bit of shout out to his work right now.
No, it's not that at all.
We also have Context 7, right?
I think so. I didn't see the pop-up for that on here, unfortunately. So, there we go.
Oh,
yes, there it is. Okay, yeah. Context 7 is a great MCP server. We already put this one in here because you have to provide an API key. But Context 7 is a service that exposes other sets of documentation. So Godot has their documentation in there. And what that does is now our MCP server can go look at the docs for Godot while we're asking Godot questions. And, you know, the AI models are very well trained too, so it knows a lot. So sometimes if something doesn't match, we can give it a prompt that says, can you tell me from the official documentation? And you'll see it go out there and search.
Yeah, which just improves its the result.
Yeah.
So there's actually another way, though, that we can guide, if you will, AI, and that's through instruction files. And there's two common types. One is Copilot instruction, and then the other one is kind of, I actually don't know when it got released, but I found out about it fairly recently, which is custom agents. And that's the one we're going to look at. So the key difference between these two is Copilot instruction files is what you want to do when you want to guide Copilot with project-specific type of information. Custom agents are when you want to create domain experts. So you want to create something that's a little more generic. Maybe you want to share it between different projects because it doesn't really have that project specific context. And these are both really powerful because they get sent up every time you do a prompt to your AI. So you don't have to continuously say the same types of information every time.
Yeah. And so let's show that right now.
Yeah.
We're going to jump in. So if you click on this little agent dropdown in the Copilot chat, you'll see there's a configure custom agent selection. So we'll select that. We'll click create new custom agent, and that's going to default to the agents folder in our workspace. And we're going to give it a name. And so our agent is going to be what?
A Godot teacher.
A Godot teacher. So let's name it Godot teacher. And that creates a new agent file for us. And the first part is a description. Now, this is just like the tooltip or what it displays down here in the bottom when you select that agent. So this is just going to be, we're going to say like, you know, an agent, oh, there we go. Look, AI filled it out for us. That teaches Godot concepts to users familiar with C# but new to Godot.
Oh, AI
Perfect.
knows exactly what we're doing. The next thing, though, that we can do is configure the tools or the capabilities that this agent is allowed to do.
Yeah, so we click configure tools, and that pops up this configure tools dialog.
Yeah, with loads of built-in stuff.
Yeah, so what do we got? We got edit files in your workspace, you know, and in there, if you can see what subtools that has, create directory, create files, edit files,
Yeah. So if you're not comfortable for whatever reason, say you have a teacher and you don't want that teacher to go making files for you, you could
You can turn
choose
that off.
not to.
So
make that.
we're going to enable all of them. And this is really VS Code's functionality. We're exposing the things that VS Code can do in your workspace to the agent you're creating. So that's why you might want to disable it in certain agents. That a research agent, you don't want it editing things. You just want it researching and reading things, but not changing things.
Yeah, exactly.
So, and then our MCP servers are listed here too. And so we're going to say, yep, we want our agent to be able to use those.
Perfect. And then the last thing though that we're going to want to do is actually tell this agent how it should behave or what things it should do or
And
not do.
The template here tells us it tells us that it says that we're defining what the custom agent's going to accomplish, how it's going to talk to the user. And so we've already crafted one of those, and we will go select, copy that, and then paste that in.
So real quick, while Andy is pasting that in, I will say this is probably the shortest description I've ever seen in a custom agent. Mine tend to be, rather lengthy and something that I'm constantly updating the more that I'm working with my agent.
Yeah. The more you're tweaking your agent to, when you notice a behavior that it's doing, you're like, I don't want it to do that or behave that way. Then you go to the agent config file and you write out, don't do that.
Yeah. Or you tell it to go edit it
Go
itself.
tell it to correct itself. That's like sending your kid to the corner, right? You go stand in the corner. I'm not going to put you in the corner. So this description here says that.
That's a weird analogy.
Her kid's really great. So this says we're telling the AI agent we want it to be an expert C# Godot developer whose role is teaching Godot concepts to new users. However, we're developers. We work in C#, so we don't need this agent to focus on the programming aspect because we know C#. Don't tell us how to create a class or how to add a property
or what a variable is.
Or don't teach us that stuff, but just teach us how do we apply that in Godot.
Yeah. And actually, so what is that? Line 7. It's probably one of my favorite parts of this, which is saying, do not create the files for us. Only instruct, only talk to us.
Yeah.
And it's really important to make sure to call out, and so important that we've gone in all capitals to yell it.
Yeah. So it listens better when you yell at it.
I don't know about that, actually. I've tried it. Didn't work. Okay. So this is fantastic. Now, one of the things that really I love about game development is how complex it is. You're always learning something new. I've been doing it for over a decade and I'm still constantly learning new things, which is just fantastic. But when you're going and you're trying to pick up a new skill, that can kind of be overwhelming. So what's really great is we can use our Copilot and our teaching agent to help us put together a plan for how we want to bring our vision to life.
Yeah, exactly. And so that, that's what we're going to start on. We'll close this down and then we're going to make sure that when we go to this the chat box, we're going to select our agent. And if you notice, it's right there now. So we'll click that. And then here's the description that we put up top. And so we're going to give it a prompt to generate this plan. And as in demo magic, I have this actually written. And so I'm going to paste this in and tell it to go. So the prompt that I'm giving AI at this point is I'm saying, hey, I want to create a game prototype with the purpose of learning Godot. It's going to be a 2D top-down game that a single player walks around in a maze and collects some treasure. And there's some monsters in there that if it runs into, it dies. And once it gets all the treasure, the exit opens up and you leave and you win the level.
Yeah. And one of the, again, the big benefit here is you're taking your vision of what he wants to make, or I guess we, in this example, and telling Copilot, hey, create a plan that lets us get to the goal of our experiment, the thing we want to do.
Yeah. Yeah. And so we could see that it gave us a quick game overview of what the game is about. And then it broke it up into high level phases. Phase 1, setting up the project. Phase 2, the player, then the maze, the treasure system, right? So it gave us all these high level concepts. Now, one thing that I say about AI is it's predictably unpredictable.
Yes.
And so we get, every time we've practiced this session and run through this, we get different plans, but they all generally have the same phases, concepts, bringing you from the start to the finish.
Yeah.
So for the sake of the demo, we have a plan that we got out of AI one time, and that's what we've used, in creating this.
To clarify, not one time as in it took one single prompt. That pretty much never happens.
Yeah, this prompt we sent originally over here, sometimes we were too vague and we're like, okay, no, we got to have a little description. So learning how to prompt AI, that is a skill you learn by using AI.
That really is. But also to get this plan, we went back and forth with AI. We kept revising it. So it wasn't a single prompt that was like, hey, do this. Oh my God, magic just popped out. We're good to go.
Everything I need.
It was back and forth.
So,
All right. So what do we have in this?
So Okay, so in this version, we have, same thing, game overview with some information. Our phase, we just start right now.
Let's start building it. So we're not going to get through the whole game, unfortunately. We don't have enough time, but let's get through creating the player, I think is what.
So we do project setup and course structure. So obviously we got to create a project. And we've already installed Godot. We downloaded the C# version of Godot.
Yep.
And so we just went into, create a new game and click create. And we have that in there. And we should see that's going to pop up. And then I want to double check.
Yeah. And if you need instructions for installing while he's doing that, you obviously can ask AI. Also, just to plug my own video,
how do I do it?
I did a video series that has a video that walks through setting up Godot for .NET.
So we see this default scene is obviously 3D, and we know we're creating a 2D game. So I'm going to click 2D. Okay. So now this looks like a 2D game at this point, not a 3D game.
Looks right. But also there's a lot going on in the engine.
Yeah.
So let's pop back over to the instructions and see what it wants us to do.
We're going to do a little split screen here. And then
I think the first step is actually create some folders.
Create folder structure.
Yeah.
Yeah.
You know
So
how
we
I
have
feel
these.
about this.
We have these folders. We have our assets. I already created some amazing game art for this.
Oh, it is
so
great.
We'll show that. But, so I put that in an assets folder.
Beautiful.
And then, I don't want to right click and create folders over and over. So you know what? Because we gave AI the access to VS Code, let's just ask it to do it. So we'll say, I've selected those, and I'm going to say, create these folders. And I'll just have it go do that.
And
so
why don't we dive in a little bit? How does it know what these are?
Yeah. So if we look at this, I selected this piece of the task, the task list. And if we look at in the prompt, it shows our game plan selected, but then it also shows those lines 20 through 23. So when I said these, it knew the context that I was talking about.
Yeah, and actually to build on that a little bit, even without anything selected, it's always trying to provide the file that you have open with context or as context with the prompt. So what's actually going up is the agent, the custom agent, and the file that's selected, or in the case of his prompt, the specific lines.
And so we can see it came back, it said it created those folders. So I'll click on one and prove it. Prove it AI. So there it is. Those are those folders. So that's how we can do that.
So I think we can close off the first part of the task.
Yeah. So we're going to edit our plan, because we want to keep editing the plan. As we're going, we might take a break, come back the next day. We want to know what have we completed. We also want AI to know what we have completed already. So we're going to check mark that one. And so the next one is
create a main game scene,
main
which
game
you
scene.
pretty much did.
Got a scene. Yeah, you get a scene by default. So I'm going to put that into the scenes and then scene folder, and it said name it main. So there we go. And what do we do next?
Mark it off.
There we go.
All right. So now we're into the good stuff. Now we're into creating a player
implementation. So I mean, it gave us some high level ideas, but I'm new to Godot. I don't know what I'm doing. So when it explains something like this, I'm not sure what to do. I'm not familiar enough. I haven't learned the skill yet. So we can use AI to do that. Right?
Yeah. So why don't you select it and let's give it a good prompt.
Okay. And here's a good thing to point out right now. I'm gonna start a new chat.
Why?
I don't want the history of my previous chats of like when I went back and forth about, create these folders, do that. I don't want this new task to necessarily have that information because it's not pertinent to completing this task. And if we change something along the way, we might confuse AI because we did it something one way at the beginning, but then we changed it before we got to the next part.
So we just kind of, I think you and I both agree, good practice is clear out the context as you're shifting tasks or features or things that you're working on, just so it has kind of fresh info. All right, so what have you written here? Please update these tasks with more information about what to do. Okay, good. You have to update the plan. I was like, we don't have update the plan.
Yeah, I want to tell it, update our plan, because it'll write it back to you in the chat, but I don't necessarily want to always reference the chat. I want it in the plan because, like I said, we might stop at some point, come back later. I want that information in my plan telling me what to do.
And this goes back to that concept of good prompting. One of the times when we ran through this, we actually didn't say put it in the plan, and it just kept going.
It just kept typing.
And so we had to hit stop and then revise the prompt. And so now obviously we're making sure to include that. But sometimes I think you default to just read my mind and know what I want.
So here we go. We broke it. It broke it into phase 2A, build the player scene in node hierarchy. So why don't you walk me through what to do here?
Okay. Could you just zoom in like a hair?
Yeah, sure.
Thank you. Okay. So I'm on line 37. We're going to, in Godot, create a new scene, and it tells you how, scene new. add character body 2D as the root node. It says click other node.
Other node.
Yep.
So character body 2D. Okay.
Yep. Rename it. Push F2. I did not know about the F2 universal thing until recently.
Rename everything with F2.
I'm always using it now. Right click. I'm on line 41. Right click and add sprite 2D as a child.
Okay. So yeah, we learned the skill of how do I add a child node? How do I right click?
Right click and now it's a child.
Add node. So sprite 2D.
And then it says in the inspector, drag. I love that this one it does drag. They tell us different ones each way. Drag player PNG from file system into the texture property. And the sprite should now be visible in the 2D viewport. So the reason, though, that it knows about player PNG is because it has access to the file. And that was the one thing that we carried over was a series of beautiful artwork.
Yeah. So here you go. There's this amazing piece of artwork.
Andy has what we call dad's art skills.
No, I don't. I have great skills. Anyways, next. What's the next line? 43,
I lost my
40,
place.
45.
Yes, 45. Okay. Add collision shape 2D as a child of character body 2D.
Yep. Okay. So what was it? Collision?
Yeah, shape 2D.
2D.
And then you're going to add right click player, add. So you're back on player. This is interesting. This is actually, oh, yeah. No.
Yeah.
I missed a line. It's got it. Yeah.
Yeah. So in collision shape 2D, it says go back to that inspector and choose shape.
Shape. Yep. And you're going to pick rectangle shape 2D.
Okay.
Yeah.
There we go.
My apologies. It didn't do a good job. This is what we were trying to kind of prompt it in breaking out these tasks so it wasn't one lengthy thing.
Although it did do sub. It did indent them with it, which is nice. So you got that.
I feel like we should have prompted in the prompt. We should have said like headers.
The word wrapping also kind of messes with that.
It does. Okay. I've lost my place again.
I think this one.
Yes, you done
49.
49. All right. Area 2D as a child of character body 2D.
Okay.
And this actually, what I love is it says for treasure / enemy detection. So it's starting to tell us a little bit as to the why. Not necessarily enough information, but some. Okay. So you right click.
Add another child node to that one.
Yeah, which is strange. This one's kind of going a little. Oh, I see. It's sub nodes. I see where I got stuck.
Yeah.
Line 49 and 50 are kind of repeating itself a little.
Mm-hmm.
Yeah. Okay. Anyway, so
it's telling you the overall goal.
And then it's doing it. I was reading it a little differently. Okay. So collision shape 2D as a child. And then you are going to do the same thing. So create a new shape in the inspector.
Okay.
And I'm assuming rectangle again. It hasn't told us, but we can kind of intuitively select that. And then it says you want to make it larger.
Yeah. Because we want to be able to hit stuff before we hit a wall or things. So
You know what's great though? Scroll down a little bit. It gives us the hierarchy.
Yeah.
So we can compare that to the other one and say, are we kind of meeting the bar for it?
Are we following it along correctly? Yep. Yeah. It is. The last task was save.
Yes. And I do think this might be a good opportunity to ask it some questions. For example, you know, why did it have us do two collisions?
Yeah. Okay. So let's see. Okay. So we have the history of what it just said. So we'll keep that history because our questions related to that history.
But let's ask it why it did that.
Why do two different collisions and why use area 2D?
And say maybe in the phase that we're in.
Yeah. In phase, what was it?
I think it's
2A. 2A. Okay.
All right. You know, and while that's going, okay, it went fast.
Fast.
Yeah.
Okay, so it tells us solid physics, the collision shape, it's part of the player. So this prevents the player from walking through walls and walking through other solid objects.
Okay.
And then it says collision shape 2D as an area 2D is for triggering events. It detects when you have triggered something. It doesn't block movement, but it fires signals when something enters the area.
Interesting. So that's really handy. And again, it's one of those opportunities where the plan's kind of telling you very quickly, hey, here's what to walk through, but you can take any part of this plan and have it dig a little deeper to understand.
Yeah.
And we can then we won't for time's sake, but we could even ask it, hey, send us the documentation for these things too, and then go off and read it. And that's something I did a bunch of.
Yeah, I want to learn more about what can I do with this area 2D?
Yep.
Where does it give me the link to the docs or, or if something was incorrect here, we'd say, okay, wait, it's not right. Can you go check the docs and double check?
Exactly. Okay, so what's the next part? Now I think we're doing the script.
Yep, phase 2B, create player movement script.
Awesome. Okay, so this again actually feels like another good opportunity to ask AI where the heck it's talking about. So what is it saying?
No, I mean, it says attach a C# script to the player node.
Yep. But it's telling us to do an icon.
So we can do, it says right click, attach It says node. Click the attached script icon, scroll page icon. I don't know what that is.
I don't know. Why don't we take a screenshot and ask it?
Okay, yeah, let's do that. So this is another great thing. We can have screenshots and use screenshots to ask AI, okay, help me explain what you just told me to do.
Yeah, and honestly, like that's one of the things, that's why actually I loved Godot for this session, because having a separate UI, a separate engine really increases the complexity of trying to learn something, because you're doing another program that's kind of off outside of it. So being able to take screenshots, send it over, ask it for help, I think we actually learned a couple of things from it. One was, this feels like a silly example, but we actually didn't know where it was talking about in one of our sessions, because I add my scripts a whole different way, and I think you did too.
Yeah.
And so we both learned, oh, okay, that's where it was talking about. And then there was another where we were looking into the color change of the area node,
Yeah.
and there was a way that I knew how to do it, and we asked it just to see what it would do, and it told us a whole different direction.
Way, yeah.
I had no idea.
Because obviously there's not just one way to do something in Godot, you know, there's different ways to accomplish it. But okay, so the result we got, we pasted in our image, so we can see right here. Here's our image pasted.
Yep.
We asked it, I selected it for context, and then asked it the question about. Then it says, looking at the screenshot, the attached script icon is located at the top of the scene panel. So, okay, scene panel's right here.
Showing it.
Left side of the tree, so it's showing the left side. It's the scroll document icon with a plus sign in the toolbar. In your screenshot, it's in the horizontal toolbar above the scene tree, where you can see the player node selected. See, it knows I've selected the node by analyzing the screenshot. It knows it's selected. So it says above it. You know what? I see this right there.
You know, I have to say, one of my favorite ones, because we, you know, again, we tried this a couple of times, and one of my favorite ones was it actually counted. It's the fourth icon from the left.
Yeah.
I was like, wow, that was actually pretty impressive.
So what we're going to do is we're going to C#.
Yep.
We're doing
C#.
C#.
We're doing C#.
And then it says a scripts folder right here.
Yep.
So we will put this into the scripts folder. Scripts. Enter.
All right.
Okay. Yep. There's our script, and we'll expand this out right now.
Actually, yeah, I think we can go full screen. Yeah.
There we go. So close that down, and we'll just go side by side. Okay. So in here, it gave us some code. It said let's see, get this speed property. So I'm going to paste this in. And then it said to also then paste this in. How do you feel about pasting in?
I don't love it. I don't love this at all. But, you know, again, for time's sake, I think it makes sense. So you're aligned with me. We got into, I don't even want to say a philosophical debate, because it wasn't a debate. It was an agreement that I think we both believe that when you're learning something for the first time, it's actually really important not to copy and paste it, but instead to retype it. And why?
Well, because, you know, it's muscle memory. If I just copy paste, I don't necessarily learn. And the point of this is teach me how to use Godot. So typing in the code, I'm going to explore the API. I'm going to get a feel for it. I'm going to use my own variable names, you know, things like that. It's really going to increase your learning.
Yeah, I agree. And actually, so if we look at the plan, it was nice enough in this one to start to break down some of what you're doing.
Yeah,
right?
and it's giving us some explanations too, right?
Yeah. And this is one of those things where we saw different degrees of it. Sometimes, I actually think this is the first time we've seen it split up the code.
Yep, it always just gave us the entire code for the whole class, as opposed to like saying, being more of a teacher and saying, go into here and do this.
Yeah, so it was kind of excelling pretty well at the teaching. What I think we could do real quick is, why don't we ask a little bit more about move and slide?
Move and slide.
Yeah, just real quick. Move and slide.
Where
is
am I?
that?
Chat.
Oops.
Yep, well, it's like the game plan again. I'm going to say, tell me more about move and slide.
Slid.
Move and slid.
Slid. I'm sure it'll figure it out.
Alternative spelling. Yeah, I figured it out.
I love watching you fix your spelling when we were doing stuff.
But yeah, look at this. It gave us a little diagram of how movement behavior works, sliding against the wall, why it's useful, how it's calculated. So basically it says that this is going to move as a physics object. It's going to take in the velocity and the directions and move our character.